Hello and welcome, I'm your CodeMonkey, and here is a free complete course on making a game from start to finish. If you've always wanted to learn how to make a game, or if you already know the basics but want to see how to organize a more complex project, then this video is for you. It's perfect for both beginners and more intermediate users. This is a completely free course video, but it has the same level of quality as my paid courses or my Steam games. You can download the project files to follow along or inspect the final game. You can even play the final game directly on Steam. We're going to start completely from scratch and build a really awesome game with tons of systems and mechanics. Building this design requires working with lots of Unity and C# features, so this is a really awesome project for you to learn. After following this course and learning all of these techniques, you will be able to build all kinds of games in all kinds of genres. This is going to involve learning about the basics of Unity and C#, learning how to make a character controller, physics raycasts, learn all about C# interface and events, using scriptable objects, handling UI, the new input system, and lots more. Very importantly, everything that we're going to do here is going to be focused on writing good, easy to understand, clean code. Meaning that I will not be teaching you bad practices that some beginner tutorials teach. The code that we're going to write here is production quality code. This is not a throwaway demo. The quality of the code and the structure of the game that we're going to build is on the same level of quality as my own Steam games. As you can see from the video link, this is indeed a complete, very thorough course, so don't try to watch this whole thing in one sitting. Take your time, take it slow, and just focus on learning. There are chapters for every single lecture in the video. Here's a quick overview of the entire course, all the steps that we're going to take to reach the final polished game. So first of all, we're going to start completely from scratch by selecting a Unity version and creating a brand new project. With that new project, we will then learn all about the basics of the Unity interface and set up a layout. Then the other important part is Visual Studio, which is where we're going to be writing all of our code. After that comes an extremely important lecture all about coding style and naming rules. Like I said, the code in this course is on the same level of quality as my Steam games, so having proper naming rules and good code style is paramount. Next, we're going to download and import all the assets that we're going to use in the course. Everything is included so you can follow along with every step of the way. With the assets imported, we're going to set up some quick post-processing just to make the game look good. Then for our first piece of logic, we're going to make a simple character controller. With that logic working, we will then implement a proper character visual with the included assets. Next, we're going to learn the basics of animation and the animator component. And with that, we're going to make our player really come alive with some simple but really nice animations. Then we're going to install the Cinemachine package. This isn't actually used too much in this course, but I still wanted to include it because it is such a useful tool, so I do want you to know about it. After that comes another extremely important lecture with regards to writing some good clean code. We're going to do a nice refactor to replace the legacy input manager with the brand new input system. Learning how to refactor is an extremely important and very valuable skill that will massively improve the quality of your code. With that done, we're going to implement some nice collision detection to make sure our character doesn't walk through walls. Next, we're going to create the very first kitchen counter and make a script to handle how to interact with it. Then we're going to learn all about C# events and create a proper interact input. Next, we're going to build a selected counter visual, which will require us to learn about the extremely useful singleton pattern. With the counters working, we're going to start working on the kitchen objects themselves. So these are going to be the ingredients and the plates. We're going to use scriptable objects to define all of the types. Then a very important part of our design is each kitchen object will have to be placed somewhere, so we're going to take some time to really think about the best way to achieve that, all while writing some good clean code. Next, we're going to enable the player to pick up an object. In doing so, we're going to learn about C# interfaces. Then we're going to make a container counter. This is from where we can spawn new objects. With that, we will enable the player to pick up objects and drop them anywhere where there's space. Then we're going to make the cutting counter. This one enables the player to cut an ingredient into slices. So to do that, we're going to make an alternate interact action. And for handling the cutting, we're going to once again use scriptable objects to define a proper cutting recipe. Then we're going to learn about a really awesome Unity feature, World Canvases, and use that to display a nice progress bar for our cutting progress. After that is a quick lecture, just going to make a very useful generic script to make any object look at the camera. Next, for another counter, we're going to build a trash bin. This is where the player can drop objects to destroy them. Then the stove counter. This one is going to be quite a bit complex. We're going to create recipes for cooking and for burning. We're going to learn how to make a basic state machine and handle timers. Next, we're going to make the plates counter. This is a simple counter that just spawns a bunch of plates. After that, we're going to make some custom logic on the plate to be able to hold other objects. With that logic working, we're going to build a complete visual for all the objects that can exist on the plate. Then make a nice UI element on the plate itself to showcase the icons of what exactly is on that plate. Afterwards, we're going to make the very last counter, the delivery counter. This is where we drop the completed plates. And in this lecture, we're also going to learn about the Unity shader graph and make a quick, simple custom shader. Then we're going to build the delivery manager class that generates the recipes that the customers are requesting. Next, we're going to build a UI to showcase the waiting recipes. After that comes something pretty crucial. We're going to add some music and then add some sound effects for all kinds of game actions. With that, the game will be almost done. So next, we're going to build a proper game start and a game end. Then make a simple main menu and handle scene loading. After that, handle creating a basic pause window. Then make an options menu, enable the player to modify the audio levels and rebind keys. After that, we're going to enable menu navigation with a controller. And in the end, as usual, comes the polish stage. So we're going to add all kinds of small tweaks and effects to make the game feel really great. Like I've said many times, polish is what separates good games from great games. After all of that, we will have our final completed project. So as you can see, you will learn about tons of topics by following this course. Also, let me point out, one of the reasons why I chose this specific design is because my next free course will be on taking the game that we're going to build here and make it multiplayer. So if you've ever wanted to make multiplayer games, then that course will be excellent for you. Definitely take your time following this course. The multiplayer free course should hopefully be out next month, or if you're watching this in the future, check the links in the description. Although that multiplayer video won't be starting from where this course ends, so definitely make sure you watch this one. Now, if you're new to the channel, then welcome, and here's a bit about me and my credentials, or why you should listen to what I have to teach. My name is Hugo, and I've been running this CodeMonkey YouTube channel for 5 years now. In total, almost 700 videos on all kinds of topics, including tons of tutorials sharing my knowledge to help you on your game dev journey. I'm also a professional indie game developer, making games for over 10 years with 8 successful games published on Steam, so what I'm teaching here is based on a lot of years of experience making a lot of games. Just like with my paid courses, I'm always going to be in the comments answering questions, so if you get stuck at a particular point or need extra clarification on something, go ahead, post a comment and I'll do my best to help. Do make sure you include a timestamp of what you're referring to. I will also be updating the pinned comment with any frequently asked questions that I see, so actually right now go ahead, pause the video and scroll down a bit just to look at that comment. Since on YouTube I cannot update the video after it's published, I will be updating that comment over the next months and years with anything that comes up. Also, I've been running this channel for 5 years, and in that time I've made almost 700 videos, so there's lots of topics that I've covered separately in more detail. All of those videos are linked in the description. Throughout this course, I will be focused on building this specific game using whatever it takes to build it, meaning, for example, when we get to using C# events, I will teach the basics about how they work in order to achieve what we want to build, but if you then want to learn about C# events in more detail, definitely go watch the dedicated video. And I also made a page on my website for this course. It contains a link to download all of the project assets. You can also download the complete project files for every single lecture. So if you get stuck at any point, you can download the code at that lecture and compare with your own. There's also references to all of the videos, and I will also be including frequently asked questions for each lecture. So definitely keep that page open in a second tab as you follow along this course. Now, this free course took a ton of work to make, so I really hope you find this video helpful. Go ahead and hit the like button if it helps you. It's a small thing, but it generally does help this video on the YouTube algorithm. Making this course was a ton of work, and by making it completely free, it means it will obviously never make as much money as if I had just made this a paid course. I'm perfectly okay with that decision, with the hopes that by making it free, it will reach and help many more people. I'm also a big believer that education should be free, so if you can't afford one of my paid courses, like if you're just a kid or going through a rough time, I still want you to have access to high quality education so you can achieve your game dev dreams. One easy way you can help me for free is simply by liking this video, subscribing to the channel, and just watching this course. That will hopefully help push this video on the YouTube algorithm and help it reach many more people. Another free way to support what I do is I'm currently working on my next Steam game called Total World Liberation. You can wishlist the game on Steam. Wishlists matter a lot for Steam visibility, so just by doing that you will be helping me. And just in case you can't afford it, and you find this free course useful, you can also support what I do in a few other ways. I spent a bunch of money making this course. I hired an artist for the 3D assets so that I had the rights to distribute them so that you can download and follow along. Same thing for the music and sound effects, the logo, and the cost to upload the game to Steam. So I would like to at least not lose money on this project. Hopefully there's enough of you who can afford to help me so that I can at least break even. And for one way you can support is I added this exact same course on my website as a regular paid course. Although I want to be very clear, there's absolutely no difference between this free video and the paid course. There is absolutely nothing behind any kind of paywall. All of the lectures are free, all of the asks are free, everything is free. You don't have to pay for anything if you can't afford it or you just don't want to. The paid version is essentially a donation. The only difference is this free YouTube video has regular YouTube ads, whereas the paid version on the website doesn't have any ads. That's it, that's the only thing. So the only reason why I made that paid version is just in case some of you can't afford it and you want to support what I do and want to help me break even on this project. But again, only do that if you can afford it. If you can't, that's perfectly fine. I hope you'll learn a ton from watching and following this free course. Beyond that, if you follow this course and you enjoy my teaching style, perhaps look into my other courses. If you like this video, then I think you will really like my turn-based strategy course. That is the perfect course to follow up on this one. It dives even deeper into some of the concepts used here, and it will help you make the jump from beginner to advanced. And since you're interested in Unity, I think my Ultimate Unity Overview course would also be very useful to you. Each lecture on that course is focused on teaching one Unity tool or feature. There's already over 50 lectures, including plenty of small but very important things that you just wouldn't see in a regular YouTube video. If you're interested in visual scripting, I have a course on making 3 unique games entirely with visual scripting and no code at all. Or if you prefer code, you can learn how to build a nice Builder Defender game. So if you enjoy my teaching style in this free course, then check out my other ones. Then of course YouTube has channel memberships and super thanks, so you can use those if you want. I also have my Patreon if you prefer that. And in a lot of my videos I have some affiliate links. If you ever pick up anything through those, I get a nice commission. And I also have some of my own assets on the Unity App Store. So if you enjoy this free course and you want to support what I do, there's plenty of ways. But again, don't feel obligated. If you can't afford it or you just don't want to, that's perfectly fine. I hope you'll learn a ton from watching and following this free course. Alright, so that's enough talk of that for now. Before we begin building the game from scratch, let's inspect the final polished game that we're going to build. So let's see that in the next lecture. Hello and welcome, I'm your CodeMonkey. Here let's take a look at the final game that we're going to build. So we start off on a simple but really nice main menu. So we've got a nice visual, a nice logo, and a bunch of useful buttons. Then of course the game has a nice loading system, so when I click on play, it's going to load into a loading scene and then finally into the final game scene. So let's go ahead and play. And if there we go, here we do see the game scene, and right away we see a nice tutorial window. So it's telling us how to play the game, so the basic interactions, and then over here the controls. Importantly, these are all rebindable, so over here this element is all dynamic. Then we can look at this tutorial for as long as we want, and we are waiting for the interact to continue. There's also a really nice song playing in the background, so the game has music. Now we can look at this tutorial for as long as we want, and when we're ready we can interact to continue. And as soon as we do, yep, there you go, we've got a nice countdown, some nice animations, a nice sound effect, and there you go, now we are playing. Okay, so here I am controlling a nice character. I can move in any direction. There is collision detection, so obviously I cannot go inside solid objects. So I can walk around, and for the goal of the game, over here on the left side we've got recipes that the customers are waiting for. So for example, one customer wants a simple burger. So for that, we gotta need to pick up a nice bun, so let's pick it up. Then the burger obviously requires a meat patty, so let's go ahead, we can pick one up from here, but this one is an uncooked meat patty, so we need to drop it over here on the stove. And there you go, it starts cooking. We've got a nice timer, we've got a nice world bar UI. And there you go, it keeps counting, and we've got some nice particles, some nice visuals, and over there even a nice indicator telling us the meat is about to burn. And there you go, the meat has burned. So now I can pick this up, and I'm holding some burnt meat, so the customer probably doesn't want to eat this. So we can go over here to the trash in order to trash it. Let's try doing another one and do it properly. So let's wait for it to cook. Pick up a plate so we can pick it up directly onto the plate. There you go, the meat is cooked, so let's pick it up. Then go pick up some bread, and there you go, here we have our complete recipe. So let's go into the delivery counter, deliver it, and there you go, a nice delivery success. Alright, awesome, we've just delivered our first recipe. So then someone else wants a salad, so let's go ahead and pick up a tomato. Here we have a big uncut tomato, so let's drop it onto a cutting board. And now we can interact with it, so we can interact with a secondary interaction key. And by interacting, we cut the tomato, so it takes a few cuts, and there you go, it slices, and it's sliced into tomato slices. So let's do the same thing for the cabbage. here we are holding a regular cabbage, then slice it, and this one actually takes a bunch more, and there you go, got both slices. Okay, great. So now let's pick up the plate, pick up both slices, and deliver to the customer, and there you go, got a nice success. Alright, awesome. And of course, we have a correct identification of if we have a correct recipe or not. So if I just pick up an empty plate and deliver it, there you go, we got a failed delivery because nobody wants just an empty plate. Alright, so here you can already see quite a lot of interactions, quite a lot of systems at work. So the character has a nice character controller, it has physics interaction, you can see how it identifies the counter that is in front of the character. I can press a button to interact with the counter, and interacting with different counters does different things. So if I interact with a clear counter, I can pick up or drop things. Over here I can pick up and drop it. With an alternate interaction, I can do the second action. Then there's the stove machine, so that one has a nice state machine, so it counts up. Over here we've got some nice particles, we've got a nice bloom, so all the visuals look really great, so we've got some post-processing. We have a bunch of UI elements directly on the world, and outside of here we've got some regular UI elements. So we've got the recipes with dynamic icons for all of them. We've got a timer over there on the top right corner showing how long we have to deliver all our recipes. And on the kitchen counter we're also using a custom shader, so this was built using ShaderGraph. So as you can see, lots of interlocked systems. Then the game also has, of course, the basics that any game should have. So I can pause the game, and there you go, we've got a nice pause menu. So we can resume to go back, or pause it again. And of course, while paused, everything is paused, so that's great. We can go back into the main menu, or we can go into options. And over here we can play around the sound effects volume, the music volume. We've got all of our controls. Importantly, these are the controls for the keyboard and also the gamepad. So the game can be played with any gamepad, so it can be an Xbox controller, PlayStation, Switch controller, it doesn't matter, all of them work. And we can also rebind all of these keys, both the keys as well as the gamepad inputs. So let's go ahead and deliver a cheeseburger, so here's some burnt meat, so let's toss this. Then pick up some more meat, pick up a plate, here we've got some cheese, we've got some bread, pick up the meat and deliver it. Alright, awesome! And of course, finally at the end, when our timer is elapsed, here we have a nice game over window showing how many recipes we delivered. Alright, so this is the final game that we're going to build. As you can see, it involves lots of interesting interactions which require learning lots of different skills. We're going to be using C# interfaces, C# events, the new input system, shader graphs, scriptable objects. We're going to learn about C# events, make a character controller, handle collisions, and so on. Like I said, one thing that we're going to focus heavily throughout the making of this game is on writing good, clean code, meaning that the final game that we're going to build will be very easy to expand upon. Thanks to how all the code is very clean, it will be very easy to add more recipes, maybe more counters with more actions, maybe things like perhaps washing dishes, adding an oven, and so on. Or really, you could make something completely different. This game is all about character and interactions, so that could be whatever you want. You could take this as a base and build some kind of sci-fi game, something like Among Us or FTL. You could make a survival crafting game like Rust or Minecraft or Don't Starve. Really, by learning how to build this game, by the end you will have gained the knowledge required to build all kinds of unique and interesting games. Alright, so now that we've seen the final game, let's actually build it. Just before we do, let's get a quick refresher of the absolute basics you should know in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to just get a quick refresher of the absolute basics you should know in order to be able to follow everything in this course. Okay, so like I said, this free course is targeted at both beginners and more intermediate users. In order to start following the course, you really only need to know the absolute basics. I've made 3 useful videos with all of the basic knowledge required to follow this course. Watch the video on how to download, install, and set up Unity, then the quick Unity basics, and the C# basics. Those 3 quick videos contain all of the absolute basic knowledge you need. So if you're a complete beginner, go ahead, pause this video and go quickly watch those. And even if you're already somewhat familiar with Unity, still go ahead and give those videos a watch, perhaps in a faster speed, just so you know everything that this course assumes that you know. Here I will assume that you know the basics covered in those videos, like what is a game object, what is a transform, what is a mono behavior, how scripts have a start and update, and some C# basics. As long as you know those absolute basics, you should be able to follow everything in this course. I will teach everything above the absolute basics. And if you are a more advanced user, definitely keep watching. The beginning of this course might not have much that is new to you, but as we build the game and start using more advanced tools like scriptable objects, C# events, and interfaces, refactoring code and focusing on project architecture and writing some good clean code, if you are not a complete beginner, you will still learn quite a lot from seeing how this project is built. And again, like I said, I answer comments every single day, so any questions you have, just post them there and I'll do my best to help. This course is split into lectures. They are all as chapters on the video so you can navigate around. Let me also take this time to point out that you are not expected to follow this course in one sitting. Go ahead and take your time, focus on actually learning. Remember, that's the only goal. You're not competing with anyone, you're gaining knowledge just for yourself. So take as much time as you need, rewatch some lectures if you feel you didn't fully get it, or just ask some questions. Whatever you do, take your time and just focus on actually learning. So again, if you haven't done so, go ahead, pause this video and go watch those 3 basics videos. With that, we're going to have everything we need to get started. We're going to start completely from scratch, so let's begin creating a brand new project in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to begin actually building our game. So let's create a completely empty project and start building it all from scratch. Okay, so the first thing that we need is to install Unity. Now I covered this in detail in that other basics video, so here I will assume that you already have Unity Hub installed. The first decision we really need to make is choosing a Unity version. So on Unity Hub, you go into Installs and install an editor. And now Unity recommends that you use the LTS version or long-term support. You should be using that one in most cases. It's what it installs by default, which as of the time of this recording, the latest LTS one is 2021.3. However, I want this video to stay up to date for as long as possible, so for making this game, I will actually be using version 2022.2. If you're watching this video right as it came out, then download this version. And if you're watching this months in the future, after version 22 LTS is out, then you can use that one. It won't probably be the exact same thing as version 22.2, so you should be able to follow everything exactly. For any changes, I will point them out in the updated pinned comment. And if you're watching this years in the future and there's an even newer LTS version, I would still recommend you follow using the 22 LTS. Don't worry about using a quote-unquote older version. Everything you'll learn here in this version will still be applicable even 10 years from now. So like I said, I'm going to be installing this one. And in terms of modules, it doesn't really need anything. I already have Visual Studio Community installed, and all of the other ones are unticked, so install. Okay, so the version is installed. Now let's create a new project. Let's go into the Projects tab. Then create a new project. And now first up here, make sure to select the right version. So again, I'm going to be using 22.2. Then for the templates, this has mainly to do with the Unity render pipelines. Now, if you're a beginner, don't worry about that too much. Just go ahead and select the 3D URP template. So scroll down, this one right here, 3D URP. Make sure to select this one and not the one that says just 3D. The URP here stands for the Universal Render Pipeline, which means our game will be playable on literally any platform. So we can make the final game and put it on Steam or consoles or mobile. It will run on everything. Then over here on the right side, let's quickly just download the template. There it is, it's done. Now select the name for your project. So I'm going to call this Kitchen Chaos and then select the folder for it. Alright, so that's it. Again, make sure you're using the exact right version. Make sure you're using the 3D URP template. Give it a name, a folder, and let's hit on create. Alright, so it's open, and right away you might or might not see a window talking about URP material upgrades. I think this has to do with the template not having the default materials updated to the latest URP version. So if you're watching this in the future, chances are you might not see this one at all. But if you do, then just go ahead, click on OK, and it will automatically upgrade all of the default materials. Alright, so here we have our basic Unity window. Now, since we started a project starting from the URP template, we have down here a bunch of URP helper files. So you can click to select the README file, and you can see it over here on the right side on the inspector. If you want, you can browse around these links in order to learn more about URP, but in our case, for building our game, we really don't need this. So over here on the inspector, let's just click this button to clean up these README files. Just go ahead, click on yes, and okay, that's it. So basically you should only have these files in your project window. So there's the scene folder, and inside we've got the sample scene, then we've got the settings, and inside a bunch of URP assets. All this should have been set up automatically since we use the 3D template. And then finally we just have the URP global settings asset. Now let's just verify everything worked correctly. So let's go to the top left, go into edit, then go down into project settings. Then over here, let's go into the graphics tab, and you should see the URP high fidelity asset assigned by default. If not, you can click on the circle icon and assign it. Then the other menus over here, the URP global settings. Again, this one should be set by default. Then down here on the quality tab, on this one, make sure high fidelity is selected. Basically, whatever you select here is the quality that we'll be using in the editor. And in turn, the selected quality over here also has a render pipeline asset. Now, in order to avoid any confusion, let's actually get rid of the other ones. So let's just click on the trash icon to get rid of the performance and the balance quality. So just click and click. Okay, so we only have this one. Then let's close the project settings and let's go into the settings folder. And over here, let's select the URP balance. There are 2 assets for each quality, so select those, leave the high fidelity and the performance, and let's delete these. Alright, that's it. By the way, if you made a mistake and accidentally deleted something, don't worry. You can always just click over here on the plus icon on the project window, and then go over here under rendering, and you can create a new URP asset with Universal Render. Okay, so just like this. So we only have one quality setting, we have high fidelity. The quality setting is using this render pipeline asset, which is also using this renderer. So that's really it. With this, we have the absolute bare minimum we need. If in the end, after building the whole game, you want to provide multiple quality settings, then you can come back to this menu and recreate them. But in order to avoid confusion while building the game, let's keep things like this as simple as possible. Okay, so that's the basic setup done. Next, we want to prepare our layout, so let's continue on to the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about the Unity layout and set it up. So first things first, let's familiarize ourselves with the various Unity windows to create our own layout. It's very important that you feel comfortable with your layout, that you have easy access to all the things that you need and you know where everything is. You can see that there's lots of tabs everywhere over here on the Unity window. All of them can be dragged and dropped in any different position. So you can customize your layout to get it looking exactly as you want. You can set it up in any way, but it will be easier to follow this course if you're following the same layout as me. I'm assuming you've seen my quick basics video, so I'm assuming you know what is the inspector, what is a game object, what is a transform, what is the console, what is the hierarchy, and so on. If this is the very first time you're seeing the Unity interface, go watch that other quick video first just to learn the absolute basics. Now for me, I've been using Unity for over 10 years now, so let's see the layout that I've developed over the years. First, the inspector on the right side, just like default. That way we always have a nice view of the selected object and whatever scripts and components it has. Then for the hierarchy, I like to put it down here on the left side. We're going to make sure that our scene is always organized, so we don't need the hierarchy to take up tons of space. Then with the project files next to it, this corner is enough to really browse all of the files. We want the console to be on the tab right next to it. Usually I find that when making the game, I want to look at the project window, but when playing the game, I just want to look at the console. So keeping them in the same place but on different tabs works great. Then over here on the center, the scene view, and again with the game view right next to it. Okay, so this is the basic layout that I normally use. Now for a couple more options, let's go into the project window. And on the top right corner, you can see over here these little 3 dots. By default, it shows you a 2-column layout, so there's a column here and a column here. But personally, I prefer the 1-column layout. This showcases all of the project files in a nice compact list view. The one thing where I prefer the other one is if you're browsing for some visual assets over here, you can increase the thumbnail size. But for most times, I really like to use the 1-column layout, much more compact. Also, since we're talking about the project window, just in case you don't know, there's over here this little button with the eye. This one has to do with package visibility. If you toggle it, then some of the installed packages are hidden, whereas if you untoggle it, then you can see all of the various packages with all the source code and so on. You can expand over here the packages, and right now it is showing all of them with source code, the things, everything there. And if you click on this, then it hides and only shows a bunch of core ones. But for the most part, you really want to leave this ticked and leave this one collapsed, nice and clean. Okay, so then on the console, over here, once again, let's go into the 3 dots. And for the log entry, for this one, I like to select 1 line. This makes the console nice and compact, which I personally prefer. You can see more logs without taking up more space. And if you want to read the whole log, you can always just click on it to see the whole stack trace. Now, there are also some more options over here if you want. For example, show the timestamp. This will show the timestamp when each message was sent. You can use a monospace font, meaning a font where every character has the exact same width. So a bunch of options, but for me, leaving it just like this works perfectly fine. Then also importantly, over here, these 3 buttons. These toggle the visibility for the type of messages that appear in the console. The left one, this one is for regular messages. We're going to use this a lot. Then we've got warnings and finally errors. If you untoggle them, then the messages of that type will not show up on the console. So if you ever come across an issue where nothing is showing up on the console, make sure all 3 of these buttons are ticked. Then on the left side, on clear, you can click on the arrow to see more options. I like to set it to clear on play. Then collapse. This one basically collapses messages that are the same, all of them into one entry. Personally, I do not like this. I want to see every single message as it comes out, even if it's repeated. I've also seen this lead to a lot of confusion for some people. They think their code is firing just one message when it's actually firing hundreds. So to avoid any confusion, make sure you leave this untoggled. Then for error pause, this will automatically pause the game when an error occurs. You should definitely have this one toggled. If there's an error, you definitely want to know about it. You want to know when it happens so you can fix it. Whereas if you untoggle this, you might get some errors and the game might keep playing, which will then lead to lots of confusion when something starts behaving weirdly. So always leave this one toggled. And then the editor button, this one is for a more advanced use case, so don't worry about it. Okay, so that's the console. Then over here for the game view, we've got a button here to select the aspect ratio. Let's go ahead and select Full HD. This one is a 16:9 aspect ratio, so everything is pretty normal. This will really only matter when we start working on the UI, but still I like to keep it as 16:9 always. Then on this button that says Play Focus, we can modify some options. Basically, Focus will play exactly like this on this small window. If you choose Maximize, then it will maximize this window when playing the game, and Play in Focus will play the game even when the window is not in focus. Then another important one is actually on the same one as the aspect ratio. Here we've got a button to toggle VSync. Usually when developing the game, you really want to toggle this. That's because right in the beginning, when the game doesn't really have anything, if you leave it untoggled, then this might run at like 1000 frames per second, and that will pretty much drive your GPU crazy. Finally, if your game view is looking a bit too pixelated, make sure over here on the scale slider, make sure this one is not zoomed in. This one should always be pushed straight to the left as much as possible. Okay, so that's the game view. Then over here on the scene view, for this one default should be good. These two buttons are extremely important. Pretty much all the time you want to keep the tool handles on the pivot and not on the center. If you ever see your handles on weird places, always come back to this. You want this on pivot pretty much all the time. Then for rotation, sometimes local is useful, but for the most part you should probably be keeping it in global. Then for the grid, showing the grid and Y, yep, that looks pretty good. A nice little visual grid. Then you've got a bunch more options if you want. Then next to it we've got snapping. This one we also don't need this for now. And finally, same thing for increment, also don't need this. Okay, then on the right for the draw mode, let's leave it on shaded. For 2D, let's leave this disabled since we're working on a 3D game. For lights, let's make sure this one is enabled. For sound, we're only going to add this in the end, so it doesn't really matter for now. Then for special effects, usually you want this one to be enabled so it shows everything. You can click on the arrow and make sure all of them are toggled. The only exception is always refresh. You probably don't need this little scene window to be refreshing at 60 frames per second, so you can leave that one unticked and tick all the others. Then these are for the hidden objects, so let's leave them toggled. For the camera, here are the defaults. And finally, gizmos, leave them all enabled as the defaults. Alright, so with all that said, here is the layout that I'm going to be using throughout the course. It will be easier to follow the course if you're using the exact same layout as me, so ideally you should be using this. But again, like I mentioned, all the windows are customizable, so if there's something that you absolutely prefer differently, then go ahead. You can drag and drop and place any windows anywhere you want. So once you have a layout you're happy with, you can go up here to the top right corner where it says default, you can click on it, and here you've got a bunch of layouts, so you can save your new layout. So I'm going to save this one as Kitchen Chaos, and then over here you can select any one you want. For example, if you ever have some issues with any kind of weird editor windows, you can load back the default layout and then go back and load your own layout. Okay, so with that, our layout is set up. The next important thing is setting up Visual Studio, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to set up our Visual Studio. Alright, so with the Unity layout set up, let's make sure Visual Studio is also set up correctly. I'm going to be using version 22 Community. This one is the free version. You don't absolutely have to use the same code ID that I'm using. You can use Rider or VS Code or whatever you want. So let's see my setup for Visual Studio. But first, let's actually set up something over here in Unity. So let's go up top into Window, and then let's open up the Package Manager. Then over here on the drop-down menu, let's select the packages and select the ones from the Unity registry. Then let's scroll down to find the Visual Studio Editor package. So here it is, this one. This package basically handles the integration with Visual Studio, so you can use the debugger and a bunch of things. Alternatively, there's also a package over here for Visual Studio Code, and there's also one over here for JetBrains Rider. So if you're using a different IDE, go ahead and install the package. For me, I'm going to install the Visual Studio one, so this one. Just go ahead and install. Okay, it's done. So next, let's go up into Edit and let's open up the Preferences. Then over here, let's go down into External Tools. And on the External Script Editor, make sure you select the one you're using. So again, for me, I'm using Visual Studio 22. And also over here, you've got a bunch of extra options. Now, if you want to play around with reading the source code for the various Unity packages, then you can tick all these boxes. But in our case, for this simple game, we don't need that. So go ahead and leave everything just like this with defaults. Okay, so with this set up, now we can go over here into Assets and open up the C# project. And this should open up Visual Studio. And alright, so here it is. Now for some more settings inside of here. In my Visual Studio, I have a really nice extension that adds a bit more colors to my code, which makes it easier to read and write. So up top, let's go into the Extensions menu and Manage Extensions. And the important one that I've installed is this one, VS4. If you want, you can go into the Online tab and over here search for it. And yep, it does show up in here. Then for the settings on that extension, let's go up here into Tools and let's open up the Options. Then over here, let's scroll down and find VS4. Yep, this one. And here are all the settings, and expand this and a bunch more settings. Now for me, I think these are only defaults. I don't remember if I changed anything. The important one is over here, the rainbow braces. So these have a bunch of colors which make it a bit easier to read the code. So let's create a simple script just to see this. So back in Unity, let's go into the project window, let's click the plus icon, and let's create a brand new C# script. Let's call it just testing, wait for it to compile, And now let's open. Now over here, I'm just going to write a bunch of simple code just to test it out. You don't have to follow this. Alright, so here's a bunch of sample code. These are the colors. You can see it makes everything a bit easier to read. Although again, this is not a requirement. You don't absolutely need this extension, but personally I do find it quite useful. I find that it helps make the code more readable than having everything be gray. Okay, so that's the setup for this extension. Next, for the text formatting options. So once again, let's go into Tools, go into Options, and then over here, let's go into the text editor. Then over here, I think I've got pretty much all the same defaults. Then we can go into the C# rules. So here are all the settings. If you notice something different on your end, go ahead and pause the video and compare the settings. But again, I think everything here is pretty much defaults. I believe the only difference that I did was over here on the code style. Over here for the new lines. Personally, I like to have the curly brackets on the same line, but if you want, you can also change it and put it on the second line. I think that's pretty much the only difference that I did. Everything else should be exactly the same as defaults. So that's the code style settings. And speaking of that, the next lecture is very important. We're going to talk a bit about naming rules. Although, just before we go, let's just clean up our testing script. So let's close this one, click on the X, then back into Unity. We don't need the script, so let's just delete it. Okay, so with that, we have Visual Studio set up and ready to go. Now let's continue in the next lecture to learn about some naming rules. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn something extremely important. Let's learn about naming rules. This one is a very important lecture that you should definitely refer back to whenever you have some questions. So first, what exactly are naming rules? These are really just rules you follow when writing your code. It is extremely important that you are consistent in applying your own rules. You don't want one class in your game to be written a certain way and then a different class using a completely different style. That would create tons of confusion. So naming rules and writing the code correctly is very, very important. One mistake that I see a lot of beginners do is they send me some code and ask why it's not working. Then I take a quick look and I see that all of the code is written in a very messy way. Some functions are in lowercase, others using snake case, some fields are in Pascal case, some in camel case, and so on. Remember that code is case sensitive, so it is extremely important that you write the code correctly. If you change a character from lowercase to uppercase, then you are suddenly referring to something completely different. If you're a beginner, keep that always in your mind. Code is case sensitive, so don't just write code semi-randomly. Write it properly as if you were doing an English literature test. Now with that said, when it comes to naming rules, you can use whatever naming rules you want. Different people like different rules. For example, you can use a prefix in your variables, you can use a postfix, you can use capitals for constants, camel case for properties, snake case for fields. By the way, here are the definitions of what those terms actually mean. Pascal case starts with a capital and every word is capitalized. Camel case starts lowercase and then uppercase for the first letter of every other word, kind of like a camel hump in the middle. And snake case is where you add an underscore in between the words. Like I said, every rule can be valid. The important thing is that you are consistent in always following through with your rules. As you might know, Unity mono behaviors have some default functions you can implement, things like start and update, which are written using Pascal case. Since you can't really change Unity's rules, at least on function names, I would say you should base your rules off of theirs. So for functions, you should probably be using Pascal case. For the other rules, like I said, choose whatever makes sense to you. Here are some of my own personal rules that I've developed over the last 10 years and the code style that I will be following in this course. For functions, I use Pascal case, just like Unity and just like the C# standard. For function parameters, I use camel case. For fields, also camel case. Properties are in Pascal case. Constants are in uppercase snake case. Then another rule is that I like to add the type of the variable as a postfix. So if it's a list, I append the list. If it's an array, I append the array. And now you might be thinking, with this, wouldn't it be an issue if you change the type, then the name is suddenly wrong? And the simple solution for that is that if I change the type, then I just use Visual Studio to quickly change the name. That's it. Then for the curly brackets, like I mentioned in the previous lecture, I like them on the same line. Some people have some very strong opinions about this. Really, it's just a visual style, and this is the one that I personally prefer. If you like Newline, then go ahead and use that. It doesn't change how the code works in any way. And a final rule, spend some time deciding on a proper name and don't be afraid to rename things. You will note how all the code that we're going to write in this course has proper names for everything. You should never use a variable with a single letter like X or K. The exception, of course, would be iterators in a for loop. Also, don't use acronyms or abbreviations. Those might seem clear right now, but in a few weeks you might not remember what they mean. Remember, you don't get bonus points for writing extremely compact code, so prioritize making your code readable and understandable, even if it requires variables and functions with long names. So these are my general rules and the code style that I personally follow. Figure out what works for you and follow your own naming rules. But naturally, in this course I won't be using my own code style, so if when following the course you're not sure how to write some type of code, you can refer back to this lecture and watch it again. Like I've mentioned many times, the code that I will teach you how to write in this course is on the exact same level of quality as my paid courses and my Steam games. So as such, because of that, this lecture, these naming rules are all extremely important. Okay, so with this very important lecture out of the way, now let's start playing with some visuals by importing some assets in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to import the project files with all the assets that we're going to use. By the way, remember that if you have any questions, go ahead and post them in the comments. I go through those every day and I'll do my best to help. Okay, so with the project created, the next thing we want is to import the assets that we're going to use to make this game. You can download all of the assets with a link in the description, which by the way, like I mentioned a while ago, that link contains a Unity package that contains both the assets and the final game. So when you download that, you get a Unity package. Just go ahead and double click or click and drag and drop it on the projects window. Here is the asset import window, just make sure you select all and let's import. Okay, so here it is, this imported the assets folder and inside comes all of the assets, meshes, textures and so on. So everything we're going to need. And then it also imported inside of it another Unity package. So if you want to import the final project with all of the code already written, it's also here. If you extract this one, you're going to get the complete project files. Now of course, don't do that if you want to follow along with the course. And be aware that if you're following along and you accidentally unpack this one, it will overwrite all of your own files. So if you want to inspect the final project files, go ahead and do that, but do that in a separate project. In order to make sure that we have no accidents, I'm going to delete this one from the current project. So just go ahead and delete. Okay, so that's it. And over here we've got all of our really nice visuals. We can look in the prefabs visuals, and over here we've got a visual for a container. So there we go, that's a container counter. Then we have a cutting counter. We've got a trash bin. Then on the kitchen object visuals, we've got all the visuals, so a block of cheese, we've got some burned meat, we've got a plate, and so on. These are all the nice 3D models that we're going to use in our game. And then over here on the textures folder, we also got a bunch of general icons, as well as actual icons for all of the various parts. Okay, so all of the assets have been imported. Now let's continue on to the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to set up post-processing. Now here, let me make a quick note. Usually when making your games, you probably don't want to handle post-processing right away. You should first get an ugly prototype up and working before worrying about any visuals. So normally I would only add post-processing much later on in the dev process, but since this is a course in video format, in order for the video to look a bit more appealing, let's set up post-processing right away. Now we already have the project set up to use URP, so adding post-processing is actually super simple. It's actually already added by default. First, before we do that, let's rename our scene with a proper name. So inside the scenes folder, it starts off with sample scene. This will be our main game scene, so let's just rename this to game scene. Okay, and now here on the hierarchy, we can see by default, this scene already contains a global volume game object. This is how you actually add post-processing. And by default, you can see that it also already has a sample profile attached. This is how you add all of the various effects. You can click on this link and it will show it over here on the project window. Now let's build this from scratch instead of starting from this one. So let's go into that file, into that asset, and just delete it. Okay, so now we have no volume profile. Now let's go ahead and click on new to create a brand new one. Okay, so now here we can add overrides, add all of the effects that we want. Let's drag some visual meshes that we imported in the last lecture to get a better look at all of these effects and what they do. So first let's make some kind of floor. So let's make a 3D object. Let's make it a plane. Let's name this the floor. Also, one extremely important thing, whenever you create a brand new object, always check the object's transform position. By default, when you create an object, it appears in front of the scene camera, which will probably not be on 000. You always want to be very careful with the position of your actual objects. So for a plane, we do want this to be on the origin, so on 000. So make sure you always do that. Then let's scale it up a bit. So on the scale, let's put it on 555. Which, by the way, you've got this nice little icon. This was added in a recent Unity version. Basically, if you enable this, then it matches all of these values. So if you just change one of them, it changes all of them. So let's put this on 5. Okay, great. Now for the visual, let's go ahead into the mesh render on the materials, and let's select a brand new material. So let's click on the circle icon. And over here, let's find the floor material. So here it is. It's the one included in the assets. So there we go, we've got a nice basic floor material. Now let's also drag the player visual, so let's go inside the assets folder, and over here let's go inside the prefabs visuals, and down here we find the player visual, so let's just go ahead and drag this one. So there it is, a nice player visual. Let's also drag a counter, so let's find, let's say the clear counter. Let's drag this one. Let's rotate it to face the camera, something like this. And let's also put a cutting counter. Again, we're just placing some visuals just so we can see what the post-processing will do. And let's also place a bunch more things. So let's say a tomato. Let's place a tomato over there. And maybe a cabbage all the way over here. Okay, so we've got a handful of nice visual elements so we can test out our post-processing. By the way, here's a quick Unity tip on scene controls. Whenever you are on the scene view, which make sure you're on scene view and not game view, those are different. So on the scene view, you can move the camera with the mouse. You can pan with mouse 3, so the middle mouse button. So hold that and pan it around. You can rotate with the right mouse button. You can rotate around the point by holding down left alt and left click and just drag it around. To rotate around an object, you can select an object, like for example player visual. Then you can press on F to select that object. And now if you hold alt and click, it will rotate around that object. Also another method is you can hold the right mouse button to move it around, and then you can use WAS to move, so D, A, and so on. Then you can even press Shift to move in faster. And you can use the scroll wheel whilst holding down the right mouse button in order to modify the speed at which you move. So there are plenty of camera controls to really get you seeing exactly what you want to see. Now for another quick Unity tip, you can move the scene camera to where you want the game camera to be. So let's say I want the game camera to see things from about this angle. So you just position the scene camera. Then on the hierarchy, select the camera game object, so the main camera right here. And with that object selected, you press Ctrl, Shift, and F. And if there you go, you can see over here on the camera preview that it positioned the main camera looking on the exact same position at the exact same direction as the scene camera. So that's the shortcut Ctrl, Shift, F, or alternatively go up into game object and over here align with view. Now if you look, here is the scene view, and over here we've got the nice camera view. So just position the camera somewhere where we can view all of the assets. Now with this, let's add some post-processing effects. So first, let's select the global volume game object, and over here we can add all of our effect overrides. First up, let's begin by adding tone mapping. So there you go, we've got the effect, and over here we've got a nice little checkbox, so you can enable it in order to enable this effect and set one of the options. Now for this one, I'm not too familiar with color correction, but I find that usually adding a neutral tone map, usually that helps. Also make sure you're looking at the game view and not the scene view. If you're looking at the game view and you enable and disable this effect, you should see a difference. Whereas on the scene view, if you enable and disable, it doesn't actually show that. Even if on the scene view over here you have all the effects enabled, even with that, some effects for some reason don't show up on the scene view. So when playing around these effects, always make sure you're looking through the game view. So like I said, you should be able to toggle this and see a visual difference on the game view. If you don't, then make sure the camera has post-processing enabled. So let's select the main camera game object, and down here there's a toggle for post-processing. Make sure this one is enabled. And then also on the render pipeline asset, so let's find that one on the project window. Over here we've got the settings, and you've got the URP high fidelity. This one should be using a renderer, so if you click on the renderer, over here you should have post-processing enabled. Again, all of this should already be correctly set up by default. So if you go into global volume and enable or disable, you should see a visual difference. Okay, so next effect. One that I always like to add is a bit of saturation. So let's add an override, post-processing, and let's add a brand new, here it is, color adjustments. Then over here, you've got plenty of things to play around with. For me, I like to add a bit of saturation, so just lift it up a little bit. Let's say just about 20. And I also like to add a little bit of contrast. So over here, let's also add 20. And there you go, it makes the colors pop a little bit more. So personally, I like this effect. Then later on, we're going to have some glowing objects, for example, the stove. Let's actually try dragging that into the scene. So let's go into scene view, and in the assets, let's find the stove counter. So here it is. And inside the stove counter, there are some things. So here it is, the stove on visual. This one is disabled by default. So on the inspector, let's just enable this game object to make it visible. Again, don't worry about the positioning of the objects on the scene view right now. We're only positioning them just to set up the post-processing. We're going to delete them all at the end of this lecture. Okay, so that one enabled. Let's go into the game view, and over here we see the stove enabled. So now let's go into the global volume. Let's add an override, go into post-processing, let's add a bloom effect. So right now, notice how that one is not glowing red hot. For that to work, we need to have bloom, and we need to enable the threshold and the intensity. If we raise the intensity, we do see, yep, there we go, a really nice glow there. By the way, here's a quick visual tip. If you want to make your game feel a bit more ethereal and magical, one good way is to put the threshold at a low value, below 1, so something like 0.5, and then put the intensity as a little bit. And with this, notice how everything has a slight glow, even colors that don't have any extra intensity. So the floor is glowing, the character is glowing, so everything looks quite a bit ethereal. This is a bit extreme, but it is an interesting effect. Also, another quick note here, in case you're not seeing anything change, make sure you go into the render pipeline assets, so the URP high fidelity, and over here make sure AGR is enabled. You can look at the stove glow. If I disable it, yep, that one stops glowing, and with that enabled, it does start glowing. AGR stands for high dynamic range, so that is how you can have a color go with an intensity above 1, which actually makes it glow when you have the bloom post-processing. If even with that you're still seeing issues, then make sure you go into the renderer, and over here for the post-processing, sometimes Unity has a weird bug and doesn't generate this post-process data file. So if that does happen, just go ahead, untoggle and toggle this, and it should work. And finally, like I said, on the camera, make sure you have post-processing enabled. So with all of that, you should be able to see the game view glow. Okay, back into our effects. With our bloom working, like I said, you can lower this below 1 to get a nice ethereal look, but this is a bit too intense on what we want, so let's make it a bit more subtle. So on the threshold, let's put it at 0.95. So there's a slight glow on the white parts, but nothing too intense. And for the intensity, let's put it at a regular 1. Okay, so I think that's a nice amount of bloom. All the colors glow a little bit, and we can see over there the stove, it is indeed glowing. Okay, great. Now, if you ever forget all of these steps and you can't get your project to glow, I made a nice video with a nice checklist of everything needed for you to glow. Definitely go ahead and watch that video whenever you have issues. Then for another fun effect, we have vignette. So let's go into add override, post-processing, and let's find the vignette. What this one does is adds a bit of darkness to the colors. So if we enable the intensity and we increase it, you can see what it does. So it adds darkness right on the corners there. Personally, I find this one looks good when it's quite a bit subtle. So let's put the intensity at something like 0.25. And then for the smoothness, let's also put it on 0.4. So just like that, just a slight darkness on the edges. So personally, I think it looks pretty good. And that's pretty much it for the post-processing on the volume component. I like how this looks. You can see the difference with the volume enabled or disabled. Quite a big difference. Looks pretty nice. But again, these are just visual, so feel free to play around, maybe add some more effects, use some different settings. These are just visuals. They don't impact the game logic at all, so feel free to make it work exactly as you want it. Then yet another thing related to post-processing but not in this component is some anti-aliasing. For that, one place where you can change it is on the main camera. Over here you see a field for post-processing and you have a bunch of types. So FXAA or SMAA. Or if you want some more higher end post-processing, you can go into the render pipeline asset, so URP high fidelity, and over here we see anti-aliasing MSAA. This one is a bit more expensive, but looks a bit better. If you want to see the difference, you can go over here into the game view, and on the slider up top on the scale, you can increase this quite a bit. So with this, we can now see the pixelation, and you can see over here if I switch anti-aliasing from 4x back into disable, you can see lots of jagged edges. And if I put it on 2x, yep, looks a bit more smooth, 4x a bit more smooth, and 8x even more smooth. So with that, you can see the difference on all the edges, all the things. By default, this renderer has on 4x and nothing on the camera. This already looks pretty good, but to make the video look even better, I'm going to put it on 8x. And on the main camera, I'm also going to leave it with no anti-aliasing. You can combine them, but if you do, then everything looks a bit too blurry, so I don't quite like that effect. So put this one on none and the other one on 8x. Although, again, this is just a visual, so if you have a low-end PC, feel free to go into the URP, and over here, disable anti-aliasing. So the game looks a bit worse, but it will run much better. Okay, let's drag the scale back down, okay. Now, one final thing we can add is some really nice screen space ambient occlusion. For that, let's go into the renderer, so not the render pipeline asset, the renderer. And over here, by default, it already added screen space ambient occlusion. If it didn't add, you can click on add renderer feature, and over here, you won't be able to see it. I don't see it because I already have it. Okay, so here it is. Basically, what this effect does is it adds some tiny shadows where geometry intersects. If we enable and disable it quickly, we can see the effect over there on the counters. So you can see with the default effects, it already works quite nicely. For example, look there on the player. We can barely see the difference between the head and the body, but if we enable this, it adds that nice little shadow. I think it looks really nice. But then we've got a bunch of settings we can play around, increase the intensity, the radius, and so on. Now, one important thing when setting all of these effects is to remember the point of view of the camera. In this case, we're making a top-down game. So before we play around with these settings, let's actually position the camera in a correct position. So let's go ahead, select the main camera, and let's position it above pointing down. So let's put it on an X of 0, on a Y of 21.5, on a Z of minus 21.3, then for the rotation on the X 46, then 0 and 0. And finally on the camera over here on the field of view, instead of 60, that's really wide. For this game, let's go with 20. Okay, so this is the view that we're going to use for our game. Let me just rotate the objects so they actually face the camera. So on the hierarchy, let's just select all the objects. Let's rotate them all around and just position them. Again, we're only using these just to see what they'll look like. We're going to delete all of these objects in a bit. Okay, so yep, that's the game view. Now that we have the camera set up, let's work on the settings for the ambient occlusion. So let's go down, select the renderer, and over here for the settings. For the intensity, let's put it on 4. For the radius, let's put it at 0.3. And direct lighting strength, let's put it all the way up to 1. Okay, so you can toggle this, enable and disable to see the difference, and yep, I do think these settings look pretty good. Finally, the last thing we need to check is the lighting window. So let's go into window, then down into rendering, and let's go into lighting. Out pops up the lighting window. Personally, I like to anchor it over there next to the inspector. And over here, we're really going to leave everything on defaults. So you can leave it as the lighting settings assets and nothing assigned. And then on the environment tab, over here, again, all of the defaults, I didn't touch any of these. So we've got environment lighting from the skybox, intensity multiplier of 1. So everything pretty much on defaults. Although again, like I said, most of these visual effects are very much personal preference. So if you want to make your game look a bit different than mine, then go ahead. You can play around with lighting over here. You can change skybox to gradient color and so on. If you want, you can use some baked lighting. Then if you want, you can add all kinds of extra effects. And also, by the way, remember that the effects are stored on this profile over here. So for example, you can click over here on the clone button and it will clone the effect. So let's click on it to find it. Yep, there you go. So that's the one that I built and here's a clone one. So if you want, you can make a clone one and then make it look very different. For example, let's go into chromatic aberration, make it really intense. And for example, let's go into the color curves. And over here, for some reason, let's drag the green up and so on. So there you go, completely different visual. So if you want, play around, make some weird effects. And if you want to go back, just revert back into the original profile. Personally, I'm quite happy with how this looks, so I'm going to be using this one, okay? Again, you can enable and disable the volume game object to see quite the big difference that post-processing makes. If you ever want to make your game look quite a lot better, always make sure to add some post-processing. Alright, so like I said, this looks really good. I like it. Now, before we go to the next lecture, let's just clean this up. So let's get rid of all of these objects, so the counter, cabbage, tomato, and so on. Let's get rid of all of them except the floor. So let's leave the floor and get rid of all of these. Alright, so here we have our nice empty scene. Let's just save our scene, and let's get ready for the next lecture. Hi there, this is a quick intermission. So how are you doing? Are you enjoying the course so far? Are you having any trouble with anything? Is there something you didn't understand? If so, remember I'm always active in the comments answering all the questions. So if there's anything you need some extra clarification, go ahead and ask and I'll do my best to help. Also remember to check out the pinned comment. YouTube videos cannot be updated, so for any notes or comments, I'll put them in the pinned comment. And definitely check out the website page for this course. As people ask more and more questions, I will keep that page updated with any frequently asked questions for every single lecture, so that way you can see what others have asked and learn from them. And you can also download the project files for each lecture, so keep that page open on a second tab and check it every time you start watching a new lecture. I really hope you're enjoying the course, and I hope you've already learned quite a few things. Go ahead and hit the like button and subscribe to the channel if you haven't already. Okay, so let's go to the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to begin creating our character. Let's make a nice character controller so we can move our character in the world. Okay, so first let's begin by creating the character game object. And now, usually, most beginner tutorials would tell you to just right-click, go into 3D object and create something like a capsule. That way you would have the game object with the visual included. However, for a good project structure and good organization, you should always separate the visuals from the logic. For example, here, let's say that I don't want my capsule exactly like this. Let's say that I want my player to be a little bit more skinny. To do that, I would have to modify the scale on this game object. So put it maybe on 0.7, so something like this. Basically, by doing that, by modifying the visual, I also modified the scale on the actual player game object. Having a non-uniform scale on a logic game object, that can cause all kind of problems with any kind of logic component. Also, I would prefer to have my character on the floor, but if I put it on y of 0, notice how the character is half underneath the floor. So if I were to use this method, I would have to apply some kind of offset in order to make the visual above the floor. So that would require rearranging all the logic to work with an offset on the y position. So because of those reasons and many more, you should not place both the logic and the visual on the same game object. Instead, you should separate them. So let's get rid of this, and instead, let's create an empty game object. Let's name this the player. Let's put it on 0, 0, 0, okay? And now inside of it, let's create, let's say, a capsule. Now this one, we can easily scale this to get any size and shape you want. So for example, 0.7, 0.7. Then since the visual is a child of the game object, we can also easily offset this. So let's say put it up by about 1 unit. So with this, we can position the visual so that basically the player game object is over here on 0, 0 and the character is above the floor. So we don't have any weird offsets. This will make all of our logic much more simplified. And now on this empty parent game object, we can attach all of the logic components we want. And then in the child visual, we can add or replace whatever visuals we want. So as a general rule, you should always try to do this. Always separate the logic from the visuals in your game object. Okay, so with that we have the player game object. Now let's make our character controller script. And before we do, let's keep things once again organized. So before we do, let's create a brand new folder. So let's right click on the assets, create a brand new folder, call it scripts. And now inside, let's right click and create a new C# script, call it the player. Wait for the code to compile, then select the player game object and attach the script. Again, remember logic components go on the parent game object, not the child visual. So the child visual, this one only has visual components, and the player, this is the one that actually has the logic components. So let's open up this script. Okay, so here's our first C# script. Like I said, I'm going to assume you know the absolute basics. Go watch the C# basics video if you haven't seen it yet. So I will assume that you know what is a function, what is a variable, what is start and update, so pretty much the absolute basics. For a character controller, we first need some input from the player. And for that, Unity actually has two methods. You have the Legacy Input Manager and the New Input System. Basically, the Legacy Input Manager is super simple and very easy to use, so this one is perfect for quickly prototyping. And the New Input System is extremely capable with tons of features, but it's also a bit more complex. So what I do is while I'm doing a simple demo or testing out a new prototype, I just use the Legacy Input Manager, but when making a more complex project, like for example my Steam game, then at a certain point I refactor my code to use the New Input System. So here I'm going to teach you both, as well as teaching you how to refactor code, which is an extremely useful skill. So let's first begin by using the simple Legacy Input Manager. We want some basic WASD movement to move our character, and we're going to need to run that logic on every single frame, so let's do it on update. And let's actually get rid of the code that Unity writes by default. Let's start completely from scratch, so let's get rid of this, just close, okay. So here, let's start by writing private void update. And now here, very important, if you're a beginner, make sure that update is written exactly like this. If you write update with lowercase, if you do this, then it won't work. The function will not be called automatically. I'm pointing this out because I have seen a bunch of comments from beginners wondering why their code doesn't work, and it's as simple as this. With lowercase, Unity will not call this automatically. It needs to be exactly perfect. So again, if you're a beginner, make sure you write the code exactly. The code is case sensitive, so this is very important. Also, another note, you saw that the code that Unity wrote by default when we made a new script, it just had void update. It did not have the private keyword. Private is what is called an accessor. You have private, then you have public, and then there are some more advanced ones. Technically, you can omit the accessor, and in most cases it will default to private. However, in writing good clean code, you should be as explicit as possible. There should be no room for misunderstandings. So while technically you could omit the private, you should always include it to make your code easy to read and easy to understand. This one is the first of many clean code rules that I will teach you during this course. Like I said, all of the code that I'm writing here is on the same level of quality that I use in my own professional games. I'm not going to teach you bad practices like so many beginner tutorials do. So always be explicit, always include the accessor. Okay, so we have our update running code on every single frame. Then to test if a key is being pressed, we just go inside input. Then over here we've got two functions. So we have getKey and getKeyDown. Both these functions return a boolean, so that's either true or false. The difference between them is that getKeyDown, this one only returns true for a single frame when the key is pressed, whereas getKey, this one stays true for as long as the key is held down. For example, for an action like jumping, you just want to know when the player presses the button. So for that one, you would use getKeyDown. However, in our case, for a character controller, we want to know if the key is being held down. We don't want just one frame, but always. So for movement, let's make sure we go with getKey. That requires a key, so let's write our key code and then choose the key. Let's say we want W. And then let's just put this inside an if, just like this. Okay, so here we have code we want to run while holding down the W key. Let's do a quick test just to verify everything is working perfectly. And for testing, we can use the super useful debug.log. This one lets us print a message in the console. So let's add one log here, just say something like pressing. And then let's also do an else, and if else, let's do a debug.log and just do a dash. Okay, so here is our very basic script. Let's make sure to save it, so Control S. Then back in Unity, over here, make sure you have the script attached to the player game object. And now we can test. And now down here on the console, we can already see dashes, so I'm not pressing any key. Also, like I mentioned in the setup lecture, if you're seeing just one message, then maybe that means you have over here the collapse toggled. If you toggle it, look how it only shows one message, but then over here on the right side, it says the number of messages. Personally, I prefer to always keep it untoggled so I can see every single message. Also, over here on the right, make sure you have info messages visible. If you untoggle this, then you don't see it, so make sure this one, and actually both of them, make sure all of them are enabled. Okay, so we're seeing a whole bunch of dashes. And one more note, if over here the scroll bar stops scrolling, so right now you can see it's stuck up instead of being down there. So if that happens, one easy way to reset that is just click over here on clear and it goes back into auto scrolling. Okay, so we have the dashes. I am not pressing any key. Now as I press, yep, there you go, there's the message. If you don't see it, make sure the game window is in focus. So select the game view and click right here on the middle to make this one the focused window. Then if you press the W key, you should see the message. And if I let go, yep, there it is, a nice dash. Okay, great, so all the basic logic is working. Back in the code here, now that the logic is working, let's get rid of the else here. And let's add tests for all of the other keys, so let's copy paste this. So we're going to need W, A, S, and D. So let's make all of these. Okay, so we have our inputs. Let's also get rid of the logs. We don't need this. All right, so we have all of our key presses. Now let's construct a vector with our inputs. And since we're just going to have two axes, the WS, that is forward and backwards, and this one is left and right, so just two axes. So because we have just two, let's use a vector2, and let's call it the input vector. Let's construct it, so we'll do a new one and start off at 0, 0, okay. Then over here, the logic is pretty simple. So when we press W, then let's go into the input vector and set the Y to +1. Then when we have an S, we want to go backwards, so put the Y on -1. For the A, we want to go left, so that's an X on the -1. And finally for the D, that is an X on +1. Okay, so with this, we have our correct input vector. Let's do a quick log just to test. So debug.log on the input vector. Okay, so let's test. All right, so we can see in the log 0, 0. Okay, makes sense. Now if I press W, yep, we've got a 1 on the Y. If I press A, we got -1 on the X. Press D, +1. Press S, and -1. Okay, great. So everything works. Except we also need to be careful about one other thing. If I press both W and D, with this, look at that, the vector is 1, 1, which is correct. That's exactly what we did. Except the vector 1, 1 actually has a bigger magnitude than just one vector. If we leave it like this, then the character will move faster when moving diagonally versus when moving in just one direction. For our input vector, we really want it to be normalized, meaning we want it to have the same size regardless of the combination of keys that we're pressing. So back in the code here, after calculating the input vector, let's simply normalize it. So we go into the input vector and we set it equals to input vector dot normalized. So this will normalize our input vector. Let's see. Now over here, if I press W, yep, got 1, press S, -1. Okay, so all of those work. Now if I press both W and D, yep, there you go. Now it says 0.71. When you combine both these and you do the math, these do end up with a magnitude of 1. So with this, our character will move at the same speed on both diagonals and straights. Okay, so we have the input vector all correct. Now let's actually apply some movement. For that, there are many ways of making a character controller. For example, you can decide to use physics or not. Over here, I want to keep the game simple, so let's not use physics. Instead, let's just move the player transform directly. Over here, we have our input vector. Okay, great. Now we want to apply this to our character position. So first, we access the transform. This one refers to the transform where this script is attached to. This script was attached to the player, so this is going to refer to the player transform. Then we want to modify the position, so let's access the position. And now for moving, we don't want to just assign it. If we do something like this, the player would never leave the center of the world. It would always be near 0, 0. So instead, we don't want to just assign it, but instead we want to add onto it. Now, if you're a complete beginner and you don't know this syntax, then this one is exactly the same as this. So transform.position equals transform.position plus input vector. So both these two lines are doing the exact same thing. Personally, I prefer to use the shorthand. I find that equally readable and more compact. Okay, so we have this, and we add our input vector to the transform position, except we can also see a really nice error. Basically, it's telling us that we are mixing two types. Our input is a vector2, where we only have an x and a y, but transform.position is a vector3, meaning it has an x, y, and z. One simple solution is to cast our input vector onto a vector3. So we just convert this from one type into the other one. And yep, we don't have the error, so let's test. And now if I press W, and yep, the character does move. Let's ignore the massive speed for now. So it does move, it does seem slightly correct. Except you can obviously notice that it's not correct. We are moving on the x-axis, so left and right, that is correct, but then we are moving up and down instead of forwards and back. Basically, we converted the vector2 directly into a vector3, so we are moving on the x and y axes. But in our 3D game, we really don't want the characters to fly, so instead we want to move on the xz axes. So back in code here, instead of directly casting this down into a vector3, let's construct a move dir vector. So let's do a vector3. Let's call it our move dir for our move direction. And over here, we construct a new vector3. And basically, we're just going to assign the input y to the z on here. So first of all, for the x, that one is correct. So input vector.x. Then for the y, let's leave this one on 0. And finally, let's use the input vector.y as a z on the move direction. Also, now at this point, you might be questioning, if we're using a vector3 here, why don't we also use a vector3 up here and then just assign the z directly? That's certainly a possibility, and for making a super quick prototype, I might even do that myself. But the proper answer to that is once again all about writing good clean code. The input logically only has two axes. There's no z-axis on your keyboard, so logically it makes no sense for the input to have three axes. And beyond that, you should keep the logic separate, so you should first get the input and then actually move the object. We're going to see the benefit of that separation when we refactor this code to work with the new input system. Doing that will in turn make enabling gamepad joystick support super easy because we have the input vector separated from the actual movement. So all of that to say, let's do things properly. Let's keep the input vector separate from the movement vector. So we just translate the xy onto xz, and then we just apply this into our transform position. Okay, so let's test. So now if I press D, go right, go left, and press W and S, and there you go. Okay, great. So it is indeed moving left, right, forward, and back. Okay, great. So it is working, but as you can see, it's moving insanely fast. You might think the issue here is just applying some sort of movement speed multiplier, except there's actually one sneaky issue here. Here on the game view, on the top right corner, we've got a stats button, and over here we can see a whole bunch of things. Specifically, we can look at the frame rate. We can see that it's running at 144 frames per second. Over here on the left side, on this button, I have VSync enabled. This will cap the frame rate to the monitor's refresh rate, so that is why I'm seeing 144 Hz. I can over here disable VSync, and yep, look at that, goes all the way up to 700. Basically now the game is running as fast as my computer can run it. And if I press the movement keys, and look at that, now it's moving even faster. Now I've completely lost track of where my player is. This is not what we want. We don't want the player to move at different speeds depending on the frame rate. We want it to always move at the same speed regardless of frame rate. So when you do any kind of movement logic on an update, you always need to make sure to multiply by time.delta-time. What this variable contains is the number of seconds elapsed since the last frame. For example, let's add a log to this. We no longer need the input vector, so let's log just the time.delta-time. Okay, so we can see that is basically telling us how many seconds it is taking to render a single frame. Once again, note how I have VSync enabled, so I'm running at 144 frames per second. And now if I disable it, let's see what happens to that number. So if I disable, and yep, look at that, that number is now much smaller and the game is now running much faster. So by incorporating this value into our calculation, we are going to be taking into account the frame rate, thus making sure that the movement is always frame rate independent. Right now with this frame rate, if I move, you can see I'm moving at this speed, and now if I enable VSync, change the frame rate, and I move and I'm still moving at the exact same speed. Okay, that's great. Except obviously it's not exactly great, it's moving way too slow, so let's also incorporate a movement speed. Now for this, once again, most beginner tutorials would teach you to go all the way up here and define a public float move speed. Maybe default it to some value like 7f, something like that. Then you have this field, and then down here you simply use it in the calculation. So movement here, multiplied by move speed and by time.delta-time. So this is what most tutorials would teach you. By making it public up here, what you're doing is you're enabling access from the editor. So if you go over here in the editor, over there on the player, we can see the move speed variable. We can see this exposed and we can modify it. This makes it really easy for testing and for iterating upon the value even while the game is running. So the game is playing, I can move and I have this move speed. Now I can modify this, and yep, now I got a different move speed, so I can use this to quickly iterate and find the perfect value. So it's great to have this variable exposed in the editor. And this feature is indeed the reason why most beginner tutorials would teach you to make it public. It's so you can see it in the editor. That is indeed a very valuable thing. Being able to easily iterate upon important values is always very useful. However, when you make something public, when you do that, you don't just expose the field to the editor, you are exposing it to every other class in your entire codebase. So some other class could access this field and set the player's movement speed to something like 0, and you would have no idea that was happening because the issue would not be on this code right here. I have an entire video on this subject, why you should not make everything public. This is an extremely important topic to know about. This one tiny change will massively improve the quality of your code. Definitely go ahead and watch that video to learn why it's such a bad thing and make sure you don't do it. So to avoid all kinds of problems, you should never make fields public. So very quickly, the obvious alternative is make it private. Making it private means that only this class, only the code in here, only this can modify this field, so you know for certain that no other class can ever modify this. However, making it private also means the editor cannot modify this field. So we've lost our very useful iteration approach. So what we can do to expose it just to the editor is to keep it private, and then we add the attribute serialize field. This way this field is still private, meaning that it can only be modified by the code inside the player class. But with this attribute, over here in the editor, yep, we do have an editable field. So only the code in that class in the editor can modify it. Nothing else can touch it, nothing else can read or write, which is exactly what we want. One of the main rules in writing good clean code is minimizing complexity, and one of the easier ways to minimize complexity is simply to minimize access. By making this field private, we are minimizing complexity because it doesn't matter how complex our game is. Maybe our code base is 1,000 classes long, it doesn't really matter because only this class can ever touch this field. So if we have a bug related to movement speed, we know for certain it has to be inside this code and nothing else. So we minimize the things we need to keep in our head, which is always a very good thing. Okay, so with all that said, we have our movement speed, and down here we are incorporating it into our calculation. Just with this, we have our character working with a variable movement speed, and by using delta time, we have our movement correctly being frame rate independent. So here's our character, and using the keys I can walk around and yep, the character moves in any direction. So we have movement fully working while using the legacy input manager. Like I said, we're going to learn how to refactor our code to use the new input system. Learning how to refactor is an extremely important skill to improve your own programming skills. It is something that you should always do when necessary. It will massively help you improve the quality of your code. So we're going to do that, but before we get to that, let's actually do something a bit more fun and add some proper visuals and animations to our player in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to replace our boarding capsule visual with a nice proper character mesh. Okay, so in the included assets project files, over here, if we go inside the prefab visuals, we see a nice player visual. Let's position it inside the player game object, so let's drag it inside. Again, because we separate the logic and the visuals, this is going to be pretty easy. We don't need to modify the parent game object at all. We just drop the visual as a child, that's it. Also, again, very important, make sure the visual is over here on local position 000. Only the parent game object should move, the visual itself should never move. If you notice some weird positions as your player moves and rotates, always check to make sure that the child visual is on 000. Okay, so with this, let's delete the old capsule. Delete it, okay. So here we have a pretty simple but really nice character visual. It's really just two spheres stacked on top of one another with a bunch of eyes. Very simple. For the visual itself, the material is using just a solid color. So here it is inside the assets material. You can see a bunch of player bodies with different colors. These different colors, they won't be used in the upcoming multiplayer video. Basically, each player will have a different color. Also, by the way, if you're a complete beginner, here's a quick lecture on materials. These are materials, and if we click select, we can see a bunch of stats related to that material. Basically, the materials have a shader and then a bunch of properties. Now, the shader is the actual code that runs on the graphics card that says how an object should be rendered. By default, you have a whole bunch of included shaders. We're using the universal render pipeline, so you should mostly be using the ones inside the URP. And by default, you probably want to be using the standard lit shader. Then of course, you can also build your own custom shaders. One excellent tool for doing that is ShaderGraph, which I have covered in detail in a previous video. It's a fully visual tool that you can use to make shaders without having to write any shader code. It's a great tool. I've also made a bunch of tutorials on all kinds of effects you can make, although right now we're not going to be using custom shaders. We're going to do that later on in the course, but for now we're going to stick with the default lit shader. So materials have a combination of shaders and the properties on that shader. For example, over here for the default lit shader, you can see that it has over here a base map, that it has a color field. This is what you can change to apply a different color to your player. Also, as to how you apply a material to an object. Over here on the player visual, you can see the objects are made up of a sphere. So this is the mesh and then the mesh render. This is the one that has the material. So both these are what stores the shape as well as the visual for the object. The mesh is just a 3D shape, but just by itself, the mesh filter doesn't actually render anything. So it needs a mesh render, which needs a material attached to it. So for example, over here on the hierarchy, let's right click on empty space and let's create a brand new cube just to see it. So yep, there you go. It does create an object, and as you can see, it has a mesh filter and a mesh render. Now to apply a different material, you can click on this little circle icon and it shows you all of the materials in that project. Alternatively, you can grab the material directly from the project window. So for example, the player body, just grab it and drop it in there. Or you can also drop the material over here on scene view. As you can see, as I mouse over different objects, it applies that material to a different object. Although note, that only works over here on scene view, it does not work on game view. So this basically sets the material over there on the object. Now, one more very important thing on materials. If you have multiple meshes only using the exact same material, and then you modify the material, it will change the visual on all meshes using that material. So for example, if I modify the color here, put it on something different, there you go, all three instances, all three objects that are all using the exact same material, they all update with a new color. If for example, you wanted the head to be a different color from the rest, then you would just create a new material. So you can right click on the project window, let's create a new material, then you can give it a name, give it colors, use a different shade or whatever, and then use this one for something different. So that's pretty much the basics for materials. And by the way, if you're a complete beginner and you have questions, remember to post them in the comments and I'll do my best to help. Like I said, I want to keep this video moving. I'm trying to teach teach as much as possible while still keeping the video a reasonable length, so if you need any further clarification on anything specific, just go ahead and ask in the comments. Okay, so with the materials out of the way, here we have our player with visual. Let's just get rid of our cube, okay? And just with this, if we test, and yep, over here we already have a nice player visual walking around. Okay, great. Except the player isn't actually rotating. Ideally, the visual should be facing the walking direction, so if I walk down, it should be rotated to face down. So let's add that. Doing that is actually going to be pretty simple. Let's go into our script. Here we are on the player script, and over here we already have the movement direction. So we're going to use this in order to make sure to rotate the game object to face this move direction. And for rotating a transform, there are many ways to do it. One obvious one is to modify the transform.rotation. However, this one, as you can see, works with quaternions. For me, even though I've been doing game dev for over 10 years, I still find quaternions quite a bit confusing, so I normally don't use this method. Another method is to modify the transform.Euler angles. This one is much more intuitive and makes more sense to me. It works with regular Euler angles, which is much easier to understand. If you don't know that name, it really just means the angles that go from 0 to 360. Then for another method, you can also use the function transform.lookAt. This one makes the transform look at a certain point, so it can be a transform target, can be a vector 3 for one position, anything like that. So this is a very useful function. We could calculate a point right in front of our move direction and look at it. Or finally, the method that I personally like to use for this specific purpose, which is just modify the transform.forward. This one has the normalized vector representing the forward axis, and importantly, you can get it and you can also set it, so you have both read and write. You can read it to get the current transform forward, but you can also write to it to essentially rotate the transform. So we can just assign this to our forward vector. Also, by the way, you also have transform.up and transform.right. Both these work exactly the same way. For example, transform.right, this one is extremely useful for 2D games, but over here we're working in 3D, so we want transform.forward, and all we need is the forward vector, which is really just the move direction. So let's set this one equals the move there. Okay, so just like this, it should already work. Let's also just clean up the log. We no longer need to see the delta time. Okay, so let's do like this. Okay, here we are, and as I move, and yep, there you go, and look at that, the player object does indeed rotate to face the move direction. Okay, so it's already looking great. All right, awesome. However, it also looks a bit odd with how it's instant. So I move left and right, look at that, it instantly rotates. So there's no smoothing, nothing, it's way too janky. So let's add some nice simple smoothing. And for that, let's use a really awesome, really useful math function called lerp. It helps you interpolate between two values. I made a quick video showcasing a bunch of uses for it. You can lerp floats, vector 3s, quaternions, or just about anything. It's really perfect for making some smooth movement or smooth rotation. So for that, we can access the function inside the vector 3 class, so we can find lerp. Then here we actually have two options. We've got lerp. This one interpolates, and we've got slurp. This one interpolates, but with a spherical interpolation. Basically, if you're dealing with rotations, like what we have here, then we want to be using slurp. Whereas if you're dealing with just positions, then you want to use lerp. So here, let's use slurp. This one, as you can see, takes an A, a B, and a T. Like I said, this interpolates between A and B based on T. So for example, if T is 0, then it will return the value A. If T is 1, then it will return the value B. If T is 0.5, then it will return the point in between A and B. If you want to learn some more about interpolation and the math behind this, then I highly recommend you look at my video on splines. Splines are basically just a whole bunch of lerps put together. So anyways, over here we can add some smoothing to our rotation by just using the current transform.forward as our A. Then for the B, this one is our target, so let's use the move there. And finally for T, let's use time.delta-time. Meaning that with this, over time the character will rotate towards our target movement direction. So just with this, let's test. So here if I move to the right, and yep, look at that, it is indeed rotating. It's way too slow, but yep, it is rotating smoothly. Alright, so let's just add a bit more speed. So over here, let's just find a float for the rotate speed. Let's put it at something like 10f. Then we just multiply it, so time.delta-time multiplied by our speed. Let's see. And move, and yep, there you go, look at that, much better. Okay, great. So as you can see, everything works. As I move, the character does rotate to face the move direction. Alright, great. So here we have our character with a nice visual, all rotating to face the move direction. Now the next step is we want to add some nice animations, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to add some animations to our player character. Now, I have already included some pre-made animations with a pre-made animator over here inside the assets folder, but let's first do it from scratch just so you'll learn how to do it. First, to animate, we're going to need the animator component. If we go inside the player visual game object, once again, remember all the visuals go on the visual game object. So for adding the animated component, we want it on the visual and not on the logic component. So anyways, over here, as you can see, by default, I already attached it with the assets included, but let's do it from scratch. So let's remove this by default. Now let's add a new component. Let's call it an animator. Also, one very, very important thing here, it's the animator component, not the animation component. These two are completely different. The animation component, this one is actually related to Unity's legacy animation system from a very long time ago. It's only here pretty much for backwards compatibility and for super simple use cases. So most of the time, make sure you're using the animator component. Okay, so to drive this animator component, we need an animator controller. Let's go into our project files and let's create a brand new animator controller. Let's call this my player animator. Then let's select the player visual and just drag the controller on there. Okay. Again, if you have issues and you cannot drag the animator onto the field, make sure you're using the animator and not the animation component. Okay, so with this, we have assigned our animator controller. And now let's double click on it to open the animator window. And if you don't see it, then go into window, then go into animation and open up the animator window. And also, if you still don't see anything, then maybe you might have some issues with your layout. If that's the case, then go onto the top right corner layout and go back into the default and then back into your own layout. And finally, if you still don't see anything on this window, if you don't see the default states, make sure you have the object selected in the hierarchy. So with that, you should be able to see these states. So this is our animator controller. Now I have a really detailed overview of the animator and the animation windows in my Ultimate Unity overview course. So you can go watch those lectures for some really in-depth explanations about everything this does. Basically, the animator is a state machine. So you have various states and you can create transitions between each state. By default, you have these three special states. There's the entry state, exit, and any state. These are used for making transitions, but we don't really need to worry about them just for now. First, let's just make a basic new animation. And for that, the easy way to do it is to open up the animation window. So let's go up top into window, go into animation and open up the animation window. So here it is. Again, that's a different window. That's animation, not animator. And for me, for this window, I like to dock it down here. So there's a nice timeline. So I think this is good. Okay. And now if we select the object in the hierarchy that has our animator, then we can see the text here. So to begin animating, we've got a nice button to create an animation. So let's go ahead and click on this. And now let's give it a name. For now, let's first make the idle animation. So let's just call this idle. And yep, just like that, we have created an animation. You can see the animation window down here has changed. We now see a nice timeline showing the time. And also on the animator controller, you can see the new animation was added as a brand new state. So a new state was created, and if you click to select it, on the right side in the inspector, you see the motion, so the actual animation selected. And you can also see that there's an arrow pointing from the entry onto the idle state. So that means this one is going to be the default state. When the animator controller starts, it will start playing right on this state. Let me just point out one more thing related to animations. So on the project window, we can see, yep, here is our animation that we just created. And you can see the inspector looks just like this. Now, if your inspector looks differently, that might be because you accidentally created a legacy animation. That has to do with the previous animation system that I talked about, the one that is legacy that should really no longer be used. So if you see a different inspector, then a quick way to fix it is to click on these three dots on the inspector, these three dots. Then you change the inspector into debug inspector. And over here, you see a toggle for legacy. So for the animations that we want to use right now, we do not want to be using legacy animations, so make sure this one is untoggled. If in your case it's toggled, just untoggle it, then go back into the normal inspector, and now, yep, it should look just like this. Okay, so we have our animation, and now it's on our animator controller. Now let's actually make an animation. So let's select the animation window, and again, let's make sure to select the object, so let's select the player visual game object. So here on the animation window, we see this nice little red button. This one enables or disables recording. So if you click on it, you can see, yep, the timeline is now red, meaning that we are now recording. And now we can do anything to any child objects and it will record any changes we make. Now note what I said, that's very important. It needs to be child objects. If you select, for example, the parent game object, then all of a sudden it stops recording. So you can only animate child objects. So let's select the player visual, let's enable recording, then let's expand the player visual. Let's make sure that our timeline is on 0, so drag it all the way to the left. And now for example, let's grab the head object and let's move it just a tiny bit. Basically just move it enough in order to make sure that the position over here is in red, meaning that we have recorded a keyframe. Then let's drag the timeline by a little bit. Let's go over here to frame 30. This one is actually going to be half a second, and it's going to be that because over here on the samples, this is the frame rate for the animation. So at 60, that means we have 60 frames. This makes 1 second, so 30 frames would be half a second. You can also zoom out by scrolling over here or dragging the handles down here. So let's go into 30, half a second, and now this one, let's move the head by a little bit, something like this. As you can see down there, we can note that it recorded the new keyframe. And now if we hit on the play button, we can preview the animation, and yep, look at that, it does do exactly that. So it starts off down and then moves up. Okay, so that's great, but we don't want it to snap back, so let's actually add another keyframe right at the end. So let's stop playing the animation. And to make sure we have a perfect loop, let's just click to select the keyframe. Let's press Ctrl C. Then let's go down into the 1 second mark. Let's press Ctrl V, and there we go, there's the exact same keyframe. So now if we hit on play, yep, there we go, we have our nice seamless loop. So the head goes up and down and repeats forever. All right, awesome. Okay, so that's great. Now let's also do one thing. Let's also record a keyframe on the body. However, we don't want it to move, at least not in this idle animation. We just want to have a static keyframe. So let's select the body. And let me actually move it a bit to the side just to make sure to record. And now manually we can modify the things over here to modify the actual keyframe data. So on this one I don't want it to move, so let's put it all the way back at 0, just to make sure we have a nice keyframe recording. Now the reason why we are recording the body position even without moving it is because the wonk animation will indeed move the body, but when we get back to idle, we want the body to go back to this exact position. So that is why we need a keyframe here. Okay, so that's done, so we can stop recording, so let's click on the red button again. Okay, great. By the way, one more note to make sure that the animation loops, go into the project window, and over here select the animation and make sure loop time is enabled. It should be there by default. Okay, so the animation is set up, and if we look in the animator, it's already the default state. So if we hit play, we should be able to see the idle animation playing nonstop. So let's hit play, and yep, there it is, the idle animation with the head moving up and down. Everything works perfectly. All right, awesome. Okay, so next up, let's make a wonk animation. Now for me, when making an animation that is based on another one, I like to actually duplicate it instead of starting from scratch. So over here on the project window, let's select the idle animation, and let's duplicate it, so Ctrl D. Let's rename this one to the wonk animation. And now if we select the player visual and then we go into the animation window, over here we see a nice little drop down menu for all of the animations, except right now we don't see the wonk animation, we only see the idle animation. That is because this menu only shows animations that are attached to the animator. So first we need to add the animation onto the animator component, and how we do that is actually super simple. Let's just open up the project window and just drag the wonk animation and drop it here. That's it. So with this we have attached a new state to the animator controller, and now if once again we select the object in the hierarchy, go into the animation, click the drop down menu, and yep, now we do see the wonk animation. So let's click to select this one, and now for this one let's make the animation. So let's look in scene view and make it bounce just up and down. So I'm going to enable record, go back here, and for the body this one already has a keyframe, so let's go up here, move it a little bit, and then copy the keyframe, put it the same one at the end, something like this. So there you go, just goes up and down. Let's actually put it offset so it looks a bit better, so something like this. By the way, in a bit we're going to replace these animations with the ones that I made previously, so don't worry about making the animations perfect unless you want to do that. Okay, so there you go, that's the animation, although for walking it should be much faster. So here's a quick animated tip. The stop bar here lets you select all of the keyframes within a certain time. So if I click to select, note how it selects both those keyframes. And also if you click and drag whilst on top of here, you can select multiple keyframes. So for example, to select everything, just click and drag to select all of them. And now you see these nice little vertical bars. So if you click on those and then you drag them, you can basically modify the time of all the animations and everything matches up. So for example, let's make this one super fast. Let's put it just 20 frames. So there you go. Now it's a much faster wonk animation. Okay, great. Let's click on the right to stop recording. All right, and back in the animator. So over here we have both animations. And now what we need is to make a transition going from idle into wonk. Otherwise the wonk animation will never play. So how we make a transition is also super simple. Let's right click on the idle state. Let's make a transition. Then now we have a nice little arrow under the mouse. And now if we go into the wonk and click on it, there you go, we have a nice transition. Now we can click on the transition itself to select it. And over here in the inspector, we see a bunch of transition options. So let's expand the settings. Yep, there you go, everything. Now, like I said, I covered all of these options in a lot of detail in my Ultimate Unity Overview course. So if you want to learn more, go watch that. Here, let's just learn the basics for how to achieve our goal in making a simple player animator. The important one is over here, the exit time. Basically, if this one is toggled, then this transition will be triggered automatically, meaning it won't play the idle animation and immediately transition into the wonk animation. So for example, if we hit play and look at it quickly, yep, there you go, there's the idle, and yep, transitions into wonk. And now it stays there forever. Okay, so that's good, but not exactly what we want. We want the wonk animation to only play when the character is wonking, and when it stops, we want it to go back into the idle animation. Now for that, we need to use animator parameters. So back in our animator, on the top left corner, we see something called layers. We don't need to worry about that for now. And then next to it, we see parameters. Then we can click on the plus button in order to create a brand new parameter, and you can see all of the various types that we can create. Now for wonking, we want something that we can set to either true or false. So let's go with a nice boolean. And for name, let's call it is wonky. Again, pay very close attention to the capitalization. This is extremely important. Just like code, is wonking is different from is wonking, so make sure the capitalization is perfect. Okay, so with that, we have our nice parameter. Now let's click on transition going from idle into wonk, and now let's untick exit time. We don't want this transition to trigger automatically, and as soon as we do, we see this nice little warning. Basically, it's telling us that this transition will never happen. So over here, we have the nice conditions. If we click on the plus icon, we can add some conditions. And for this one, we want this transition to happen from idle into wonk when the parameter is wonking is set to true. So that's it. This is our transition. Now let's just do the reverse. So let's right click on the wonk, make transition, go back into idle. Let's click to select transition, get rid of the exit time and conditions when is wonking is set to false. Okay, so just like this, our basic animation logic should be working. So let's test. So here we are, and the character is playing the idle animation. By the way, you can look at the animator while the game is running. So let me just drag the animator window, just drag it and put it on the side of the game view so we can see both at the same time. Okay, great. And right now, note how it's not updating, so there's nothing moving over here on the animator component. That is because, like I said, you must select the object. So on the hierarchy, make sure you select the player visual, and yep, there you go. Now you do see that updating. So make sure the object is selected in the hierarchy. And over here, we see a nice little progress bar showing the idle animation constantly playing and looping. Okay, great. Another important thing is over here the parameters. You can manually change the state of these while the game is running. So for example, if I click, it's going to trigger the is wonking parameter, which should trigger this transition and should go into wonk. So if I click, and if there you go, transitions into the wonk animation, and now, yep, it is playing the wonking animation. And if I click to untick it, look at over there what happens, untick, and there you go, transitions back into idle. All right, awesome. So as you can see, we have all of our logic working. We have the animator with both of our states, and by changing this parameter, we can change which animation is playing. Now, of course, the goal is not to trigger this manually by clicking on it, but rather doing it through code. But at least for now, we know that our animator is fully set up. Again, if you want more detail on the animator and animation windows and everything related to animations, then check out those lectures in my Ultimate TNT Overview course. And also later on, for more advanced use cases, I have a video on the animation rigging package. This one is for more advanced use cases for making dynamic procedural animations. It's really fun, so definitely check it out, but only after finishing this course. That one is a much more advanced tool. For now, let's continue here. So we want to trigger our parameter, but do it through code. And again, here we have yet another clean code question. Technically, we could add that code directly over here on the player script. We could just grab the animator component and change the parameter. And in this case, for this very simple game, that would actually not necessarily be a very bad approach, since the game is so simple with so few animations. But like I said, I want to teach you proper good practices, so let's make it properly and actually separate the animations from the logic. For that, let's go into our project, right click in our scripts folder, create a new C# script. Let's call it the player animator. Let's select the player visual game object and attach the component. Okay, so now here, first let's grab the animator. Now one approach is, like we've seen, we could just make a serialized field and drag the reference in the editor. That's one approach. Or alternatively, since the animator is attached to the same game object as this script, then we can just do a get component. Both approaches are really valid. So here let's use get component just to see a different approach. So we just have a field for our animator, so animator. And then we just do a private void awake. And then awake lets you get component of type animator. And we set our animator variable. Again, like I mentioned, very important, make sure you don't mix animator and animation. These are two different components. We want the animator. Okay, so with this, we have a reference to our animator component. And now how we modify the parameter is actually very simple. We just access the animator, and then we have a bunch of set functions. You can see we have one for each type. So we've got a set bool, set float, then down here a set trigger, set vector. So function to set any parameter type. Now we made it a boolean, so let's use the set bool. And this one, as you can see, takes the name for the animator parameter. By the way, strings are a horrible way of identifying things, but sadly this system really does require strings to identify the parameter we want to change. If you're wondering why strings are bad for identifying things, the reason is because it's very easy to make a mistake. For example, if you use is wonking here, then this will work. However, if you instead write is wonking, then all of a sudden it does not work. If you write is wonking like this, doesn't work, like this, doesn't work. And even though it doesn't work, it will also not throw any compiler errors. That is because for the compiler, a string is a string, it's always valid. But then when the code runs, this one is going to be different than our parameter, which is named the example like this. Always remember that strings are case sensitive. So that's one reason why you should never use strings to identify things. It's very easy to make tons of mistakes that are then again, very difficult to find out. But like I said, in this animated system, we have to use strings. There's no other way. In order to minimize our usage of strings, one thing we can do is, for example, let's define a constant up here. So let's make a private, make it const for a constant, meaning this will never change. Make it of type string and call it isWonking. Again, refer back into the naming rules section. For constants, we always use uppercase, snake case. So isWonking, and let's set it with isWonking. Again, make sure you don't make a mistake here. Make sure you type it exactly like you did on the animator. Then down here, let's use isWonking. And now if we do make a mistake, so if we accidentally use something different, now we do get a compiler error, so at least we have a little bit of protection. Okay, so this one takes a string for the name and then a simple boolean for the value. So this is going to be the value that we want to set to our parameter. Now for this one, we want it to set to true when the player is wonking and false when it's not. So for that, we need to ask the player what it's doing. So let's go over here into our player class. And let's make a function to return just that. So let's make it public because we're going to access it from another script. We're going to return a bool and call it isWonking. Now over here, we just need to return if the player is wonking. So let's make a local field to store that state. So over here, private bool isWonking. Again, note the capitalization. For fields, we start with camel case, whereas for functions, we have Pascal case. So these are different, okay? So basically, in order to define if we are wonking, that's very simple. It's just down here we have the movement direction. So we are wonking if the move direction is different from vector3.0, which by the way, vector3.0 is just a shorthand for writing 0, 0, 0. So if the movement direction is different from 0, then we are indeed wonking. So we define that, we update that field on every update, and then over here we just return it, okay, just like this. And now back in our player animated component, over here first we need a reference to the player. So let's add it here. Let's add a serialized field of type player. And we need to compile this in order to drag the reference. So let's just comment out this line just to make sure the code compiles. Now here with the code compile, let's drag the reference of our player. Okay, that's it. And then over here for the animator, set isWonking. Let's go into the player and let's ask isWonking. And of course, we don't want to do this just on awake. We want to do it on every single frame. So let's do a private void update. And on update, let's do this. All right, that's it. So this should be working. Let's test. So here we are, starting off as idle, and now as I move, yep, there you go, it is playing the wonking animation. And now if I stop, and yep, there you go, back into idle. All right, awesome, everything does work perfectly. Okay, great. We can even look at the animator to see the state change. So here with both side by side and with the object selected in the hierarchy, right now you can see isWonking is false, so it's on idle, and as I move, that one stays true, that one goes into wonk, and now if I let go, if there you go, back into false, back into idle. All right, awesome. So with this, everything is working perfectly. If you're having issues, make sure you pay attention to the capitalization. So make sure the name you wrote here is exactly the same one that you wrote here, and it's exactly the same that you're using here. Alright, so all of our animations are working perfectly. Now, if you want, you can go ahead and make your own animations, or you can use the ones that I pre-built. So in the included project files, inside the assets here, we've got the animations, and we've got the player with the idle and the wonk animations. If we double click on this to look at it, you can see, yep, it looks exactly the same. So there's a parameter called isWonking and our transition, so everything is exactly the same. Just over here, let's select the player visual, and on the prefab, like we saw, we already had the animated component. We just removed that one from the prefab in order to build it all from scratch. But if you want to use my animations, then we can just go ahead, remove the animator that we added, and then right click on this one on the remove component. Let's revert back the changes. And there you go. Here we have our animator with the player controller. So that's the one in the included animations. And just like this, if we had on play, and actually over here I found an issue, although in your case there shouldn't be any issue because I have updated the assets. But this is a good time to teach you about any issues with animations. So if you select the animation and you select the animation, then over here you might see some of them in yellow saying missing. Basically the way that animations work is based on the actual name of the object. If it cannot find an object with the exact same name, then it cannot load the same animation. So my problem is that when I initially made the assets package, I made this animation and the object was previously named face, and then I renamed it to head, so now it no longer loads. So if you ever have problems with loading animations, just make sure the names perfectly match. So in my case, I can just click in here in order to rename this keyframe on the animation. And I'm just going to use the name that I renamed it. So head, and just like this, yep, the animation does play correctly. So just a nice quick tip, if you ever have problems with animations, always remember that the stored keyframes, they're all stored based on name. So if you rename the thing in here or over here on the game object, if you rename, you're going to have missing animations. But if you make sure the names match, then the animation should load perfectly. So let's hit on play. And if there you go, there's the idle animation. And if I move, yep, there's the nice wonk animation. So everything still works perfectly because it's only using the exact same parameters. All right, awesome. So like I said, if you want, feel free to make your own animations or use the ones that I've included. For me, I'm going to be using these ones. So the ones that we made just for learning, which I created down here, so the My Player Animator and these animations, I'm just going to delete these just to keep the project clean. So just delete, and just like that. Okay, so now that we have our character fully working, let's quickly handle our camera. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to quickly install Cinemachine. This is a Unity tool that makes handling cameras super easy. Our game isn't really going to have a moving camera, so this part isn't strictly necessary, but Cinemachine is a super useful tool, so I definitely want you to learn about it. Okay, so let's begin by installing the package. Let's go into Window, open up the Package Manager. Then up top, let's make sure we are in the Unity registry. Make sure you're on the Alt tab, and now just scroll down until you find, yep, there it is, Cinemachine. Okay, so let's go ahead and install this. Alright, it's installed, so let's close this. And now the way that Cinemachine works is by creating what is called a Cinemachine virtual camera. So let's go up top into the Game Object menu, then scroll down into Cinemachine, and over here you can see that we can create a multitude of virtual camera types. Now, just by the names, you can see how this tool is insanely useful. For example, making a FreeLook camera. Doing that from scratch is a bit tricky, but with Cinemachine it is super easy. For our case, like I said, we want the absolute most basic thing possible, so let's just create an empty virtual camera. Okay, that's it. This creates a virtual camera over here in the hierarchy. In turn, this object has the Cinemachine virtual camera component. And also importantly, when we added this, it also added over here on the main camera. If we scroll down, we can see it has a Cinemachine brain component. Basically, the way Cinemachine works is it works on top of the main camera, so it doesn't replace it, it works on top of it and drives the main camera. So now that we're using Cinemachine, if we try modifying the main camera game object, so for example over here, if I try to drag the field of view, nope, does not work, I cannot move it. If I try to move the position, nope, can't do it. If I try to rotate it, nope, that does not work. Like I said, when working with Cinemachine, the Cinemachine brain is what drives the main camera. So rather than modifying the things over here on the camera itself, what we need to do is change them on the virtual camera. So over here we have pretty much the exact same options that we have on the main camera. For example, modifying the FOV, over here we've got the lens, so we can modify the FOV, and if we look in the game scene, as we modify this one, yep, it does modify the actual properties on the actual main camera. Now this has tons and tons of options related to everything. The most important ones are all kinds of options down here for the body and the aim. So this is where the camera is positioned and where it's looking at. Using this, you can make a follow camera in 5 seconds. It really is insanely useful. If you want to learn about Cinemachine in more detail, I have a dedicated video on it. I go through what all of these options do. Then I also have another super detailed video on how to make a camera system with pan, zoom, scroll in both 2D and 3D and a bunch more features. Again, all of it using Cinemachine. But in our case, we really want to keep it simple, so let's just position our virtual camera on the same settings that we had previously. So first, let's set the field of view. So for our game, we want something narrow, so let's go with just 20. Then for the position, let's put it above. So 0 on the X, then 21.5 on the Y, and minus 21.3 on the Z. Then for the rotation, 46 on the X, and then 0 on the others. Okay, so our camera is positioned in the exact same position. And if we head on play, yep, everything still works the same. The camera is looking from the same point of view, and the character still works. Everything's still exactly the same. Now, since we're using Cinemachine, we can easily add some things on top of this. Like for example, we can add some noise to our Cinemachine camera to make it smoothly move a little bit. This one is a fun, simple effect that can make our game feel a bit more dynamic, especially in games like this where we have a fixed overhead view. How we do that is over here on the Cinemachine virtual camera, we've got a field for noise. So let's click and let's select Basic Multi-Channel Perlin. And then over here, we've got the noise profile, so we can choose one of the included ones, or we can create our own profile. So for example, let's go with handheld, normal, mild. And by the way, you can actually modify these settings while the game is playing. So here it is, the game playing, and you can see what this effect does. It adds a nice little wobble to the camera. And then over here, amplitude and frequency, so we can play around these. So you can make it really intense, so something like this, that is way too intense. So there you go, quite a lot. So for something more subtle, maybe put 0.5 and 0.5. There you go, just a slight little movement in the camera. So this would help make the game a little bit more dynamic, so this could be a fun effect. Although actually in my case, in order to make sure that the video doesn't get way too compressed, I'm actually going to disable this on my end. So just set the channel noise to none. But you can see how easy it is to add complex camera features when using Cinemachine. And of course, when using Cinemachine, if you want, you can use it to make your game a lot more unique. Now for me, I want to design here where the camera is fixed. But let's say, for example, you wanted the camera to actually follow the player. Like I said, go watch that dedicated video to learn all about Cinemachine. But over here, very quickly, let me just show you how to do that. But at the same time, don't bother following this part. It's just to show what Cinemachine can do that I'm going to revert back to this state. So first of all, for testing, one great thing about Cinemachine is you can have multiple virtual cameras. You can have as many as you want. And then the priority and the game object enabled state is what defines which camera is actually being used. So for example, on this second one, let's make it follow the camera and put the priority on 20 so that it's above. Then over here for the body, I'm going to select transposer. Let's put it with world space. It requires a follow target, so let me drag the player as the follow target. and put it slightly above and behind. Okay, so it's pretty similar as before. Then for the aim, let me also drag the aim player target. And just with this, it should already work. So if I head on play, yep, there you go. Look at that. The camera is now moving and following the player, so I can move the player anywhere. And yep, the camera follows along. So as you can see, it's this simple to really make some complex camera movement. Doing some complex camera logic just like this would require a ton of work manually, but with Cinemachine, it is super easy. Then you can even play around with either priority or enable and disable. And there you go, Cinemachine even transitions between the state of all your virtual cameras. So as you can see, lots and lots of things you can make with your camera very easily, all thanks to Cinemachine. Like I said, in my case, I just want a fixed overhead camera, so I'm just going to delete this secondary virtual camera. And there you go, just this one on top, looking at the player, looking down with a low FOV. And yep, this is exactly the kind of camera that I want for my game. Okay, so that's Cinemachine. It's a really awesome tool for making camera handling much easier. So this was a quick lecture all about learning about Cinemachine. Now let's handle the task that was actually left undone quite a while ago. Let's finally learn how to refactor code and implement the new input system. So let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to refactor our code from the legacy input manager onto the new input system. So the simple character controller that we made is working perfectly fine with the legacy input manager. Like I said, this one is excellent for making quick prototypes and demos. As you can see, it's super easy to use. But now let's quickly refactor this code to use the new input system instead. Also, like I said in the beginning of this course, here I'm going to be focused primarily on building this game. So for example, for any Unity tools that I use, like the new input system, I'm going to cover enough to be able to use the tool and achieve our goals in building this game. But of course, every tool does a lot more than just what we're going to use. So definitely make sure to watch the dedicated videos linked in the description. For example, the input system tutorial is 40 minutes long, covering everything you need to know about system, whereas here we're just going to learn enough to know how to use it. So let's refactor this code to make it work with the new input system. Except before we work with the new input system, let's just refactor this code so we can completely decouple the input from the player class. Again, we want to focus on writing good, clean code, so we should keep all of our input logic in its own class that other scripts can access. Remember, the goal with clean code is to minimize and manage complexity. So every class should do one thing and just one thing, meaning that the player class should only handle the player, and then the input class should only handle the input. The only reason why I put this over here in the beginning is exactly to teach you about refactoring and how it's a very common thing that you should be doing all the time. This is exactly how I build my own games. I start by making a prototype and I write the input directly inside the player class, then at some point I refactor the code to split them up. So don't be afraid to refactor code, it's a perfectly natural part of the game dev process and actually a very good thing. Okay, so let's make a script just to manage our inputs. Let's make a new C# script, call this game input. Let's create an empty game object, give it the same name, input. As always, keep things clean, so put it on 000. Let's attach the script and open. Okay, so here's our script and let's get everything related to the inputs. On the player for the input, we are calculating the input vector, then getting the actual inputs from the keyboard and returning the input vector. So let's put this on the other script. So over here, let's make a new function. Let's make it public since we want to access it from the player. We're going to return a vector2 and let's call it getMovementVector. Now here, let's really just copy paste the exact same code that we have on the player. So let's copy paste all of this. Let's go and paste it here. Okay, so we get the input vector, we get the inputs, we normalize it, and then return the input vector. Okay, so that's it, super simple. Also, by the way, here we have an interesting question, which is, do we normalize the input over here, or do we do it over here on the player? Both options can be valid. You can make it so that the game input class returns a regular input, or you can make it return a normalized vector. You can use either option, but whatever you do, make sure you are explicit. So over here, I am going to normalize the input inside the game input class. However, I'm also going to make sure to rename this function. So instead of getMovementVector normalized. That way it is 100% clear this returns the movement vector as a normalized vector. Okay, great. So now let's use this in our player. Over here in our player class, we need some reference to our input class. Now later on in this course, I'm going to teach you about the singleton pattern, but for now, let's just do a simple direct reference. Again, remember, don't make it public, make it a serialized field private. So over here, let's make a serialized field private of type game input, and let's call it just game input. Okay, so we have this, we're going to drag it in the editor, then over here, we simply grab the vector2 for the input vector, we simply go into this one, and we get the movement vector normalized. And okay, that's it, no more errors. Let's just make sure to save all of our scripts. And back in the editor, let's go into the player and just drag the reference for the game input. Okay, so just like this, everything should still work. Everything should work exactly the same as previously. Let's test and make sure. So here we are moving, and yep, everything still works. I can move in any direction. Okay, so far so good. And what we have done here is essentially we have refactored our code and completely separated the input from the player class. This is an excellent thing, so again, don't be afraid to refactor code. Also, what we did here of putting the code in a separate class and then doing a quick test to make sure that everything still works the same as previously, this is exactly what you should do whenever you do some kind of reorganizational refactoring. In the end, you want to end up with the exact same behavior as previously, just with the code organized in a different way. Okay, so now that we have this separate game input class, now we can very easily refactor the legacy input manager onto the new input system. So the first thing we need is to install the package, so let's open up the package manager. Let's make sure up here we are in the Unity registry, make sure we are in all, and let's scroll down to find the input system, so here it is. Let's go ahead and install. Okay, the package is installed, and right away we see this message. Basically, it's asking us if we want to enable the new input system. Now, you could click on yes, but let's actually go ahead and click on no. We're going to enable it manually, so click on no. Then let's close this window. And now let's go up here into edit, then let's go into project settings. Then on the left side, let's go into player. And now let's scroll down, expand over here the other settings tab, and keep scrolling down until we see, yep, here it is, the active input handling. This is where you can select which input system you're using. Basically, if you click yes on that window, it would automatically set this option to use the new input system. So it would only enable that one and completely disable the legacy input manager. But like I said, the legacy input manager is still pretty useful, so normally for me, I prefer to enable both of them. So let's go ahead, click on both, and this will restart the editor. So okay, let's go. Alright, the editor has restarted, so now the new input system is now enabled. Okay, so the way that this system works is by creating something called an input actions asset. So on the project files, let's click on the plus icon, let's create something, and let's find the input actions. So we need to scroll down here, so click on the little arrow to go down and find the input actions. Creates this file, let's call this the player input actions. Okay, now let's go ahead and double click on it. And yep, there you go, out pops out the input system window. Basically, this one is where we're going to manage all of the settings for all of our inputs. Also, by the way, like I've mentioned, if you're watching this in the future and for some reason the input system got a new update and changed this window, if so, make sure you check the pinned comment. I'll keep it updated with any changes on anything in this course. So over here, we've got the action maps, then we've got the actions, and then we've got properties. Now, action maps are how you can have different maps. For example, one action map would be for the player whilst walking normally, and you could have another one whilst driving a vehicle. Then for the individual actions in each action map, and finally the properties for each action. Again, if you want to learn about the entire input system itself in more detail, go ahead and watch my dedicated video on it. In order for this course to not be 20 hours long, I'm really only going to use enough to make sure that we can achieve our goal. So over here, we just need one action map, so let's click on the plus icon. Let's name this the player. And now for the actions, right away we have a new action. So let's just rename this one. Let's call this action move. Then with this action selected, over here on the action properties, we can select the action type. Again, in the dedicated video, I cover what all of these mean. For movement, we do not want a button. We want movement in multiple directions, so let's go with value. Then over here for the control type, for this one, let's go with a vector2. And then let's expand our action. Over here, we can see our bindings. However, we don't want this default binding, so let's actually delete this one. Instead, let's click on the plus icon, and over here for the type, first for the keyboard, let's go with this one, up, down, left, right, composite. So this one adds essentially 4 bindings. Let's go ahead and name this WASD. Then for the up, let's select the binding. So over here on the path, let's click on it. Then we can either find it manually over here or click on the listen and now press the W button. Yep, there you go, W. Then for down, let's go ahead and listen S. Then for the left, listen A. And for the right, let's listen D. Okay, great. So with this, our input asset is correctly set up. One thing you must never forget is up here, make sure to save the asset. You can see this little asterisk here. That means we have unsaved changes. Also, alternatively, there's an autosave there. But for now, let's just manually save the asset. Okay, great. So now let's see how to actually use this in our code. There are many ways we can use the input system. One way is by using the built-in player input component. So for example, on the player, we would add the player input. So you could add this one, attach an input actions asset. So this is our player input actions. Then over here, we have various behaviors in order to be able to trigger our actions. But in this course, like I said, I'm going to be using the exact same code quality that I used in my own Steam games, so I will not be using this component, so let's remove this. Instead, I will be using the native C# method. So let's select the player input actions, and over here on the inspector, we see this nice toggle to generate a C# class. Let's go ahead, enable it, and for these fields, we can leave them all on defaults, that's okay. Let's just go ahead, click on apply, and now it's going to generate those scripts and compile them. Okay, great. Basically what this is doing is auto-generating some C# code, and on the player input actions we can see over here, yep, we've got the generated script. If you want, you can even open this to see all of the source code. Now all of this, like it says here, this was all auto-generated, so don't make any modifications here. If you change anything, any manual changes will be lost when you save some changes in the input asset. So if you want, go ahead and read through in order to see how all of this works. But in order to use it, it's actually super simple, you don't need to worry about this script. First thing we need is to construct our script class that was auto-generated, so let's do it over here in our game input. Let's make a private void awake, and on awake let's construct it. So let's do a new player input actions. So we construct an object of this type. So we have this, although just like this it won't be active, so we need to manually activate whatever action map we want. So let's go inside and let's go inside the player. So this is the action map that we created, and let's call enable on it. Okay, so just like this, it's really already working. All we need to do is modify our code over here on the get movement vector. So for that, we're going to need to access this. So let's actually make this a member variable. So private, let's store it up here instead of making a local variable in here. Okay. So we have this one, and then down here on the input vector, let's go inside the player input actions, inside the player action map, and then we called it move. So we've got this one. And then we defined it as a vector2. So over here we can call read value. And this one takes in the type of the value. Now we defined it as a vector2, so let's read it as a vector2. And just like this. This returns a vector2, which is really going to be our input vector. So let's put it exactly like this. And we can now get rid of the rest of it. Alright, so that's it. And just like this, we should already have everything working exactly the same as previously. So let's just do a debug.log just to make sure. So let's test. So here we are, and the output is 0, 0. Now I press W. There you go, +1, -1, left, right, and all of the ones in between. All right, awesome. So we have the new input system, all of it working flawlessly. Also, by the way, over here we can normalize the input just like we were doing previously. So we do it over here through code. Or alternatively, we can also go into the player input actions. And over here, there's something called a processor. So you can go into this action, add a processor, and make it normalized. So these processors here can be quite useful. I cover them all in detail in the other dedicated video, but over here, let's stick with making it through code that works just as well. Okay, so that's our refactoring done. With that simple change, we are now using the new input system. So you can see how by refactoring our code to make sure to use the game input class, when we change from the input manager onto the new input system, when we made that change, we did not have to touch the player class at all. The player class just has the game input to get the movement vector and does not care what system he uses to get that. So here we have a very practical, very excellent example of the power of writing good, clean code. Because we separated things correctly, we managed to change something completely and not have to make any changes on any other class. So now that we're using the new input system, let's just quickly see one of the main benefits of this system, which is easily supporting gamepads and more keys. For example, a lot of people like using WASD, but some people also like to use the arrow keys. With this system, that is super easy to add. So let's go into the move, let's add another one. Let's add another one, up, down, left, right composite. Let's call it arrow keys. Then let's just put them. So let's listen on the up arrow. Then over here we've got the down arrow. Then we have the left arrow. And finally we have the right arrow. Alright, so we've got all the arrows. And now we don't even need to touch any code at all. Let's just make sure to save the asset, which again, in turn, that is going to auto-generate the C# class and going to compile. Okay, so we don't need to touch any code at all. Let's just hit on play. And now if I move, we're using the WASD keys, yep, still works. And if I go into the arrow keys, yep, also still works. All right, great. Now for another one, let's make it for a gamepad. So I just connected an Xbox controller, and we can see over here on the log, yep, the game did identify it. So this is the new input system in action. Let's once again open up the input actions. And over here on the move, let's add another one. And this time, let's just make it a regular binding. And now over here on the path, once again, if we want, we can go down here and specifically find some joysticks. So you can find any of them, or once again, let's just use the listen. Now I'm just going to move the thumbstick on the controller. Yep, there it is. And now if you wanted, you could go specific and make it just work with Xbox controllers, or you can just use the generic left stick. This will make it work with an Xbox controller or a PlayStation or really anything. So let's go with this one. And that's it, nothing else we need to do. Let's just save the asset and that's it. We don't need to touch any of our code to make our game playable with a controller. So let's go ahead and test. So here we are, and first of all, if I move the keys, yep, still works. Move the arrow keys, yep, both of them works. And now if I use my gamepad, and yep, there you go, everything works perfectly. Alright, awesome! So as you can see, this is one of the main benefits of the new input system. It makes handling different inputs really super easily. As you saw, we didn't have to touch our code at all. We just had new bindings, and just like that, our game is playable with all kinds of inputs. So here you can really see just how powerful new input system is. Okay, so with this, our basic character movement is working great. We can walk around, everything looks great. Now in the next lecture, let's apply some collisions to our player. Hey again, here's another quick intermission. I hope you've already learned a ton from the course. Have you seen the benefits of writing good clean code? Has the course already helped you understand some more advanced concepts? I really hope the answer is yes to both of those. Remember to follow the website page as you follow along. I will be adding frequently asked questions to every lecture. If you ever get stuck, you can just download the project files for a lecture and compare with your own. And definitely check out the related videos when I reference them. This course is focused on making this game, but you should definitely learn more about some of these concepts in more detail, and you can learn that in the videos that I mentioned. By the way, if you're watching this right now, this is the secret callout, so go ahead, post a timestamp in the comments with a nice monkey emoji. I want to see how many people make it this far. Okay, so that's it for now. Let's go to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to apply some collisions to our player movement. Okay, so here we have our game so far. We have our player walking around and everything looks pretty good. However, now let's create over here in the hierarchy, let's right click, create a brand new cube. So there you go, let's place it over here and push it down. Okay, there's the cube. Make it just a little bit bigger. So there's the cube, and by default it has a box collider component, so it has physics. And the player, if I move, and nope, there's our issue. The player is going right through the object. Now the player is not meant to be a ghost, so let's fix this. Over here in our player script, we are carrying the input vector, calculating the move direction, and then just moving the transform. So right now we're moving it no matter what. Now before we do that, let's first do a test to see if any object is in the way. And how we're going to do that is by firing a raycast. This one is a physics operation that basically fires a laser from a certain point towards a certain direction and then tells you if it hits something. How we do that is let's go inside the physics class and let's call the raycast function. This one, as you can see, has many versions of this function with all kinds of parameters. Let's use this one, option number 7, which takes a vector3 for the origin, a direction, and a max distance. So first for the origin, that is from where we want to fire our raycast. Let's put the player object in, so that's transform.position. Then for the direction, this is going to be our move direction, so let's use our move there. And finally for the distance, let's use some kind of player size, player width, something like that. So let's define up here a float for the player size and put it at 0.7 units. Let's try out with the size just like this. Okay, so basically this returns a boolean. It's going to return true if it hits something and false if nothing is in the way. So let's just do a bool, call it can move, and basically we can move if this raycast doesn't hit anything. So we can move if this one is false. So if the raycast is false, then can move is going to be true. That's very simple. So if we can move, then we move the transform position, otherwise we don't. Okay, that's it, super simple. Let's test. So here we are, I can move around, and if I go towards the cube, and nope, no longer works. So I can no longer go inside that cube. Okay, great. Now in your case, if it's not working, first of all, make sure that the cube, make sure it is touching the floor. We use the transform position as the origin, which is right on the floor. So if the box is raised up, then you won't be able to go through, so make sure the cube is touching the floor. Also make sure the cube has a box collider component. It can be any type of collider, but if you made a cube, then it should have a box collider by default, and it should have the same shape as the visual. And also remember that the 2D and the 3D physics systems, those are completely separate. They are completely different worlds. So make sure you're using 3D components and not the 2D ones. So for example, if I add box collider 2D, if I add this one, then it will not work. So make sure you're using the 3D and not the 2D components. Same thing over here on the script, make sure you're using physics and not physics 2D. Also finally, if you're still having issues, make sure you check the player position. Again, the player should be on a Y of 0. The only thing that might have an offset is the player visual, although if you're using the same as me, then this one should also be on a Y of 0, so all of these on Y of 0. And then you can also check the floor. By default, this one has a mesh collider, but if it is exactly on Y of 0 with no rotation, then it shouldn't cause any issues. Alternatively, you can also just disable or remove the mesh collider from the floor, since we're not going to need that. So with all of that, yep, everything works. I can move the player, but I cannot go through solid objects. Alright, awesome. So it is working. But for this particular use case, a raycast isn't necessarily the best method we should use. Basically, a raycast is, like I said, kind of like a super thin laser. But as you can see, the player visually has an actual body shape. So the visual and the logic are using completely different shapes. If I go ahead and push towards the box, you can see it works just fine. However, if the player is a bit more off to the side, and the center of the player right in front of it is not the box, and I move, and yep, there you go, now I am going through the box. The reason is because the raycast is being fired from the center of the player, and like I said, it's kind of like an infinitely thin laser, so it has no shape. So as long as the center of the player is not hitting the box, then it can go through it. Whereas what we really want is for the visual and logic to have pretty much the same shape, so let's not use a raycast. Over here on the code, instead of a raycast, we can use a physics query with an actual shape. There are all kinds of casts you can use. And as you can see, all of them with different shapes. So you've got a box cast if you want to have a box, a capsule if you want a capsule, or a sphere cast. All of these work pretty much the exact same way, except instead of a raycast which fires an infinitely thin laser, these are going to have an actual shape. And for player controllers, for the most part, you really want to be using a capsule cast. That's usually the generally accepted player shape, although alternatively a box cast also can work very well. In our case, let's just go with a simple capsule cast. This one, to define a capsule, has a 0.1 and a 0.2. By the way, if you have no idea what is a capsule, then we can go over here in the hierarchy, let's right click, create a 3D object, let's make it a capsule, and there you go, this is a capsule. It's kind of like a stretched sphere. So it has round the top, round the bottom, and then over here in the middle, it's just a cylinder. And over here for the raycast, takes a 0.1 and a 0.2, so that is going to be the bottom of the capsule and the top of the capsule. Basically, with those 2 points, we can define the height of the actual capsule. Okay, so let's just get rid of this capsule, let's just delete it. And over in the code, let's put those. Now for 0.1, it is indeed going to be the transform.position, since that is the point at the bottom. And for the second point, for this one, it's essentially going to be the player head. So we can take the transform.position, so this is the bottom, and we can essentially just lift it up. So let's add a vector3.up and multiply by some kind of player height. So let's define up here a float for the player height. And I tested it in the editor, and the player is about 2 units tall. So over here, let's go ahead and move it up by that much. Okay, so next we want the radius. So this is pretty much the player size that we defined previously, so let's use the same thing. But as always, let's make sure to write good clean code. Since now we are referring to a radius, let's actually rename this to be a bit more clear. And by the way, here's a quick Visual Studio tip. You can right click on a symbol, and then you can click on the rename option. Alternatively, use the shortcut Control R. If you do that, then now you can change the name. So for example, player radius, and note how it changes every single instance of that variable. So this renaming feature is extremely useful. Always make sure to rename something if you find the name that works best. Okay, so let's rename this to player radius. Then we have direction, so that is as usual going to be our move direction. And then finally we have the move distance. For that we can use the actual move distance. So that is going to be the movement speed multiplied by time.time. So I just find here a float for the move distance. And we just do that, just move speed, time.time. We have the move distance, and we use it both in here as well as down here. Okay, so here we have our capsule cast. The rest of the logic is exactly the same, so if this one is false, that means it didn't hit anything. So if it didn't hit anything, then we can move, and then we move the transform. Okay, let's test. And over here, now if I go towards the box, and yep, still works exactly the same as previously, that's great. And now if I go towards the edge, and make sure that the center is not hitting the box, and now I try to move forward, and nope, now we no longer go inside the cube. So even on the edges, everything still works perfectly. Alright, awesome. So it works, it looks good, but it also is a little bit janky. For example, let's stretch this cube out a little bit, so let's put it just on one direction, so stretch it like this, let's see. Now if I move towards it, then nope, I cannot go through it, so that is correct. And if I move left and right, yep, that's also correct, that works. However, if I now press W and D at the same time in order to move diagonally, and nope, right now it does not move. The reason is because the diagonal vector, that one is indeed hitting the collider. But usually in games, when you move diagonally and you cannot move in one direction, then it tries to essentially hug the wall and move around it. So if I press W and D, it should essentially be moving straight to the right. So let's solve that. So here in our code, we're making our capsule cast. Okay, that's great. Then we need to test if we cannot move. So let's do if we cannot move. So if can move is false. If so, then that means we cannot move towards this direction. And if we can't, then essentially we basically want to split the movement direction and just move on the X or just on the Z. So first, let's attempt just the X movement. So attempt only X movement. Let's create a new vector 3. Let's call it move dir X, and we make a new vector 3. Let's take in the move dir.x, then 0 on all the others. So we only want to test moving in the X direction. And then let's do literally the same thing. So let's get our can move, try to move under this direction. So let's go instead of move dir on the X. So we do that capsule cast. And if we can move, then that means we can move only on the X axis. So can move only on the X. And if so, let's set the move dir equals the move dir X. So if we can move, then down here when we use the move dir, we're going to move only on the X. And if we cannot move, then that means we cannot move only on the X. And if so, then let's attempt only Z movement. So over here, again, let's do the exact same thing. So let's copy this. Let's just change this one. So instead of move dir X, we've got move dir on the Z. So over here, we use 0 on the X, 0 on the Y, and access the move dir and get the Z. Then let's use this movement direction over there. And finally, the same thing. So if we can move, then that means we can move only on the Z. And let's set the move dir equals the move dir Z. And if not, then we cannot move in any direction. Okay, so that's it. Now this might seem a bit confusing, but it becomes a lot more clear when you see it in action. Again, remember the scenario we're trying to solve, which is when moving diagonally. So for example, when we're moving forwards and to the right. If we do that, then let's say this one is going to hit something, so we cannot move. So if we are trying to move both forwards and to the right, then we're going to only attempt the X movement, so we're only going to try moving to the right. And then we're going to see, yep, going to the right, that does work, so we can move, and we're going to move just to the right. Alright, so let's test and see if all of this is working. Alright, so here we are, and if I move straight to the wall, and nope, there's a limit, so I cannot move anymore. Okay, great. Now if I move just left and just right, then it does work. Now if I press W and then D, and yep, there you go, now it does hug the wall and continues to move. Same thing if I go on the left, so over here if I press D, no I cannot go through it. Now if I press D and S at the same time, and there you go, it hugs the wall and moves around it. So now our controller is much more easy, much more understandable. Okay, so this is great. Now this is one of those tiny things that makes your character controller feel much more responsive, so that's great. However, we also do see one more issue. Right now you can see that I'm right next to the wall, and if I press A and D, then look at that, I'm moving with this speed. However, now if I press W and D, look at that, now I'm moving diagonally and it's actually moving slower. Basically, this is the same issue that we saw previously where we had to normalize the input so we didn't go faster in diagonals. Basically, now we have the opposite problem. Since we are normalizing the vector, we are cutting down on the left-right vector. And with that, basically, if we are moving diagonally, then we are essentially going slower, whereas if I stop moving diagonal and just move left-right, it moves at a different speed. Now, the solution for this is really super simple. Over here in our code, when we are constructing the move dir X and move dir Z, when we do this, very simple, let's just normalize it. So if this one is less than 1, then it will be going into 1. So let's normalize that one and that one. Okay, that's it, let's test. And now if I'm here, move forward and hug the wall left-right, yep, it does work. And if I stop moving diagonally and just go left-right, yep, all still works with the exact same speed. All right, awesome. Okay, so that's really it. As you can see, it's super simple to add collision detection to your movement scripts. You just do a physics query to test if our character should move and just move it. By the way, if you want to learn more about collisions and physics queries, there's a bunch of interesting videos that you can watch. For example, one is on various methods of finding a target. Then another one is on various methods of handling projectiles. And finally, another one is a very quick checklist on why collisions are not working. Basically, there's lots of really interesting things you can do with physics, so make sure you understand these functions. Okay, so now that we have all of this working, let's first just clean up our scene. So over here, our default cube, we don't want this, so let's just get rid of this. And with this, we are ready to build our first kitchen counter, and let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to begin building one of our main game mechanics. We're going to make a kitchen counter and handle the logic for the player to be able to interact with that counter. Okay, so let's begin by making our kitchen counter. And just like we did when we made the player, let's first make an empty game object and place the visual inside of it. So let's right click on the hierarchy, create an empty game object, call this the clear counter, so it's going to be clear on top so we can place and pick up objects. Let's make sure to reset our transform, so let's put it on 0, 0, 0. Let's move it just a little bit, just so it's not exactly on top of the player. Okay. Now inside, let's add the visual, so let's go inside the assets folder. And then over here, we've got the prefabs visuals, and inside we've got the counters visuals. And over here, let's find the clear counter visual. So let's go ahead and drag it inside the game object. Again, make sure the child visual is on 0, 0, 0, the local position. Okay, great. Now, just like we did in the last lecture, where we added collision detection, that should already be working by default, but in order for it to work, it needs a physics collider. However, note how the visual over here, there's no collider, and inside there's no collider, there's only visuals. Again, this is the same thing that relates to separating logic and visuals. Basically, the visual prefab, this one only has visual components, so only meshes, animations, and that sort of thing. And the main parent game object, this is the one that is going to have all of the logic components. So that means any kind of scripts behavior as well as any colliders. So over here on the parent game object, let's add a new component. Let's find a box collider. Again, make sure you add a box collider, not a box collider 2D. And I chose a box collider just because this is the shape that makes most sense for our counter. And now let's scale the box collider. Again, that's the box collider, not the transform, so leave that one with the scale of 1, 1, 1, that's good. And over here on the box collider for the size, let's put it up with a size that fits the visual, so 1.5, 1.5, 1.5. And finally, we just need to lift it up a bit. Over here on the scene view, you can see those little green tiny lines. These refer to the box collider shape. So let's lift it up by a little bit in order to make it perfect. Let's put it up by 0.5 on the Y. All right, so there you go. That one does have the perfect shape. If we test just like this, it should already be working. So okay, so here's my player, and if I move towards it, and yep, there you go, it does work. So it is a solid object, I cannot go through it. Okay, great. Let's just visually rotate the collider. So let's do that, and again, for rotation, let's make sure we rotate the parent game object and not the visual. We want the visual to be on rotation 0, 0, 0. Okay, great. So on the parent game object, let's just rotate it around. By the way, here's a quick Unity tip. If you want to rotate, hold down Control and then click to rotate. And now instead of rotating on every angle, it goes on a 15 angle increment. So just hold down, and this way you can easily get it to 180 degrees. So that's just for fun, just to make it face the player. Okay, great. So now let's interact with this counter. And doing this is actually super simple. We already learned how to do a raycast to handle collisions, and for interactions, that's exactly the same thing. So let's go into our player script, and we're going to do a raycast to handle that. But before we do, let's organize our code here. Let's make a proper function to handle our movement. So let's make it private, since this is going to be a local function. Return void and call it handle movement. And then inside, let's put all of this code. So let's copy all of this, put it in there, and then on update, we simply call this function. Okay, great. And now let's make another function. So private void, let's call it handle interactions. And we just call this function on our update. Okay, great. Everything is much more organized. So now here, let's do a raycast. So once again, go inside physics, do a raycast. For the origin, let's start on transform.position. For this, obviously, we want the move direction. So one approach would be to make this a field variable sorted up here, so that way we can access it in both functions. However, if you remember how we handled the whole issue with the diagonals, basically we're modifying the move direction. So if we're moving diagonally, then this one modifies to only move left or right. We don't want that for the interaction. We want pretty much the exact same one, even if it's pointing towards a solid object. So let's not make this a member variable and reuse it. Instead, let's just grab it again, create it again over here. So we get it, and we want this one even if it's pointing towards a solid object. So let's use this as our move direction. And now for the distance, let's define a fixed distance. So something like 2 units would work. And also here's another very important lesson with regards to writing good clean code. So you would think to write code like this. So let's put the 2 right in here. That would work, everything would work perfectly. But then let's say you get back to this code after 1 week. Would you remember what this 2f means? The answer is probably not. You would probably very easily forget exactly what this means. So because of that, you should never use numbers directly in the code like this. Instead, you can either make a field up here if you want to make it customizable, or much simpler is actually what we already did previously. So let's define a local variable with a proper name. So let's define a float, and this one is going to represent our interact distance. So let's call it exactly that, interact distance, and let's put 2f. And over here, instead of using a number, let's just use that variable. Now, if we were to get back to this code after a long time, it would be extremely clear what this parameter represents. The technical term for what we did here is called magic numbers, and I've also covered them in detail in another quick video. But as a rule, always remember very simply, never use magic numbers. Okay, so with this we have our raycast. It's pointing forwards for this distance. But this is actually not very useful, because the raycast, this one only returns a boolean. So all this tells us is if there's something in front or not. It does not actually get us the actual object reference. So for that, let's use a different version of the raycast function. So as you can see, we've got all kinds of versions. In order to get the object reference, let's use this version right here. This one, which has an out parameter for a raycast hit. Note the out keyword here, this is important. This means that this is an output parameter, whereas the other parameters, those are all essentially inputs that you give to the function, whereas this output, this is basically a value that the function outputs. So let's use this. So we've got the origin, we've got direction, then we've got the raycast hit. In order to use it, we need to make sure to write the out keyword here. And then also very important, we need to write the type. So let's call it raycast hit. And then the name, so let's call it raycast hit. Basically what we're doing here is essentially defining a variable of this type with this name. We're defining it and giving it to the function immediately so we can use it afterwards. If you don't include the type, if you just include the name, then you get an error because this name, raycast hit, this was never defined. Alternatively, you can define it before you pass it in. So over here, you can do a raycast hit, and just like this it works because you are defining it here and using it here. But in order to make the code a bit more compact, you can just define it here in the same place where you get it. Okay, so let's use this. And with this, the function still returns just a boolean, so just hit something or not. But then we've got the raycast hit output. This will be filmed with data from the collision if we do hit something. We can inspect this to see what data it contains, so you can right-click on top of the type, and then go to definition. And up here we do see the definition for the raycast hit struct. You can see this is a structure to get information back from a raycast. You can inspect this to see all of the kinds of things that this one returns. For example, you have a vector3 point for the impact point in world space where the ray actually hit a collider. You can get the normal of the surface and so on, so you can get all kinds of things. For our use case, what we want is to identify the object that we hit, and for that we can use the transform. So this is going to be the transform of the rigid body or the collider that was hit. So let's just do a quick test. If we hit something, let's do a log on that object. So let's do an if. So if this one is true, then that means we hit something. So if so, let's do a debug.log, go inside the raycast hit, and log the transform. Okay, so like this, we should be able to see on the console if we do hit something. Let's also do an else, just to be able to easily see when we hit something. So on else, let's just log an empty dash. And in our game, in order to make sure that our collision is working, that we are correctly detecting it, let's just duplicate this object. But before we do, let's make this a proper prefab. If you have an object of a certain type that you want to create multiple instances of it, you should be using a prefab rather than just duplicating an object. That way with the prefab, if you make any changes to that prefab, it applies to all of the copies of that prefab. So let's first make this one a prefab. And again, since this is our first prefab, let's first make a nice folder to keep things organized. So a folder for our prefabs. And to make a game object prefab is super simple. You just click and drag directly from the hierarchy and drop it inside the folder. There you go. There's our prefab. And now let's just duplicate this. Make sure it has a different name. So it has a 1, so that's enough. With this, we should be able to see it just for testing. Let's put it just off to the side. Okay, so let's see. So here we are, and on the console we see a dash. So by default, we are not hitting anything. Okay, so that makes sense. Now if I move towards this object, and if there you go, it does identify that object. And if I stop moving, it stops identifying. Okay, great. Now if I move towards this one, and if there you go, this is the one with the name of 1, and this is the one with the name of none. All right, awesome. So just like this, we are correctly identifying what object is in front. Except we also have an issue. So if I move towards the object, then yep, it does work. But if I stop moving whilst I'm still facing that object, right now it's returning none. Now the reason for that is because of the move dir that we're using here. If we're not moving in any direction, then basically this vector will be 0, 0, 0. So we're going to be firing a raycast towards no direction at all, so obviously it's not going to hit anything. The solution to that is super simple. We just need to keep track of the last interact move direction. So let's go up here, define a field for that. So let's make a private. Let's make a vector3 and call it the last interact direction. And then down here when we have our handle interaction, so we get the movement here. Okay, that's great. So then we just check if the move direction is different from vector3.0. By the way, this is a constant, a shorthand for 0, 0, 0. So if it is not 0, then that means we are moving in some direction. So if so, let's set the last interact direction to this move direction. And basically if it is not, if move here is 0, then we are not going to modify this. So this one is only going to contain the last interact direction. And then down here, instead of using the move direction, let's just use this one. So that way, even when we stop moving, we are still going to be using the last interact direction. Okay, so with this, let's test. So here we are, and if I move towards it, yep, it works. And if I stop moving, and yep, it still works. All right, great. So we can move towards it, point towards a certain object, and then, yep, it still works. Okay, great. Now let's actually interact with this counter. And to do that, let's make a class for the counters themselves. So let's make a new script, a new C# script. Let's call it the same name, so clear counter. Okay, there's our script. Now, very importantly, for attaching the script, remember that we have two instances of our prefab. If you just select it in the hierarchy and you just drag it on there, if you do that, then you're not actually adding this script to the prefab itself, you're only adding it to this specific instance of that prefab. So if you look at this one, yep, it has a script, but this other one, which is a copy of the same prefab, this one does not have it. Also over here on the inspector, you can see the little script icon has a nice little plus. That means it is something that you are adding on top of the prefab. So that means this script is not present on the base prefab. Basically, this is not what we want. We don't want just this object to have this script. We want all instances of this prefab to have this script. So instead, let's get rid of this one from here. We want to modify the prefab itself. So one way to do that is to select the prefab on the project window. So here it is, the actual prefab. And now we can drag the script on there. So that works. Or another alternative is select the prefab in the hierarchy. And on the inspector over here, we see a nice button to open the prefab. And if we actually go into scene view, then we can see what that does. So with the object selected, so this is an instance of that prefab. But if we click on open, then essentially we are opening and we are working inside the prefab. So now if we make sure to add our script, and let's go back outside this prefab. So on the top left corner over here, we can see where we are. So we were inside our scene and then we are inside the clear counter prefab. So if we click on the scenes, we can go back. Now it tells us that we made some changes to the prefab, so let's save them. And yep, we added that script and we can see both instances of the prefab, they both have the same script. And we can see on there on the icon that this is not an override. This is an actual script added on the base prefab. So whenever working with prefabs, always make very sure that you are adding it on the right place. If you want something on the base prefab, make sure you either add it on the prefab itself, or go inside the prefab by double clicking on it, or select an instance in there and open to go inside the prefab. So always keep in mind differences between a prefab and an instance of a prefab. Okay, so we have our script, let's open it. And over here, let's just make one super simple function. So let's make it public because we want to call this from our player class. Let's return void and just call it interact. Okay, that's it, super simple. For now, let's just do a debug.log and just say interact. Okay, so that's it. And now over here on the player, when we have our handle interactions function, so we interact, we do our raycast and we find out if we hit something. So when we do, the first thing that we should do is identify what this transform is. So is this something just like a dumb cube, or is it an actual counter? Now when it comes to identifying things, this is another place where a lot of beginner tutorials would teach you to use the Unity tag system. So that's over here in the editor when you select any object. Over here in the inspector you can see a tag, so you can see untagged and you can add all kinds of tags. This is something that a lot of beginner tutorials teach, but Unity tags are horrible. You should never use them. I covered in more detail why that is in the advanced concepts video. The main reason is because of, well, pretty much the same thing that I mentioned a while ago when we were handling animator parameters. So we were doing this and I talked about how this one takes a string and how strings are a horrible way for identifying objects. They are very brittle, very error prone, it's very easy to make mistakes. And tags have the exact same problems because tags are strings. So we do not want to use tags to identify objects. Instead, over here on the player script, let's use a different method for identifying objects. And the best way to do that is to simply get our counter component. So we have our transform, and then from inside that transform, we can call the function try_get_component. This one then takes the type of component. And again, note how this is an out parameter. So let's put out, and we want to test if this is of type clear counter. So clear counter, and call it clear counter. And this one basically does the same thing as a raycast. So it returns a boolean, so either true or false. So if this one is true, then that means that object has that component. So over here we know has clear counter. By the way, if you're not familiar with try_get_component, this is pretty much the same thing as the regular get component, except it automatically handles the null check for you. So if we just do this, it's exactly the same thing as this. So you do an if raycast it, let's access the transform, get component. Component of type clear counter. And actually this one is not inside an if, but let's store this. Clear counter equals this. Then you do if this one is not null, then we know has a clear counter. So basically what we have up here is the exact same thing that we have down here. So just using try get component, it's just a bit more compact and I find much easier to read than to always get the component and test if it is not null. Over here we just have one function with a nice out parameter and everything works perfectly. So that's the try get component. I much prefer that method, so let's use that. By the way, on the try get component, over here you can see it has a type inside some angled brackets. Basically these are called C# generics. These are an extremely powerful C# tool. I have a dedicated video on them and I've used them in tons of videos. Definitely go ahead and learn about them. Basically this lets you write code that works with many classes, not just one specific type. In this case, the try get component can work with any type of component. So it can be Unity built-in components or it can be components that you made yourself. Then if it finds a type, it returns true. So for right now, it's not strictly necessary to know the specifics about how C# generics work, but definitely make sure you add that video to your queue and watch it afterwards. C# generics are an extremely useful C# feature. Okay, so we do this, and basically if we are inside of here, then we know this object has a clear counter, and we have our clear counter reference. So over here, it's super simple. Let's just call the interact function. Alright, so that's really it. Let's just get rid of the else. We no longer want that log, so we should be able to see a log whenever we call our interact in a counter. Alright, so here we are, and if I move around, okay, that's good. Over here the console is empty, alright. Now if I move towards the counter, yep, there you go, I'm interacting with it. And if I move towards this one, yep, there you go, interacting. Alright, great, so with this we are correctly identifying the object and interacting with it. Now let's just do one final thing. Over here we are doing a raycast to find the counter. And right now we are doing a raycast towards any object that has any kind of physics collider. So maybe that's our counter, or maybe it's just a random wall. For example, if we had an invisible wall in front of our counter, then this code would not work. That's because this raycast and this raycast hit, it only returns the very first object that it does hit. So if the counter was behind a wall, then the raycast hit object here would be a reference to that wall object. Perhaps that's what you want, or perhaps not. In that scenario, one thing you can do is instead of using raycast, you can use the function raycastAll. And difference for this one is instead of returning just a boolean, just true or false, instead it returns an array of all of the objects that it hit with that raycast. Then you could cycle through them and identify the object. So that's one approach. Or another option is over here on the raycast. If we look at these function versions, we can see that some of them has what it's called a layer mask. Basically, you can set a certain game object to a specific layer, and then if you use a layer mask, then you can make sure this raycast will only hit objects within that layer. Anything not on that layer will be ignored for that raycast. This is super useful, so let's learn how it works. For a layer mask, we can go up here and define a type of layer mask. So let's make another serialized field, private, let's make it of type layer mask. Let's call it the counters layer mask. Okay, so we have this, and then down here when we have our raycast, let's use it. So let's find the function that matches up these parameters with the layer mask. So here it is, we have the origin, then we have the direction, the raycast hit, the max distance, and then finally we have our layer mask. So let's use our counters layer mask. Okay, great. Now back in the editor, let's select our player game object, and yep, there we see our field of type layer mask. And you can see how we can select all kinds of layers, and how we set these layers to an object is, let's just select our clear counter. Although again, we want to make sure that this change applies to all counters, not just this one specific instance. So let's go inside the prefab. And over here, we've got a field for our layer. And you can see we've got a bunch of default layers. And then we can add some more. So let's add some layers. And over here, let's go to the first empty one. And let's call it counters. Okay, we've added the layer. So let's go back, select our object. And now on the layer, let's put it on the counters. Now it asks you if you want to modify the layer for all child objects. Now, since we made sure to keep the logic and physics components only on the parent object, let's just modify this one and leave the other ones on the default. So let's just modify this object only. Okay, so with that, our counter is now on the counters layer. Let's leave the prefab, make sure to save it. Okay, great. And now if we go back into the player and over here on the counters layer mask, yep, we do see the counters layer. So let's just click the selected. By the way, this drop-down menu, you can actually select multiple. So you can select all kinds of layers, so this is multi-select, but we only want the counter, so only like this. And just like this, if we do test, and now if I move towards it, and if there you go, got the nice interact on both of them. So everything still works exactly the same, but now if we had another physics collider in front of it, it would still work because we're using a layer mask to only raycast against counter objects. Alright, great. Now I should point out another way to work with layers is with something called a bit mask. That's a bit more advanced. Usually the layer mask is much easier to follow, but if you want to learn about bitmask, go ahead and watch that video. And also another quick note, in this game we're only going to interact with one single object type. It's only going to be a counter, even though we're going to have multiple types of counters. But for games where you want to interact with multiple objects, like for example having an interact action to talk with an NPC, another one to open a door or push a button, for those kinds of multiple interactions, to build a system like that, make sure you look into my How to Interact with Objects video. It covers how to do all of that, how to interact with all kinds of objects. It's all based on C# interface, which we're actually going to use in a few lectures, and also have a dedicated video on that topic. So keep following this course, but then make sure to watch those videos, add them to your watch list, and make sure you do watch them. Watch that How to Interact video. It is something that is necessary in so many games, and most tutorials don't actually teach you the correct way of doing it. Anyway, so back in our game, we are correctly identifying and interacting with each counter. But obviously we don't want to interact automatically just like this. Instead, we want to press a nice button to interact, so that means we're going to need to create an interact input action. So let's do all of that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to create a proper interact input action, and in doing so we're also going to learn about a very powerful C# feature called events. Okay, so here we have our game, so we have the player, and if we move towards the counter, yep, we are correctly identifying it and interacting with it. Except of course we don't want the interaction to happen automatically, it should be on a player input. So let's make our interact action. Let's go inside our player input action, so let's double click on it. And let's make a brand new action. So we've got the move, and now we're going to have another one, so let's click on the plus icon. For this one, let's call it interact. And for this one, action type, we do want it to be a button. Okay, great. Then on the default binding, let's go into path, let's listen, and by default, let's bind it to the E key, just like so many games. So let's go ahead, select this one, and once again, let's make sure to save the asset and let the C# class be generated. Okay. Now over here in our game input script, in order to listen, that is very simple. So we go inside the player input actions, then inside the player action map, and then we can find the interact action. And then over here, we can see a whole bunch of events that we can interact with. We've got these three: cancel, performed, and started. These are the three phases of every input. Again, I cover these stages in detail in the input system video. The important thing is that these are C# events, which I also covered in another dedicated video. Essentially, they are a way for how you can write code to then get notified when something happens, rather than running code on every single update constantly testing something. For example, over here on the movement, movement is a pretty constant action, so it does make sense to ask the input on every single update if any movement is pressed. But for an action like the interact, the player is only going to press that, say, once every 5 seconds, so it makes no sense to constantly check for that action on every single update. Instead, we just want to be notified when that action is triggered, and that is exactly what an event does. Again, watch the dedicated video to learn all about C# events in detail. They are insanely powerful, and we will be using them more and more as we go through this course. For now, here are the absolute basics. Events have publishers and subscribers. The publisher creates and fires the event when something happens, and the subscriber listens to that event and gets the listening function called when the event is fired. Now on the generated C# class, we've got these three events. The one that we want for this case is the performed event. So let's go into this one, and basically we want to add a listener to that event, and we can subscribe to that by doing plus equals, so this assigns a listener to that event. And now Visual Studio has a nice shortcut, so if we press on tab, yep, there you go, it automatically creates the function. Now if you're not using Visual Studio, you can just manually write this function. The only thing you need to make sure is that the function signature perfectly matches the event signature. As usual, we can inspect the event, so we can right click on it and go to definition. And yep, here is the definition. And you can see that this is an event of type action with a callback context. Action is what is called a delegate. I also have a video on delegates if you want to learn more about them in detail. For now, we don't really need to worry about what is a delegate, we just need to use it. So in order to subscribe to the event, we need to make sure that this one returns void, because an action returns void, and needs to have a parameter of this type, callback context. If I erase this parameter, yep, there you go, now we have an error because the function signature does not match. So it always needs to match the exact same signature, okay? And also one more note over here, when subscribing to the event, make sure you only add the function name, meaning you do not add parentheses. We do not want to call the function, we just want to pass in the function itself as a reference. Okay, so now when the player presses the interact action, it's going to fire off this event, which in turn will call this function. So over here, let's do a debug.log just to see what this contains. For example, let's print out the callback context. Okay, so let's see. So here we are, and if I press on E, yep, there you go, I've got a nice event. Okay, great, so with this we know when the player presses a key. Now the next step is how do we get the player class, how do we get this one to know when this is performed? And the answer is we're going to do the exact same thing. We're going to make an event over here on the game input class, and the player will listen to that, which in turn the game input grabs from the input system. Again, the whole point is separating our concerns. So the player does not care about the input system, does not care about the interact action, it only wants to know when something related to interact happens. So over here, let's make that nice event. First of all, let's make it public because we want the player to access it. Then we need to add the event keyword. Next, we add the delegate type. Like I said, you can learn more about delegates in my dedicated video. You can create your own custom delegate for your event, or you can just follow the C# standard and just use the standard event handler. And this one exists inside system. So let's make sure to go up here and add using system. And this one has the event handler class. This one is pretty much the C# standard for events. As you can see, it returns void, it has an object for the sender, and an event args parameter. Like I mentioned in the events video, you are not forced to use this delegate. You can use whatever delegate you want. Like for example, you saw that the performed used an action delegate. So you can use anything you want, it's just that the event handler is the C# standard, so it's easier to follow. Unless you have a specific reason to deviate from the standard, you should probably use this one. So let's use this, and then finally for the name, usually you start the name with on and then whatever happened. So in our case, let's go with on interact action. Okay, so we have defined our event, and now for firing it, let's go down here into when we have the interact performed, and let's go into the event, and for firing it, it's pretty much exactly the same thing as calling a regular function, so we just call it with parentheses. Then usually for the object sender, this is a reference to whoever is sending this event, so usually the this keyword. And then for the event args, this is in case you want to send some arguments with the event. In our case, we don't really need to send any extra data for this one, just firing the event is going to be enough. So for that, we can use the constant event args.empty. Okay, so that's it. With this, we are firing an event. Except just like this, we're actually going to have one potential error. If we have no subscribers, no listeners to this event, then essentially this field will be null, so this one over here is going to trigger a null reference exception. Let's do a quick test just to see this happening. So here, if I press on E, yep, there you go, we have a null reference exception. So when working with events, you need to first test if there are any listeners, and only then do you actually trigger the event. So you do if this one is not null. If it is not null, that means there are some subscribers, so we can fire the event. So like this, it will work, but there's an even more compact way to do this, which is perfect for events. So instead of this, we've got our onInteract action, then we can add a question mark. This is called the null conditional operator. Basically, the code is going to execute from left to right. And then when it gets to this question mark, it's going to evaluate the left side. And if it is null, then the execution will stop right here on the question mark and will not throw any errors. Whereas if this one is not null, then it continues executing to the right. Except with this syntax, we have an error. We cannot put parentheses directly after the question mark, but what we can do is simply just call invoke, and that does the exact same thing, that calls a function. So what we have here is exactly the same thing that we had previously. So what we have over here and over here, these are the exact same thing. It's just this one is much more compact, and especially for events, this one is super useful. Okay, so with this, we are correctly firing for our event. Now let's actually listen to it. So let's go over here into the player class, and let's listen to our event. Let's do it on a private void start, make it on start and not on awake. This is a very important rule, which I'm actually going to cover in detail in the next lecture. But for now, just make sure to listen on start and not on awake. So over here, we access the game input. Then let's access the onInteract action event. And as usual, let's listen to it. So let's use press tab to listen to it. So it is exactly over here that we want to run our interact code. So let's go down into the handle interaction code that we had previously, so this one. So let's copy paste all of this code, put it up here. So we get the interaction, go into the object and trigger the interact. Now obviously code duplication is a big no-no. So we're only duplicating our code just for a quick test, just to make sure it works. Once again, refactoring is super useful, so we're going to refactor this code to get rid of code duplication in the next lecture. But for now, we just want to test to make sure that this does work. So let's just remove the interact over here from the handle interactions. So the only interact function being called is over here when we have our actual input. So let's test and see if we can press to interact with the counter. Alright, so here we are, and as I move around, if I approach the counter, yep, there you go, we no longer have the automated interaction. And now if I'm facing the counter and I press the interact key, yep, there you go, here we have our nice interaction. Alright, awesome, so I can approach, I can interact and do whatever I want. Alright, so here we learned about C# events. These are super powerful, so if this is the first time you're hearing about them, then you've just added an awesome new tool to your toolbox. Definitely make sure you watch my dedicated video to learn about them in more detail. Events are super useful. The next thing we're going to need is just a visual to highlight the current selected counter, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to add a visual to our selected counter, and in doing so we're also going to learn about the very useful singleton pattern. Okay, so over here we already have the logic to identify the counter in front of the player, and we can interact with it. However, whilst the logic works, there is no visual indicator at all, so let's add that. Now, as usual, the super quick and dirty way of doing it would be pretty simple. Over here on the player script, we could just directly enable a visual mesh on the target counter. So down here on the handle interaction, when we have this, over here we could tell the clear counter to enable some kind of visual. Technically that would work, but that would be some pretty dirty code. We would basically be making the player responsible for enabling some kind of visual, which would mean that we were mixing logic with visuals. Again, we always want to try separating the logic from the visuals as much as possible to keep our code nice and organized, so instead of doing the quick and dirty route, let's do it properly. Back in the editor, let's create a brand new C# script. Call this the selected counter visual. And now let's go into the prefab. Again, let's go inside it, so let's select the clear counter on the hierarchy, then on the inspector, let's open up, go inside the prefab. And now let's select the visual inside it, and let's duplicate this, so you can press Ctrl D to duplicate it. Let's name this one selected, and then inside there's a visual with a mesh filter and a mesh render. So over here, let's swap out the material. So let's click on the circle icon, and now included in the assets is this material, counter selected. So it's all the way, yep, up here, the counter selected. Basically, it's just a solid white color with a low alpha. So on the kitchen counter inside the select game object, let's make sure to use this one. With this, we have kind of like a ghost visual. So if we enable and disable this game object, we can see the difference. Also, let's do one tiny thing, which is right now we duplicated the actual visual, meaning that these objects are exactly the same, they have the exact same size, and when that happens, you might end up with some rendering bugs. If two meshes are on the exact same position, you might sometimes see the colors constantly flip back and forth. So in order to make sure that doesn't happen, let's make this one deselected a tiny bit bigger. So over here with the selected game object selected, on the inspector over here we've got the scale, and also we've got this nice little button here. If it's like this, then we can modify each proportion differently from one another. Whereas if we click, now these are all linked. So now modifying one will modify all of them, so let's put this on 1.01. Meaning this one is going to be literally just 1% bigger. So that's enough of a difference to make sure we don't have any rendering bugs. And by default, let's also start with the visual hidden. So let's do that not on the parent select game object, but rather on the kitchen counter inside of it. Let's make sure to disable this game object. By the way, the quick shortcut is Shift, Alt, and A. You can enable or disable the object, very useful. So let's start with this one disabled so that it's hidden. And basically the goal is that when this counter is selected, we're going to enable it and show this visual, and when it's not selected, we're going to disable it. Okay, so over here on the selected, let's add the script that we made, so the selected counter visual. Alright, so let's open it. Now here, first thing we need to know is which counter is selected. Meaning we need to know which counter the player is currently looking at. So let's go over here onto the player script, and let's basically just do some simple logic to keep track of the selected counter. So over here, let's make a field, so a private. Let's make it of type clear counter, and just call it the selected counter. Then down here we have our handle interactions logic. Okay, so we do all of this. We try to find a counter in front, and if we do find it, then we have it here. So here, let's just check if it's different. So if this clear counter, if the one in front is different from the current selected, then let's set the selected to this one. And let's also make sure to essentially unselect. So we want to make sure to set this one to null when there's nothing in front of the player. So if the raycast does not hit anything, then there's nothing in front of the player. So let's set the selected counter back into null. And also, if there is something, but that something does not have the clear counter script, then it's also not a counter. So over here, let's also do an else selected counter equals null. So basically, if there's a counter in front of the player, then it's going to set it. If not, then it's going to be null. Let's just do a simple debug.log to check on the selected counter, okay? And also, just briefly, now that we've made this selected counter logic, actually up here when we have our interact action, like we saw we were previously copying some duplicated code, but now we no longer need this since we already know the selected counter. So over here when we've got the interact action, let's just check if we do have a selected counter. So if it is not null, if so, then we go there and we call the interact function. So that's it, we no longer need all of this logic. Okay, that's great, so let's test. Back in the editor, let's go back into scenes, let's make sure to save the prefab. Make sure the script was attached, save it, and let's hit on play. And right now, if I'm down here, yep, there you go, we've got null. And as I approach, yep, there you go, that one is the clear counter. And if I move towards this one, yep, it's that one. Okay, so basically we are keeping track of the currently selected counter. Now basically we just need to notify the visual whenever this one changes. So when this one is pointing at that one, or pointing at null, or pointing at that one, we need to know when that happens. And for that, we basically have two options. Now, one option is pretty much what I mentioned a while ago, which is over here we have the selected counter, so we can run some kind of logic on the selected counter. We can do that over here on the player. Then perhaps over here the counter would fire off some kind of event saying it has been selected, and then the counter visual would listen to that event and update itself. Now, that approach would be useful if we wanted to add some kind of logic on the clear counter while selected, and that approach would also have the benefit where the visual counter would only listen to events on its own counter. So that's one approach, pretty much a very direct approach. But another one is very simple. The player would simply fire off an event whenever the selected counter changes, and then all of the counter visuals would listen to that event, then they would identify if the event relates to that counter, and if so, update their state. Now the benefit of this approach is that the logic doesn't get bothered with any selection logic. So over here the clear counter script never really knows if it's selected or not, and that's a good thing because it doesn't need to know. Although the potential con with that approach is that all of the selected counter visuals are all going to listen to the same event. So both approaches have pros and cons. Here let's go with the second approach where all the counters listen to a player event. The potential performance con doesn't really matter on a game of this scale. We're only going to have about a dozen counters, so even if 11 of them are just wasting on listening to the event, it's really not going to matter. And going with this approach will actually help us learn about the singleton pattern, which is extremely useful. So first let's go over here onto the player class and let's make the event that we're going to fire. So as usual, let's make it public so we can access it. Let's make it an event. And as usual, let's also use the standard event handler. Let's make sure to add using system. So here Visual Studio adds it automatically. Okay. And let's call this on selected counter changed. Also, this is a great moment to learn about the event args. This is how you can extend a C# event in order to pass in some more data. So how you do it by following the C# standard is very simple. We just create a class. So over here, let's make a public class. Then for the name, usually you include the name of the event with event args at the end. So in this case, on selected counter changed and then event args. Then on this class, we make it extend event args. And finally, inside the class, we add whatever data we want. Like for example, we want the current selected counter, so let's make a public clear counter and put the selected counter. Okay, so we have this nice event args with a bunch of extra data, and then over here on the event handler, we use the version that takes a generic and we pass in our event args. Again, I covered the generics in more detail in a separate video. Definitely go watch that one if you haven't seen it yet. C# generics are one of C#'s most powerful features. Okay, great, so we now have our nice event. Now let's fire it off. So let's go down here to when we're modifying the selected counter. So here it is, we've got all of these ones. So when we modify, let's fire off the event. So we go into this event, and as usual, let's use the question mark and then call invoke. Then for the object sender, it's going to be this, so pretty much the standard. And then for our custom event args, let's construct an object of that type. So construct a new object. And then inside we pass in the selected counter and we set it to this selected counter. Now, don't be confused by the fact that we're using the exact same name. If you actually mouse over the cursor, Visual Studio actually helps you by telling you which object refers to this. So with the cursor here, note how all of these are highlighted, but this one is not highlighted. That's because this is the field inside the onSelected counter changed event args, whereas this one out here is the object that we're referencing in here. So even though these two have the exact same name, here we're accessing the field inside of that, and we're assigning it to the reference that we have down here. Okay, so that's really it. We're firing off the event when the selected changes, and we're passing it in. And let's also make sure to do it over here, so let's copy and paste some code, and there you go, just like this. Except, of course, we can already see a bunch of code duplication. Usually that means it's time to refactor, so let's do that pretty quickly. Let's go down and make a brand new function. So let's make a private void. Let's call it setSelectedCounter. And we're going to receive a clear counter for the selected counter. Then over here we just set this.selectedCounter, so we're modifying the member variable with the one that we receive on the parameter. And then let's also fire off the event. So let's copy paste the event, just like this, the exact same thing. Okay, so that's it. And now up there, instead of code duplication, we just do this. So over here we set the clear counter, just call the function, pass in that one, and get rid of this. And on that one, just pass in null, just like this, get rid of all of this. And here the same thing, just pass in null. Alright, so with this our code is much cleaner and everything still works exactly the same. So here we have everything done on the player side. Let's just get rid of our log, we no longer need this. So we're still handling the selected counter logic, and then down here we're firing off the event. Now all we need to do is go over here into the selected counter visual script. And here what we want to do is to listen to that event. In order to do that, we need a reference to the player object. Now, so far when we've been listening to events, like for example on the player class, up here we were listening to some events on the game input, so there you go, the onInteract action. So for the game input reference, we just added it as a serialized field. We did this and then we dragged the reference directly. And technically we could do the same thing over here on the selected counter visual, but we're going to have like a dozen counters in our map, so it would be pretty tedious to drag and drop the player reference to every single one of them. So instead of using a serialized field, another approach is to use the singleton pattern. This one is an extremely useful programming pattern. It's very useful for things where you only have one instance of something. In this case, we're making this game single player, so we're only ever going to have a single player. By the way, here's one obvious quick note. Like I mentioned in the beginning of this course, after this video, there's going to be another one converting this game into multiplayer, and in that case, we will have multiple player instances. But this is also an excellent reminder of how refactoring code is perfectly fine. For right now, for this game, it is intended as single player, so for now we're going to use the singleton pattern. Then in the future, when we convert this to multiplayer, we will simply refactor that logic. Again, don't be afraid of refactoring code. It's a perfectly natural part of programming and game development. Okay, so let's implement the singleton pattern. This is actually super simple. The name sounds intimidating, but it really is very simple. Over here on the player script, let's make a public field. This one, let's make it static. If you don't know static, basically it means that this field belongs to the player class itself and not to any instance of a player. So for example, if you had 100 players, you would have 100 instances of move speed, you would have one for each player, but there would only be a single static field because this static field belongs to the class itself and not to any instance. So let's make a field of type player, and then for the name, the convention is to call it instance. And the reason why I'm using Pascal case here, so capitalized in the beginning, the reason for that is because this is actually not going to be a field, but instead it's going to be a property. Remember the naming rules that we covered in the beginning of this course. It's very important you follow your naming rules. Always be consistent so your code is easier to understand. So with that said, since this is the first time we're using a property, let me quickly explain what it is. Basically, it's the exact same thing as a regular variable, except you can add some logic when getting and setting that field. So here let me write some quick code just to show the difference between a property and a regular field. So for a regular field, you would call this maybe instance field, something like this. So this is a regular field. Then you would have some kind of public static return a player and call it get instance field. Then over here you would return the instance field. And then maybe another public static void set instance field, where you receive a player for the instance field. And you would set the player.instance field into this instance field. So this is how you do this logic with fields. And now with properties, you would do public static player, then call it instance. Then on the property itself, you open up the curly brackets. Inside the property, you put a get, then you return something. So for that something, usually a property has a field underneath it. So you'd have a private static player for the instance. That's a different name from this one. On the get, you would return that. And on the set, you would set the instance equals the value. If you're confused here, don't worry. Basically, I'm just repeating just so you can see the difference. Here we have a field with a get and a set function, so regular functions. And up here we have a property, and inside the property itself has a get and set functions, which can also do some logic, so you can do some logic in between, or you can just return the underlying value. So basically using a property is pretty much the exact same thing as using a separate get and set function. Also, one more bonus thing, which is that C# is smart enough to automatically create the underlying field for a certain property. So if you just want to do a get and a set, then you don't need to define all this. You can just define a property, and then inside you can just do get and set. And there you go, this code here works the exact same thing as we had previously, which in turn is the exact same thing as all the code we have here with a getter and a setter function. So here it is, a valid functional C# property. Now I have to say that personally I very rarely use properties. In fact, the only place where I use them is over here on the singleton pattern. For everything else, I normally use regular fields with get and set functions. Personally, that's just the way that I like to code, but that's really just personal preference. So if you do like to use properties, then go ahead and use them. Anyway, so the reason why I like using a property specifically for the singleton pattern is because the implicit implementation allows you to do something really nice. Again, remember the goal with clean code. We want to minimize complexity, and the best way to do that is minimize access. Here, if we set this property and we set it as public, then that means that any other class can both get and set, so anyone else can have both read and write access. So we have the exact same problems that I warned you about when I spoke about why you should not make everything public. And of course, if we make this private, then at that point we kind of lose the purpose of our singleton, since no one else will be able to access this. Basically, we want to be able to access this reference from classes outside of this one, we just don't want those classes to also have write access. Now thankfully, properties have an excellent thing, which is you can define accessors for here both the get and the set. So we can make the property itself public, which means by default both of these will be public, but then we can also add the accessor over here private, which in turn means that the get will be public, so any other class can get this, but private means that only this class can set it. This way we have the exact level of accessibility that we want. This is the reason why for this specific use case properties are very useful. With just this one line of code, we already have our instance with the perfect level of accessibility. So now that we have this field, to set it, let's make a simple awake. So let's go over here, private void awake, and on awake we just set instance equals this. However, remember that a key point of the singleton pattern is you only have a single instance of something. So in this case we should never have more than one player. If we do, then something went wrong. So we can add a nice safety feature here. Let's just check if instance, if it is not null, meaning it has already been set to something. If so, then that's an error, something bad happened. So let's do a debug.log error, because this should never happen. So let's say there is more than one player instance. This way we have a nice safety check just in case something goes wrong. Alright, so that's really it for the singleton pattern. We just define a property with a public get and a private set, and on awake we just set the instance. That's it. As you can see, it's super simple. And now for the really useful part. Over here on the selected counter visual, now we can access the singleton instance in a super easy way. Let's make a private void start, and on start we just access the player class, and from the class we can access the static instance, so we can access the singleton, and now we can listen to the onSelected counter event. And over here by default, Visual Studio gives this function the name of the event and also the property. This isn't a very descriptive name, so I like to rename this, so Ctrl-RR, and just rename the instance here. Instead of instance, let's rename it to player. Okay, great. So over here we can listen to this event. However, here is yet another extremely important thing. Note how I made this on start. That is very important. If you do this over here on awake instead of start, and over here on the player, you're also setting the instance on awake. If you do that, basically there is a chance that this code will run before this code. And if that happens, well then this one, the player instance, has not been set yet, so this will be null and it will throw a null reference exception. Now whether this happens or not is actually somewhat random. It depends on the order in which Unity decides to run both these scripts. If Unity decides to run the player first and this one second, if that happens then there's no problem, but if Unity decides to run this first and then this one, then we have a problem. Let me do a quick test and see if in my case it triggers that error. And yep, in my case it did trigger that error, so here we have a null reference exception, and yep, it is being fired on this line. Now, one solution to this problem is you can tell Unity specifically which order the script should run in. So you can go up here into Edit, then go into the project settings. Then on the left side, you've got something called the script execution order. And basically over here you can set the order in which all of these scripts run. So if you were to make the player script run before the default time, that would make sure that even though both these scripts are on awake, this one would run before this one. So that would fix that problem. However, you should really only use this approach in the last case possible where there really is no other way. In this case, we do have another better way. Personally, I have a very simple rule that I like to follow that helps solve this issue. As you know, Unity has both an awake and a start. And all of the awakes on all the objects will all run before all of these starts. So the simple rule that I follow is that I use awake for the initialization of that script, and for any external reference, for that I use it on start. So in this case, for initializing the player and setting the instance, that relates to the initialization of the player, so let's do it on awake. Whereas over here on the visual, since here we're going to access the player, which is an external reference, for this one, instead of doing it on awake, let's do it on start. This way we are guaranteed to make sure that this instance has been set. Okay, so with all of that, here we have our instance, so that works great, and we have our event, so that's great. Then here we have our event, and inside we've got our event args, so we can go inside the event args object, and inside we have our selected counter. So all we need to do is just compare which counter this visual belongs to. So let's actually make a field up here. So as usual, let's make a serialized field of type clear counter. So we have this one, and before we go into the editor, just make sure it compiles, let's comment this out. So now let's go back into the editor. And over here, let's drag the reference. But again, remember, we're working with a prefab, so let's click on open to go inside the prefab. And now whilst inside it, let's select the selected game object and just drag the clear counter reference. Okay, great. Let's go back outside and save the changes. All right. So now here in the code, it's actually very simple. So we just do an if the selected counter matches this clear counter. If so, then we want to show this visual. If not, we want to hide it. So let's also add a reference for that visual. So let's add another serialized field of type game object for the visual game object. Then back in the editor, again, let's go inside the prefab, and on the select, let's drag the child kitchen counter. So drag that one, that is the visual game object. Okay, let's go back, save. And back in the code here, let's make some simple show and hide functions. So private void show and a private void hide. And now on the show, just going to visual game object and call set active. So this enables or disables the game object. So for show, let's set it to true. And for hiding, let's set it back into false. Okay, so now it's super simple. If the selected counter is this counter, then let's show the visual. If it is not, then let's hide the visual. All right, that's it, super simple. Let's test. So here we are, and if I approach that counter, yep, there you go, look at that, the nice selected visual. And if I go into this one, yep, there you go, I can see it. All right, great. So here we added a really nice visual to our selected counter, and more importantly, we learned about the super useful singleton pattern, as well as learning about C# properties, and a very helpful rule for how to avoid code timing issues. So this was a really detailed, really important lecture. If you're feeling confused about anything, go ahead, watch it again, or just post a question in the comments and I'll do my best to help. So with all of this is all great. We have the selected counter and we can see which one is actually being selected. Then by pressing a button, we can actually interact with it. So I can move and interact with any of these counters. But right now, just interacting with them doesn't really do anything. So the next thing we need is to create some proper objects for all of our ingredients, so we can later pick them up and drop them on counters. So let's begin doing that in the next lecture. Hey again, quick intermission. You're past the 15 lecture mark, so congratulations. Looking at my regular core stats, it seems about 80% of people give up by this point, so great job with sticking with it. The difficulty and complexity is increasing over the lectures, so I just want to check in to make sure you're understanding everything. Remember to post in the comments if you need extra clarification on anything, and I'll do my best to answer. Also check the website to see what questions others have asked. And of course, remember this is your learning journey. You're not competing with anyone but yourself. So take your time, rewatch some lectures if you need to, just focus on learning. Okay, let's go to the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to create the kitchen objects like the various ingredients. Okay, so far we have our player, we can walk around, I can approach each of these counters, and I can interact with it. Now the next goal is to create objects the player can pick up and drop when interacting with a clear counter. So let's begin by making the actual objects. So let's create a new empty game object, call this one the tomato. Then again, as usual, let's separate the visual. So in the included assets, let's go inside of it. Then we've got the prefab visuals, and we've got the kitchen objects visuals. And inside we've got all of the ingredients. So let's just find the tomato visual and drag it as a child of the tomato. And again, as usual, make sure to put on position, local position 0, 0, 0. And for the main one, let's put it on a Y of 0 and just push it a little bit off to the side just so we can see. Okay, great. Now, this one is obviously not going to exist over here in our world. Instead, we're going to spawn it. So let's make it a prefab. Let's just drag it over here into our prefabs. Okay, there it is. Let's delete it from our scene. And actually on our prefabs, let's make a nice folder to keep things nicely separated. So inside the prefabs, let's make a subfolder. Call it the kitchen objects. Let's put the tomato inside of it. And let's also make another folder for the counters. And let's put the clear counter inside of it. Okay, so everything is nicely organized. All right. Now that we have this, let's go inside our clear counter script. And over here, let's add a simple reference to our prefab. So let's make of type transform, call it the tomato prefab. By the way, here you could make this prefab reference of type game object. Which type you use in this scenario is pretty interchangeable. I talked about those differences in another video. So when using prefabs, using them as transforms or game objects, that's pretty much personal preference. And personally, I just prefer to use them as transforms. Okay, so we have this. Let's just make this a serialized field so we can set it in the editor. And over here in the editor, let's open up, go inside the counter prefab and just drag the tomato reference. Okay, great. Let's go back outside, save. Now back in the code here, when the player interacts with it, let's just spawn it. So let's call instantiate, pass in the tomato prefab. And now here is a good question, which is where exactly do we spawn this? We don't want to spawn on this counter's origin. Remember that the counter, the way we set it up, the origin on the actual object is over there on the bottom. We don't want to spawn the tomato inside the mesh. That would not make sense. Instead, what we want is to spawn up here. So the next question is, okay, so how do we get this point on top of the counter? One approach would be to use a vector3 directly in the code. That would work, but not very usable. So a more designer-friendly method is to simply use an empty game object as a target. So on the counter, let's first go inside our prefab. And over here, let's create an empty game object inside of it. Let's call this the counter top point. Let's make sure to leave this one as empty, so no components, just a transform. And now let's just position it, so let's lift it up by just about enough, so let's make sure we see. So there you go, just about that. So let's put it on position, a Y of 1.3. Alright, so this point is going to be our spawn point. Let's make sure to save the prefab. Then back in the code here, let's add a reference to our point. And for reference, let's also use a transform reference. Call it the counter top point. Okay, now let's just comment this line just so the code compiles so we can drag the reference. Back in the editor, inside the prefab, let's just drag the counter top point reference. Okay, great. So now here, when we call instantiate, let's instantiate it inside the counter top point. So this will spawn the object, so let's say the transform for the tomato transform. And then we go inside this one, and let's just make sure we position it correctly. So let's put it on a local position of vector3.0. So this will put the object exactly on top of our counter top point. Also here, very important, don't make a mistake. Make sure you're modifying the local position and not the global position. Okay, so with this, let's test. Over here in the editor, let's go back, save our prefab, and hit on play. So here we are, let's approach the counter and interact with it. And yep, there you go, it does work. The tomato was indeed spawned. All right, awesome. Okay, so with this, we have pretty much our basics working. We can move up to a counter, we can interact with it and spawn an object. But now let's say that we want to spawn a different object. So let's say now we want to spawn some cheese. First of all, let's make the actual object. So on the tomato, let's press Ctrl D to duplicate this one. Let's rename this to the cheese block and let's go inside of it. Now in here, instead of the tomato visual, let's drag, here it is, the cheese block visual. So let's use this one instead. Okay, there's our nice visual. Let's make sure to save the prefab and go back out. And now let's say that we want this one to spawn a tomato and this one on the left to spawn some cheese. So let's override the prefab and over here drag the cheese block. And now if we hit on play, can go up to this one and yep, there's a tomato, go up to this one and yep, there's some cheese. Okay, so it all looks great. But now let's say we want to know what object we just spawned. Like what object is on top of this spawn transform. Just like this in the code, all we have is a transform reference. So with this, the only way to know what type we spawned would be if we had different prefabs for every single object. Then we could compare them one by one and see which one this matches. But then let's say, what if we wanted an actual string for the object? Well, then we would need to add tons of fields for all these strings for all of the objects. Then what about an icon for each type? Once again, we would need tons of fields, each one for each icon. But if we did it just like that with a bunch of lists, then they would be separated. That's not very good. we should have a proper way of defining our object types and all the data related to them. So this is exactly where scriptable objects come in. These are objects you can create in your project files, which are perfect for anything where you have multiple instances of a type. Like for example, multiple weapons, multiple armors, multiple recipes, or maybe multiple ingredients. As usual, I have a dedicated video on scriptable objects. They are super useful, definitely watch that for more detail. Over here, let's just use them. So the first thing we're going to need is to actually define the type, and we do that in a C# script. So in our scripts folder, let's create a new C# script. Call this the kitchen object SO. Now personally, SO is just what I like to append to my scriptable object definitions, just to make it very clear that it's a scriptable object. However, this is not a requirement, it's just a naming rule that I like to follow. And we're calling this kitchen object because we're going to use this to define any kitchen object we want to interact with. So that's going to be our ingredients, like for example the tomato and cheese, but also things like a plate, and then potentially you could implement things like a frying pan or frying extinguisher or anything like that. So this is going to represent any kind of kitchen object the player can interact with. Okay, so let's make the script, and now let's open it. And over here, okay, first things first is this is not a mono behavior. Instead, let's extend scriptable object. And then technically you can have functions inside a scriptable object, but for now let's just get rid of this, so just an empty class. And over here, let's just place whatever fields we need to store whatever data we want. So like I said, first we want a prefab, so let's make a public transform for our prefab. By the way, here note how I am indeed using public. This is pretty much the one exception to the rule. I only use scriptable objects as read-only data containers, I never write to them. So since I follow that rule, I usually make the fields in the scriptable object public. That way I can access them directly without having to make a public getter. But if you want, do feel free to keep following the general rule of not making anything public. You could definitely make this just a regular serialized field and expose with a get function, that would work. Personally, I just find it simpler to make it public, since I know that as a personal rule I will never write to a scriptable object field. Okay, so we have a transform for our prefab. Let's also add a sprite for the icon sprite. And finally, let's just add a simple string for the object name. Alright, so we have our scriptable object definition. We have all of the fields for all of the data we want to store. Now, how do we actually create a scriptable object? For that, let's go up here before the class name, and we're going to add the attribute, so let's add the square brackets. And the attribute is the create asset menu. This takes some optional parameters. Again, I cover them in detail in the dedicated scriptable objects video. For now, let's just leave all the parameters as empty, just use defaults and close the attribute. Okay, so that's it. Let's save this and go back into the editor. And over here, if we go into the project window, click on the plus icon, and right up top, yep, we do see a kitchen object SO. So if we select it, yep, there you go, it creates a brand new object inside of our project files. Let's name this one tomato. And obviously, let's keep our project nice and organized, so we don't want this inside the scripts folder. Instead, let's make a proper folder, so create a new folder, call it our scriptable objects. And then inside, let's put a different folder for each type. So let's make another subfolder, call it the kitchen object SO, and let's place the tomato inside of it. Okay. Now with the tomato selected, we can look in the inspector, and we can see, yep, it does have all of the fields that we defined. Okay, great. So now we can just assign them. So this is the tomato, so let's drag the tomato prefab. For the icon sprite, let's find it. So there are sprites included in the regular assets, so here is the tomato sprite. So it's inside the assets, then inside textures, icons, and we have all of the icons. And finally, for the readable name, let's just call it tomato. Alright, so that's it. Here we have a really nice scriptable object containing all the data required for our tomato. Okay, awesome. With that then, we can now go back into our clear counter script. And here, instead of entering a field for our tomato prefab, instead of this, let's store a reference of type kitchen object SO, and let's call it kitchen object SO. And then when spawning, let's go inside our scriptable object and just spawn the prefab reference. So this is going to be the kitchen object transform. Then over here in the editor, let's go inside the clear counter and let's assign the tomato kitchen object. Okay, so let's save it and test. So here we are, let's approach, hit, and yep, there you go, it still spawns the tomato. Okay, great. Now let's make another type for our cheese block. So let's create a brand new kitchen object SO, call it the cheese block. And again, let's assign, first of all, the prefab, there it is. Then for the sprite of the cheese block, and finally, this is the cheese block. Okay, so now, for example, let's go into the second one. And on the second counter, let's override and say this one spawn a cheese block. So let's test. So here we are, approach this one. Yep, there's tomato, this one, and yep, there's some cheese. Okay, great. So everything is working so far. However, the original problem that we're trying to solve, identifying the spawn prefab, we still don't have a solution for that. Basically, when we spawn a prefab, we need to know from which scriptable object this prefab came from. So essentially what I like to do is just attach some reference to the scriptable object in our prefab. However, again, remember that scriptable objects are not mono behaviors. So if I select the prefab and I try dragging the scriptable object, nope, it does not work. So what we can do is just create a new script. So let's make a brand new C# script. Let's call it kitchen object. Let's attach this to both prefabs, so both the cheese and the block, attach the same one to both of them, and let's open. And over here, very simple, let's just add a serialized field for our kitchen object. So a serialized field of type kitchen object SO for the kitchen object SO. Then let's also make a quick function to expose it. So we're going to return kitchen object SO, get kitchen object SO, and we just return the kitchen object SO. Yep, just like this. So now here in the editor for the tomato, yep, we've got the field. So let's say this one is a tomato, and the cheese block, this one is a cheese block. Now here, obviously, we need to make very sure to drag the correct reference to the right scriptable object. If you drag the wrong one, like for example over here on cheese, you would say this one is a tomato. If you did that, then obviously you would get some very weird results. So make sure to check and double check that you drag the right references. Both over here on the prefabs, make sure they are referencing the correct scriptable object. And on the scriptable object itself, make sure they are referencing the correct prefab. Okay, so now if you go here on the clear counter, we spawn our object. Okay, great. Then on this object, we can do get component of type kitchen object, and then we can just ask it to give us the kitchen object SO. So for example, let's do a debug.log on this one. So inside, get the kitchen object SO, and then let's print out the object name. All right, so here we are. Let's interact with this one. And yep, there you go, interacted and spawned a tomato. And on this one, yep, interacted and spawned a cheese block. Okay, awesome. We spawned a transform prefab, and we identified the spawned object is indeed this type of object. Alright, so here we'll learn about one of the most powerful Unity features, scriptable objects. These are extremely useful for defining a type and then creating multiple instances of that type with whatever data we want. So that can be some ingredients like we have here, or it could be some weapons, could even be some NPC data, maybe some quest data, and so on. It really is an insanely very useful feature. Definitely go ahead and watch a dedicated video on scriptable objects. Then if you want, you can also watch some more videos where I've used scriptable objects. For example, the Minecraft crafting system using scriptable objects, or the Hydroneer crafting system, which again also uses scriptable objects. Okay, so this is done, it's working great. Now let's continue to the next lecture, where we're going to help the kitchen object know where it belongs and help each counter know what kitchen object is on top of it. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create a kitchen object parent, meaning that the kitchen object will know where it is, and the counter will know if something is on it. This is important so that later on we can pick up a kitchen object from one place and drop it in another. Okay, so here we have our player. I can move towards this counter, interact with it, and yep, spawn a tomato. Then on this one, spawn some cheese. Okay, great. But I cannot do anything else. In fact, if I interact a bunch more times, really all I did was just spawn a whole bunch more cheese. So instead, I want to be able to spawn some cheese and then pick it up. So let's think about exactly what that means. We want a kitchen object to essentially be placed on a specific place. Based on the design that we're trying to implement, we're never going to have a kitchen object just randomly strewn around the world. We're not going to have tomatoes all over the floor. Instead, the objects will always need to be placed somewhere, and that somewhere can be either a counter or it can be being held by the player. So essentially that means that each kitchen object is going to have some kind of parent that it's attached to. We're going to make sure the counter knows if there is a kitchen object placed on top of it, and we're also going to make sure the kitchen object itself knows where it is. So first, let's do that logic over here on the counter. So on the clear counter script, let's keep a field for a kitchen object. So just a simple private of type kitchen object. Then when the player interacts with it, by the way, we can get rid of these debug transforms, debug logs, we no longer need them. Okay, so when the player interacts, so if the kitchen object is null, if so, then we're going to spawn it. Then when we spawn it, let's assign it. So this one equals the kitchen object, get component of type kitchen object, okay. So if that one is null, we spawn it and we assign it. And just with this, we should have fixed the issue where we can spawn infinite objects. So over here, I can interact, and now if I interact a bunch more times, and now look in the hierarchy inside the clear counter, and I go inside the counter top point. Nope, there's only one tomato. Okay, great. So with this, basically, we made the clear counter know if there's something on top of it. Now let's do the other side. So let's go into the kitchen object and make sure that it knows where it is. So over here on the kitchen object script, let's add a simple field for a counter. So private of type clear counter for the clear counter. And now let's just basically make two functions, one to set it and one to get it. So a public void set clear counter. And we're going to receive a parameter of type clear counter. Okay, great. And then we're going to have a public return a clear counter for the get clear counter. And we're just going to return our clear counter. And on this one, just set this.clear counter equals this clear counter. All right, so on this function, we're assigning this field, and on this function, we're returning this field. So now back on the counter script, we get the kitchen object reference. So on this one, let's call set clear counter and pass in this one. And if it is not null, so if there's something on top of this, let's just do a debug.log. Let's go onto the kitchen object and get the clear counter. So we should be able to click once and spawn an object, and click twice, and the second time we should be able to see the name of this clear counter. Alright, so over here let's approach and click, and yep, it spawned. Now click again, and yep, we've got the message. This one is on the clear counter. Okay, great, so far so good. So the counter knows if there's a kitchen object on top of it, and the kitchen object itself knows where it is. Now let's add some logic to be able to change a parent counter. So over here on the clear counter script, we basically just need to call the setClearCounter function with a different counter reference. So just for testing, let's add a serialized field for the second counter. So clear counter for the second clear counter. Now we're doing this just for testing, just to make sure the logic works before we come up with a more general system. So just for testing, let's come up with some input. And again, for testing, using the legacy input manager to get something quickly up and running is a great thing. So let's quickly get a button input on the counter. So let's make a private void update. And for testing, we only want the testing to work on one counter. So let's also add up here just a bool testing. And then on update, if we are testing and we have the input.getKeyDown on, let's say, the T key. So if you have that, then we can run some kind of testing code. So let's say, for example, if the kitchen object is not null, so if we have something on top of this kitchen counter, let's go into the kitchen object and call setCounter, and let's pass in the second clear counter. So basically with this, we should be able to interact to spawn an object, and then press the T key, and we should be able to see that object be set to a different parent. So here in the editor, let's just set that. Let's say this one is our main counter. So let's drag a reference to the second one, the second clear counter, drag it, and make this one the testing script. And also just to verify that it worked, over here, let's do a get on the clear counter. Alright, so let's test and see. Okay, so here we are. Let's approach this one, interact, and there you go, spawn tomato. And now if I interact again, yep, it says the tomato is on this clear counter. Now if I press the testing key, yep, there you go, the tomato was moved onto the other counter. Okay, so the parent changed, the logic worked. However, obviously we have two big issues. The first one is just the visual. You can see the object is still placed on top of this counter, even though technically now it belongs to this one. And the second issue is that this counter still thinks that it owns this kitchen object. And this other counter does not know that it now owns this object. So we need to sort all of that. First, for the visual, it's actually very simple. Here when spawning, we are spawning it inside the counter top point and then setting the local position to 0. So whenever we move to a different second parent, when we do that, we can just ask that second parent to return the counter top point and move it there. So for that, let's make a function to return that. So public, we're going to return transform. So get the kitchen object follow transform. So this is going to be our counter top point. So let's return the counter top point. Then let's go into the function on the kitchen object when we set the clear counter. So over here on the kitchen object on this function, so we set the clear counter. Then let's modify this transform.parent, go into the new clear counter in order to get the kitchen object follow transform. And again, let's make sure to set the local position back into vector3.0. Okay, so with this, when we set the clear counter to a different one, it should automatically teleport to the other counter. So let's test. So here we are, and first let's interact with this one. There you go, it spawned. Now if I press the testing key, and if there you go, it does move visually. Okay, great, so far so good. However, the counters still have the wrong data. By the way, here's a quick Unity tip. On the inspector, you already know that you can only see the public and the serialized fields. However, there is actually a way to look at private fields. On the inspector on the top right, there's these three dots, and if you click on it, over here you can modify it into a debug inspector. And when we go into this one, yep, this one does show all of the private fields. So you can see, for example, on the clear counter, so that's the right one. This one over here, the kitchen object, is indeed assigned. And we can go into the other one, and we can see this one has it as null. So Debug Inspector is really useful in these kinds of cases. If you want to inspect any kind of private fields, you can go to this and see it. Now let's swap back into the regular inspector. And let's fix that issue by notifying the counters that the object is changed. So over here, basically we have two options. Over here on the clear counter, when we modify the parent, when we tell the kitchen object to go to a new parent, when we do that, we can make the new parent responsible to updating itself, or we can just make the kitchen object itself be the one responsible for notifying the new parent. Both approaches can work. Personally, I think it makes more sense for the kitchen object to handle itself. So we just call this function to set the new parent. And when this happens, basically this kitchen object needs to tell the old parent that it is no longer there and needs to tell the new parent that it is on there. So on the counter, let's make some function to set and get a kitchen object. So over here on the clear counter script, let's go down. Let's make first one to set. So public void set kitchen object and receive a kitchen object. And just do this dot kitchen object equals this kitchen object. Okay, great. Then let's make a getter. So public return a kitchen object, get the kitchen object, and just return this kitchen object. Okay. Then let's also make one just to clear it. So public void clear kitchen object. And this one just sets the kitchen object into null. And finally, just a nice helpful function to test if this counter has anything on top. So just a public bool has kitchen object. And over here, we just return if the kitchen object is not null. Okay, so some 4 very simple functions. Now, if we go into our kitchen object script, over here, when we tell it to change the parent, let's first go into the current parent and clear it. So let's first of all do a quick test for null. So if this .clear counter, which is the current parent, so if this one is not null, then we go into the current parent, so the clear counter, and we tell it to clear the kitchen object. And then we go into the new parent, and we tell new parent to set the kitchen object, and the kitchen object is this one. Now here, be very, very important, don't make the mistake of clearing the wrong counter. Keep in mind that over here, this .clear counter, this refers to the previous clear counter, whereas the one in the parameter, this is the one, this is the new one. So make sure you clear the kitchen object from the previous clear counter before you assign it, and then you set it on the new clear counter. So be very, very careful here. Make sure you don't make mistakes between the quote-unquote old clear counter and the new clear counter. Okay, so that's it. Basically, we have this function to set the new clear counter, so set the new parent. We clear the kitchen object from the old clear counter, we add it to the new one, and we update the visual. Now, we can also add some nice safety checks here, just to make sure we never make a mistake. The kitchen object should never be set to a parent that is already holding something. So before we set the kitchen object, before we do that, let's make sure that one is empty. So over here, just do an if the clear counter, so that's a new one, if this one has a kitchen object, then it already has something on there. This should never ever happen, so let's do a debug.log error and say counter already has a kitchen object. We're going to eventually add tests to make sure that this never ever happens, but having the error here will be helpful just in case we miss something. So if it has a kitchen object, we're going to fire an error, but this should never happen, so we just set the error, update the visual, and so on. Okay, so finally, let's just go over here into the clear counter script. And down here, we have the interact action. So we instantiate the kitchen object. We're currently repositioning it, and then we're setting this field, assigning it to this one. Now we made the kitchen object responsible for doing all that, for modifying the position and for setting the field, so we don't need to do this. Instead, we really just need to go and get the component of that, and just pass in set clear counter, and pass in as this one. So we no longer need all of this, now our code is much more simple. Also importantly, up here, we were previously setting the clear counter and then doing a debug.log, but when we set it to the new one, that is actually going to clear this field, so if we leave this, then this is going to throw a null reference exception, so let's just get rid of this log here, we no longer need it. Okay, so let's test and see if all of our logic is working. Alright, so here we are, let's go to this one, interact to spawn it, okay, great. And once again, we can look in the debug inspector, so let's put it on debug, look at this clear counter, so that's the right one. And yep, there you go, it does have the kitchen object. And if we look in the other one, yep, this one has null. Okay, great. Now if I press the testing key, yep, visually it did change. And if we look at the counter, so if we look at the old one, so that's the right one, this one is at null. Okay, that's great, correct. And if we look at the new one, yep, this one does have the reference. All right, awesome. So now that we are correctly changing the kitchen object parent, for example, we can now interact again with this one, and yep, it does spawn a brand new one. And of course, if we try moving it to the other one, then we should have our error as intended. This one is currently already occupied with kitchen object, so we should not be able to drop something on there. But if I press the testing key, yep, there you go, nice error. Okay, so that's great. We're basically going to fix this error later on when we add checks to make sure the object can only be spawned when it can be spawned. But for now, all of our basic logic is working. We can spawn an object and change the parent. Alright, so with that, here we have added a really important feature to our game, that is the ability to know where a kitchen object is. Now the next step is to enable the player to be able to pick it up and drop it somewhere, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to enable the player to pick up a kitchen object, and in doing so we're going to learn about another awesome C# feature called interfaces. Okay, so right now with our game, I can already move the player, I can approach a counter, interact with it to spawn an object, and with the testing key I can move it to a different parent. So all of that logic is working, now let's make it work actually with the player. Let's say when we interact once we want to spawn it, and if there's an object already on top of it and I interact again, then I want to give it to the player. Okay, so here on the clear counter script we've got our interact function, and in order to make that work we need to have a reference to the player. So let's just pass it in over here as an argument for our interaction. So just pass in the player reference. Now over here, let's do the logic that I said. So if the kitchen object is null, so if there's nothing here, then let's spawn it. Okay, great. But if there is something, then let's give the object to the player. So how we change the object parent is just like what we did up here. So let's go into that one, set the clear counter, and pass in the player reference. Except, of course, this obviously does not work. The parameter on this function is supposed to be of clear counter. It does not work with the type of player. Basically, all the logic that we built for setting the parent and changing the parent, this whole thing only works with a counter, so it does not work with any other type, so we cannot set the player as a parent. Now, to solve this problem is exactly where C# interfaces come in. Again, I have a video going through them in detail. Definitely watch it to learn everything about interfaces. Basically what it is a contract. You define some functions in the interface, and then any type can implement that interface, and you can write some code that works with the interface, which in turn means that the code will work with any type as long as it implements that interface. So in this specific example, we're going to make an interface to represent a kitchen object parent. Then we're going to implement that interface on both the counter and the player, and that way both of them will be able to be parents of a kitchen object. So let's do exactly that. Now the first thing we do to define an interface is let's make a C# script. So let's right click, create new C# script. And now the standard is to start interface names with the capital I and then the name. So in this case, let's name it I kitchen object parent. And let's open it. Okay, so now to make an interface, first of all, this does not extend MonoBehavior. Nope. And secondly, this is not a class. Instead, this is an interface. Now, like I said, an interface is essentially a contract where each class that implements that interface must follow that contract. What that really means is that you can define a bunch of functions here. By the way, quick note, you can also define properties, but not fields. I cover all of that in the dedicated interface video. But for now, here we just want some functions. Like for example, let's just put all of the parent functions that we made previously on the counter. So over here on the clear counter, a while ago we made all of these functions that we needed to make it work as a kitchen object parent. So we got the transform, set kitchen object, get it, clear it, and has it. So let's just copy all of this and paste it over here on the interface. However, one important note is on the interfaces, you don't actually include any function implementation. The implementation is up to the class that implements this interface. Although again, I should also point out another quick note, as of C#7 you can include a default implementation, but that's for more advanced use cases. So for here, let's just use the basic and not apply any default implementation right here. So we just define the function and put a semicolon, so just like this, just the function definition with the exact signature. So just like this. Okay, so now with that we have defined our interface and all of the functions that we wanted to have. With this, now let's go onto the counter script. So over here on the clear counter script. Over here, let's implement the interface. And the way we do that is pretty much exactly the same as by extending a class. So over here, we are already extending MonoBehavior. Then let's set a comment and let's say we are also implementing the iKitchen object parent interface. So right now you might be wondering, so is this pretty much the same thing as extending a base class? And kind of, except for one huge difference. When extending a base class, you can only have a single base class. Like for example, over here we have MonoBehavior. You cannot extend multiple base classes. There can only be one. However, when it comes to interfaces, you can implement as many interfaces as you want. So over here we have defined our interface. And right now we don't even have any errors. That's because we already implemented pretty much all of the exact functions. Also, Visual Studio has a really nice helpful icon over here on the left side. It is basically saying that this function, this implementation is based on the interface. But let's see what happens if I decide to comment out these functions. So if I comment out all of this, and if there we go, over here we have an error. It is telling us that this class does not implement the members for the interface. Like I said, an interface is like a contract, so you must write all of the functions included in the interface. So we must implement these, so let's get rid of the comments. Okay. With this, our interface is perfectly working over here on the clear counter. Now let's just go into the kitchen object over here on this script. For now, we're still working with the type clear counter, so let's just refactor this to, instead of working with a clear counter, let's make it work with a kitchen object parent. So let's just change this from type that to kitchen object parent. Let's also rename this. So let's use Ctrl+RR for the kitchen object parent. Then we got a function to return the kitchen object. Okay, that's good. For this one, instead of set clear counter, let's once again rename this to set kitchen object parent. And inside, again, we receive of type I kitchen object parent. Then let's also rename the parameter to kitchen object parent. Okay, so all the names here I have changed. Okay, they're all correct. We set it, we assign it. Over here instead of counter, let's say kitchen object parent already has that. So just like this. And finally down here, let's return I kitchen object parent and rename this to get kitchen object parent. And we return that. All right, so we have changed everything. I can even do Ctrl+F to search for a counter, and nope, there's no instance of any counter. So all of this code has now been rewritten to work with a kitchen object parent. So like this, everything should be working exactly the same as previously. We have no errors here. And over here on the clear counter, we just have this error on the player. Let's fix this in a little bit. For now, let's just comment it. Let's just test it out to see if everything still works exactly the same as previously. Also, one final thing, since we modified the interact function over here on the player class, when we have the interact, we just need to pass in this reference. Okay, so let's test. All right, so here we are. Let's approach this one, interact. Yep, there it is. Now let me press the testing key, and yep, there you go, it does move. Okay, so everything is still working exactly the same as previously. Once again, another successful refactoring. Now here comes the magical moment. So right now, again, everything is still working exactly the same as previously, so we can only have counters as parents. But now let's go over here onto the player script. And over here, let's also implement the same interface. So let's implement the I kitchen object parent. And again, as usual, we have our error, so we need to implement this. Also again, Visual Studio is very helpful, so we can click on the light bulb icon and let's say implement the interface. And if we scroll down here, it will automatically create all of these functions. So let's just actually implement them. So for implementing this interface, the code is really going to be exactly the same. So let's go up here into the clear counter. Let's go down, find all of these functions. Let's copy them, and on the player, let's paste them down here at the bottom. So we just need to also pick up the kitchen object as well as a reference to the top point. So over here on the clear counter, let's just grab both those. So let's just grab the kitchen object. So go into the player, and over here, let's add a field for the kitchen object. And finally, let's add another one for the counter top point. So over here, a serialized field for the counter top point. Except obviously the player is not a counter, so this name makes no sense on the player. So let's just quickly rename this and call it kitchen object hold point. Okay, here we have our new name. We've got the kitchen object, and down here, all of our functions, they're all working, no errors. All right, now let's just assign this in the editor. So over here, let's just go into our player. There's the player script and requires a reference to the kitchen object hold point. So for that, let's do it just like we did for the counterpoint. So inside the player, let's create an empty game object. Call it the kitchen object hold point. And now basically let's just position it just slightly in front of the player. So let's put it on a X of 0, on a Y of 1.3, and on a Z of 1. So there you go, just ahead, that's where the player is going to be holding the objects. Finally, over here on the player, let's just drag that reference. Okay, so far so good. Also, one note here, like I mentioned previously, in order to implement the interface, it requires you to write the function code. Basically, what this means is that different objects can implement the exact same interface whilst having different implementations. So for example, over here on the player, when setting the kitchen object, perhaps over here you could play some kind of item grab animation, or maybe when clearing a kitchen object you could do some kind of logging. The only thing that needs to match perfectly is just the function signature. And the function signature, that means the return type, as well as the name and any parameters. The implementation itself, that is up to the class that wants to implement that interface. But in this case, we want it to behave pretty much exactly the same way, so like this it should be working. So we can now go back here onto the clear counter script, and okay, we have our interaction, alright, great. So if there's nothing, we're going to spawn it, and if there is something on top of it, we want to give it to the player. So now let's go into the kitchen object, and call the function setKitchenObjectParent, and pass in the player reference. And that's it, no errors, because again, this takes a parameter of type kitchenObjectParent, and the player does implement that interface, so that's all valid. Now with this, let's test and see if our code is working. Alright, so here we are, and let's interact with this counter, and there you go, the object has been spawned. And now if I interact again, yep, there you go, look at that, the player picked up the object. And since our logic is using a transform hold point as the parent, the player is automatically carrying this tomato. Alright, awesome, so this is really great. Now over here on the counter, we no longer need all of this testing code. We now have the ability to actually pick up objects from the player. So let's get rid of all this so we don't need this testing code, don't need a reference to the second clear counter or the testing. Okay, great. So here you can see the power of interfaces. By just implementing the interface, we can now place an item anywhere we want, and importantly, on any type we want. So the counter can hold a kitchen object, the player can also hold it. We could make a dog character and make it hold a kitchen object. We could make a vehicle hold it, or anything. Again, interfaces are really awesome, one of the best C# features. Definitely go ahead, pause this course for now and watch a dedicated video on them. You should be very familiar with interfaces. They will help you in making all kinds of systems and games. If you want to see a clear example of the power of interface, you can go watch my How to Interact with NPCs video. That video takes advantage of interface to make sure that the player can interact with any kind of object. Alright, so thanks to interface, we can now change the parent of the kitchen object and put it on either a counter or the player. Now in the next lecture, let's make a proper different counter type. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create a different counter type from where we can grab some ingredients. Okay, so far here we have our character working and we have an empty counter, and by interacting with it, we can spawn an object. But obviously that's not the behavior we want in the final game. We want different counter types that do different things. The clear counter should only be used as a place for putting down and grabbing objects. It should not spawn anything. So let's build a new counter type. And for that, one option is to make a brand new prefab and build it all from scratch. Another option is we can duplicate this counter and change a bunch of things. Or there's a third option that was added in recent Unity versions. You can now have what is called prefab variants, meaning that we can have a base counter and then we can make variants for all the types. So let's do exactly that to learn about prefab variants. Now first, let's duplicate this one just so we don't lose any changes. Let's rename this prefab to _base counter. Now I like to add an underscore just so that the base prefab is on top, since this window is sorted alphabetically. Now let's go inside the base counter. Let's go into the scene view, so here it is. And basically over here, we only want to have all of the things that all of the counters will have. So all the counters will have a box slider, all with the same shape, so that's good. They will also all have a counter top point. However, for the visual, different counters will have different visuals, so let's get rid of this. Same thing for the selected, let's get rid of this. And on the actual object, different counters will have different scripts. So let's also get rid of this. Okay, so that's it, this is the base counter. It only has all of the things that every single counter will have. So let's go ahead, save this prefab, go back outside, and now let's right-click on the base counter, and go into Create, and over here, let's scroll down and find the prefab variant. Now let's name this the clear counter, except obviously we can't have two different names, so let's put this one into backup. We're going to get rid of this one in a little bit. So on the variant, let's name it clear counter. Let's open up this variant. And now here, let's add everything just like we had on the old clear counter. So since it's going to be exact, let's actually go inside the backup one. So here, let's just copy the visual in the selected. So let's copy this. Go back inside the clear counter variant, and over here let's paste it, so Control V. So yep, there it is, the selected and the visual. Finally, just a script, so over here let's add the clear counter script. And now let's just drag the references, so the kitchen object, we're actually going to remove this in a little bit, but for now let's assign it. The counter top point, let's drag it, and on the selected we also need to drag the kitchen counter reference. Okay, so here is our clear counter as a variant of the base counter. So let's go ahead, save this, and go back outside. And now we can finally delete the old prefab of the clear counter, so let's go ahead and delete this. And of course, over here on the scene, we've got some broken prefabs, so let's get rid of both these. And let's drop the clear counter variant, so let's drop it, place it over here. So let's put it on X of 0, Y of 0, and Z of 3.5. Okay, so that's the clear counter. Let's just put another one to the side, and perfectly on the side, so on an X of minus 1.5. Okay, now we can begin making our container counter. So for that, once again, let's make a variant. So right click on the base counter, go into create, and let's create a prefab variant. Call this the container counter, and let's go inside of it. Now here, first thing we need is the visual. So let's go inside our assets. We've got the prefab visuals. Inside we have the counters visuals, and let's find the container counter. So let's drag it inside. Again, for the local position, make sure it's all on 0, 0, 0. Okay, great. Then we need to make the selected, so let's duplicate this visual. Let's rename this to selected. Let's go inside on all of these. And let's modify the material for the selected material. So let's click on the circle icon and select the counter select material. Okay, we've got our nice little ghost icon. And just like we did previously, let's start with these disabled. So all of these game objects disabled, so they are hidden. And on the selected, let's make sure the scale is 1% bigger, so 1.01. Also on the selected, this one does not need an animator, so let's get rid of this. Now let's add the selected counter visual. And obviously for this one, we're eventually going to need to refactor it to support multiple visual objects. As you can see, this selected has multiple. But for now, just make sure that it works. Let's just drag just the first one. Okay, great. So our container counter has been built. The only thing that we need is the main logic script, so let's do that. Let's go into our scripts folder. Let's create a brand new C# script. Name it the container counter, and let's select the main game object, attach a script, and let's open it. Alright, so now here let's first think what we want. For this counter, we want the player to interact with it, and when it does, we want to spawn an ingredient and give it to the player. So that means that we're going to want pretty much the exact same behavior that we made over here on the clear counter. So when the player interacts, we spawn and we give it to the player. So let's actually copy all of this code. Let's go into the container counter, and over here let's paste this. We just need to grab the references to the kitchen object and the kitchen object SO. So again, just like we did on the container counter, let's copy all of these references. And over here let's paste all of them. And of course here we have an error. In order for this to work, this needs to implement our interface. So let's do exactly that. So let's implement the iKitchenObjectParent. And back in the clear counter, let's just copy the exact same code. So all of these functions, let's just copy them. And on the container counter, just paste them. Okay, great. So we don't have any more errors here, so everything should work. We should be able to interact with the container counter, and we should be able to see an object being spawned on top of it. Over here in the editor, let's just make sure to assign it. So let's assign a default kitchen object. So let's say a tomato, and the counter top point. Let's drag the reference. And okay, everything else should be working. So over here on the selected, we've got the visual game object, and on the container counter, we've got this. Okay, great. So let's go outside into scene view. And over here, let's just place some container counters. So let's drag one up there. Let's place it on an X of 1.5, on a Y of 0, and Z of 3.5. And let's also place another one down here. So let's rotate it to face it upwards. Okay, so on position 0, 0, minus 5. Okay, great. And let's make them spawn different things. So on this one up here, let's actually spawn a cheese block. And on this one down here, let's spawn a tomato. So let's also modify the icon here. So from cheese block, and let's put a tomato icon. So here it is. Okay, we've got 2 counters and 2 clear counters, so let's test. So here we are, and if I approach the container counter and I press the interact button, and nope, nothing happened. We cannot interact with it at all. Even the selection visual, even that one is broken. So as I approach, nope, the visual is not showing up. Now the reason for this is actually pretty obvious. If we go over here on the player script, down here when we're handling our interactions, so let's go into the handle interactions function, Over here we are doing a raycast, and we are trying to get component of type clear counter. So basically we're not doing anything if that object has a container counter instead of a clear counter. So again, we have a similar issue to the one that we had in the object parent logic. Basically we have two types, a clear counter and a container counter, and we want the player to be able to interact with both of them. So as a solution for this exact same problem, we could also implement an interface just like we did. That would work, that would enable the player to interact with multiple counters. But in this case, since the counters are all very similar, very related objects, they're all going to be kitchen counters as opposed to object parents where the player and the counter are completely different. In this case, since they are all very similar, a better approach is actually to use inheritance. Now here I should point out that inheritance is one of those things that is simultaneously very powerful but also very dangerous. Usually beginners get really excited when they first hear about inheritance, but after gaining some experience they start to see the massive downsides. One funny joke about it is, let's say you want to write some code that all it needs is a banana class, but because of messy inheritance you end up with a monkey and the entire jungle behind it. Basically the banana extends a monkey, which extends a tree, which extends a jungle, and so on. So you just want a small thing, but because of a complex inheritance you end up picking up a huge object. So all of that to say, inheritance is something you must use very, very carefully. It's a powerful tool, definitely, but you need to make sure to absolutely use it in the right approach for the problem you're trying to solve. Now in this case, like I said, since all of the counters are going to be very closely related, in this case it does make sense. And of course in the future, if that does change, we can always refactor. If you're a beginner, definitely go ahead and research a bit more on C# inheritance, the pros and cons. I don't have any dedicated video on that topic myself, but if you search, I'm sure you'll find tons of content. Again, it's a very powerful but also very dangerous tool, so definitely use it wisely. Over here, let's make sure we're wise, so let's use it. First thing we need to do is define the base counter class, so let's create a new C# script. Let's call it the base counter. So over here on the script, let's get rid of the functions. We don't want any default functions. And let's also make sure that we do extend mono behavior. We do want that. We still want to use this as a component. So let's leave the script just like this. Let's save it. Then let's go over here into the clear counter script. And on this one, instead of extending mono behavior, let's extend the base counter. Okay, that's it. That's the only change. And now let's go into the container counter. And over here, same thing. Let's extend the base counter instead of mono behavior. So now both these counters extend the exact same base counter script. So now if we go into the player script, so here we are on the player script, and on the handle interactions function, over here instead of trying to get a component of type clear counter, let's try to get the component of type base counter. So let's also rename this, so Ctrl RR to rename this to base counter. And of course we need to rename all these references that expect a clear counter instead of a base counter. So over here for the selected counter, let's modify the type to base counter. Then also up here, when we've got the event args, let's modify the type, okay? So over here we have the interactor. Let's leave this for a bit. Let's go down and let's fix this issue. So let's go down into that function to set the selected counter. Instead of this type, let's receive a base counter. Okay, so all of these errors have been solved. There's only one left, and it's this one, the interact. We see this error because obviously the base class does not have any kind of interact method. So let's add that. Now for adding methods to a base class, it's actually very simple. It's really just like any other method. So first the accessor. For the interact, we want the player to be able to access it, so let's make it public. And also since we're talking about inheritance, I should probably mention the other accessor. Now you already know about public and you also already know about private, but there's another one you might not know, which is called protected. Basically, this one means that whatever function we define with this accessor, it is going to be accessible to this class and any class that extends it. So for example, if we had a function that was protected, the clear counter could call this function because it does extend this base class. However, the player would not be able to call this because it is protected. Now in our case, for the interact action, we do want the player to call it, so let's make it public just like we had previously. Then another keyword. For every function that we want the child classes to be able to implement in their own way, we can define it as virtual. And finally, the function signature as normal. So for the interact, we made a return void, call it interact, and we received a player argument. Okay, so that's it. That's our basic signature. For the implementation, let's leave it empty over here on the base counter. So by default, it's not going to do anything. In the game design that we're building, we're never actually going to end up with anything like this. So if we want for safety, we can just add a debug.log error. to say just base counter.interact, because this should never be triggered. Also, I should point out, for a more advanced method, instead of making it virtual, you could make it abstract. And basically what that does is that forces all of the classes to implement their own implementation. So you would make this abstract and just put it just like this, as if this were an interface. But in doing so, you would also need to define the base counter as abstract and so on. So basically this is a more advanced method, so don't worry about it for now. Let's keep it a bit more simple. So let's make it just virtual void interact. Okay, great. So we have this, let's save this. And now if we go on the clear counter, over here on the interact, notice how we have a green squiggle line. Basically, this is a warning. It's telling us that we are hiding the base function. Now, in reality, we don't want to hide it. Instead, we want to override it. So before the void, before the return type, we just add the keyword override. And yep, this will now override the base function. So when the player interacts with an object of type base counter, and that object is actually a clear counter, when the player calls the interact function, instead of running this code, it's actually going to run this code. Now let's do the same thing on the container counter. So over here, let's also add the keyword override to override the base function. Okay, great. So we have no errors here. And on the player, we also don't have any more errors since that one does now implement the interact function. So with this, let's test and everything should still be working. So over here, let's approach the interact counter and let's interact with it. And yep, it does work. It spawned some cheese. And down here, yep, it spawned a tomato. And then if we go onto the empty counter and interact, and yep, it still works. Okay, so here we added the ability to interact with two different counter types. All right, great. Now note how the selected logic isn't really working well. You can see the container counters, they are both selected, even though the player is not looking at them. And actually, if I approach it, then it actually becomes deselected. Basically, the reason for that is because the selected script, that one is still referencing the clear counter instead of the base counter. So right now, it's only being selected when the selected counter is null. So that is why as I approach, it actually hides itself. So let's fix this. Let's go inside the container counter prefab, and inside we've got the selected. And yep, over there we have a reference to that. So let's open up this script. And over here, all we need to do is just modify this type. So let's make it of type base counter. And let's rename this to base counter. Okay, that's the only change we need. And by the way, since we're here, let's also fix the other issue. The issue we had where we need to support more than one visual game object. So instead of having a field of type just game object, let's receive a game object array. So let's modify this to game object array. And then down here on the show hide is actually very simple. So let's just do a for each game object for the visual game object. In the visual game object array, we go inside, set it to true, and on this one we set it to false. Okay, that's it, super simple. Now let's just update the prefabs. So first over here on the container counter, let's drag the container counter reference as the base counter. Okay, great. And for the visuals, let's just drag all of them. So let's drag the counter solid, drag it on top, then the counter hole, drag it on top, then the single door, drag it, and the black, drag it. And also, by the way, over here on this counter, this one actually has an object sprite. This is the actual sprite in there, but for the selected, we really don't want that. So if I enable this game object, here we've got the object sprite. Let's actually delete this. We don't need the actual icon sprite to be highlighted, so let's leave it just like this. So we only have these 4 objects, and all 4 of them are on the list. Okay, that's great. So all the references in here, they're all working perfectly. So let's go back outside, let's save the prefab, let's go inside the empty clear counter. And on this one, same thing, on the selected, let's drag the insider reference. And for the base counter, let's also drag that reference. Okay, so let's go outside, save it, and let's test. And now let's see if the selected works. So as I approach this one, yep, it works, and on this one, yep, it works, and down here, yep, it works. All right, awesome. So we can interact and we can highlight our selection. Okay, everything is working great. So now that all of the code is working, we can inspect the code to see if we can refactor anything. We can see, for example, if there's any kind of common logic that all of the counters share that we should probably write in the base counter. And you can see right away that both the clear counter and the container counter, both of them implement the kitchen object parent interface. That behavior is something that all of the counters will share. So instead of defining it on each counter itself, let's actually do it on the base class instead. So let's get rid of the interface implementation here, and also on the container counter, let's get rid of that. and set on base counter, let's implement that one. So I kitchen object parent. And for the functions, let's do the same thing. So let's cut this one from here and let's paste it on the base counter. So okay, now we need these 2 points. So let's go ahead, copy all of this. Let's go into the base counter, paste it. Except for the base one doesn't need a kitchen object so just the counter top point and the kitchen object. Okay, so there are no errors on this one. Let's go into the container. Let's get rid of the kitchen object and the counter top point. Okay, great. Now we see an error, but before we worry about that, let's actually go into the clear counter and let's do the same thing. So let's get rid of this, get rid of this, and down here, get rid of all these functions. Okay, so now the counter scripts are much more simple. All of the common code is now written directly on the base counter. Now for solving this, the container counter needs to know if there's a kitchen object on top of it. So now here we have an interesting question with 2 possible approaches. Basically, we need access to this object. So one approach would be to make this protected. Like I said, protected means that any classes that extend this base counter class, any of those classes can then modify that field. So like this, yep, there's no more errors. That's one approach. And the other approach is to instead keep this one as private. And whenever we want to interact with it, we simply interact through these functions. Both approaches can work, and when in doubt, as usual, you should probably go with the more limited option. So let's leave it as private and work with these functions instead. Over here on the container counter, instead of testing if the kitchen object is null, let's just test has kitchen object. So if it does not have a kitchen object, then we're going to spawn it. And for spawning over here, we could grab the actual transform follow. So this one up here, we could call this function to get it. Or since that is actually going to be handled automatically when we call this function to set the parent, then let's actually not use this at all. So we just spawn it and set the kitchen object parent. Okay, great. So now let's just look at the clear counter. For this one, like I said, it's not really meant to spawn anything. So let's actually remove all of this code. This one is only going to serve to pick up and drop items. We're going to handle that in the next lecture. But for now, let's just go back into the container counter. And let's do the proper logic that I mentioned in the beginning. Basically on this one, we want to spawn the object and we want to immediately give it to the player. So when we call setKitchenObjectParent, instead of passing in this, let's pass in the player reference. And that's really it. For the container counter, this is all we're going to do. So the player interacts and it spawns an object and gives it to the player. Okay, so that's it with this. As you can see, the code for all of our counters is much more simplified. So basically it only handles the logic related to that specific counter. Everything else is on the base counter. So let's test this. So here we are, and if I approach the counter and interact, and yep, there you go, spawn some cheese and gave it to the player. Okay, great. Now, just for fun, when I made these assets, I actually included a nice animation. So if you go inside the container counter, over here on the visual, note how this already has an animator with an animator controller attached to it. You can double click to open it up. And over here you can see it's very simple. Basically just has 2 animations. One is the container close and one is the container opening and closing. These transitions are basically triggered by this parameter. This is a trigger parameter. So when triggers goes into the open close, and when this one ends goes back into close. So let's just quickly add these nice animations. However, again, as usual, let's make sure to write some good clean code. So let's not add the visual over here on the logic script. Instead, let's make a proper new script. Over here, let's create a new C# script. Call this the container counter visual. Okay, now we want to attach this only to the visual game object, so only this one let's attach, okay. And over here, the first thing we need is to get the animator. So let's store a field for the animator. And since it's on the exact same object, we can just make an awake and get component of type animator. And we just assign this field, okay. So with this, we have the animator. Now we just need to know when we should play the animation. So let's go over here on the container counter script, and basically let's make an event that we're going to fire when the player grabs an object. So let's make a public event of type, let's stick with the standard, so let's use event handler inside using system, okay. Let's name this on player grabbed object. And then down here, when the player interacts and gets an object, let's fire off this event. So invoke, let's invoke with this an event args.empty. Okay, so we are firing off this event. And over here on the visual, first we need the field for the container counter, so let's add it up here. Let's add a serialized field of type container counter. Okay, we have this field. Now let's listen to the event. But again, we're accessing an external reference, so let's make sure to do it on start and not on awake. So let's go into this one and listen to the onPlayerGrabbedObject event. Okay, so here we have the event, and it's over here that we want to access the animator and call setTrigger in order to play the animation. Again, when working with animator parameters, suddenly we do need to use strings. There's no way around that, but at least we can make it a bit more clean by defining a constant. So up here, a private const string, call it open close, and let's make sure to use the exact same parameter name, so open close. And then down here on the setTrigger, let's call this trigger. Okay, so that's it, some very simple visual logic. And now over here inside the prefab, all we need is to drag the container counter reference, so let's drag it. Also make sure that it has the animator and the animator controller. So with that, everything should already be set up. So let's go back into the scenes, save the changes, and let's hit on play. So here we are, and if I go towards the tomato and interact, and if there I go, it plays a nice little animation. All right, awesome. Okay, so here we created a brand new counter type, and we refactored our interact code to be able to interact with any counter type. The player can interact with the container counter to pick up an object. Now, the next obvious thing that we need is to enable the player to drop an object on the clear counter, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to enable the player to pick up and drop objects. Okay, so we already have the player working. I can approach this container counter, interact with it, and yep, the player picks up something. Now all that's left is being able to approach a clear counter and being able to drop this object, so let's do that. Let's go over here on the clear counter script. And when we interact with it, we're going to do a bit of logic. First, let's just check if this counter is empty, meaning if there's no kitchen object on it. So let's test if has kitchen object, or if not. So let's say if we don't have a kitchen object, then there is no kitchen object here. And if not, then there is a kitchen object here. Okay, these are the two valid options. So if there is nothing here, then let's check the player itself. So we go into the player and we can ask the same question. So has kitchen object. So if the player is carrying something, so over here the player is carrying something. If so, then basically we just want to drop that object from the player and drop it in here. So that's very simple. We just go into the player, we get the kitchen object that the player is holding, and we just modify the kitchen object parent onto this object. Alright, so that's it. Just with this, it should already be working. Let's do a quick test before we handle the rest of the interactions. Okay, so here moving the player, and if I just interact with the clear counter, and nope, nothing happens. Okay, great. Since the player is not carrying anything, nope, nothing happens. Alright, great. Now let's pick up something from the container counter. Okay, so now the player is carrying a tomato, approach the clear counter, press the button, and yep, there you go, there it is. Alright, awesome, everything worked. Now this is an excellent point to know just how easy this was to implement, and the reason why it was so easy was because we focused hard on writing some good clean code for how the object and the parent system works. Because we took some time to think about that, it was now very easy to implement this brand new action. So this is a very, very clear example of the power of writing good clean code. Okay, so with that now let's implement the rest. So over here there's no kitchen object here and the player is carrying something, but if not we've got the else, so player has nothing. So if the player doesn't have anything, so let's not do anything. So player not carrying anything. So those are all the possible states up there. And then down here, if there is a kitchen object on this clear counter. If so, then let's check if the player has a kitchen object. So in this, the player is carrying something. And if not, then the player is not carrying anything. So basically, if there is a kitchen object here and the player is carrying something, if so, then we don't want to do anything since we can't give the player two items. However, if there is a kitchen object here and the player is not carrying anything, then we want to give it to the player. So let's just get the kitchen object, the one that is on this clear counter. And let's do the exact same thing. So set the parent and set the parent onto the player. Okay, so that's it. As you can see, some very simple logic. So let's test. Okay, here we are, and if we interact, nope, nothing happens. Okay, great. Now pick up a tomato, go there, drop it, and yep, there it is. Now if I interact again, yep, there you go, I picked it up again. So I can go somewhere, pick it up, drop it, and everything works perfectly. All right, awesome. Now the last thing that we need to fix is the container counter. Right now it's giving out an object every time, even if the player has something. So if I pick up, yep, it works. Now if I pick up again, there you go, we've got our nice harmful error. This should never happen. So let's set some nice checks. So over here on the container counter, okay, we have our interaction. And before we spawn anything, let's just see if the player can pick up something. So once again, very simple. Let's just go into the player and we check, does the player have a kitchen object? If so, we're not going to give it anything. But if the player does not have a kitchen object, then yep, the player picks it up and we give it the object. Okay, so that's it. It's this simple. Let's test. So here we are. Let's pick up some cheese. Okay, great. Now pick up another one. And nope, nothing happens. Okay, great. We're already carrying something, so we cannot drop anything. Now drop it in there. Now pick up a tomato. And yep, it works. I can pick it up, drop it, and yep, everything works. Okay, great. Let's just do one more thing. Over here, the container counter is spawning the object. And the object is the one that we assigned. So over here in scene view, we've got the container counter. This one is placed on the scene, and we made an override to spawn a cheese block. Technically, we could keep doing this. Pretty much just duplicate objects, modify the sprite, modify over here the kitchen object. That would work. But another better approach would be to simply make some prefab variants. And yep, that does work. You can make a variant of a variant. So let's do exactly that. Over here on the container counter, let's right click, go into create, let's create another prefab variant. And let's say container counter, this one will be the tomato. Now let's go inside the prefab, and over here make sure it has the kitchen object for tomato. Okay, great. And over there on the sprite, so let's find the object sprite and choose the tomato sprite. So there you go, this one. Okay, let's exit and save. All right, now once again, let's right click on the container and let's make yet another one. This is going to be the one for the cheese block. So let's go inside of it and over here modify it for the cheese block, and inside the actual visual, let's modify the sprite, and it's actually down, so the cheese block. Okay, great. Let's go back outside. And since we're here doing this, let's make all of the other grabbable objects from the containers. So let's first make the kitchen object SO. So let's go over here. We can right click, go into create new kitchen object SO. Let's make one for the bread. Then let's duplicate this one. We're going to have a cabbage, and finally we're going to have the meat patty uncooked. Alright, so now let's make sure to assign all the data for all these scriptable objects. First we need to make the actual kitchen object, so let's duplicate tomato, name this one bread, let's go inside of it. And first for the kitchen object itself, let's make sure to drag the correct one. Okay, there's the bread. And for the visual, this one is not a tomato, so let's go inside our visual assets, inside the prefab visuals, let's pick up the bread visual. Okay, there it is. That's all we need, so let's go outside, save the changes, and then select the bread scriptable object, drag the prefab reference, okay? For the sprite, this is the bread, and finally just call it bread. Okay, let's do the same thing for the other one. So next up for the cabbage, let's do the cabbage, drag the cabbage scriptable object, let's go inside and modify the visual, so the cabbage visual. Okay, that's it. Then on the cabbage scriptable object, drag the reference for the prefab, let's assign the sprite, and finally give it a name, cabbage. And finally, the meat patty uncooked, so let's do that one. So let's duplicate it, name it meat patty uncooked. Let's go inside, modify the kitchen object SO for this one. And for the visual, let's select, here it is, the meat patty uncooked. Okay, let's go back outside. And on the scriptable object, let's just drag the prefab, assign the sprite, so this one is the uncooked, so it's this one. And finally, meat patty uncooked. Okay, great. So we added all of these scriptable objects. We also have the prefabs with the visuals and the logic script. Now let's just make the container counter. So once again, let's create another variant. So prefab variant, this one is for, let's say for the bread. Then let's make all the other ones already. So let's go make another prefab variant. This one is going to be for the meat patty uncooked. And finally, another variant. Also here, make sure you're creating a variant of the container counter. Don't make an accident of creating a variant of something else. So let's make another variant, one final one. And this one is going to be for the cabbage. Okay, we have all the variants. Now let's just assign them. So let's go inside the bread. And over there, modify the scriptable object for the bread. And for the icon, modify for the bread icon. Okay, let's go to the cabbage, save the changes, modify that one for the cabbage. Go into the icon and modify the icon. And finally, the meat patty uncooked. Let's go ahead, modify this one for that one. and the icon, put it on that one. All right, everything is working. Now let's just place them over here in our scene. So let's get rid of the ones that we made some overrides. So let's get rid of that container counter. Instead, for that one, let's drag the cheese block, put it right in there. Let's put it on X of 1.5, Y of 0, Z of 3.5, okay. Then down here for this one, let's put the cabbage next to it. Let's rotate it to face upwards. So like that. Let's put it on X of minus 1.5, Y of 0, and minus 5 on the Z. Then for tomato, let's get rid of this one and use the proper tomato one. So let's rotate it, put it on X of 0, Y 0, and minus 5. Okay, next we want some bread. So let's put the bread up here on the left side. Let's put it on X of minus 3, 0 on the Y, and 3.5 on the Z. And finally, the meat patty and cook. Let's put it over here a bit more on the side. Let's put it over here on X of 7.5, 0, and 3.5. Alright, so we have positioned all of them. Let's just make some more clear counters so we can actually place the objects. So let's put this one over here on minus 4.5, this one over there. Let's also put some counters, let's say one on the right side, and a bunch more down here. Let's rotate them upwards. Let's put this one on 1.5, minus 5, and one more over here on the side. Okay, great. So we have all of our container counters as well as a bunch of clear counters. So let's test and make sure that everything works. Okay, so here we are. Let's go down, pick up a tomato. Yep, there's a tomato. Now a cabbage. Yep, there's a cabbage. Now some bread. There's some bread. And some cheese. There's some cheese and some meat. And yep, there's some meat. All right, awesome. Everything works. So with this over here, we added the ability to pick up and drop objects on an empty container and spawn them from all kinds of container counters. Now in the next lecture, let's build a counter we can interact with in a very interesting way. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create a cutting counter. So this is going to be a counter where we can place an object, like for example a tomato, and after doing a secondary interaction, we can slice it. However, before we do that, let's just fix one slightly annoying issue. So right now the player is walking around, okay, that's great, I can approach a counter and interact with it, that's great. However, if I approach a counter from the side, look how the player is pointing towards the right. And if I press the W key, I can indeed select it, but the player does not rotate to face the counter. So that's just a minor visual issue, but still I'd like to fix it, so let's do that very quickly. Basically, the issue is over here on our player script, so we scroll down and find our handle movement function, okay. So here we were doing a bunch of capsule casts in order to fix the problem with the diagonal movement. So you try to move in one direction, if not, try to move in just one of those. And if we can move, then we assign the move direction and then move it. Basically, the problem that we have here is that if I press W to face towards the counter, then over here when we do this logic, so it's going to first attempt the X movement only, and the X is going to be 0, so the move there X is going to be 0, 0, 0, so it won't actually move anywhere, which means it won't be able to move. So this one becomes true, which then sets the move direction to 0, 0, 0, which then down here when we have our rotation, it's not actually going to rotate to anything. So we want the player to still not go through any objects, but we only want to modify the move there over here if we actually move in any of these directions. So the solution is actually super simple. So over here for the can move, we can move if there's nothing on there, and if the move direction.x is not 0. So that's really it. If we are attempting to move in the X at all, and if there's nothing on there, then we can move, which means we then assign the move direction. If not, then we don't touch this. And same thing down here. So we can move if there's nothing on it, and if the move there.z is not 0. So that's it, just this one simple change, and now the player should be able to rotate. So here we are, and if I look over there, and the player is currently looking to the left, and if I press W to point towards the container counter, and if there you go, the player does rotate a little bit. So that feels a bit more natural. Alright, so that's just a tiny visual thing that I wanted to fix, okay, so let's keep going. Now let's handle the actual cutting counter. So first of all, as usual, let's make a counter variant. So let's right click on the base counter, create a new prefab variant, call it the cutting counter. Let's go inside of it. And over here, first thing we need is the visual. So let's pick up from the assets the cutting counter visual. So here it is. Then we need the selected. So let's duplicate this one. Let's rename this one to selected. And on the animator, let's get rid of it. And instead add the component, the selected counter visual. Okay, great. Now let's drag the visuals for the visual game object array. And by the way, here's a quick tip. On the right side on the inspector, you can see this nice little lock icon. So if you click on it, then that means this inspector will not change as you select other objects. So I can click on and select something different, and this one does not change. It is still showing the selected object. Now this is useful when you want, for example, to drag multiple things. So you can lock the inspector, then the hierarchy, you can use shift-click to select multiple objects, and then just drag them all directly inside the array. That's it, just a nice quick tip. So everything is done, let's unlock it, there it is. Okay, so that's it. Let's just assign the selected material. So the counter selected material, let's make it just 1% bigger. So let's select them all, 1.01, okay. And let's start with all of them disabled. Okay, so the basic setup is done. Now let's make our script to run this. So let's go down, let's create a brand new C# script for the cutting counter. Let's select the parent game object and attach a cutting counter, and let's open. Now here, as usual, instead of all this, let's start off by extending the base counter, okay? Once again, thanks to how we set things up using such clean code, this is pretty much all we need to make a counter. With this, the counter already works as a counter. Then next thing we need is to customize any logic specific to this counter by just overriding the interact function. So that's it. Now over here, we can put whatever logic we want just for the cutting counter. And for this one, for starters, it's actually going to be just like the empty counter, meaning we're going to be able to drop objects on this. So let's just go directly into the clear counter. So here it is. And let's just copy all of this code, go into the cutting counter and paste it. Okay, so the exact same logic. So checks if there's a kitchen object or not, checks if the player is carrying something or not, and picks up or drops it. With this, let's do a quick test just to make sure this one is working exactly like the clear counter. So over here, let's just make sure to drag the last references. So on the cutting counter, let's make sure to drag the counter top point. So drag that reference. And then on the selected, drag the cutting counter reference. Okay, everything is good. Let's exit this prefab, make sure to save all the changes. And over here in the scene view, let's place one of our cutting counters. So let's paste in right in there. Let's put it on X of 4.5, 0, and 3.5. Okay, so let's test. All right, so here we are. Now if I approach and I interact, nope, nothing happens. Okay, great. Pick up some cheese and drop it on there. And yep, there it is. I can pick it up. I can pick up some bread, drop it, and yep, everything works. Okay, so far so good. Now the next goal is to use the knife and actually slice the object that is on there. And for that, the first thing that we need is we're going to need a different input. Right now, we only have the movement and the interaction, so let's add another alt interaction. For that, let's go into our input action, so let's open it up. And over here, let's make another action. So create a new action, call it interact alternate. And for the binding, let's put it on another key. So let's listen, and I think on F makes sense. So let's go ahead, select this one. Then as usual, let's make sure to save the asset, which in turn is going to generate the C# class and compile the code. Okay, great. Now we can go here into our game input class, and let's do the exact same thing we did for the interact action. So first of all, let's listen to it. So let's go inside the player input actions, inside the player action map. So this one is the interact alternate, and let's listen to the performed event. Okay, and when we have that, let's fire off an event, pretty much the same thing. So interact alternate action. And down here, let's just fire off this event. So let's invoke using this and event args.empty. Okay, so we have the input for the interact alternate. Now let's go on the player to listen the same way we were listening to the regular interact action. So over here on the player script, let's see how we're doing things. So we go into game input and listen to that. So let's do the same thing, game input and on interact alternate action. Let's listen to this one. And when this one happens, let's do pretty much exactly the same thing, except we're just going to call a different function. So instead of interact, let's call interact alternate, which in turn obviously means we need to define this function. So let's go into our base counter. So here we are on the base counter, we've got the interact, and let's make another one exactly the same, just a different name, interact alternate. Okay, that's it. And now we are only going to implement this in the ones that need implementation. So for example, on the cutting counter, over here, let's override that one. So public override, and let's override the interact alternate. And now here, let's check if there's something placed on here. So if there's a kitchen object placed on this counter, if so, then let's basically cut it. And for cutting it, the simplest way is really to destroy whatever object is on there and just spawn the slice object. So let's handle destroying a kitchen object. For handling that, let's go over here on the kitchen object script. And let's make a simple function for this object to destroy itself. So let's go up here, make it public, return void. And for the name, I like to use the name destroy self to make it destroy this object. And really all we need to do is just destroy and call destroy on this game object. However, before we do, let's make sure to clear the parent. So let's go into the kitchen object parent, clear it, and then destroy the game object. Okay, that's great. It's really this simple. And then on the cutting counter, let's get the kitchen object that is on here and tell it to destroy itself. Okay, so that destroys the object. And after we do, let's just spawn the slices object. So for now, just keep things simple. Let's make a direct reference up here. So let's make a serialized field. Let's make it of type kitchen object SO, and for the cut kitchen object SO. Okay, so we have this. Then here in the editor, let's make sure to drag the reference. So let's go inside the cutting counter. Let's open up the prefab, and inside, let's assign this one. That means we need to create the object. So let's actually do that first. So let's create a brand new kitchen object SO. Let's call it for the tomato slices. Then if we do this, we need to create the prefab. So let's once again do the same thing. Tomato slices, make the prefab. Let's go inside this prefab. Let's modify the visual. So use the tomato slices visual. Okay, and drag the reference for the other kitchen object for the tomato slices. Okay, so the visual prefab is good. And let's just go into the kitchen object. Let's just make sure to drag the prefab reference. Then let's assign the tomato slices icon and just call it tomato slices. Okay, so we have the kitchen object SO. Now we can go into the kitchen cutting counter. And over here, let's open up and set this one to the tomato slices. Okay, so we have all the references. Let's go back outside, save it. And back over here in our code. So we have this. Now we just need to spawn this object. So we're really just going to spawn it pretty much exactly like we did over here on the container. So we just go into the scriptable object, spawn the prefab, and set the parent. So let's do exactly that. Over here, we destroy the object. Then we instantiate the cut kitchen object. And instead of getting into the player, let's put it on this. Okay, so that's it. We should be able to place a tomato directly on top of the cutting counter, and it should be able to transform from a tomato into a tomato slices. Okay, so here we are. Let me pick up a tomato, go up there, drop it, and okay, that works. Now if I press the Alt Interact key, press it, and yep, there you go, it did work. The tomato was destroyed, and the tomato slices were spawned, and now I can pick them up, place them anywhere, and yep, everything works. Alright, awesome. So with this, the basics are fully working. Let's just briefly clean up this code. We already saw a little bit of code duplication. So the cutting counter is going to spawn an object, and the container counter is also spawning an object. So we're copy pasting these two lines of code in multiple places. So instead of doing that, let's put it in just one place. And actually a good place to put this is on the kitchen object class itself. So it makes sense that this one is responsible for spawning more objects. So let's put it over here. However, let us not make it a regular function. Instead, let us make it a static function. Again, just like we saw for the singletons, by making it static, it means that the function is going to belong to the class itself as opposed to any instance. So let's go all the way down to the bottom of the file. Personally, I like to put statics at the end. And over here, let's make public, make it static. We're going to return a kitchen object. And let's call it just spawn kitchen object. And for our parameters, let's receive the kitchen object SO. And let's also receive the kitchen object parent. Okay, so that's it. And we're going to do the exact same thing. So let's go into the cutting counter and copy the code that we were using. And over here, just paste it in there. So we go inside here, spawn the prefab, and set it on this parent. And finally, let's return it. So let's return the kitchen object. Over here, let's pick it up. So the kitchen object, we get it. And then we do kitchen object, set the parent. And finally, we return the kitchen object. All right, so that's it. Here we have a super simple function that we can call very easily. It will automatically spawn an object and set the parent. So now let's just call this from somewhere. So over here on the cutting counter, instead of doing all this, let's just go into the kitchen object. Again, remember, let's go through the class name itself and not any instance. And over here, let's call the function, pass in the cut kitchen object SO, and for the parent, it's going to be this. All right, so that is now much, much simpler. And let's do the same thing over here on the container counter. So if the player is not carrying anything, let's give the player this object and give it to the player, just like this. As usual, when we do some kind of refactoring, let's do a quick test to make sure everything still works exactly the same. Okay, so here we are, and if I go to the counter and pick it up, yep, it does work, does spawn the object. Now I can drop it in there, I can cut it, and yep, there you go, everything does work. Alright, so far so good. So with all of this, basically we have created a brand new counter where we can cut objects. However, right now there's obviously one huge glaring flaw. If I now pick up a cabbage and I drop it on the cutting counter and I interact with it, that cabbage has suddenly magically turned into tomato slices. Now that is obviously not intended, so for that let's define a proper cutting recipe, and let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to create another scriptable object type. This one is going to be for handling our cutting recipes. So here's our game. I can pick up a tomato, drop it on the cutting counter, cut it, and there you go, slice tomatoes. However, if I could pick up a cabbage, go there, cut it, and there you go, cabbage turns into tomatoes. So we have an obvious issue. The cutting object is currently hard-coded instead of being based on the object we put on top of it. So to solve that, let's make another scriptable object type. Like I mentioned, scriptable objects are excellent for storing and organizing data, so it's perfect for this use case. Basically, we want a scriptable object to hold a reference to the regular object and the cut object, so we can then identify the input in order to spawn the output. Okay, so let's build that. Let's create a brand new C# script, call it the cutting recipe SO, and let's open it. Okay, so now here let's do exactly that, so something extremely simple. So instead of mono behavior, this one is a scriptable object. Let's add the create asset menu. And finally for the fields, let's do just an input and output. So we've got of type kitchen object SO. Let's go for the input and another one for the output. Okay, so that's really it, super simple. Now here in the editor, before we create it, let's keep things organized. So let's make another folder. Let's make it for the cutting recipe SO. And inside, let's right click, create a new cutting recipe. Let's call it tomato to tomato slices. And over here, let's select the reference. So the input is going to be our tomato and the output, the tomato slices. Okay, so this is how we're going to handle things. So let's go ahead and make actually the final kitchen object SOs. So let's make yet another one, a kitchen object SO. Let's make it for the cabbage slices. And then let's have another one for the cheese slices. Okay, so now let's make these. So as usual, let's duplicate tomato, make the cheese slices, and another one for the cabbage slices. Let's go inside of it, and first of all, drag the kitchen object SO. So this one is the cabbage slices. And let's go modify the visual. So instead of this one, the cabbage slices. Okay. So we have this. Let's save the prefab, go outside. Then the other one we made, the cheese slices. So let's swap this out. Let's find the cheese slices and modify the kitchen object SO. Okay. So finally, just assign the references. So on the cheese slices, drag the cheese slices prefab. Let's assign the icon and call it cheese slices. Okay, so finally on the cabbage slices, so these are the cabbage slices. Let's pick up the icon and let's drag the prefab reference. Okay, so far so good. We have created our new icons. And over here, let's just make all of the other cutting recipes. So we've got two more. So one is going to be the cheese block onto cheese slices. And the other one is going to be cabbage onto cabbage slices. So all we need is just to drag drop the scriptable objects. So for this one, cabbage, let's drop the cabbage on the input, cabbage slices on the output. For the cheese block, that's the cheese block on the input and the cheese slices on the output. Okay, great. All of our data is now stored in some really nice scriptable objects. So now let's go here into our cutting counter. Instead of having a hard-coded kitchen object, let's receive a field of type cutting recipe SO, except we're going to have multiple, so let's actually make an array of this. Call it the cutting recipe SO array. Now for the interaction, this is picking up and dropping things, so let's leave that the same for now. And over here on the alternate, basically we need to find out which recipe we should apply to this. So how I identify that is pretty simple. So we've got the kitchen object that is placed on this object, and we've got a list of cutting recipes, which in turn has the input. So we just need to cycle through all the recipes in order to find the one where the input matches. Okay, so let's go down here, make a function to do just that. Let's make it private. We're going to return a kitchen object SO. Let's call it get output for input. So we give it a certain input and returns the one that matches that one. So it takes a kitchen object SO for the input kitchen object SO. And now here, let's cycle. So do a for each cutting recipe SO in the cutting recipe SO array. So let's cycle through all of these and just check if the cutting recipe SO, if this one dot input matches the input that we received. If so, then this is the one we want. So let's return the cutting recipe SO dot output. And to make sure that the function works, down here, let's return null. Okay, so that's it. We give it an input and we get back the output. So now up here, we just need to make sure to do it before we destroy the current kitchen object. So let's store a kitchen object SO for the output kitchen object SO. And we just get the output from the input. And for the input, pass in the get kitchen object. So that's the one inside of this cutting counter. And let's get the kitchen object SO. So that gives us the output. And then we just spawn that output. Okay, so that's it. Let's test. Finally, back in the scene, let's just go inside the prefab. And over here on cutting counter, we need to make sure to add all of the recipes. So let's add, so the cabbage, then a second one for the cheese block, and finally for the tomato. Okay, so there are all of our recipes. Let's go outside, save the changes, and let's test. Okay, so over here, let's pick up a tomato, go up there, slice it. There you go, got some tomato slices. Now pick up some cheese, go here, slice it, and there you go, got some cheese slices. And finally the cabbage, go up there, slice it, and there you go, some cabbage slices. All right, awesome. So everything is working perfectly. However, now let's say that I want to pick up some bread, and bread should not really be able to be cut. So if I go ahead and I cut it, and there you go, there's our error. We have no recipe that takes bread as an input, so that obviously leads to a null reference exception. Now here we have two options for solving this problem. One option is simply over here when we do the interact alternate. We get the output for the input, and if this one returns null, then we just don't cut it. So we don't destroy it and we don't spawn it. Or alternatively, we can actually add some validation over here when dropping objects. So we can make sure that we only drop valid cuttable objects. Now both approaches are valid, and actually we do need to implement both of them. We'll see why in a bit. So let's do both, starting off with the validating the drop. So first we check if there's no kitchen object on this cutting counter. Then we check if the player is carrying something, and then we drop it from the player on this. So over here, let's just check if there's any recipe that has whatever the player has as an input. So let's go down here, make a function to do that, private, let's return a bool, and call it has recipe with input. And we're going to receive a kitchen object SO for the input kitchen object SO. And over here, let's do pretty much literally the same logic. So we have this, and if we find a match, then let's return true. So there's a recipe with that input, if not, return false. So now up here, when the player is carrying something, let's check if has recipe with input, and give it the player, get the kitchen object the player is holding, and get the kitchen object SO. So if there's any recipe that takes whatever the player is carrying as an input, if so, then we drop it. Okay, so like this, let's test and see if we can drop the bread. Okay, so let's pick up some bread, go ahead, drop it, and nope, does not work. Pick up some cheese, and yep, that one does work. However, now we actually also need the other validation that I mentioned. The reason is because if we place a valid object, like for example the cheese there, so that works, and I can cut it, and yep, that does work. However, now the recipe, the cheese block, became cheese slices, and now cheese slice is no longer an input to any cutting recipe. So now if I try cutting again, yep, there you go, I've got another null reference exception. So we need to validate putting objects on top of it and also actually cutting them. That logic is also pretty simple, so let's go down to the interact alternate. So we just check if there's a kitchen object on the cutting counter and has recipe input. And let's get this kitchen object, get kitchen object SO, just like this. So we're only going to cut if there is a kitchen object here and it can be cut. Okay, so let's test. So first of all, the other one, let's pick up bread and nope, cannot drop. Okay, great. Now pick up some cheese and I can drop. Now interact, cut, now cut again. And yep, there you go, no more errors. All right, awesome. Okay, so here we have everything working perfectly. I can pick up a cabbage, go up there, cut it into slices. I can slice some cheese and I can even slice some tomatoes. Everything works perfectly. Now, the one thing missing from our design is we don't actually want this action to be instant. We don't want to just press a button, everything slices instantly. Instead, we want to have the player press the button a few times in order to actually cut. So let's do all that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to add the mechanic for the player to be able to cut multiple times in order to actually cut an object. Okay, so we have our cutting counter. I can drop a tomato and press a button. There you go, it cuts it straight away. Now we want the exact same logic, but we want it to take a few cuts before the cut object is spawned. So let's start off by going here onto the cutting counter, and basically let's keep track of some kind of progress. Basically the way we do that is pretty arbitrary, it's up to you to decide. For example, you could use a normalized float. However, for cutting, since this is going to be a discrete action, let's actually count the numbers with an int. So let's store a private int, just call it cutting progress. Okay, so now let's begin by actually initializing this progress. So when the player drops something on there, let's set this one to 0. And then down here, when we have the interact alternate, we do our logic, and when we do, let's just increase this by 1. And now we need to know if the object has been cut, so we need somewhere to define some kind of maximum. And for that, we can actually do it directly on the recipe SO. So inside the cutting recipe SO, over here we've got the input, we've got the output, and let's also define an int for the cutting progress max. Okay, that's it. And back here in the editor, let's go into the tomato to tomato slices. Let's say this one takes just 3 cuts. Then for the cheese, let's also take 3 cuts. And for the cabbage, let's say it's a bit thicker, so let's say it takes 5 cuts. Okay, so back in the cutting counter here. Down here, we are adding to our cutting progress. So then we just need the recipe SO in order to grab the maximum. So let's actually go down here and actually make a different function. So this one just returns a boolean. This one a kitchen object SO. Let's make another one. This one is going to return a cutting recipe SO. So get the cutting recipe SO with input. And we're going to receive, as usual, the kitchen object SO for the input. And really going to do the exact same thing that we did up here, except instead of returning the output, let's return the recipe itself. Okay, so now that we have this more logical one, we can actually get rid of all of this copy-pasted code. So over here, we just get the cutting recipe SO, and we just get it and pass in the input. So we have this one, and over here, if this one is not null, then we're going to return this one .output. And if not, we're just going to return null. Okay, so we're doing the exact same logic, just a bit simpler, okay? And up here, pretty much the same thing. So has recipe with input, let's get the cutting recipe SO, and basically just return if this one is not null. Okay, so we have our 3 nice helper functions. So let's just use this one to get the cutting recipe SO. So let's actually copy this and go up here, so we do the cutting progress. Then let's pick it up and do one for this input. So the input is going to be this one, the object currently on the cutting counter. And over here, we already know that there's going to be a recipe with this input since we've gone through this if. So then we can just check if the cutting progress is bigger or equal to the cutting recipe SO, and let's grab the maximum. If so, then yep, we do spawn it. Okay, so that's it, some very simple logic. Let's test. So here we are, let's pick up a tomato, go up there, and okay, now I'm going to press the alt to interact. Okay, press once, and yep, okay, so far so good, nothing. Now 2 times, and now if I press a 3rd time, boom, and yep, there you go, got the nice slices. Now for cheese, same thing, 1, 2, 3, yep, it works. And finally for the cabbage, this one should be 5. So 1, 2, 3, 4, and 5. And yep, there you go, everything does work perfectly. All right, awesome. So with this, we now have progress in our cutting logic. Although, of course, just like this, it's not very good for the player. The player has no way of knowing what exactly is going on, so we need some kind of visual feedback. So for that, let's add a really nice visual progress bar. And for doing this, we're also going to learn about a really awesome Unity feature. These are world canvases. So before we make the world canvas on the cutting counter, let's actually set something up over here on the scene itself. Let's first create a regular canvas. We're only going to use this in a couple of lectures, but let's first do that one just for now. So let's go on the plus button, go into UI, and let's create a brand new canvas. Okay, so there you go. That creates a canvas and an event system. Now, like I said, we're only going to worry about this in a little bit, but for now, let's just leave those as is. And also, since we're here creating some objects, let's also take some time to organize our hierarchy. Unity sadly doesn't really have any folder objects, so you can't organize the hierarchy in any folders. However, you can use empty game objects essentially as folders. So let's make a brand new empty game object. Let's call it counters. And now, very importantly, for empty folder objects, make sure you put them on 000 so nothing breaks. So make sure you put it on there before you drag the counters. And now let's just drag all the counters inside. So all the clear counters, put them all inside. This one, also drag it inside. And all of these counters, put them all inside. So there you go, now our hierarchy is quite a bit more clean. Okay, so now let's make the cutting progress. So let's click on the cutting counter. And let's go inside our prefab, so let's go inside of it. Now over here, let's right click on the hierarchy and we're going to create a UI. Let's create another canvas. Now for this one, let's give it a name. Let's name it the progress bar UI. And for this one over here on the inspector for the settings, instead of being screen space overlay, let's make this one a world space canvas. Basically, screen space means that it would occupy the entire screen, whereas world space means that this exists in the world in whatever position it is. So let's make it world space, and over here the fields actually unlock. So let's put the positions all on 0, and for the width and height, let's also put it on 0. So basically the canvas is going to be exactly over here. By the way, the shortcut that I just used was the F in order to focus on the object. So this is useful if you're zoomed out or zoomed in way too much, okay? So we have this and we want the bar to be a little bit above, so let's actually lift it up on the Y by a little bit. So over here, let's put it on a Y of 2.5, okay. Now, like I said, the goal with this is to make a progress bar. So inside the progress bar UI, let's create a new UI image. Let's name this one our bar. Let's put it with a width of 1 and a height maybe of 0.2. So there you go, just a really thin bar. And for the color, you can play around, tint it with any color you want. Now for progress, I think maybe a blue or a yellow, something like that makes sense. So let's go with a yellow, kind of like this. Okay, so there's our really nice progress bar. And for this, let's actually use one really nice trick for making a super easy progress bar. The image component has a really easy way of making a slider image. However, it only actually works if you assign an image over here. So let's assign one in order to be able to see those options. And for that, in the included project files, there's a texture white 1x1. This is literally just a 1x1 white pixel. So here it is, just a 1x1 image, fully white. And as soon as we assign it, we do see over here the image type. So we see a bunch more options. And the one that we want is to set the sprite as filled. This one lets you do some really cool, really easy effects. For example, you can make it radial and look at what happens in there as I modify over here on the fill amount. So as I go down, look at that, it's radially filling. So for some kind of circular progress bar, this would be excellent. But in our case, what we really want is just a horizontal bar. So over here for the fill method, instead of radial, let's go with horizontal. And yep, there you go. Now by playing around this, we have a really nice progress bar. Then if you want, you can modify left to right, right to left, but yep, like this, it looks great. Now in order to modify this visual, really all we're going to need is modify over here the fill amount. This one is a normalized value, so between 0 and 1. So 0 is completely empty, 1 is completely full. However, one issue with this is when the bar is empty, then we can pretty much not see, so we can't see the actual size of the bar. We can see what size it should be. So with this, it's pretty difficult to see how far along we are. But solving that is pretty simple. We can really just add some kind of background. So let's duplicate the bar. Let's name this one the background. For this one, for the image type, we don't want anything, so let's leave it on simple. And for the color, let's put it on kind of a dark gray. Okay, great. And now here's one very, very important thing, is over here on the hierarchy, let's click and drag and place it above the bar. The reason why that is super important is because the sorting order and how it works in Unity. Basically, when it comes to UI elements inside a canvas, the sorting order is based on the order in the hierarchy. Basically, it renders from top to bottom. So the bar on top, the background, this is going to render first, and then the one below it, the bar, is going to render afterwards, which means it's going to render on top. So for the background, we want it to be behind, so place it above on the hierarchy, and that way it renders the background and then renders the bar. Also, by the way, for 2D sprites, Unity has another different sorting method. It's all based on sorting layers and sorting orders. I have a video on that topic if you're interested in 2D games. Okay, so with this, we have the background, and then we have our film bar. This way we can see if the progress is being filmed or not. Also, one more tiny thing that I like to add is Unity has some really nice, really easy to add effects. So you can go into Add Component, and let's search for a shadow. This one does exactly what you expect. It adds a nice drop shadow. Over here on the effect distance, let's put it on 0.1.1 in order to see. And actually, let's not do it on this one, but do it on the background. So let's get rid of this. Instead, going to the background over here, and let's add the same shadow. So if you put it on 0.1 and minus 0.1, yep, there you go, a nice simple drop shadow. Or the other one that I prefer, so instead of the shadow, let's add a really nice outline. Once again, for the effect distance, 0.1, 0.1, or maybe actually 0.05, just to be just a tiny bit. And let's raise it on the alpha, so there you go, nice little outline to our bar. This is just a visual thing, so you don't have to add this, but personally I find that it looks pretty good. So with all of this, we have our visual perfectly set up. We've got our nice bar. All we need to do is play around the fill amount in order to fill it. So now all we need to do is to connect this to the logic. But as usual, let's make sure to write some good clean code. So we do not want the cutting counter to directly touch on this image. Instead, let's make a script to handle that. So let's right click, create a new C# script, call it the progress bar UI. And just personally as a rule, I like to append the UI to any UI script. You don't have to do that, it's just a rule that I personally find helpful to follow. That way, just by looking at the scripts, I can immediately see this one is a UI, this one is script and logic, and so on. So on the progress bar UI, on the main game object, let's attach the script and let's open it. Okay, so now here we're going to need a reference to our image. So let's add a serialized field, private, and we're going to need the image type. And now importantly, this is inside using Unity Engine.ui. So let's go up here using Unity Engine.ui. So we have our image component. Okay, great. Let's call it the bar image. So we have our reference. And now with this, obviously, we need to have some kind of reference to the counter so we know when the progress changes. So it's really the same thing that we've already done so many times throughout this course. So let's add a field up here, serialized field, private cutting counter for our cutting counter. Then over here in the editor, let's drag the references. So drag the reference to the cutting counter and another one to the bar image. Okay, great. Now we just need some kind of event to update the bar image. So let's go over here into our cutting counter script. Let's make an event to spawn that. So public event, let's use the event handler, the default standard. Let's call it on progress changed. And let's also make a nice event args to be able to send the current progress amount. So let's make a public class on progress changed event args, and let's extend event args. And then inside it, let's put the current progress. However, let's also pass in the progress as normalized, since that's what the bar will use. So public float, progress normalized, and we're going to make this event of this type. Okay, great, so we have our event. Now, whenever we modify the progress, we just need to fire this event. So over here, when resetting the progress, let's fire it. So let's invoke, pass in this, instantiate our event args, and pass in the progress normalized. And to get the normalized progress, it's actually very simple. Basically, we just need to divide the current progress by the maximum. So cutting progress divided by cutting progress max, which is actually inside the recipe SO. So we need to pick that one up. So let's go down there to pick up the cutting progress recipe. So we pick this one up and we go in there and get the maximum. However, over here, we also need to be very careful because there's one sneaky issue here. This has to do with how C# works and how ints are divided with other ints. For example, if we had a cutting progress of 1 and cutting progress max of 5, you would think 1 divided by 5 would equal 0.2. However, if we actually did that, over here we would actually get a 0. And the reason for that is because we are dividing two ints. Cutting progress is an int, cutting progress max is also an int. And if you divide an int by an int, then the end result will also be an int. Since you cannot define 0.2 in an int, the decimal gets cut down and you end up with just 0. So that would not be correct. In order to get the right value from this calculation, we need to make sure to convert one of these values onto a float. So that's really simple, we just cast one of them, so just cast this one to the float, just like that. Basically, now this one will first be cast to a float, and then we're going to have a float divided by an int, and the end result will be a float. So if you ever do some math and you get some weird results, always make sure to check the type of your numbers. Okay, so here we are correctly firing the event, and then down here when adding our progress, let's do the same thing. Let's also fire on the event. So now we can go back into our progress bar UI, and over here let's listen to the event. And again, remember that if we're accessing an external reference, let's do that on start and not on awake. So cutting counter, listen to the on progress changed event. When that happens, let's just go bar image and set the fill amount to what we receive from the event, so the progress normalized. Okay, so that's really it. And also up here on start, let's initialize it as 0f, so the bar is nice and empty. Okay, so let's test. Back in the editor, let's just go back into the scenes, make sure the prefab has been saved, and let's hit on play. And right away, yep, we do see the bar. Yep, it is empty. Now pick up some cheese, drop it, and if I cut, and yep, there you go, added a little bit of progress, now a bit more, and there you go, there's our cheese. Okay, great, everything does work. Now let's add just one more tiny bonus thing. We can add some extra logic in order to hide this visual if the bar is either completely empty or completely full. That is actually pretty simple. Over here on the progress bar UI script, let's just make some basic show and hide functions. So private void show, and then we're going to have a private void hide. On these ones, just game object set active, this one set it to true, and this one set it to false. Now on start, we subscribe to the event, and then let's hide it, okay? Also here, it's very important, make sure you hide it after you listen to the event. If, for example, you called hide on awake, that would disable the game object and the start would never run, so it would never listen to the event. So if you ever set the game object as inactive, make sure you do it only after you're listening to whatever events you want. So we have this, that's great, and then when the progress changes, let's just do a basic test. So if e.progressNormalized equals 0f, or if the progress normalized equals 1f, so if the bar is completely empty or completely full. If so, then let's hide it. And if not, then let's show it. Okay, that's it, let's test. Okay, and yep, by default starts off hidden. Let's pick up a tomato, go up there, and yep, still hidden. Now I cut, and there you go, there it is, cut again, and yep, there you go, it hides itself. Okay, great, so we've got a nice little visual. Let's do just one more final thing. Let's add a really nice animation. If we go inside the cutting counter, and we'll look at the cutting counter visual, over here, note how it already has an animator. Just like we did for the container counter, it's all very simple. So basically just has a cut parameter. When that happens, it just cuts the counter. So it just plays a simple animation. Since it's going to be pretty much exactly like the container counter, let's actually duplicate that script. So let's go down, find that script. So the container counter visual, let's duplicate this. So Control D. Let's rename this to the cutting counter visual. Okay, let's open. And over here, let's rename the script. So the cutting counter visual. Okay, great. Then for the parameter, let's rename this. Instead of open close, it's going to be called cut. And for the string, it's cut. Again, make sure you write it case sensitive. Make sure it's all correct. Then instead of having a container counter, we've got a cutting counter and a cutting counter. And finally, we just need to listen to the correct event. So technically, we could listen to the onProgress changed. However, that one also gets fired over here when the cutting progress is 0. We don't want the cut animation to play when this happens. So let's just make another simple event. So a public event handler. Let's call this just onCut. Okay, and then down here when we have our cutting progress, so we cut and let's just invoke this event. Okay, that's it, super simple. So now on the cutting counter visual, let's go into the cutting counter and into the onCut event. Let's listen to this. And we're going to set the trigger exactly like this. So get rid of the container counter like this. Okay, there you go, a very simple script. So now here back in the scene view, inside the container counter prefab, let's just go inside the visual. Let's attach the cutting counter visual. Just need to drag the cutting counter reference and that's it. Let's exit the prefab, save it, and let's play. Okay, so now let's pick up a cabbage, go up there, drop it, and Alt Interact. And if there you go, we've got a nice little animation. All right, awesome. So I can drop things, I can cut them, and everything works perfectly. All right. So here we added a cutting progress to our cutting counter, and we also learned about yet another very useful Unity feature called World Canvases. And at the same time, you might have also noticed that the canvas is looking at the camera in kind of a weird way, basically just pointing straight forward. This can sometimes make it difficult to see, so let's work on that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to build a very simple but very useful script to make an object look straight at the camera with various options. Okay, so we previously made the cutting counter, and when I place something, yep, there's a nice progress bar. So now that this is working, let's do one more thing. Right now, look at how the bar is oriented. it's looking quite a bit slanted. That's because we have a perspective camera and it's looking from top down. Now, this is one of those things that is kind of personal preference, so maybe you don't like it just like this. But a lot of the times you want these World UI elements to face the camera just like a regular UI. One example of this problem is, for example, let me pick up the cutting counter, duplicate it, and let's put one down here. So rotate it upwards. Okay, let's put it on 4.5, 0, and -5. Now, if I place something on there and I cut it, yep, look at that, the bar is now inverted. So let's make a simple script to solve this problem. Let's go into our scripts, create a new C# script, call it look at camera. Let's go onto the cutting counter prefab, let's open it up, go inside, on the progress bar, let's attach this script, so the look at camera. Okay, now let's open. So from here, let's use an interesting function. So let's use a private void late update. So not update, we have the late update. So if this is the first time you're hearing about this, like the name implies, this one is going to run after the regular update. So every single update and all the objects is going to run, and then all the late updates. So kind of like you've got awake and start, you have update and late update. Why this is useful specifically for this script is because for this element you really want this to run, the orienting logic, you want that to be done after whatever that object does in the update. In this case, this object will never move, so it's not really an issue. But for example, if you had some kind of moving vehicle with a world canvas on top, if you had that, you would want to set the world canvas location to look at the camera after the vehicle had moved. Otherwise, the canvas would not look perfect. So anyways, because of that, here we're doing on late update. And now we can just look straight at the camera. So we can just do transform.lookAt. And for the target, pass in the camera.main.transform. This function makes this transform look at another transform or another point, so this will make it look straight at the camera. Also, by the way, one quick note here. In some older tutorials, you might see people telling you not to use camera.main. The reason for that is because this field did not used to be cached, so every time you use this, it would cycle through every single game object in the scene until it found the main camera, so that was obviously really bad for performance. But nowadays, this field is now cached by default on the Unity backend, so you no longer need to cache it yourself. Accessing it directly just like this is now fine. Okay, so with this, let's test. Just make sure to save the prefab and let's hit on play. Let's go ahead, pick up a cabbage, put it up there, and yep, there you go, look at that, how it's looking straight at the camera. And for this one down here, same thing, cut it, and yep, there you go, both of them are looking straight at the camera. Okay, so that's great. You can also see exactly what it's doing if we try to move the camera. Again, we're using Cinemachine, so let's move the virtual camera. So over here, if I just play around with the position.x, look at that, look how, as I move the camera, yep, the objects are perfectly looking straight at the camera. So that's great, that's what we want. But also, you might notice one thing. Notice how the bars are actually inverted. Instead of going left to right, they're actually going right and left. Basically, this has to do with how the canvas by default assumes you are essentially going to look at it from behind instead of looking forward. So that is why when this game object is pointing straight at the camera, it's essentially inverted. So to solve this, actually quite simple. We basically just need to look in the exact opposite direction. But at the same time, sometimes we might want this exact behavior, having something look straight at the camera. Maybe we do want it to be inverted sometimes. So for that, let's make a nice complete script with all of our possible options. And for defining options, this is also an excellent way to learn about one more thing, which are C# enums. Enums are an enumeration, meaning a fixed set of options that you can have of something. So these are really useful when you have a fixed set of something, like for example, maybe a fixed number of options. So for example, up here, let's make it private, make it an enum, and let's call it mode. And then inside we can define all of our options. So let's say we have the regular look at and then look at inverted. Okay, so we have these two options in our enum. Now let's do a field of this type and expose it in the editor. So let's make a serialized field, private of type mode, and call it mode. Okay, let's save this and look what this looks like in the editor. And if we go inside the cutting counter and we look at the progress bar, you have a look at that, the mode shows up and it shows up as a really nice drop-down menu. So since we have a limited number of options, we've got a really nice menu where we can choose each one you want. So that's really awesome. That's one of the benefits of enums. They are really easy to use over here in the editor. Now back in the code here, let's decide which one to use. So on the late update, let's just do a switch on our mode. In case we are on the regular look at mode, then let's do exactly this. Let's simply look at it. In case we are on the look at inverted, For this, we just want to look at the inverse position. So that's actually pretty easy. We just calculate the direction vector from the camera to this object. So a vector 3, call it dir from camera. And to get direction from the camera, we start from this object, so this transform.position, subtract the camera.main transform position. So this gives us the direction pointing from the camera. And then we just do transform.lookat. And instead of looking at the camera, let's look at the opposite position. So let's look at transform.position, so our current position, plus the direction from the camera. So we're going to be looking at the exact opposite point. Okay, so that's it. Let's test. And right now, by default, we have the regular lookat. So let's just see it. Let's just place some objects. Okay, so right now it's still inverted. And something really nice is you can play around the enums even as the game is running. So let's go inside the cutting counter on the progress bar UI. For this one, let's swap from lookat to lookat inverted. And yep, look at that. That one is now looking perfectly. So this one is using lookat and this one using lookat inverted. Okay, great. It's all working. However, yet another thing that is all about personal preference. Note how the visual has a slight slant. This is due to how the visual is actually looking directly at the center of the camera. So you can really see it if I move the camera left and right, how it slants going left or going right. Again, this is all personal preference, it's just a visual, so maybe you do want this look. But let's see another method. So over here in our modes, let's add two more. Let's add camera forward and camera forward inverted. And then down here on our late update, let's add those. So the camera forward, and then we have the camera forward inverted. So for this one, for the camera forward, it's super simple. Let's just take this transform, use the forward, which again you can get or you can set it. And let's set it to the exact same one as the camera.main.transform.forward. And for the inverted, exactly the same thing, except instead of forward, we do minus forward. Okay, so let's see what this looks like. Okay, so here's the game with both counters. They're both currently using the lookat mode. Now if I put a lookat inverted, yep, that one goes left to right. Okay, great. Now if I put camera forward, yep, look at that. Now that one is perfectly straight. So even as I move the virtual camera left and right, look how that one is always perfectly facing the camera as if it was a regular UI element. And for the inverted, does the exact same thing, but inverted, so just like that. So that's it. These are the four modes. Again, these are all just visual elements, so pick whatever you prefer. For me, I'm going to be using this one, the camera.forward, so that everything is perfectly horizontal. So I'm just going to make sure to go inside the prefab, and on the prefab itself, modify it and set it as camera.forward. And now if I add a cheese there, yep, looks great. And if I add a cabbage here, and yep, it also looks right. Alright, so here we created a really nice, useful, generic script to make an object look straight at the camera in various ways. Note how this one has nothing to do with canvas or a progress bar or anything. It's really a generic script to look at the camera, so you can apply this to anything where you want it to look at the camera. Okay, so with that, the cutting counter is fully done. Now let's handle the trash counter in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, let's create the trash counter. This one is actually pretty simple. It's how we're going to drop something and just destroy it. Okay, so making the trash counter is going to be super easy. Once again, going to be another great practical example of the power of writing good clean code and having good organization in your project. So let's do the same thing that we've already done a bunch of times. So first of all, let's make the prefab variant. So let's right click on the base counter and create a brand new prefab variant. Call it the trash counter. Okay, let's go inside. And first of all, let's drag the visual. So find the visual prefab on the trash counter. Okay. Then let's duplicate it to make the selected. So let's rename this to selected. Let's add the selected counter visual. Let's add the visual inside of it. And on the visual, let's select the other material. So the counter selected. And finally on the selected, put it 1% bigger, 1.01. And start off with the visual disabled. Okay. So that's the basics, just like we've already done so many times. Now let's make the script to run this. So let's right click, create a new C# script, call it the trash counter. And by the way, here we're already starting to have quite a bunch of scripts, so we should probably organize the scripts folder. So let's make a new folder. Let's call it counters. And let's make another one and call it scriptable objects. So on the counters, let's drag the base counter, clear counter, the container visual, the cutting visual. Then down here, the trash counter. Okay, let's drag them all onto the counters folder. And on the scriptable objects, let's put the cutting recipe and the kitchen object SO. Okay, now our folder is a bit more organized, so let's open up the trash counter. And over here, as usual, let's begin by extending the base counter. Okay, great. Then let's implement the regular interaction, so override the interact. And on this one, again, it's going to be super simple. We just check if the player is holding something, and if so, we destroy it. So just check if player.hasKitchenObject. So if the player is holding something, go into the player, get the kitchen object the player is holding, and simply call destroy self. And that's it, it's this simple. Back in the editor, let's just attach a script. Let's make sure to drag the countertop point reference, and on the selected, drag the base counter reference. Okay, with this it should be working, so let's exit the scene, let's save the prefab, and let's drag it over here onto our scene. So let's drag the trash counter and put it maybe somewhere over here on the corner. So let's put it here on an X of 7, Y 0, and minus 3.5. Then let's also fill up these spots down here. So let's duplicate the clear counter, put one in there, put another one in there. Let's put another one on the side, and for the trash counter, let's align it. So let's put it a bit more to the side, so on 7.5. Okay, great, and let's put it inside the counters, and now we can test. Okay, so let's see if we can interact with it, and yep, as I approach, yep, I do see it highlighted. Okay, great, and if I interact, obviously nothing happens since the player isn't holding anything. Now if I pick something up, let's say a tomato, and I don't want this tomato, so I want to trash it, and yep, there you go, it does get trashed. Alright, awesome, so this is literally it. Like I said, this is once again another excellent example of the power of writing good, clean code. This was super simple to implement because we have a really nice structure for how all of our counters work. Also because our interaction system is very well built. Also because the kitchen object system is very well made. It's because of all of that great, very clean code that we were able to implement a brand new counter in literally about 60 seconds. So once again, I hope that by following this course, you now understand why I'm always talking about the importance of writing good, clean code. It's exactly because of this. If you write your code correctly, it makes developing the game so much easier. At first, it might seem like the quick and dirty approach is faster, and usually in the beginning it is faster, but as soon as you add some complexity, the quick and dirty approach suddenly won't scale, whereas the well-built, clean code approach, this one will continue scaling very well. So here we have a fully functional trash bin so we can dispose of unwanted objects. Next, let's build a much more complex counter. Let's build a stove counter, which also requires building a really nice state machine. So let's do that in the next lecture. Hey again, another quick intermission. You're past the halfway point, so congrats again. By now, I really hope you've already learned a ton from the course. We've already covered lots of topics and built a ton of systems. I hope you've been following the website as you go through the lectures, and I hope reading the frequently asked questions has helped you in some way. Let me know in the comments how you've used the course website. Did you just read the FAQ, or did you also download some project files? Let me know, I'm curious to know. If you enjoy my teaching style, also look at my other courses after finishing this one, especially the turn-based strategy course. That one is an excellent follow-up for this one. Okay, there's still quite a bit more for us to build and learn, so let's continue in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to build the stove counter. So we want to place some uncooked meat, then we wait for a bit for it to be cooked. However, if we wait too much, it's going to get burned. So let's implement that. Alright, so as usual, let's first begin by making our counter. So let's go inside the prefabs, the counters, let's right click on the base counter and create a new prefab variant. Call this the stove counter. And as usual, let's go inside of it. Let's find the visual. So inside the prefab visuals, the counters visuals, here is the stove counter. So let's drag it. Then let's duplicate this, rename this one the selected. Let's set the component, the selected counter visual. Then let's go inside on all of these. And by the way, this visual actually has some nice visuals that we're going to implement in a little bit, but for the selected, we really just want the static objects. So let's pick up all of these and let's select the counter select visual. Okay, nice and white. Then let's lock over here the parents so I can select all of these and drag all of them. Okay, great. And start off with all of them disabled. Okay, so that's the basic setup as usual. Just for the counterpoint, since this one has a nice little sub on top, let's lift it up by a little bit. So put it on a Y of 1.456. Okay, that looks pretty good. Just move it a little bit to the center. Okay, great. So now let's make our script. So let's go inside our scripts folder. We've got our counters. So in here, let's create a brand new C# script for the stove counter. Let's wait for it to compile. Let's attach the script and open. Okay, so here as usual, let's extend the base counter. Now, like I said, the goal for this one is to be able to cook our meat, and for that it's going to be based on a timer. And to actually cook the meat, we're going to need to know which one is the uncooked meat type and which one is the cooked meat type. So for that, we really want the exact same logic that we did for the cutting action. We want some kind of place where we can store an input and output as well as a cook timer. So for that, let's actually just duplicate. So let's go inside our scriptable objects for the cutting recipe and let's duplicate this one. So Control D. And let's name this one the frying recipe SO. Okay, let's go inside. And over here, let's rename the object. Then we have an input, we have an output. And then instead of progress, let's have the frying timer max. And since this one is a timer instead of an int, let's make it a float. Okay, so that's it, pretty simple. Then back here in the editor, let's create our scriptable object. So let's go inside, let's make a nice folder. So a folder for the frying recipe SO. And inside, let's create one. So let's create a brand new frying recipe SO. For this one, let's call it meat patty uncooked into meat patty cooked. Then for the inputs, let's choose the meat patty uncooked. Now we have to make the other one. So let's go ahead and make that one. Let's duplicate this one, rename it to the meat patty cooked. And the object name, meat patty cooked. Let's select the different sprite. So this one is going to be the meat patty cooked, okay? And finally for the prefab, let's also make it. So for the meat patty cooked, let's go inside of it and also make sure to save the changes on our stove counter. So okay, now in here, let's get rid of this visual and use the other visual. So we want the meat patty cooked, and let's make sure to drag the scriptable object. Okay, so it's all good here. Let's go back outside, save it, and finally over here on the meat patty cooked, let's just grab the prefab reference. So there you go, that one. Okay, so this one is working, and since we're here, let's actually make the other one right away. So let's make the meat patty burned. So the prefab, and let's also duplicate this to make the meat patty burned. Then on the text, let's rename this to burned. Let's choose the burned icon. And for the prefab, let's go into our meat patty burned and swap it out for the burned one. So there you go, nice and charred. And over here, swap it for the meat patty burned. Okay, let's save it. And finally down here, just make sure everything is correct. So the meat patty burned, just drag the scriptable object, the transform prefab, just like that. Okay, so all of our burned references, over here all of our cooked, and over here all of our uncooked. And again, when going through this process, always make sure that you match all the references on the scriptable objects and also over here on the kitchen objects. So meat patty burn, yep, meat patty burn for the uncooked, and for the cooked, there it is. Okay, everything is good, great. So now we can go back over here into our frying recipe SO, and for the output, let's output the meat patty cooked. And for the frying timer, let's put it on 3 seconds. Okay, so that's it, great. Now back in the code here on the stove counter, let's add an array of our frying recipes. So a serialized field, private, it's going to be an array of frying recipe SO, so frying recipe SO array, and call it frying recipe SO array. Okay, great. Then back here in the editor, let's go inside the stove counter. Let's make sure to drag that. So let's drag the meat patty from uncooked into cooked. Okay, let's also drag the counter top point. And finally, since we already made the script over here on the selected, we can also drag the selected. Okay, so our stove prefab should be working. Okay, let's go outside, make sure to save the prefab. Okay, now let's continue with the rest of the script. So let's make our override. So override the interact action. And when we interact with it, let's validate dropping the object just like we did on the cutting counter. So let's go over here into our cutting counter script and let's just copy pretty much the exact same thing. So let's copy all of this interact code. Let's go over here in the stove counter and just paste it. Now we also need to copy in our recipe. So over here on the cutting counter, let's copy paste those functions. So these functions go into the stove counter and over here, let's paste them. They're going to work pretty much the same thing. So we get an input, except instead of being a cutting recipe SO, we're going to have a frying recipe SO. So let's replace all the cutting recipe references with frying recipe reference. Then for the array, this one is the frying recipe SO array, and obviously let's rename these. So Control R to rename all of them into frying recipe SO. Let's also rename the function. Instead of get cutting recipe SO, it's the frying recipe SO. Okay, so there's no more mentions of cutting over here. So let's use this function up here and up here. And just make sure to rename these the frying recipe SO. And down here, also same thing. So the frying recipe SO. Okay, so down here we have no more mentions of any cutting. Let's just go up here and solve all of these problems. So first we check if there's no kitchen object here, and if the player is carrying something, then we see if what the player is carrying matches any kind of frying recipe. If so, then the player is carrying something that can be fried. Then we set the parent, and for now let's not worry about the progress. So let's just get rid of all of this, just like this. Okay, so with this we should be able to drop, but only an uncooked meat. So back in the editor, let's just set up our scene. So let's drag a stove counter onto our scene. Let's put over there on X of 6, Y of 0, and 3.5. Alright, so let's test. Okay, so now if I pick up some cheese, I go up there and I drop it, and nope, doesn't work. Okay, great. But if I pick up some uncooked meat and I go and I drop it, and yep, that does work. Okay, great. So it works, and I can only drop the actual objects that match the recipe. Now, unlike the cutting counter, this one will not be based on a player-alt interaction. And actually over here, let's fix this minor issue. Basically, we added this debug.log error to the base interact because pretty much every single counter is going to implement this interact function, but not all counters are going to have the interact alternate action. So on this one, let's just do nothing. Let's not spawn an error. Okay, just a quick fix. So like I said, the stove counter, this one is going to be based on a simple timer. And for making some time-based logic, basically we have two approaches. One approach is to use a simple float timer, or you can also use a coroutine. Now, a lot of tutorials will teach you how to use a coroutine, and that's not necessarily a bad practice. It does work. It does achieve the desired result. So to do that, you would just make a function like fry timer. So you'd make a private, you have to return I in numerator, then call it something like handle fry timer. Then inside you can do a yield return and return a new wait 4 seconds. And to start this coroutine, you would do maybe on start, you would call start coroutine and start the handle fry timer. So this is one approach. This is definitely perfectly valid timer code. However, personally, I am not a fan of coroutines. It's not because of performance or anything. It's simply because I don't like the pattern that they force you to use. I don't like being forced to make a function that returns I enumerator. I don't like using yield return. I don't like having to use the start coroutine function. I don't like being forced to use this on a monobehavior object. Those are all requirements for making a coroutine work. And personally, I find those are way too many requirements that create a very strange pattern that I really don't like. So that's really the only reason. I don't like coroutines because I find this pattern to be quite a lot convoluted. So instead of coroutines, what I like to use are simple basic float timers. So just make a simple private void update. Then we just need to keep track of a certain timer. So for example, a simple private float frying timer. Then on the update, let's first check that we have an object, so it has a kitchen object. If we have a kitchen object, then let's increase the timer by time.time. By the way, here when working with a timer, you can increase or decrease. It's pretty arbitrary, both ways work. The obvious difference is only if you test if it's above the max or if it's under 0. In here for frying, it does make sense to start at 0 and then the frying timer max. So you do that, and if the frying timer, if it is bigger than the maximum, so let's get the frying recipe SO, let's get the frying recipe SO with input, so let's get this kitchen object and get the kitchen object SO. Okay, so we go into the frying recipe SO and we get the frying timer max. Okay, so if it's above the max, then this one has been fried. So here let's just see what we did on the cutting counter. So let's get this kitchen object and tell it to destroy itself. And then let's go into the kitchen object class. In order to spawn another kitchen object, let's go into the frying recipe and spawn the output. And we're going to spawn it inside of this counter. Alright, so that's it. This should already be working. We don't have a visual yet, so let's add a debug log. So up here, just a debug.log on the frying timer. And up here, let's also just reset the timer. So frying timer, let's put it on 0f. And let's also do a debug.log and say fried. However, like this, you might already be guessing that we're going to have a bunch of bugs, but still, let's just test it just like this. Okay, so over here I can move around, I can pick up some uncooked meat, I can drop it there, and after a little bit, there you go, there's the timers. And yep, there you go, it did work. You can see the timer increased until 3, then it was fried, then it was reset, and then we've got a null reference exception. Basically, this is the exact same problem that we had on the cutting counter, where first we put an object like tomato, and that is indeed an input for a recipe. So we cut tomato into slices, but then the slices are not an input for any recipe. So over here we put some uncooked meat, so that's great. We fry it, which means we destroy the uncooked meat and we spawn the cooked meat. But then next time the cooked meat is not an input for anything, so obviously this one is going to return null. One thing we can do to sort of solve this problem, which is also going to be beneficial in terms of performance, is simply caching this field. So let's go here, define a frying recipe SO, instead of constantly getting it on every single update, which might be a bit costly in terms of performance. Instead of this, let's just get it over here when the player drops something. So the player drops something and we assign the frying recipe SO, so we assign it, cache the value, and then do this. Okay, that should have fixed the null reference problem, but we still have a bunch more problems, but still, let's test it out. Okay, so here, let's pick up some meat, put it there, and let's look at the timer, and yep, there you go, everything is cooking, great, and yep, there you go, it finished, it cooked, and the timer was reset, and now it's finishing, it's cooking, and so on. So this is obviously another pretty serious problem. Basically, it's constantly frying the meat and spawning more and more objects. Instead of constantly spawning from the same recipe, what we want is for the stove to first fry the object, but then if the object is fried, then we want to burn it. So really, that means that we want the stove to have multiple states. Meaning that we're going to need to make a simple state machine. So let's do just that. Now, if you're a beginner, the concept of a state machine might seem daunting at first, but it's actually extremely simple, at least to make a very basic one. All we need is really just a bunch of states. So to define those states, let's go up here and make a simple enum. So let's make a private enum, call it state. And now let's put all the states for our state machine. Now for the stove, let's say we have idle when there's nothing on top. Then let's say we have a frying state for when the ingredient is actually being fried. Then we have fried for when the ingredient has already been cooked, but it's still getting some heat. And finally, if we leave it too long in that state, then everything ends up burned. Okay, so these are all of our states for our state machine. And now to make the actual state machine, it's actually quite simple. First of all, we just need to store the current state. So up here, make a private of type state and store the current state. And then on update, let's just do a switch on the current state. And now here, basically, we're going to do different logic depending on the state that we're at. So let's say if we're idle, we do something. Then if we are frying, we're going to do something else. Then if we are on the fried, also something else. And finally, if we are on burn, do something else. So here are all of our states. And the logic that we did down here, this is the frying logic. So let's actually just copy all of this. And let's paste it inside the frying logic. And for the state machine, we're only going to run any of these states if there's a kitchen object inside of it. So let's actually put that switch in there, just like this. Okay, so that's it. So when idle, we're not doing anything. And when frying, we're going to run our frying timer. We're going to fry the object. Let's also get rid of the log. We no longer need this. Then we destroy the current object and we spawn a brand new object. Now what we need is to handle over here the state field. We need to modify this when changing states. So first of all, let's handle the start. So let's make a private void start. And on start, let's begin with the state on state.idle. Okay, great. Then down here, when we interact, when the player drops something that can be fried, over here, let's set the state and put it on state.frying. And over here, we should also probably reset the timer. So let's set the frying timer back into 0F. Okay, we set the timer and we reset the state. Finally, up here, let's not reset the timer since we're resetting the timer down there, since it makes more sense down there. So we do the frying timer, we end up frying, and then obviously we need to modify the state. So modify state and put it on state.fried. Okay, so that's the basics of our state machine. With this, everything should be working just the same as previously, except we're only going to fry once. So let's actually just put a log here, debug.log, object fried. And let's put one down here outside of the state machine. Just do a debug.log on the state. Okay, like this, let's test. Okay, so here we are. Let's pick up some meat and drop it on there. And there you go, it goes from idle directly into frying, and then it's fried. And yep, there you go, now it stays on fried. So it no longer goes on frying, and it's no longer spawning any more objects. It went from frying into fried, and yep, everything worked. All right, awesome. So we have the frying state working perfectly. Now let's handle the burning. In terms of logic, it's really going to be the exact same thing. We're going to have a frying timer. So let's copy this code and paste it down here. Now, technically we could reuse the exact same float timer, but that would be a bit confusing. So let's keep our code as clear as possible and really just make a different timer with a more descriptive name. So up here, a private float, call it the burning timer. Then let's initialize this timer. So when we go into the fried state, let's set the timer, the burning timer into 0. Then down here, let's use this burning timer. Okay, great. When timer is elapsed and the object is spawned, let's go into the burn state. And now obviously we need another recipe. So let's make another scriptable object. Back in the editor, let's find the frying recipe SO. Let's duplicate this. Call it the burning recipe SO. Then over here, let's modify the name. Instead of frying timer max, let's call it burning timer max. Okay, great. So now over here on the stove, let's use pretty much the exact same thing. And let's make over here private of burning recipe SO, the burning recipe SO. Then down here, we just need a function to get the burning recipe SO. So let's copy this and paste it over here. This one's going to return a burning recipe SO, so let's replace this and this. Rename this into burning recipe SO. We're going to need an array, and over here let's just change the name. Instead of frying recipe SO, the burning recipe SO. And finally, let's just find a new array. So let's go all the way up here, make another array, an array of burning recipe SO. And this is the burning recipe SO array. And finally, if we go down here, let's use this array. Okay, that's it. So now let's use this function to set our burning recipe SO. So when we set it to fried, let's set the burning recipe SO and let's get it with the input, and the input is going to be the object that is on here. So the kitchen object dot get the kitchen object SO. Okay, so we're initializing our fried state and setting up the burning recipe SO. And over here we use that one dot max, and we go into that one and use the output. So over there, object fried, and over here, object burned. All right, so that's pretty much it. We modified everything to say burning timer. Over here, we are correctly initializing. So we go through the burning timer, through the burning recipe SO, which we are grabbing up here. Then we spawn the output on the burning recipe SO, and we go into state.burned. Okay, so all that's left is just filling in this array. So back in the editor, over here, let's make the object. So let's make a brand new folder for the burning recipe SO. And now inside, let's create a new burning recipe SO. Call this one the meat patty cooked into meat patty burned. And over here, let's set the input. So the meat patty cooked onto the meat patty burned. And for timer, let's make it take a bit longer to burn. So let's say 5 seconds. Okay, that's great. Let's just drag the reference. So let's go into the stove counter and let's make sure to open up and go inside the prefab. And over here on the prefab, just drag the burning recipe. Okay, that's great. Let's go outside, save the prefab, and let's test. All right, so here we are. Let's pick up some meat, drop it on there, and look over there. It's frying, and after a bit, yep, it's fried. There you go. It spawned that one. And now if we wait for 5 seconds, it should go from frying to burn. And yep, there you go. That one is charred. Everything is burned. Everything is great. All right, awesome. So everything worked as intended. With this, all of our logic is working. Now let's handle picking up objects from the stove. Now technically it's already working, so I can approach the stove and pick it up the object, and there you go, drop it in there. So that does work. However, if we look over here in the log, the state machine is now in the wrong state. So over here, let's do a quick fix. Let's go down into the interact action. Okay, so here it is. So if there's no kitchen object, then the player places it. Okay, that's good. But if there is a kitchen object, so if there's something on the stove counter, when the player picks it up, let's also manually set the state and put the state back into idle. Just like this. Okay, that's it. So let's test. Okay, so over here, let's pick up some meat, put it in there. It's cooking, and let's wait until it gets finished. Yep, there you go. It's done. Pick it up, and there you go, out. Now, if I want, I can put another one, and yep, there you go. The logic is reset, and everything is back to normal. Okay, great. So all of the logic is working perfectly. Now let's just get rid of our logs, so we don't need this. So let's get rid of that debug log, this one, and this one. Okay, great. Everything is nice and clean. And now let's add some nice fun visuals. So if we go inside the stove counter, and over here is the visual, and I include these two prefabs inside the visual. So one of them, this one, the stove on visual, this one is just a glowing red square. Now again, there's a weird bug on this specific Unity version, so post-processing isn't showing over here on scene view. But if I leave it enabled and I go back outside, and now if I look in the game view, yep, there you go, there's a nice glowing red square. If you don't see it glowing, make sure you add the bloom post-processing effect. So if you missed something, you can go back into the post-processing lecture and make sure everything is set up correctly. So there's a nice glowing red square, and there's also a bunch of particles. So you can enable this one, press on restart, and there you go, just some nice particles just jumping up. This was made with the Unity particle system. So for example, on the hierarchy, you can right click, go up here into effects, and you can create a particle system. So that's what this is. It has a particle system. And over here you can see all of the various settings. For these particles, they just jump up and fall down. So for jumping up, that is the emission. You can actually see a visual over there of the cone. That is the spawning cone, which you can find over here on the shape. So in the shape, it has the shape of a cone. Then you can see the radius thickness, and so on. So that is from where the objects are being spawned. Then up here, you can see the lifetime of each object. So each particle is going to last for 0.7 seconds. You can also see the speed, so that's the speed at which they come from there. The start size, that's how big they are on start. And note how the particles are spawning, jumping up and falling down. So that falling down is over here the gravity modifier. If you put it at 0, then they just keep going up. And if you put it at 2, yep, they go up and they fall down. Next down here on the emission, this is how many are being spawned. So if I put this on 200, there you go, tons and tons of particles. Next is over here the size over lifetime. So this one has just a basic curve. So they start off on full size and over the x-axis. This one is the lifetime. So as the particle goes from the beginning until the end of their life, they basically go down on size. So that is why they become quite a bit smaller. Also, by the way, this one down here, this one is called an animation curve. This is another really useful Unity feature. I have a dedicated video on animation curves. And finally, down here, just have the renderer. So it's just using some basic particles. So we can inspect the material, it's including the assets. And there you go, it's just using the default particle material, just with the alpha on half, and that's pretty much it. So as you can see, just a very basic, very simple particle system. Now all we really want to do is just, for both of these, we want to enable or disable them depending on if the stove is on or not. So let's make a script to handle the visuals. So let's go down and create a brand new C# script. Let's call it the stove counter visual. Then let's go into the stove counter visual and let's attach the script. So here it is, attach it and open. Alright, so now here we just need references to those two objects. So as usual, let's make a basic serialized field. Let's make it of type game object for the stove on game object. And the other one is the particles game object. Okay, let's save. And back here in the editor, let's drag the references. So the stove on visual and the sizzling particles. Okay, great. So now all we really need to know is when to turn these on or off. And for that is really going to be based on the state over here on the stove counter. So if it is on the state frying or fried, then we want to show them. If it is on idle or burned, we want to hide them. But as usual, we don't want to mix the logic and the visuals directly. So let's do that through a really nice event. Let's make a public event. Let's use a standard event handler. Let's call it on state changed. And let's also include the state on the event args. So let's make a public class, call it on state changed event args, and let's expand event args. And then in here, let's just put a public state for our state. However, here we also have a really nice error. So this one is telling you there's inconsistent accessibility. Basically, that's because we made this one public. So any class, like for example our visual class, can indeed see this class. However, from outside, that class cannot see the private state. So that is why we have inconsistent accessibility. We cannot have something public which inside has something of a specific type which is private. So in order to make this work, we need to modify this state and make it public so that the other classes can see it. Okay, so that's great. Now let's just fire this event whenever the state changes. So over here, when you go into the frying state, let's go and invoke, and as usual, just this. And I actually forgot to add that, so let's go up here. Let's use the one with generics, so the on state changed event args. Okay, great. So then down here, when invoke the event, let's create of this type. And inside passing the state equals this state. Okay, so this is all we need. So then down here, going to the burn state, let's fire the event. And down here, frying, fire the event, and on idle, fry the event. All right, that's it. So we have all of our state logic. And now over here on the stove counter visual, obviously we need a reference to the counter, so let's add that. So a serialized field, private, make it of type stove counter for the stove counter. And then we can do, and as usual, for accessing external references, let's do it on start. Go into the stove counter, and let's listen to the on state changed event. And over here, it's going to be very simple. We just want to show if it's on the state frying or fried, and if not, we don't want to show. So let's define a bool, call it show visual. And this one is going to true if the e.state equals the state.frying, or e.state equals the state.fried. So if it's either of these, then this is going to be true. If not, it's going to be false. So then let's just go into the stove on game object. and call setActive and pass in this. And same thing for the other one, for the particles game object. Okay, that's it, super simple. Let's just drag this reference. So over here inside the prefab, just drag the reference. Let's leave the prefab, save the changes, and let's hit on play. And alright, so it starts off disabled. Okay, so there's no visual. Now if I pick up and I drop it, and there you go, a nice visual. So the glowing red hot and the particles, and now it's frying. And if I leave it until it burns, when it burns, then it's going to turn it off. And if there you go, it turns off. Alright, awesome. So now if I pick it up, wait until it gets cooked. So it's cooked, pick it up, and there you go, turns it off. Alright, awesome. We've got a really nice visual. All that's left is to have a proper visual progress bar. And with this, we actually have another interesting clean code question. Right now, the progress bar that we made over here on the cutting counter, that one is great, so we would like to reuse that. However, if you look over here on the progress bar UI, we can see this is only working with the specific type cutting counter. So by default, this will not work with a stove counter. So as usual, we have multiple approaches to solving this problem. One option would be to simply completely duplicate the script. Then we would make a completely different progress bar UI class that would work only with the stove counter. So that's one approach that would work. And that approach might be good if you want the progress bar to behave very, very differently. But over here, I want both of them to behave exactly the same. So instead of having some code duplication, we can write some good clean code, but doing exactly what we did with regards to the kitchen object parent. Meaning we can use a nice interface we can then implement on anything that has some kind of progress. So let's do exactly that. First of all, let's actually go inside the cutting counter. So let's go inside the prefab. And over here, we've got the progress bar. And this one is just a regular game object. But since we're going to reuse this, let's make this a proper prefab. So let's find over here all of our prefabs and just drag the progress bar UI inside the prefabs folder. Okay, great. So this is now a proper prefab. Now let's define our interface. So let's create a brand new C# script. As usual, interface starts with I. So let's call it I. And for this one, we want it to represent anything that has progress. So let's just call it literally has progress. Personally, I like to use the word has to indicate that a certain object has certain behavior. So in this case, objects that implement this interface will have some kind of progress behavior. So now over here for the interface, let's first make it so this one does not extend mono behavior. Instead of a class, this one is an interface. Okay, great. So now for the functions that we're going to need, if we look in the progress bar and we look at the cutting counter references, we can see the only one is literally just this. So we just have to listen to the event, and then the rest of the progress bar works inside of it. So realign the interface is the only thing we need to define. So let's actually go inside the cutting counter. So here we have the onProgressChange event, and then we have this. So we can literally just copy this, go into the iHasProgress, and let's put exactly this. Okay, that's it. That is literally all we need. Now, if we wanted, we could also make a function to expose the progress amount. But since we included it over here on the event, then we really don't need it, just this is enough. Now let's go over here on the progress bar UI script. And instead of working with the type cutting counter, instead let's work with a type that has iHasProgress. So let's rename this to hasProgress. And it's going to have the exact same event. The only difference is over here, instead of the event args being the one inside the cutting counter, is the one inside the iHasProgress. So let's make sure to change this, iHasProgress. Okay, so the signature matches. Let's just obviously rename this. So let's rename, instead of cutting counter, let's rename hasProgress onProgressChange. And that's pretty much it. We don't have any more errors. So everything over here is now working nicely with our interface. And back here in the editor, whilst we're still inside the cutting counter, sadly, interfaces do have one downside when it comes to Unity. If we look in the progress bar UI, down there we can see the progress bar UI. And previously we had the counter field exposed in the editor. However, now by changing into an interface, there we have the issue. The field does not show up here. Interfaces do not show up in the editor because Unity basically has no way of knowing that the interface will be implemented by some kind of game object. So sadly, this is the one thing that doesn't work very well with Unity. The solution that I normally do is actually pretty simple. Instead of exposing the interface, which does not work, instead let's just make this a regular private field. And then let's make a serialized field, and for this one, let's make it of type GameObject, and let's call it hasProgressGameObject. Okay, so like this, we have a regular serialized field with a regular game object. So if you look here, yep, we do have that field. So now we can indeed drag the cutting counter reference. And then over here in the code, in order to get the hasProgress, that is super simple. HasProgress, we just go into the hasProgressGameObject and get component of type iHasProgress. Okay, so that's it. Now our code does work. However, of course, one big potential issue with this is that over here we have a field of type GameObject, meaning that we have no guarantee that this field does have a component that implements the interface. So we cannot make sure that we drag the correct reference. We can drag any reference, doesn't have to have our progress interface. So in order to keep ourselves safe, let's add a nice safety warning. So over here, if has progress equals null. So if this one is null, that means that that game object does not have any progress interface. If so, let's do a debug.log error. And let's say the game object, and let's pass in this game object, does not have a component that implements I has progress. So this way, if we make a mistake, we will have a nice error message. Basically, this is the one workaround that you need to use since Unity does not support dragging references in the editor if they are interface references. Okay, so with that, everything is good. So all of our progress bar UI, this should all be working perfectly. We just need to go over here into our cutting counter script, and let's make it so that we implement our interface, so I has progress. And we got an error just because even though we did define that interface member, the onProgress change, again, keep in mind that the types depend on not just their name, but where they're at. So this type that we have here is the one that we define here, which is not the same one that we have here. So even though they have the exact same name, because they are in different places, they are actually different types. So we need to make sure to use the type in the interface. So over here, let's just go into the I has progress and use that exact type and get rid of this one. Okay, so that's it. That's the change we need. And down here when firing, let's just fire with that type. And down here, the same thing with that type. Okay, great. So like this, the cutting counter should still be working exactly the same as previously. Again, when refactoring any code, always do a quick test. So let's do that. Let's make sure to save our counter, save the prefab, go back outside, hit on play. Now let's pick up some cheese, put it there, cut, and there you go, the progress bar still does work. Okay, great. Now let's apply it to the stove, and that is actually going to be very simple. First, let's go inside the stove, so let's find the stove counter, let's open it up, go inside the prefab, and over here let's drag the progress bar UI prefab, so let's drag that. Then down here we already have the hasProgress game object, so let's drag the stove counter, and that's it. There's nothing else we need to touch here. We just need to go over here into the stove counter, and as usual, let's implement the interface. So the I has progress. And now let's implement it pretty much just like we did on the cutting counter. So we can actually just copy this. So we just need to implement the event. So that's it. And now for firing the event, let's go down and see where we are modifying all of our timers. So let's go down to when the player drops something. So we do the onState change, and now let's invoke this event. So this, and for the progress bar, for the progress normalize, this one's very simple. So just frying timer divided by the frying recipe SO dot frying timer max. Okay, that's it. We are modifying the progress. Now let's go up here when we are in the frying state. And when we do, let's fire off the onProgress change event. Okay, great. And finally down here when we have the fried, over here let's also fire, except obviously we have the burning timer and the burning timer max. And then just to make sure that the bar actually hides itself when we go into burned, let's also fire an event. This one doesn't have a timer, so let's just put it on 0F. Okay, that's really it. We don't need to touch the progress bar UI at all. Let's test this. Just make sure to save the prefab. Let's go back outside and hit on play. And right away, yep, the bar is indeed hidden. Now if I pick up some meat and I drop it, and there you go, got a really nice bar going up. And yep, going up on the burning state. And as it gets to the end, let's see if the bar hides. So it gets to the end. And yep, there you go, the bar does hide. All right, awesome. And if I pick up something, actually this was the one event that we forgot, so let's fix that. So let's just copy the one where we set the progress normalize to 0. And over here, if the player picks up something, let's set the progress back into 0. So here we are, let's pick up some meat, drop it on there. Okay, let's wait for it to be cooked. Okay, it's cooked now. Before it burns, pick it up, and there you go, the bar is gone. All right, awesome. Okay, so here we have, again, another example of the power of writing good, clean code. We made a nice generic progress bar, and we very easily made it work with a completely different counter. Which, of course, would also work with literally anything that implements that interface. It doesn't have to be a counter. Now, let me make one note here. Basically, I showed you how to make a generic progress bar and reuse it. But let's say you want to do something specific just for the stove. Well, one approach, like I mentioned, is to duplicate the code and make a progress bar that works only with the stove. But another approach is to simply add more elements on top. For example, during the polish stage, we're going to do exactly that. We're going to add an extra UI element that will show up to warn the player when the food is about to burn. So I just wanted to point that out how you can mix and match both of them. You can have both generic components coupled with specific components. But for now, our progress bar, everything is looking pretty good. So let's leave that burn warning just for the poly stage. Now the next very important thing we need is some plates, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create the plates counter. This one is just going to spawn some plates, which we can then pick up to grab some objects. Okay, so let's begin making the counter as usual. So let's go inside our prefabs, inside our counters, right click the base counter, make a new prefab variant, call it the plates counter. Let's go inside and let's drag the visual for the plates counter. Let's go into scene view so we can see it. Okay, let's duplicate this, make this the selected. Let's go inside and we can actually hide the circle sprite. We only need this one. So on this one, let's modify it for the counter selected. On the selected, let's make it just 1% bigger. And let's add the selected counter visual. Okay, then inside, obviously, drag the reference for the kitchen counter. Okay, that's our basic setup. Now let's make our script to run this. So let's create a brand new C# script for the plates counter. Let's attach the script to the plates counter and open. Okay, now here as usual, let's extend our base counter. And then first let's handle the spawn timer logic. So basically we want to spawn some plates every once amount of time. So let's store a simple float for the spawn plate timer. Then let's make a simple update on timer. Let's increase the spawn plate timer by time.delta_time. And then just check if it's above a certain maximum. So if it is above something, in this case we're going to have a fixed value. But still, like I mentioned at the very beginning of this course, let us not use magic numbers here. You should never use magic numbers. Instead, if you wanted to make it editable, you could also make it appear as a serialized field. But in my case, for the design that I'm going for, I'm perfectly content with having a fixed value. So just up here, pretty simple, the spawn plate timer max. And let's default it to 4F. And let's use it over here. Okay, great. So this is what we want. However, for spawning, it's actually going to be a bit tricky. The plate is supposed to be a kitchen object. The player should be able to carry the plate. And right now, for the design that we define, is that each kitchen object can only have one parent, and each parent can only have one object. But over here, we want to spawn multiple objects. Now let's quickly see what happens if we try spawning multiple as usual. So let's just go into the kitchen object, spawn a kitchen object, which means we need the plate SO. So let's do it up here. As usual, a serialized field, private, kitchen object SO for the plate kitchen object SO. So we're going to need to make this, and then we're just going to spawn this object on this. Okay, so this is going to throw an error, but still, let's see. Let's first create the object. Over here, let's go inside our scriptable objects, our kitchen objects. Let's create a brand new kitchen object. Call it just the plate. For the object name, this one is a plate. For the sprite, let's go with the plate sprite. And for the prefab, let's make it. So let's duplicate one of these, call it the plate. Let's go inside it, and obviously make sure to save the changes. Then over here, let's drag the plate visual, get rid of the tomato, and on the plate, let's make sure to assign the plate. And finally, let's exit this, let's make sure to save it, and on the plate, let's drag the plate prefab. Okay, so we have the kitchen object SO. Now let's just go inside our plates counter, and over here, let's drag the reference, so the reference to the plate kitchen object. Let's also drag the reference to the counter top point, then on the selected, drag the reference to our base counter, and finally start off with the selected disabled. Okay, so this should be working. Let's just add a plate counter over here onto our scene. So let's pick up a plates counter and put it somewhere in here over there on the side. So on an X of 7.5, then 0, and let's say on 0 maybe. Let's make sure we have space for one more counter over there. So let's duplicate this empty counter. And let's put it over there, pointing to the side. So this one is on 7.5, 0, and -2. Okay, so now let's just make sure that they perfectly match. So let's put this one on a Z of -0.5. Okay, so let's test. All right, so here we are, and look at that. And after 4 seconds, yep, there you go, it spawns the object. And then it immediately tried to spawn another one, and there you go, we have the error. Kitchen object parent already has a kitchen object. Basically, the way we designed our game and set up the code assumes that a single counter will only hold a single kitchen object. So we cannot have multiple plates on the same counter. Now, one solution for this problem is actually quite simple. When we spawn the plates, instead, let's not spawn a kitchen object. Instead, we're just going to spawn a dumb visual. Then when the player interacts with the counter, that is when we're going to spawn the proper kitchen object. So let's do that. Although again, let's keep the logic and the visual separate. So over here, let's first just handle the logic. So we just need to keep track of how many plates were spawned. So for that, let's store up here a private int for the plates spawned amount. And let's also do another private int for the plates spawned amount max. And let's say we can spawn at most 4 plates. Okay, so over here, instead of spawning the object, let's first of all actually reset the timer. So let's put it back to 0, 0. And on the plate spawned amount, let's check if this one is under the plate spawned max. And if so, let's go into the plate spawn amount and increase it by 1. Okay, so that's the logic, super simple. Now let's handle the visual. So let's first make our script. So let's create a brand new C# script for the plates counter visual. Now let's make sure to add the visual. So let's go inside the prefab, and over here we've got the visual. Let's attach it. Okay, open. Now here, basically the first thing we need is we need to know where to spawn the visuals. So let's actually add a reference to our counter top point. So let's add a serialized field for the private transform for the counter top point. Then let's also add a reference for the prefab we're going to spawn. So let's call it the plate visual prefab. Then here in the editor, let's drag the references. So the counter top point, place it in there. And for the plate visual prefab, let's go up here and find the visuals for the kitchen objects. So these are just the visuals, and let's drag the plate visual. So the plate visual, not the plate kitchen object. Okay, now back in the code here, we obviously need to know when a plate is spawned. So let's go into the plates counter and make a nice event. So public event handler as usual, on plate spawned. And down here, let's just fire the event. So we just invoke with this and event args.empty. Okay, that's it, very simple. And then on the other script over here, let's just listen to it, which also means that we need a reference to our counter. So let's add over here the plates counter for the plates counter. So we're going to need to drag the reference, and then on start, let's listen to the on plate spawned event. And when that happens, then let's spawn. So let's call instantiate on the plate visual prefab. Let's put it inside the counter top point. So this is the transform for the plate visual transform. And that's pretty much it. Okay, so like this, it should be working. When the plate is spawned, we should be spawning a brand new visual. Back in the editor, we just need to drag the plates counter reference like that. Let's exit, save the prefab, and let's test. Okay, so here we are, and if we wait for 4 seconds, we should be able to see a plate spawn. Yep, there you go. And if we wait for a little bit more, we should also be able to see some more plates being spawned, except we can't really see them. That's because we're spawning them on the exact same spot every time. But if we pause the game, and over here look in the hierarchy and find the plates counter, and inside the counter top point, yep, we do have 4 visuals. And if we wait for longer, then nope, it's not going to spawn anymore. It's only going to spawn 4 plates. Okay, great. So to solve the visual, let's just offset them by a tiny bit. To know how much we should offset, let's keep track of how many plates have been spawned. So let's store up here on the visual script a list of game object. Call it the plate visual game object list. Let's also make sure to initialize this. So let's do on awake. Let's initialize this list. And then when we spawn them, okay, so here we have the object that we spawned. Now basically we just need to modify the local position. And let's put it on new vector 3. On the X, let's put it on 0. Then on the Z, we're also going to have 0. And then over here on the Y, let's offset it by a certain amount. And basically it's going to be based on how many plates have been spawned. So let's define up here a float for the plate offset Y. Let's put it at, say, 0.1f. And over here, we're going to offset it by this much, multiplied by how many plates have been spawned. So we can go into our visual list.count. So you can do it like this, and then we just need to add it to the list. So let's add this plate visual transform.game object. Okay, so now each game object should be spawned at a different height. So let's see. So here we are, and if we wait for 4 seconds, we should be able to see a plate. And there you go. And now after 4 seconds, we should be able to see another one placed slightly above, and yep, there it is. Okay, great. So everything is spawning perfectly, both in the logic as well as the visual. Now let's actually pick up a plate. So on the plates counter, as usual, let's implement the interact. So let's do a public, let's override the interact function. And now for picking up, let's first see if the player is actually empty-handed. So if, and we check the player has kitchen object. So if the player does not have a kitchen object, then the player is empty-handed. Okay, great. Then let's see if we have a plate that we can give them. So if the plate spawned amount, if it is bigger than 0, then there's at least one plate here. And if so, let's give it to the player. So how we do that is, well, over here for the logic, let's just increase it by 1. Then let's actually spawn the object. So on the kitchen object, let's spawn the plate kitchen object SO and spawn it on the player. And finally, we just need to update the visuals. So let's make another event. So up here on plate spawned and on plate removed. Okay, we have this event. And then down here, let's just, whenever the player picks it up, let's invoke this with this and event args.empty. Okay, great. So now in the visual, let's listen to this. So over here on start, for the plates counter, listen to this event. And when this event happens, we just want to destroy the very last plate. So let's grab the game object for the plate game object. And we're basically just going to go into our list. So the plate visual game object list. And let's pick up the very last one. So let's go into the list.count -1. So this is going to be the very last element of the list. Then let's remove this one from the list. So plate.remove this one that we just grabbed. And then we simply call destroy on this one. Alright, so that's it, super simple. So over here on the plates counter, we do all of our checks. We cut it down by 1. We spawn the actual kitchen object and we fire the event. And over here, the event listens and updates the visual. Okay, let's test. So here we are, let's wait for a plate to be spawned. And when it's spawned, there it is. I'm going to pick it up. And yep, there you go, the player is now carrying a plate. Let's drop it here. And there you go, there's another one. Now let's wait for a bunch more to be spawned. Okay, so the plates counter is full. Now if I pick up, it should only eliminate the last visual. Pick it up, and yep, there you go, it eliminates that one. Now I can drop it in there, and yep, there you go, another one spawn. Alright, awesome. Okay, so that's really it for the basics of the plate counter. It periodically spawns some plates, which the player can then pick up. Now in the next lecture, we're going to add the ability for the player to be holding a plate and pick up another object onto the plate. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to add the ability for the player to be carrying a plate and pick up objects onto that plate. Okay, so here we already have the plate counter working. It has some basic logic. After a bunch of time, it spawns a plate. It spawns up to a certain maximum. And I can pick up a plate, and yep, the player is carrying a plate, so I can put it anywhere. Then I can, for example, pick up some tomatoes, slice them, and pick them up. However, now I am not able to place the tomatoes on the plate. So let's add that logic. Let's begin over here on the clear counter script. First, we're testing if there's no kitchen object here, and the player is carrying something, that the player drops something in there. But then we're testing if there is a kitchen object here, and if the player is carrying something. So it's over here that we want to check if the something that the player is carrying, if it is a plate. Now our plate is also going to have a bit of custom logic. So to help both identify and hold that custom logic, let's make a proper script to handle it. So back in Unity, let's create a brand new script. Call it the plate kitchen object, and let's open this. Now over here on this one, instead of extending mono behavior, we're going to extend kitchen object. So the plate is really just a more specific type of a kitchen object. Again, like I mentioned quite a while ago, you want to be very careful with inheritance. You need to have a very good reason to do it. Here we want the plate to behave exactly like a kitchen object, just with a tiny bit of extra logic, so in this case it makes perfect sense. Let's just go ahead and save this. And wait for Unity to compile. And over here, let's find our kitchen object with the plate. So here it is, the prefab. As you can see, we have a kitchen object. Now, instead of having that one, let's replace that with the plate kitchen object. And since we are extending kitchen object, we have the same fields. So let's make sure to add the kitchen object SO and get rid of the other one. Okay, great. So now back here on the clear counter, when there is a kitchen object here and the player is carrying something, we can check if the player is holding a plate. And for that, we can check the type. So if, let's go into the player, and let's get the kitchen object the player is holding, and we test if this object is of type plate kitchen object. If so, then that means player is holding a plate. And if that is the case, then we basically want to give the player whatever object is over here, we want to add it to the plate. So let's go into the plate script to add that function. So over here, let's make a public void, let's call it add ingredient. As a parameter, we're going to receive a kitchen object SO. We really only care about the type. We're going to destroy the actual kitchen object like we've been doing when creating different types. So the plate is really just going to store a list of types. So up here, let's store a list of kitchen object SO for the kitchen object SO list. Then when we add the ingredient, let's just add it to the list. So this kitchen object SO. Let's also make sure to initialize the list. So let's do it on awake. Let's initialize our list. And now from the other side, we just need to call this. So over here on the clear counter, if the player is holding a plate, let's first get the type of plate. So plate kitchen object, or the plate kitchen object. We go into the player to get the kitchen object, and we cast this as a plate kitchen object. Okay, so we have this, and then over here, let's call add ingredient, and let's add whatever is currently on this counter. So let's get the kitchen object and get the kitchen object SO. Okay, so we're adding it to the plate, and then let's destroy what is here. So get kitchen object and destroy itself. Okay, so that's it. So if there is something here, and if the player is holding something, and that something the player is holding is a plate, if so, we're going to add that ingredient to the plate and then destroy the object in here. So let's test. Okay, so here let's pick up a tomato, let's slice it, let's put it on a clear kitchen counter because that's the only one where we added the logic. So on this one, let's pick up a plate, and now whilst I'm carrying the plate, and if I approach and I interact with it, and yep, there you go, it does work. The object vanished from the counter and supposedly was added to the plate. Again, we can use a really nice debug inspector to see it. So let's pause the game, let's select the plate, let's see the plate kitchen object, so here it is, this one, and let's change the inspector into debug mode, and down here, yep, we do see the kitchen object SO list, and it does have some tomato slices. Okay, awesome. So with this here, we have our basics. We can have some ingredient, and we can basically pick it up from a plate. Now, one thing about our plate, this is where we're basically going to carry the final recipe that we're going to deliver to the customers. And based on the design that I defined, I want something pretty simple, meaning for the design that I'm going for, there won't be any kind of double burgers or double cheese. So each final recipe will only have at most one of each ingredient. So let's add some basic logic just to prevent adding duplicates. Over here on the plate kitchen object, when we add an ingredient, since the function will now not necessarily succeed every time, let's actually rename this. And again, use the very useful Visual Studio shortcut. So you can press Ctrl+RR or right click and let's rename. Since this function will no longer succeed, we're just going to try to add an ingredient. So try add ingredient. And then let's also make it return a boolean. Basically for any function where you're not sure if it will succeed, I like to add try and make it return bool. So this way it works pretty much exactly like the try again component that we've already seen so many times. So it tries to do something and returns whether it succeeds or not. So over here, instead of always adding the ingredient, let's see if this one is a duplicate. So let's do an if, and let's go into the list and check if the contains, and if the list already contains this kitchen object SO. If though, then already has this type, so let's return false. And if not, then that means this is a brand new ingredient. So let's add it and return true. Okay, so that's it. Now let's go over here onto the clear counter. So we try to add the ingredient, but then we only want to destroy if this one succeeds. So let's put this one inside an if. So if we do manage to add the ingredient, then yes, let's destroy itself. If not, then we don't destroy anything. Okay, so let's test. So let's go ahead and slice 2 tomatoes. So one, slice it, put it here. Then another one, slice it and put it here. Now let's pick up a plate, go up here, try to pick up this one, and yep, it does work. Now for this one, and nope, it doesn't work. Okay, great. Now one more thing in our logic, we only want to pick up certain things. Like I said, only things that won't be used in the final recipe. For example, no customer is ever going to request a full entire tomato. The recipes only have sliced tomatoes, so we should not be able to drop a full tomato directly on top of a plate. So let's change that. So over here on the plate script, let's basically just create a list of our valid ingredients. So let's make a serialized field, private, make it a list of kitchen object SO, and call it the valid kitchen object SO list. Okay, so we have this list. And over here in the editor, let's just drag the ones that we want. So let's first of all select the plate object. Okay, here is the plate prefab. And over here we've got all of our kitchen objects. So let's just drag the ones that we want to add to the plate. So the final recipes will have some bread, yep, but they will not have entire cabbages. They will only have cabbage slices. Same thing, no cheese, only slices. For the meat, we're only going to be able to add meat cooked, but also meat burned. Then we're not going to be able to add a plate onto a plate, of course not. And finally, instead of a tomato, just tomato slices. Okay, that's our valid list. And over here, again, it's very simple. So we can just go, if the valid kitchen object SO list, if this one contains the one that we want to add, then we can add it, but if not, then let's return false. not a valid ingredient. Okay, so let's test. Alright, so let's pick up a tomato and also some tomato slices. And now if I pick up a plate and I go into the tomato, nope, doesn't work, but the slices, yep, it does work. Okay, great. So here we have all of our basic plate rules. Everything is working perfectly, but it's only working over here with the clear counter. So let's do a little bit of code cleanup, and then let's add this logic to all the other counters. So first, to clean up this code, over here we are testing if this is a plate kitchen object. Then we cast to an object, and then we call the function. So let's simplify all of this. And let's do it just like Unity does with their try_get_component function. So let's make a custom function that takes an output parameter. The best place to put it is on the kitchen object. So here we've got the kitchen object script. Okay, great. Let's scroll down and make a nice function here. So let's make a public. We're going to return boolean in case this succeeds or not. Let's call it try_get_plate. And over here, let's make an out parameter. So don't forget the out keyword. Let's return of type plate kitchen object for the plate kitchen object. And over here, we do exactly what we did. So we test if this object is a plate kitchen object. If so, then let's set the plate kitchen object equals this as a plate kitchen object. And we return true. But if not, then this is not a plate, so let's return false. And one thing when working with output parameters, you always need to make sure to set the output before you exit the function. So over here, that's the error that it's telling us. We must assign it to something when we return. So over here, we don't have a plate kitchen object. So to solve this, we just set this to null. Okay, great. Now over here on the clear counter, instead of doing all of this, basically let's ask the player if this is a kitchen object. So let's try to get the plate. Out plate kitchen object for the plate kitchen object. So you try to get it, then we try to add the ingredient, and so on. Now obviously we could further simplify things by making a function that would try to get the plate and try to add the ingredient. That could work, but since some counters are going to have a bit more custom logic, I think keeping them separate like this makes more sense. So first we try to get the plate, then we try to add the ingredients. So let's apply the same logic to the cutting counter. So over here on the cutting counter, let's scroll down to where there is a kitchen object here and the plate is carrying something. So on the clear counter, we just want to copy all of this. So let's go over here and we do the exact same thing. Okay, that's it. And the other counter from where we can pick up things is from the stove counter. So here we are on the stove. Let's scroll down until we find the interaction. Okay, there's something here. The player's carrying something. So it's over here. Let's do that and do the exact same thing. Except on the stove, again, let's remember that this is using a state machine. So when we pick up something, let's do pretty much the same thing that we did here. So let's make sure to reset the state, fire the events, and so on. Okay, so those are the only counters that we need to implement. We cannot drop things on top of a container. We cannot drop things on top of the plate counter or the trash. So these are the only three types that we need to implement. So with this, let's test. Okay, so let's begin with some meat. So let's pick up some meat, put it on the stove. Let's pick up a plate, wait for it to cook, pick it up, and yep, there you go, it does work. Now let's test the cutting counter, so let's pick up some cheese, let's slice it, pick up some plate, and go, and yep, there you go, it does work. And again, if we inspect, we can make sure that it is indeed working, so let's go into the plate, and let's put this on Debug Inspector, and yep, there we do see this one has a meat patty cooked and some cheese slices. Okay, great. Now the last piece of logic that we need is pretty much the opposite. So right now it works if there's a sliced object on the plate, and the player is holding a plate object. But now we want the opposite, so let's say there's a plate in here, and we slice some cheese, and now I want to drop the cheese on the plate. So let's do that. And basically for this one is only going to happen on the clear counter. That's the only counter type that can have a plate on top of it. So over here on the clear counter, then we check if there's no object there, but that's not what we want. We want if there's a plate on the counter. So if there is an object there, and if the player is carrying something, then we check if the player is holding a plate. But if not, so if the player is not holding a plate, so player is not carrying plate, but something else. Over here, we need pretty much the exact same logic, except just testing for the object on this counter. So let's do if, let's get the kitchen object on this counter. This one tried to get the plate. So out plate kitchen object for the plate kitchen object. So if so, there's a plate over here. That means the counter is holding a plate. So then let's go into this plate kitchen object. Let's add the ingredient. And we're going to try to add whatever the player is currently carrying. So the player dot get kitchen object and get the kitchen object as so. So we're going to try to add this. And if we can't add, then we're just going to destroy whatever is on the player. Okay, that's it. And over here we've got a nice error just because we defined it with the same name up here. So up here we're already defining the variable, and over here we're defining the same variable with the same name. So we can either give this a different name or just not define a brand new variable here. So just it's defined up here and we're using it here. Okay, so all logic is working. Now here, make very sure that you're not mixing references. Keep in mind when you're referencing the kitchen object on this counter and the one on the player. Those are two different things. So over here, if the player is not carrying a plate but something else, then you check the kitchen counter. So over here, you're not checking the player but checking the counter. Then you go into that plate and you try to add the ingredient and you try to add the one that the player is carrying, and then you destroy the one the player is carrying. So again, be very careful here. Make sure you don't mix references. So with this, it should work. So let's make sure to save our script and let's test. Okay, so here we are. Let's first pick up a nice plate. Let's drop the plate in there, pick up some bread, drop the bread, and yep, there you go, it does work. All right, so now we can do a bit more natural interactions. So for example, let's pick up some meat and put it on cooking. And there you go, the meat is fried, so now I'm currently carrying just some meat. So I place it there, then I pick up some bread and put some bread on top of the meat. And yep, everything does work flawlessly. Okay, so here we created a plate, and we created some custom logic to define what the plate can and cannot pick up. Now all that's left is actually being able to see what is on the plate, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to add a nice visual to our plate. Okay, so right now we can already pick up ingredients onto the plate. So if I pick up the plate and I pick up some cheese, there you go, there's some cheese on the plate, but we cannot see it, so let's solve that. And the way we're going to do that is actually in a very simple way. If you look in the included assets inside the prefab visuals, there's this nice plate complete visual that I built. Basically, it's a full burger that contains all of the ingredients. What we're going to do is actually very simple. We're just going to enable or disable these game objects. That's it. So let's do exactly that. Let's make a new C# script, call it the plate complete visual. Let's attach a script over here, and let's also make sure to put this one inside the plate. So let's save this prefab. Let's go inside the plate prefab. So inside the prefabs, here the kitchen objects, we've got the plate. So inside the plate, let's drag that. Let's drag the plate complete visual. Okay, great. So now let's open up this script. Over here, let's first add a reference to our plate kitchen object. So a serialized field, private for the plate kitchen object for the plate kitchen object. Back in the editor, let's drag the reference. Okay, great. So now here, basically, we need to update this visual whenever the plate gets any ingredient added to it. So let's go over here into the plate script and basically just need to fire off an event when that happens. So let's make a public event handler, and let's call it on ingredient added. Okay, and for this one, let's also make an event args to contain the data of what object we added. So let's make a public class on ingredient added event args. Let's extend event args. And inside, let's make just a kitchen object SO, kitchen object SO. Okay, great. And let's make the event of this type. All right, so now let's just fire off this event. So down here, when we try to add an ingredient, if we do add the ingredient, let's fire off this event. So let's invoke with this, and let's create a brand new one, passing the kitchen object SO as this kitchen object SO. Okay, so we have our event correctly being sent. Now over here on the plate complete visual, let's listen to it. Again, as always, let's make sure to do it only on start. So the plate kitchen object on ingredient added, let's listen to this event. And over here, we just need to either enable or disable the visuals that relate to the kitchen object inside over here, the event args. However, of course, the question is, how exactly do we find them? The plate complete visual has all of these game objects. How do we know which one belongs to that kitchen object? Now, technically, one way would be to do a simple transform find and find the child objects by name. Technically, that would work, but like I mentioned in the beginning of the course, strings are a horrible way to identify things. They are very error prone. So let's not do that. Instead, let's use a proper approach where we can define some kind of link between a kitchen object SO and a game object. And we can do that very easily by just defining a struct. So up here in our script, let's do exactly that. Let's define a public, make it a struct, and name it kitchen object SO underscore game object. And then inside, it's very simple. We just have a kitchen object SO field, and then also a game object field. That's it, super simple. By the way, if you don't know what is a struct, basically it's very similar to a class, except it's stored in different places in memory and behaves somewhat differently. I have a very important video on that subject, what is the difference between value types and reference types. Classes are reference types, so when you pass in a class into a parameter, you are passing in a reference to that object, whereas structs are value types, so when you pass in a struct onto a parameter, you are passing in a copy. It's a bit of a tricky thing, so definitely make sure you go watch that video for more detail so you don't get confused in the future. Here I defined it as a struct simply as kind of a teaching moment, but also because it just makes sense that if I just want to store some data without any logic, then it should probably be a struct and not a class. Although in this case a class would work just as well. Anyway, so here we have a struct. Inside the struct we have a field of type kitchenObject.so and another one of type gameObject. So now let's just make a list of this type that we can expose in the editor. So up here, a serialized field, private, let's make it a list of kitchenObject.so gameObject and call it kitchenObject.so gameObject.list. Okay, that's it, super simple. So let's save and make sure this compiles. So actually, let's just comment this out, just make sure our code compiles, okay? And over here in the editor, we see the tricky thing when it comes to using fields of custom types. If we look in the inspector, nope, we don't see anything, so we cannot see our custom type in the inspector. If you make a custom type like this struct, and you want to show it in the inspector, then you need to add the attribute serializable, which exists inside system. So let's go up here using system, and let's add the attribute serializable, just like this. Okay, so do this, save, and let's look. And if there we go, now we do see our custom struct. So we've got a list, and we can click on the plus icon, and there you go, we've got an element, and it does have a field for a kitchenObject.so and one for a gameObject. So that's great. With this now we have a really nice place where we can link one object to another. So let's just do exactly that. So for example, let's put the bread over there, and let's assign the kitchenObject.so for the one with bread. Let's do the same thing for all of the others. So let's add a whole bunch more. Okay, so we've got the bread, then we're going to have the meat patty cooked, then the tomato slices, then we have the cheese slices, the cabbage sliced, and finally the meat patty burned. So we've got numbers 0 through 5, so we have 6 elements, and over here, yep, we do got 6, so we have all of them. We can get rid of these last 2, okay, great. And now let's assign the proper objects, so this one for the meat patty cooked, then we've got the tomato slices, then we have the cheese slices, then the cabbage slices, and finally the meat patty burned. Okay, great, so all of the references match. Now back in the code here, so we have this list fully filled out. And when we have this, really very simple, we just cycle through the list to find the right game object. So let's do a for each of type kitchenObject.so gameObject in our kitchenObject.so gameObject list. And we check if this kitchenObject.so.kitchenObject matches the one that we received in the event. If they do match, then go into this one, grab the game object, and set active into true. Okay, so that's it, some very simple logic. And also we can start with them disabled by default in the editor, or just over here, just do something very simple. Just do a for each, cycle through every single one of them, and set every single one of them to false, so that they are hidden. Okay, so with this, all the ingredients on the plate should be visible. So here in the editor, let's just make sure all the references have been set. Let's go back, save the prefab, and let's set on play. Okay, so here we are, and by default, look at that, an empty plate, and yep, it is empty. And now let's slice some cheese. Now let's place some cheese on there, and yep, there you go, we've got some cheese. Now let's pick up some bread, drop some bread, and there you go, got some cheese and some bread. Then let's cook some meat. So let's cook it, and let's pick it up with a plate. And as soon as I go, boom, there you go, I've got a nice cheeseburger. All right, awesome. So with this, I can now do a complete burger, so let's finish it. Let's just add some more tomatoes, so slice them and add the tomatoes. And finally, some sliced cabbages, slice them, put them there, and there you go, here we have a fully complete burger. Okay, so that's great, all of our visual logic is indeed working. However, this visual is a bit hard to see, it's not very clear to the player. So just looking at it from this distance, does that have a tomato or not? There's a tiny sliver of red in there, but you can't really see it. So we should probably add some nice clear icons on top to clearly indicate what exactly is on this plate. So that's exactly what we're going to do in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to add some really nice icons on top of our plate so we can easily see what is on there. Okay, so for the icons, let's do the exact same thing that we did for the progress bar, meaning let's use a world space canvas. So let's go inside our plate kitchen object prefab. And over here, let's right click, let's create a brand new canvas. Let's name this the Plate Icons UI. Then for the settings, let's make it world space, put it on 0, 0, everything, width and height also on 0. Then let's lift it up a little bit, so put it on a Y of 1, okay, like that. Now inside, let's define an icon. So let's start by making an empty game object. Call this just the icon template. Let's put it with a size of 0.3.3, so okay, something like that. Then inside, let's add a new UI image, name this the background, and make it stretch to fill the parent, so put 0 on everything. Okay, there's our background. For the background image, instead of a square, let's actually go with a circle. For that, Unity actually has a bunch of built-in sprites that it added in the last versions. However, it's not actually over here by default. In order to see those default sprites, we need to install the 2D Sprite package. So let's quickly just go into Window, Package Manager. Let's make sure we are in the Unity registry, make sure we are looking at all. And over here, let's find the 2D Sprite package. Okay, so let's install this. Okay, there's the package. So now if we go into the background and we search for a sprite, and over here, make sure you click to actually show the assets from the packages. And now we see a bunch of default hexagons, a bunch of isometric tiles, a square, so on. And if we search for a circle, yep, here we've got a bunch of circles. So let's use this one over here on this path, so let's use it. There you go, we have a nice circle. Now let's duplicate this image, and for the second one, let's name it icon. And for this one, let's assign just a random sprite, so let's say the bread. And again, remember how the sorting order on the UI, this one is based on the order in the hierarchy. So make sure that the icon is underneath the background in the hierarchy. That way it shows up on top. Okay, so we have our icon template. That's great. Of course, we're going to dynamically generate all of this through code. We're going to have multiple icons, and for positioning them, Unity actually has some really useful components. Let's select the Plate Icons UI, and over here let's add a component. Now for example, a built-in component is the Grid Layout Group. This basically helps you position all of the child objects. So let's put the size of the canvas over here on 0.9.9. Okay, so there you go, a nice square window. Then over here on the settings for this, for the cell size, let's put it at 0.3.3. And if there you go, already shows up over there on the corner. And we can see what it will look like if we just duplicate this object. So let's make a bunch more templates. And if there you go, that's what it looks like. So as you can see, this component is super useful for automatically positioning all of the child objects. Now, if we want, we can play around all of these. We can add a little bit of spacing on the X or on the Y. But let's actually leave both those with 0. Let's leave everything on defaults. Just over here on the child alignment, let's put it on middle center. Okay, so there you go. That looks pretty nice. So you can see how this built-in component is super useful. There's actually 2 more. So this one for the grid layout, this is great when you want to put things horizontally and vertically. But if you just want horizontally, then there is the horizontal layout group. And if you just want vertically, there's the vertical layout group. So all of these components are really awesome, really useful. Okay, so with this, our objects are placed. And note how I named this an icon template. Basically, a template is just what I call something that is kind of like a prefab, but not really a prefab. Through code, we're going to duplicate this template and dynamically modify the icon. So we're going to use it very much like a prefab. We could actually make this into a proper prefab. So I could just drag it over here onto the project files and make a regular prefab. That could work. And the only reason why I prefer this method of not using a prefab is just because this object, this template, stays here on the object as opposed to cluttering over here your project files. If you have tons of single-use UI elements with tons of objects you need to spawn, you can end up with tons and tons of prefabs, and you might not even know where each of those is used. Whereas with this method, the template stays exactly where it's used and does not take an asset slot over here on the project files. So personally, this is just the approach that I prefer for spawning UI elements, but like I said, prefabs work as well, so if you prefer using prefabs, go ahead and make it. Okay, so let's make our script to run the Plate Icons UI. So let's go into our scripts, and on the scripts folder, let's create a brand new C# script for the Plate Icons UI. Over here, let's attach a script and open it. Okay, so now the first thing we need is a reference to our plate. So let's begin by making a serialized field private for the Plate Kitchen object for our Plate Kitchen object. Okay, let's save it and drag the reference. So over here, there's the plate icons. Let's just drag the plate reference. Okay, great. Now on the plate, we already made this event when an ingredient is added. So basically, we just need to listen to this in order to add the new icon. So over here on the UI, let's do, as usual, private void start. And on start, let's go into the Plate Kitchen object and listen to that event. And when that happens, let's spawn an icon. Although here, let's actually use a different method from the one we used on the plate visual. Over here on the plate visual, whenever we had the event, we really just modified the object that was added. So over here, the equivalent would be to spawn a new icon whenever that one was added. But instead of doing that, right now let's listen to this event, and when this happens, let's update all the icons in this display. Basically, this other method is useful when the contents can be added as well as removed. Now in this case, they are never going to be removed, so in this case, both methods work fine, but still I want to show you the second method just so you can use it when you need it. So for that method, we just need to know exactly what is on the plate. So over here on the plate kitchen object, we just need to expose the kitchen object SO list. So let's do exactly that. So public, we're going to return a list of kitchen object SO. Let's call it get kitchen object SO list. And we just return the kitchen object SO list. Okay, very simple. Then over here on the plate icons UI, let's just make a function to update the visuals. So private void, let's call it update visual. And when we have the event, let's call our update visual. Okay. So now here, let's basically just cycle through all the ingredients. So let's do a for each kitchen object SO in the plate and get the kitchen object SO list. Okay, so we're cycling through all of the ingredients on the plate. And then we want to duplicate our template. So that means we need a reference up here. So let's add a serialized field, private, type transform, call it the icon template. Okay, and let's save the code. And over here in the editor, let's drag the reference. So let's drag the icon template. By the way, I left the others over here. That's not a problem since these are going to be destroyed, those we're going to see in a little bit. The only one that matters is the first one. Okay, so here we have the icon template. So to spawn it, we do it just like we do with any prefab. So we just call instantiate, pass in the icon template, and then transform parent. So let's put it as a child of this object. This part is important. We need to make sure the object is spawned as a child of this object. If over here you put something like null, then the template won't be spawned as a global object, so it won't be somewhere in the world. So in order to make it positioned properly, let's make sure to use transform to become a child of this object. Okay, and then since we're using the other script, the grid layout group, this is already going to be automatically positioned. So just like this, it should be spawning the icon. And with the icon spawned, all that's left is really just setting the image. And now again, the quick and dirty approach would be over here when we spawn. Let's say we pick up the item transform. And over here, we could go inside and do a find in order to find the image, in order to get the component of type image and so on. So that is one approach. That would be the quick and dirty approach. But again, we want to do things properly. So let's do it the proper way instead. So instead of this, let's make a proper script that we're going to run on the icon template. So let's create a new script. So a new C# script, call it the plate icon single UI. So this one represents just a single icon. Let's go ahead and attach it to the template. So over here, let's drag it. And now when using this template method, really the only one we need to worry about is this one. The other duplicates, we can just leave them. They don't really matter. But still, just to avoid confusion, I'm actually going to delete them. So okay, we just have one icon template, okay, and it has our script. Okay, let's open. Now over here, let's basically just make a function to set a kitchen object SO. So public void, let's call set kitchen object SO. And we receive parameter of type kitchen object SO. Okay, great. So then we need to set the image. So let's just go into a serialized field, private of type image, which is inside unityengine.ui. So for this one, for the image, we have a reference, and then we set the image.sprite, go into the kitchen object and grab the sprite. Okay, so all we need to do is drag this reference. So over here in our template, let's drag the icon image. Okay, great. So now back here on the plate icons UI, so we spawn it, that's great. Then let's do a get component in order to get our script. So the plate icon single UI, okay. And then we just call set kitchen object SO and pass in this. Okay, that's great, this is much better. Now again, you might be thinking that this method is a lot more verbose than just setting the image sprite here. We had to create another completely new script. We had to write this logic and over here get it and use it. The quick and dirty approach would indeed be quicker, but remember that while the quick and dirty approach might be faster at first, it will mess you up over time. So just take a few extra seconds to do things properly. This approach is much more scalable. Let's say, for example, on this function, you want to change not just the sprite, but also trigger some kind of spawn effect or animation. With this, it's very simple. We've got this function right here. We receive the kitchen object SO, and we can do whatever we want with it. So like this, we have this script that is responsible for anything related to the single template. And we've got the general one, which just spawns them and just gives them the kitchen object SO. So all of our logic is nicely separated. Okay, so just like this, it should already work. However, like this, you might already be thinking, won't this spawn way too many icons? And yep, it will. Basically, every time we add an ingredient, we're updating the visual, where we're cycling through every single one and spawning all of them. So with this, we're constantly going to spawn more and more items. This is not what we want. Over here on the update visual, we do want to update and spawn all of the icons, but before we do that, we actually need to clean it up. We need to clean up the icons from the previous event. So before we do that, let's just cycle through all the children on this transform. So that's pretty simple. You can just do a for each transform child in the transform. So this way cycles through all the children, and then just call destroy on this child.gameObject. So that won't work, that won't destroy all of the previous children. However, of course, we also have one issue. The icon template itself is also a child. So if we do this, we're going to destroy the icon template, which then over here we're going to have an error because we're going to instantiate null. So we want to destroy all the children except for the template. So over here, that's pretty simple. We just check if the child equals the icon template. If so, then let's just skip it. So we can just call continue, and there you go, it skips. Okay, great. So just one more final thing. If we leave the template like this, meaning the game object is enabled, like this, the template will always be visible plus whatever ingredients we have. We don't really want the template to be visible. This is just meant to be a template that we can instantiate. So that's pretty simple to fix. Let's make a private void awake, and on awake, let's grab the icon template, grab the game object, set active into false. Okay, so now the icon template won't be disabled, so it won't be visible. And then over here, when we are instantiating, the instantiated ones will also be disabled. So let's make sure we go in there and enable these. All right, that should do it. So all of our logic should be working. There's only one more tiny thing we need to take care of. This one is a world canvas, so like we saw with the progress bar, we need extra logic to make it look towards the camera, and thankfully we already wrote an excellent generic script to do just that. So let's go into the plate icons UI, and let's add a component, and let's add our very nice look at camera. So like this, and let's set the mode the same that we use, so let's put it camera.forward. Okay, so everything is great, everything should be perfect, so let's finally test. Let's leave the scene, save the prefab, and hit on play. Alright, so let's go pick up a plate, and there you go, there are no icons visible. Okay, that's great. Now I'm going to place a bread on top of the plate, and there you go, I've got a nice bread icon. Okay, great, now let's make some meat, cook it, and as soon as it's done, I'm going to pick it up, and there you go, I've got a bread and some meat. Now let's put some cheese, slice it, put it there, and there you go. Now I can easily see that plate has some bread, some meat, and some cheese. Now let's just add the rest of the ingredients to make a full mega burger. So let's add some tomatoes and add some nice cabbage slices. And yep, there you go, it works perfectly. So here we have a complete burger with everything, and we can easily see on the icons everything this contains. Alright, awesome! Okay, so here you'll learn how to make yet another super useful element that you can easily add to all of your games. Personally, I use this kind of logic a ton in all kinds of UI things. For example, in my upcoming Steam game, Total War Liberation, the items in the inventory, they're all added using this method. So there's a template and I duplicate that template. Same thing for all of the action buttons. All of those are based on having a template and duplicating it. It's a really easy way to do this kind of thing. With all of that, here we have a full plate and we can easily see what is on there. So with this, the next obvious step is to actually deliver some orders. So let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to build the delivery counter. This is where we're going to drop some items that the customers have requested in order to complete the orders. Also, just for fun, we're going to learn how to use ShaderGraph to make a simple custom shader. Okay, so let's begin by making our counter. So let's go into our base counter, let's create a new prefab variant for the delivery counter. Let's go inside and now let's find the visual for delivery counter. Let's duplicate it to make the selected. Let's go inside, modify the material. Then on the selected, make it 1% bigger, 101, add the component, the selected counter visual. Let's drag the kitchen counter like that. Okay, that's our basic setup. And also start with the kitchen counter disabled. Okay, great. Now let's make a script to run this. So let's go into our counters folder and let's create a brand new C# script for the delivery counter. Let's attach it and open. Okay, so now here as usual, let's begin by extending our base counter class. All right. Now let's override the interact function. And for now, let's actually do it exactly like the trash counter, meaning let's just destroy the object. So we just check if the player is holding something. So if the player has a kitchen object, let's go into the player, the kitchen object, and let's destroy it. However, another rule over here for the delivery counter is this is only going to accept plates. So let's see if the player is carrying a plate object. So player get kitchen object and test, try to get the plate. So out plate kitchen object for the plate kitchen object. We try to get this, and if it is a plate, then we destroy it. Okay, that's it. Here in the editor, let's just compile the script and drag the references, so the countertop point, and on the selected, let's drag the counter reference, and let's exit this, save the prefab, and let's drop it over here on the corner. So let's find over here the delivery counter, let's put it over there, angle it on this side, put it like this. Let's also just quickly reposition all of our counters, since we already have all of the types that we're going to use. So on delivery counter, let's put it over here on this corner, so X 7.5, 0, and Z of 2. Then next to it, let's put the plates counter, so over there, okay. Then next to it, let's put a clear counter. After that, let's put the trash counter. And then let's also put another empty one there, so let's duplicate this one. Move it up to about this, and put it like that. Now we just need to move all of these down here. So just select all of these counters, and let's move them down by about this. Okay, so on minus 5.5 like this. Okay, so everything is nicely positioned. Just over there, right now we cannot access that container, so let's actually modify those as well. Which, by the way, over here there's the canvas in front, so as I click, I'm actually selecting the canvas in the hierarchy. So here's a quick info tip. On the hierarchy, on the left side, you've got these two buttons. So one of them hides the object, and the other one simply makes it unselectable. So if I click on this, and I click through, any of the click goes through the canvas. So that makes it much easier to select over here all the items in our scene. So let's just select all of these. Okay, all of these. Now just push them all to the side and make another empty one and put it over here. Okay, that's a nice layout. Now let's just finish the rest. So over here, let's just duplicate our empty counters and place a bunch more. Let's put one more to the side. And now these ones over here, so let's put it over there and rotate it here. And duplicate another one, and another one, and another one, and just one more. And get rid of this one. Okay, great. So here we have pretty much our complete map. Let's also just move the camera a tiny bit, just make sure that it is nicely organized. So put it over there, just so everything is nice and centered. Okay, so there's our map. Now let's get back to working on our delivery counter. We already added this code, so let's just quickly test. So here we are, and if I pick up something like, for example, some cheese, go into the delivery counter and interact, and nope, nothing happens because that one only accepts plates. Now if I pick up a plate, go there, deliver, and yep, there you go, it does work. Okay, great. So this is the basic logic that we want. For defining the actual recipe logic, we're actually only going to do that in the next lecture, but for now, let's add one more nice thing. Let's add a simple custom visual over here using Shader Graph. This is a great way for you to learn the power of Shader Graph and just how easy it is to use. This is a visual tool for making shaders. It's really very easy. Personally, I don't know how to write shaders with code, but I can build some pretty nice things using Shader Graph. As usual, I have a dedicated video on it. I also have an entire playlist showcasing how to make all kinds of interesting effects, and even one special video covering some changes in recent Shader Graph versions. So over here, let's learn the basics how to use it. So first, here in our project window, let's create a brand new folder. Let's name it just shaders. And now inside, let's create one. So let's create, then go up here into Shader Graph. Then we're using URP, so let's go inside there. And here we've got a bunch of options. Now don't worry about picking the quote-unquote wrong option. All this does is just create a template. So for example, if you accidentally create an unlit shader, you can then easily swap it out for lit. So right now, let's go with the unlit shader. And for the name, let's name it Moving Visual. Okay, there's our Shader Graph file. Now let's just double click to open it. And up here we have the nice Shader Graph window. By the way, you can make this full screen. So you can either right click over there on the tab and maximize, or alternatively, you can just click on this window and you can use the hotkey Shift Space. And yep, there you go, it does maximize. Okay, great. Now, by default, we have this down the center. This is called the master stack. These are the actual properties that we're going to need to use. Then on the left side, we have the properties blackboard. On the right side, we've got the graph inspector. And finally, down here, we've got the main preview. All of these windows can be scaled. And also, if you don't see these windows, or if you accidentally hide them, they're all up here on these three buttons. So the blackboard, that's on the left, the graph inspector, and the main preview. Okay, so now here we've got a nice empty board, so we can add whatever nodes we want. So we can right click and go into create node. and then we can write something or just click anywhere and press on space, and there you go. Now we can cycle through and browse all of these menus to see all of the nodes that exist. There's tons and tons of them. Or alternatively, just go up here and use the search bar. So for example, let's find the sample texture to the node. So here it is, this one. Okay, we've got this node. What this one does is it takes a texture and grabs the color from it. So on the left side of the node are the inputs, and on the right side are the outputs. Within the parentheses, you can actually see the types. So for the input texture, this one is of type T2, so that means it's a texture 2D. Then on the output, you can see there's a 4, meaning it contains 4 floats, which in this case refers to the 4 colors. So that's red, green, blue, and alpha. So for an input, we want a texture, so let's add it over here as a property. Let's click on the plus icon, and we've got a whole bunch of types. For the texture, we want a texture 2D, so let's go with that. And then for the name, now usually there are 2 standard names. There's one called main text or base map. Main text used to be the more common name, but when working with URP, for some reason they decided to name the main texture as base map. So over here, let's stick within the URP standard and just call this base map. Okay, there's our property, and if we click the selected, and on the right side we can see the graph inspector, and we can see all the properties for this actual property. So we see a name, reference, and a bunch more things. Now the really important one is over here, the reference. This is the actual name that you're going to use if you want to interact with this shader through code. The name on the property, this one is just a text string, so this can be whatever you want. You can even have spaces and so on. Whereas the reference name, this is the really important one. And by default, when you set up a name, it should already set the correct reference. Usually the standard is to name it just like the name, both without any spaces and with an underscore in the beginning. So just like this. Okay, then we can give it a default texture. So let's go ahead and select something. For example, over here, the bread texture. Remember, this is just the default. This will not be hard-coded directly into the shader. We can then modify this. Okay, so we have our nice base map property definition. Now we can just drag it over here on the board, and yep, there it is. And now we can just click on the circle icon in order to drag a connection, and let's connect it over here onto the sample texture to the input. And yep, right away we do see it does work, so we are correctly sampling the texture. However, if you look on the main preview, over here there's still nothing. That's because we don't have this node connect to anything. We need to connect it to the final master stack in order to render something. So again, on the output over here, we can see a 4. So these are all of our colors. And actually, one very useful node is the preview, since so many things in Shader Graph can be hard to visualize. So we can move these nodes around, and let's add the preview node. And this does exactly that. So you can fit it an input, and you can see down here what that input contains. So for example, let's drag just the red channel. And if there you go, over there, we can see the red channel for this texture. We can drag the green channel, the blue channel, or look at the alpha channel. Yep, there you go, it does work. So this preview node is super useful for being able to see what your shader is actually doing. Over here we have the colors, so let's get rid of the preview right now. And in order to make it work, we really just need to connect the RGBA and go up here into the base color. And right away it should work, but you might not be able to see anything over here on the main preview. I believe this is a rendering bug in the current tech version, so right now nothing is shown. So if you still don't see anything, it's actually pretty simple. Just go up here on the top left side and make sure to save the asset. Okay, save it, great. Then let's exit from our maximize view. And now let's close this tab. Let's click on play just to play the game. Now let's stop playing. And now if we open the shader again, yep, there you go. Now we do see the shader compiling over there, that color, that is the shader compilation. And after a little bit, it should work. Let's just maximize this. So yep, there you go. There we do see our texture. Okay, great. So again, this is just a simple rendering bug on the current tech version. If you're watching this video in the future, chances are you don't even have this bug, so there's no need to worry. Okay, so right now we do see it working. We can see our bread texture, and it's currently being applied on a sphere. For our use case, we're working with 2D textures, so this would be best to be seen on a quad. So we can right click over here on the preview in order to select the preview mesh. So let's go with a simple quad, and yep, there it is, we have our nice quad. Okay, great. So over here we have our basic shader. All it does is just shows a texture, that's it. Now let's actually use this. And first, let's always make sure to save the asset. On the top left side, on the moving visual, if you see an asterisk here, that means you have unsaved changes. So always make sure to save them. In my case, I don't, but still, never hurts to save. Now over here in scene view, let's go inside our delivery counter, so let's open it. And now for the display for our arrow, let's make it a flat quad. So let's right click in the hierarchy, let's create a new 3D object, and let's make it a quad. Let's call this the delivery arrow. Let's place this on top of the counter, so let's rotate it to face upwards. By the way, on the rotation, make sure the color is facing upwards. Most shaders by default, they only render one face and not the other one. So make sure you put the face with the color upwards and not the other one. Okay, so let's rotate this one upwards. So there you go, 90 over there. And let's just put it just exactly on top of the counter. So just enough so that it's visible. Okay, great. So now let's make a material for our arrow. So let's go inside the materials folder, and over here, let's create a brand new material. Let's call this the delivery arrow. Let's make sure to use this material on the quad. So let's just drag it over there on the mesh render. Okay, so it's using our custom material. And over here on this shader graph drop-down menu, over here we can select what shader we want to use. So in our case, let's go inside the folder shader graphs. And inside, yep, here we have our moving visual shader. So let's go ahead and use this. And yep, right away we do see that it does work. Here we have our texture being drawn exactly on top of our material. Okay, so far so good. Now again here, remember one very, very important thing that I said. The texture that you define the shader, over here the default for the property, this one is only the default. The important one is the one that we have on the material. I'm emphasizing this point because I've seen a bunch of people make this mistake. If you modify default texture whilst inside the shader, like for example if I change here from bread, let's say into the cabbage slices, if I modify that, note how it does not modify any materials that were created. We are only changing defaults. So if you want to change the texture that is actually used, make sure you change the one on the material that you created and not the default. I changed the default but did not change this shader. However, if I now were to make another material, which by the way, here's a quick tip, you can right-click directly on the shader file and go into create and create new material, and it will automatically create the material using that shader. And actually here it didn't update default just because I didn't save the shader. So I modified this one for the cabbage slices, and now if I save the asset, and now if I right click there and I create a brand new material, and yep, now that one does have the new default. But again, remember, what you set over here is just the default. What really matters is what is on the material. After the material has been created, modifying the default here does nothing. So always keep that in mind. In most cases, you want to be changing the property on the material itself, not the default on the shader. Okay, let's just clean up both of these. All right, so let's continue. Now here we have our sprite working, okay, except we don't want to show some bread, so let's actually use the proper arrow sprite. So let's select this one. And yep, it does work, it is printing the sprite. However, one obvious thing is that the arrow is not transparent like it should be, so let's solve that. Back in our shader graph, in order to make this a transparent shader, we need to actually go into the graph settings. So in the graph inspector, go into graph settings, and over here you see a bunch of settings that relate to the graph itself and not any selected property. So let's go into graph settings. For example, like I mentioned a while ago, you can modify between lit and so on. So this is where you would change that. You can also up here add multiple targets. So you can create a shader in shader graph and make it work with the universal render pipeline or the high definition render pipeline or the built-in render pipeline. All of those are supported through shader graph. Now for our goal, in order to make this a transparent shader, let's just go over here onto surface type, and instead of opaque, let's change to transparent. And as soon as we do, look what happens there, and if there you go, it adds a brand new alpha channel. If we just save the asset right now, and nope, look at that, it still doesn't work, it's still not transparent. Basically we made this shader transparent, but now we need to feed in the transparent channel over here onto the alpha. This is the one thing that is different from a previous version of shader graph. Previously you could just feed the alpha channel over here onto the base color, and shader graph would automatically apply it. But in recent versions, you need to add it over here separately. So if you have any issues with transparency when following some older shader graph tutorials, always remember this change. I covered that along with some other changes in a very useful video. So if you're following along some older shader graph tutorials, make sure you watch that video to learn what you need to do to update them to the latest version. Okay, so here on the symbol and texture, we already have the alpha channel, so we just connect this onto the master alpha. And right there, we already see it working. Let's just go ahead, save our asset, and here in scene view, yep, there you go, now we do see our arrow. Now, one more small thing, you might notice that from some angles it's not exactly transparent. Basically, it actually is transparent, but since we made this a lit shader, sometimes the light might make the transparent parts visible. One option to solve that is over here on the graph settings. Instead of making it lit, let's make it unlit. That would work. So yep, with the unlit shader, the transparency is perfect. But if you really want to keep it lit, then the other thing you can do is just over here play around with these settings. You've got smoothness, AO, and so on, and over here you can even modify the workflow mode. So for transparency, instead of making it metallic, let's go with a specular workflow. And then over here, set the smoothness to 1 and the ambient occlusion down to 0. And now if we save this shader, and look at that, and yep, now the transparent parts are indeed fully transparent. Finally, over here on the right side on the mesh render, if you want, you might want to play around over here with the cast shadows. So maybe you don't want this one to cast shadows. Maybe you don't want it to impact light probes and so on. Okay, so with this we have our nice transparent arrow. Let's make sure to save our delivery counter, so let's go outside back into scenes. And let's hit on play. And yeah, there you go, we have our transparent counter with our nice arrow. Now we want the arrow to actually move. And doing that is actually super simple. Going back here in our shader graph, let's just modify default just so we can see the arrow that we want to see. So let's select the arrow sprite. Okay, there's our arrow. Now for moving, over here on the simple texture, we've got an input for the UV. The UV is what defines what portion of the texture we're going to grab, which by default just gets the whole texture. So since this field represents where we're going to grab from texture, by playing around with this we can grab different parts. So to do that, let's just add a standard UV node. So here it is. This is the standard UV channel. So if we connect this, then nothing changes. Everything still renders exactly the same. But now we can modify this. And to do that, we're really just going to use some basic math. Remember that when working with shaders, even though you do see colors, everything is really just numbers. So a UV2 is just a number, the color is just a number, the alpha is just a number. So visually, everything might look like images, might look like colors, but really in the end, it's all just numbers. So for example, how do we move this texture? Well, it's actually pretty simple. We just add a number onto it. So over here on the UV, let's just add an add node. So this just adds two numbers together, very basic. So let's take the regular UV and let's add something on top of it. For example, we can make a vector 2 and let's put it on, say, 0.10. And let's add this one onto this one. And now if we drag this one onto the input, look over there on the preview what happens. And if there you go, look at that, it moves slightly to the left. So if I modify this one, put it on 0, there you go, at that, 0.1 on that, 0.2 on that, and so on. So you can see that by modifying here, I'm essentially offsetting the texture. I'm offsetting on the X, and over here I can also offset it on the Y. Basically, I'm offsetting the texture by 10%. The UV is a normalized value. This is not pixels. So that is why 0.1 is 10% regardless of how big the texture is. And if we go way past 1, then the texture essentially loops back. So this is really all we need. For our moving arrow, we're going to have 0 on the Y, and on the X, we're going to constantly either increase or decrease. That's how we're going to have our moving arrow. So again, the only issue here is that I'm modifying this manually. We don't want a fixed amount on the shader, instead we want a nice animation. So for that, we have the very useful the time node. This one has various time-based outputs. The one that we want for this case is the time, which is just the total time. This one is constantly increasing since the start of the game by the number of seconds. So if you use this over here directly on the add, and there you go, look, that texture is constantly scrolling. Okay, so that's great, except obviously we have one issue. We don't want it to scroll diagonally. We only want to scroll in one direction. So for that, we can essentially create a simple property to act as our speed. So let's over here on the blackboard, let's create a new vector 2, call it our speed property. And for default, let's default on, say, 0.1 on the X, 0 on the Y. And now if I drag the speed over here onto our blackboard, okay, great. This is basically a multiplier, so we just need to multiply the time by this. So let's add a multiply node. Also, by the way, quick tip, over here on each node, you've got a nice little arrow, so if you want to make it a bit more compact, so if you don't actually need to see the preview, so make that. And in this case, let's take our time, multiply by our speed, and then for the output, pass it into the add. Okay, so look at that, now it is indeed moving in this direction. And over here on the speed, we can play around the values. So if we put it at 0.5, now it's moving faster. And if I put it on the Y, now it's moving diagonally, put it 0 on the X, and now it's only moving vertically. Okay, so this is really what we want. Let's just go ahead, save our shader, and now let's just select our delivery arrow material. And over here, yep, we've got the speed. If you don't see it, make sure that on the speed property over here you have it exposed. So we have the speed, instead of moving on the Y, let's move on the X. And actually like this, it's reverse going backwards. So over here we can just put a negative value. So let's put it on -1. And if there you go, now the arrow is moving perfectly. Also here, let me make one important note. Just in case you're using this shader with a custom texture instead of the one included in the course, if you do that, make sure that the texture that you use, so over here I'm using the arrow texture. Over here on the arrow import settings, down here under wrap mode, make sure it is set to repeat. If you set it as clamp, you might get some weird visuals or nothing at all. In order for the texture to constantly loop and constantly repeat itself, that one needs to be set to repeat. Okay, so here it is in game and we have a really nice moving texture. For that, we created a simple but really nice, useful custom shader. Definitely go ahead and watch the various effects that I made in the shader graph playlist. This tool is super useful, definitely make sure you know how to use it. I've used it for making a building effect, I've made some nice outlines, a really nice wind shader, also a really interesting dissolve effect, and even a cool transition shader just like in the game Hades. So this really is a super powerful tool. Make sure you watch that playlist to really learn how to use it. Alright, so here we learned about shader graph and created a really nice custom shader. However, the delivery counter still only has a visual, so let's create some proper logic for generating and delivering the correct recipes in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to build a proper delivery manager that will generate recipes that the customers are ordering and validate to see if the player made the right dishes. Alright, so right now we have the player capable of making dishes. So for example, I can put some cheese, cook some meat, cut the cheese, and then pick up both of them. Then let's say pick up some bread, and there you go, got a nice cheeseburger, and deliver it. Okay, so that works, but right now they just vanish on the delivery counter. So there's no recipe we need to follow, no validation, none of that. So let's add both those things. Okay, first of all, let's make our script. So let's create a brand new C# script for the delivery manager. Let's make a new game object to run it, so a new delivery manager, attach the script. Let's make sure to keep things clean, so reset the transform. And also, by the way, since we're here, let's go ahead and put the plates and delivery counter inside the counter so everything is nice and organized. Okay, great, so let's open up this script. Now here, basically we need to define some sort of list to store all of the recipes that the customers are waiting for, which of course begs the question, what type is that going to be? Now, technically, one thing we could do, since a recipe is really just a list of kitchen objects, over here we could have a list of kitchen object. This would be our recipe list. Technically that would work, but that really looks quite dirty. Instead of having a list of a list, we should probably have a proper type for this. So let's write some good clean code and define a proper recipe scriptable object. Back in Unity, let's go inside the scriptable objects folder and create a brand new one. Let's call this the recipe SO. And over here, let's make this a scriptable object. So extend scriptable object, make the create asset menu. And over here for the fields, for the data that we need. Really, like I said, a recipe is just a list of ingredients. So just a list of kitchen object SO for the kitchen object SO list. Okay, that's it. That's really all the data that we need to define a recipe. Just to be able to identify them for the player, let's also add a public string for the recipe name. So just a nice name string. Okay, great. Now back in the editor, let's define. So let's go inside the scriptable objects and make a brand new one for our recipe SO. And now inside, let's create a brand new recipe SO. For this one, let's call it just burger. And over here, first of all, for the name, just name it burger. And then for the kitchen object list, well, to make a burger, first let's add some meat. And we want some cooked meat. We don't want to serve uncooked or burnt meat, so only the cooked meat. Then for a simple burger, obviously we need some bread, and that's about it. So some bread, some meat, that's our very basic burger. Now let's also make another one, so let's duplicate this one and name this one the cheeseburger. Over here, let's name it cheeseburger. And like name implies, has bread, meat, and obviously some nice cheese slices. So there you go. Okay, we have a cheeseburger. Now let's also make a mega burger, so something with everything. So let's call this one the mega burger. And over here for the string name for the mega burger. And for that, we have meat, bread, cheese. Let's also have some nice cabbage slices and also some tomato slices. Alright, that's our mega burger with everything. And finally, let's also make just a nice simple salad. So let's duplicate this for a salad. Let's name it salad. And for the salad, we don't have any meat, we don't have any bread, and also no cheese. So just cabbage slice and tomato slice. That's a simple salad. Okay, so here we have all of our recipes. So back here on the delivery manager script, instead of making a list of game object, let's just make a list of recipe SO, and name it the recipe SO list. This is where we're going to place the recipes that the customers are waiting for. So let's actually rename this. Let's put it waiting recipe list, okay? So the customers are waiting for whatever is inside this list. And now we could make this a serialized field and set it in the editor, but we don't want to have a fixed list. We want to periodically spawn new recipes. And in order to spawn new recipes, we also need to know which ones we can spawn. So for that, we could add a list of all of the recipes. Then we could pick a random one from the list and add it over here to the waiting list. That would work, that's one good approach. But since we already did something similar to that various times in this course, here let me teach you a different approach that sometimes might make more sense. For that second approach, we just need one thing. We need a scriptable object to hold all of our recipes. So let's do that. Let's do a brand new C# script. This is the recipe list scriptable object. And then inside, this one is going to be a scriptable object. Let's add the create asset menu. And inside, we're just going to have a list of recipe SO for the recipe SO list. So that's it, super simple. Now let's just create one object of this type. We can put it inside the recipe SO list since we're only going to have one. So let's make a recipe list SO, name it the recipe list SO. And then over here, let's just drag our recipes. So we've got a burger, a cheeseburger, we have a mega burger, and finally a salad. Okay, so basically we have a scriptable object with all of our recipes. And now, just for safety, since we only want to ever have a single one of these objects, a recipe list SO, for this one we can go back here in the script and simply comment out the create asset menu. So now back in the game, over here we can no longer create another type of recipe list SO. So just a nice safety thing since we probably only need just one. And let's also add an underscore just so it shows up at the top of the list. Okay, great. So we have this, and now over here on the recipe manager, we can basically expose that in a serialized field. So let's make a serialized field, make it private of type recipe SO list, recipe list SO for the recipe list SO. And now here in the editor, we just drag that reference. All right, that's it. So basically the difference that we did with this method is over here on delivery manager, instead of having a list of all of our recipes, we just have a reference to one object, and then that object holds a list of all the recipes. In this specific use case, like I said, this approach doesn't really have many benefits compared to just storing the list here. But let's say we had another script that also needed a list of all of our recipes. If we did that, we would basically have duplicate references. So this script would have a list of all the recipes, then some other script would also have a list of all the recipes. And then if you wanted to add a brand new recipe, you would need to add it to all the lists on all the scripts. Whereas like this, any script that needs to know about all of the recipes just needs a reference to the recipe list SO, and whenever we want to add or remove a recipe, we just need to update this one object and everything works perfectly. That's one of the benefits of this approach, where you have a scriptable object to hold a list of all of the objects of some type. Personally, I find this pattern to be quite useful. Okay, so on Delivery Manager, we have a list of all of our recipes. Now let's just make a simple timer to spawn them. Like I mentioned previously in the spawn plate logic, you could just use a coroutine if you like that. Coroutines can be useful for running timers, but personally, like I mentioned, I do not like coroutines. I don't like the pattern they force you to use. So over here, I'm just going to make a simple float timer. So a private float for the spawn recipe timer, another one for the recipe timer max, and let's say 4 seconds. Then we just do a simple private void update. On update, let's count down the timer, so time.delta-time. And if the spawn timer is under 0f, let's reset the timer. And now let's basically spawn a recipe. So for that, let's grab a random one from the list. So we go into the recipe list SO and grab the recipe SO list. Then we're going to grab a random one, so let's get a random index, so random.range between 0 and the recipe list SO dot recipe SO list dot count. So you get a random one. This is going to be a recipe SO for the waiting recipe SO. And then we simply go into the waiting recipe SO list and we add a brand new recipe. Okay, that's it. Super simple. Let's just make sure to initialize the list. So let's do here a simple awake for the waiting recipe SO list and just initialize it. Okay, so like this, it should be working. However, we're also going to generate recipes nonstop. We don't want that, so let's define some kind of maximum. So let's define a simple int for the waiting recipes max. Let's say we can have a maximum of 4 recipes waiting. And then down here when the timer elapses, so if the waiting recipe SO list.count, if it is under the maximum, then we generate and add it. Okay, that's it, pretty simple. Now for testing, let's just add a log here to print the name. So debug.log on the waiting recipe SO that we generate. So let's print out the recipe name. Okay, so let's test. So here we are, and yep, one was spawned right away. So we have a salad, and after 4 seconds, yep, there you go, another salad. And if we wait for 4 seconds, we should have another one. There you go, a mega burger recipe. And finally, after 4 seconds, we have, yep, we have another burger. And now, no matter how much time passes, there should be no more since we're at the limit. And yep, time passed and no more. Okay, all right, awesome. So we are correctly generating recipes that the customers are waiting for. Now let's have the logic to try to fulfill these orders. So over here on Delivery Manager, let's make a function to deliver a recipe. So let's make a public void, make it public since we're going to access this from the delivery counter. Call it deliver recipe. And the recipes are going to be delivered whilst on a plate. So let's receive a parameter of type plate kitchen object. And over here, the logic is actually going to be pretty simple. We just need to cycle through all of the recipes that the customers are waiting for and see if the ingredients on this plate matches the ones on any waiting recipe. So over here, let's cycle through all of our recipes. So let's do a for int I at 0, going through the entire recipe list.count, I++, okay. Let's grab the recipe SO for the waiting recipe SO, and we grab from the waiting recipe SO list on this index, okay, so we have that. Then first, let's do a quick test just to check if the waiting recipe has the same number of ingredients as there are on the plate. If not, then we already know that it's not valid. So over here, let's do a quick test. So waiting recipe SO, let's check the kitchen object SO list.count. If this one matches the plate kitchen object, let's get the kitchen object SO list and also check the count. So over here, we know that has the same number of ingredients. So this is the first check. Then we need to cycle through all of the ingredients on this recipe and all of the ingredients on the plate and basically see if both of them match. So let's first cycle through the ingredients on the recipe. So for each kitchen object SO, let's call it the recipe kitchen object SO in the waiting recipe. So let's go into the waiting recipe and get the kitchen object list. Okay, so here we are cycling through all ingredients in the recipe. Then we need to cycle through all of the ingredients on the plate. So let's do another cycle for the plate kitchen object SO. And we're going to go inside the plate kitchen object, get the kitchen object SO list like this. So here we are cycling through all the ingredients on the plate. Okay, so now here basically we need to see if this ingredient that we're cycling through, if this one matches the ingredient on the recipe. So here we check if the plate kitchen object SO, if this one matches the recipe kitchen object SO. If so, then the ingredient does match. So in order to keep track if it does match, over here before we cycle through all the ones on the plate, let's define a bool for found or ingredient found. Let's default it to false. And over here, if we have matched, then this one becomes true. And by the way, over here, we can also break out of the cycle. Now, if you're not familiar with break, basically this is going to break out of the for each. So let's say the plate has 10 ingredients and the second one matches. When this cycle gets to the second one, it triggers a break, so it no longer goes through the remaining 8. So basically it breaks out of the cycle, so it keeps writing some code right down here. Okay, so we cycle through all of the ones on the recipe. Then we cycle through the plate, and if we do find that ingredient on that plate, then we have an ingredient found. So over here, if we have a not ingredient found, then over here that means this recipe ingredient was not found on the plate. So if that happens, then essentially over here we have a fail state. So the ingredient that this recipe requires is not on the plate. So let's go up here when we have the same number of ingredients. Let's define a boolean called the plate contents matches recipe. Let's default it to true. And over here, if we don't find at least one of them, then the plate contents do not match the recipe. And afterwards, we can check this bool again. So if this one is true, that means they all match. If just one of them does not match, then this one won't be false. So over here we know player delivered the correct recipe. So over here let's do a quick debug.log and print out a message. And after we do, let's also do a return so we stop the rest of the execution. So basically if we find a waiting recipe that matches, we don't want to keep going. And also here, if we do find it, let's also remove it from the list. So let's go into waiting queue, remove at, and remove at this index. Okay, so we're going to remove this recipe. But if this doesn't happen, then it's going to keep cycling, and it's going to cycle through all the recipes. So basically, if it reaches the end of this for, then basically no match is found. So the player did not deliver a correct recipe. So let's do another debug.log in here. Okay, so this is all of our logic. It looks a bit complex, but I hope this was easy to follow. When we see it in action, it all becomes a bit more clear. So all that's left is just calling this function from the delivery counter, so let's do that. Over here on the delivery counter, it accepts plates, it destroys plates, but before we destroy, let's go into the delivery manager, which means we need to access a reference. So again, we could add a serialized field, or in this case, it makes perfect sense to make this a singleton. So let's make it here, public static of type delivery manager, call it instance with a public get and a private set. Okay, then over here on awake, let's set instance equals this. All right, so now over here on the delivery counter, we can go into the delivery manager, access the instance, and deliver our recipe and pass in the plate kitchen object. Okay, that should do it. Let's test. Alright, so let's look in the log to see what they are waiting for. So there are 2 cheeseburgers waiting, another mega burger and a cheeseburger. So let's make a cheeseburger to deliver. So first of all, let's cook some meat, let's slice some cheese, let's pick up the meat before it burns, pick up the cheese, and we just need the bread. Okay, this is a valid cheeseburger, so let's deliver it. And if there you go, the player delivered the correct recipe. Okay, great. Now let's deliver something that nobody asked for, let's say just some meat. Actually, let's burn it, just for fun. Alright, so there we have a bunch of charred meat, so nobody really wants this, but if we deliver, yep, there you go, player did not deliver a correct recipe. Alright, awesome, so over here everything worked. We have a bunch of recipes being generated, and then we have the logic so that when the player delivers something, it checks if the player delivered something correct or incorrect. So everything is great. All that's missing is obviously some nice UI, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to create a nice UI visual to display our waiting recipes. Okay, so our delivery manager is already working. We are randomly spawning some random recipes every once in a while. Now instead of looking at the console, let's add a proper UI. So for that, over here in the editor, let's go inside the canvas. And by the way, let's click on the button to unlock the canvas. And this is actually the first time we're using the regular canvas. Quite a while ago we just created it, we didn't really set it up, so let's quickly do that. For the random mode, this one is meant to be a regular UI, so let's leave it on the screen space overlay. Then over here on the canvas scaler, instead of constant pixel size, let's go with scale with screen size. Then for the reference resolution, I like to use 1920 by 1080. And finally, I like to fully match with the height. Basically, this means that objects in the canvas will only be scaled if the height changes. For example, let's add inside just a quick UI image just to test. Let's look in the game view. So there you go, there's the image. Let's just put it on a different color. Okay, so there's the image. And note how if I modify the aspect ratio here, so let's say I put it on 5:4, there you go, the horizontal size of the window changed, but note how the element was not scaled. So I can put it even on free aspect, so really wide and does not change the size. Whereas if I modify this, if I modify the vertical size, the image does indeed get scaled up or down. Personally, I like the setup because it means that I only have to worry about positioning things horizontally. If the vertical part gets changed, everything gets automatically scaled. Okay, so great. So over here, let's go back into Full HD, alright, and let's get rid of the image, alright. Back in the scene view, let's quickly look at the canvas, so we can select the canvas, press the F in order to zoom out, and also we can press the 2D button up here to go into 2D mode. Okay, so here's our nice UI. Now inside the canvas, let's create an empty game object, call it the Delivery Manager UI. Then in the inspector, let's make it stretch to occupy the whole thing, so let's put 0 on everything. Okay, so this window now occupies the entire screen. Now inside, let's do just like we did a while ago for the plate icons, meaning let's make the template that we can then clone, but let's also put those templates inside of a container. So first of all, let's make the container, so a new empty game object, call it just the container. The reason why I'm going with this approach is because I also want to have other objects outside of here. If you remember how we did with the templates, we can actually go there and see. So let's go inside the prefabs, inside the counters. Actually, it's on the kitchen objects, so let's go inside the plate. Over here for the template, basically we use the plate icons UI, this main canvas as the container. But if you remember how we did that, in order to make sure we didn't end up with duplicate icons, we always destroy the previous one when we spawned a brand new one. So every time we were cycling through the children of this object in order to destroy all of them except the template. So over here we're going to use a container so that we can apply that logic only to the children of the container, and that way we can have other objects outside of the container. For example, outside of here, let's say we want some nice text just saying recipes in waiting. So on the Delivery Manager, let's make it a child of that one. Let's go into UI and let's make a text Mesh Pro. And this is the first time that we're using Text Mesh Pro, so this window pops out. Let's actually import the Text Mesh Pro Essentials. Okay, just let it import. Okay, that's it. We don't need the examples or extras, so let's just close this window. And over here on this window, let's name this the title text. Let's set the text to something like recipes waiting. Let's put it up there on the corner, so let's anchor it on the top left corner. Also for the text, I like to put it on a width and height of 0, but of course that makes the text really vertical. So then down here on the wrapping, let's just disable it. So there you go, looks like that, and let's put it over there on that corner. Now in scene view, we are seeing things different. So if you want to see what this looks like, just go into the game view, and over there, yep, we do see the recipes. Let's just make it in bold. So there you go, just some nice text. Okay, so that's our text. And then for the container, let's make inside the delivery template. So let's create an empty game object. Let's call it the recipe template. And for this one, we're going to want to anchor it to the top left corner. So with the template selected over here in the inspector, let's click, and we want to click up here. However, we also want to set the pivot. So let's make sure to hold down Shift in order to set the pivot over there. Okay, great, that's exactly what we want. So we want the template right in the corner. Then let's give it a size of, say, 250 by 100, okay? Now inside the template, we just need two things. We want the name of the recipe as well as the list of all the ingredients. Although before that, let's actually make a nice visual for the background. So a new UI image for the background. Let's make this one stretch to occupy the whole thing. Let's put everything on 0. Okay, that's the background. Let's put it on a black with just a little bit lower alpha. Okay, that's good. Then for the name, let's make a text field. So inside the template, let's create another text. Call it the recipe name text. Then over here, let's put it a bit small. So on a font size of maybe just 20, let's put it in bold. And let's also again put the width and height of 0. And over here, make sure to disable wrapping. Okay, so that's the text. So we've got it up there. Let's just anchor it to the top left corner. Okay, great. Over here, we can change the name to recipe. And then what we need is the icons down here. And for that, we're going to do pretty much the exact same thing that we did on plate. But before we do that logic, let's just get this basic setup working. So let's just position everything. So first of all, the container for all the templates, let's anchor it on the top left corner. And let's push it all the way over there. And for positioning them, let's use this time the vertical layout group. So inside, let's duplicate the template just to be able to see them. Okay, so that's pretty much what we want. We can actually set the width and height both to 0, and let's set the spacing to something like 30. Okay, so that's our basic UI. Now let's make the script to run this. So over here in our scripts, let's create a brand new C# script for the delivery manager UI. Let's go into the parent game object and let's attach the script. Let's open. Okay, so now here, first we need a field for the container and another one for the template. So let's do a serialized field, private transform for the container, and another one for the transform, and this is going to be the recipe template. Then let's do pretty much the same thing we did previously. So first of all, let's actually go on awake in order to hide the template. So game object set active into false. Okay, so first we hide the template. Then let's make an update visual function. So private void update visual. And for updating, we're going to do the exact same thing that we did. So first, let's cycle through the container and destroy everything except for the template. So do a for each transform child in the container. And if the child is the template, if so, then we're going to continue. And if not, we're going to destroy the child game object. Okay, so we have the cleanup. Now all we need is to cycle through all of the waiting recipes. So that means that over here on Delivery Manager, we need to expose our waiting recipe SO list. So let's go down here, make a function to do that. Public going to return a list of recipe SO, get waiting recipe SO list, and we just return the waiting recipe SO list. Okay, great. So now here on the UI, we can now go into Delivery Manager, access the static instance in order to get the waiting recipe SO list. So let's cycle through this. So do a for each recipe SO in the waiting recipe SO list. And for each of them, let's instantiate and let's spawn our recipe template, spawn it inside the container. And then we just need to set this to enabled. So let's grab the transform for the recipe transform. We grab this one, grab the game object and set active into true. Okay, so like this, the only thing missing is the text, but that's okay for now. Let's just see where we're going to call this function to update the visuals. And as usual, we want to be smart and write some good clean code. So let's not do the dirty approach of just updating this on every single update. Instead, let's only call this function when something actually changes. So over here on the Delivery Manager, let's just make some simple events. So public event handler. Let's call on recipe spawned. And another one, call it on recipe completed. And actually, as soon as I add the event handler, which also add the using system, now here we have an interesting thing. We've got a nice namespace collision. It's telling us that random is an ambiguous reference between UnityEngine.random and system.random. That is because both these namespaces, UnityEngine and system, both of them have a class named exactly random. So the code here does not know which class we're trying to use. To solve this conflict, we really just need to be more specific. In this case here, we want to use the UnityEngine version, so let's just write the full name UnityEngine.random. And yep, that works. Okay, so now let's fire off the events. So first of all, the on recipe spawns over here. When we spawn a recipe, let's invoke this event. So this event targs.empty. And let's also get rid of the log. We no longer need that. Okay. Now we could also add the waiting recipe on the event targs, but in this case we don't need it. Just firing the event is enough. And then down here, when the player delivers something, if the player delivers the correct recipe, we remove it from the list. And then let's fire off the event. So on recipe completed, let's invoke with this and event targs.empty. Okay, so we have the event, and down here we also don't need a log. Okay, so that works. And finally over here on the delivery manager UI, let's just make a private void start. On start, going to delivery manager, access the static instance, and listen to both these events. So the spawn, and let's also listen to the other one. So delivery manager instance on recipe completed. When either of these work, let's just go and update the visual. So just like this. Let's also rename this because again, instance doesn't sound like a very good name. Let's actually rename this to delivery manager, and same thing up here. By the way, I'm using the Visual Studio shortcut Ctrl+RR in order to rename this to delivery manager. And finally, we also need to update the visual on start, just to make sure the previous ones do not show up. Okay, that's it. So like this, it should be working. We should be able to see no visual, and then as more are spawned, we should be able to see each one being spawned until the maximum. So let's see. Just over here in the UI, let's make sure to drag the references, so the container and the template, and let's hit on play. And okay, right away, actually it spawned one recipe, it spawned instantly. Then after 4 seconds, there you go, a second one. And after 4 seconds, we should be able to see, yep, another one. Now 4 more seconds, and we should see the final one. And now, no matter how long we wait, it should no longer spawn anymore. And yep, that works. All right, awesome. So the basic logic is working. Now let's handle the proper logic on the template. For that, like I mentioned previously, one approach would be over here. You could go and do a transform.find, find the actual recipe name text, then get the text mesh component and set it. That would work, but like I mentioned previously, that would be very dirty, not good at all. We should avoid using find at any time, and we should also avoid the individual logic from the total logic. So let's do it properly and make a proper script to handle each spawn template. So let's create a brand new C# script. Call this delivery manager single UI. Single just because it refers to a single recipe. And also right now we already have quite a few UI scripts. So let's organize our project again. So let's organize a new folder for the UI. And inside let's put all of our UI scripts. So delivery manager single, this one, the plate icons, and the progress bar. So let's put all of these nicely organized in the UI folder. Okay, so with the script, let's go into the recipe template and attach the script. Now let's open. And over here, let's begin by adding a field for our text. So a serialized field. And over here, it's also very important. For the text, we are not using the text inside Unity Engine.ui. This is the legacy text. It is not TextMesh Pro, so this is not what we were using. Instead, we want to use TextMesh Pro UGUI, which is inside TM Pro. So we need to go up here and add using TM Pro, and now we can use this type. And also make sure you're using TextMesh Pro UGUI and not TextMesh Pro. This one also exists, but don't mix these two. These are two very different types. If we go over here in the editor, and if outside the canvas, if I just create a new 3D object, a new text object, if I do that, then if we look over here in the inspector, we see this one is of type TextMesh Pro. Whereas for the ones that we're using inside the canvas, if we look, this is TextMesh Pro, it's a UI text. So these are the two different classes within TextMesh Pro. You have TextMesh Pro and TextMesh Pro UGUI. We're working on the UI, so we want this one. Okay, so we named this the recipe name text. Okay, that's it. Over here in the editor, let's drag our reference, all right. So in the script, let's make a function to set the recipe. So a public void, and let's call it setRecipeSO. And we're going to receive a recipe.so. Then we just go into the recipe name text and we set the text to recipe.so.recipe_name. Okay, so that's pretty much it. Now over here on the UI script, when we instantiate our recipe transform, let's get component of type of our delivery manager single UI and call setRecipeSO and pass in the recipe.so. Okay, so let's see if the name shows up. And yep, right away it does show up, so we can see that we generated a cheeseburger recipe and right now a mega burger recipe. Okay, great. So all that's left are the icons down here. So like I said, that is going to be yet another usage of our template pattern. So inside the recipe template, let's create an empty game object, call it the icon container, And then inside that, let's make the template. And template is just going to be an image, so we can just create an image straight away. Call it the ingredient image. Let's scale it with a size of 40 and 40. Let's put an image by default, just like that. And on the icon container, let's put the width of 0, height of 0. And let's put a horizontal layout group. Put it over there on the left side. And we can create a bunch more just to see how it looks. Okay, so that's pretty much it. Now over here on the single script, let's add a serialized field, private transform for the icon container, another one for the icon template. Then we do the same thing as usual. So when we set the recipe SO, let's first of all clean up the container. So let's do a for each transform child in the icon container. And if the child is the template, then we want to continue and ignore it. If not, we want to destroy the child.gameObject. Okay, so that's the cleanup. And then let's do a for each kitchen object SO in the recipe SO.kitchen object SO list. Second through all of this, let's instantiate our icon template. Instantiate it inside the icon container. So this is going to be the transform for the icon transform. Then as usual, we need to go into the game object, set active in order to enable it. And also let's go up here, make a private void awake, and on awake the icon template game object, let's disable it. Okay, we don't want the template to be visible. Okay, so we instantiate the template, we set it as active. Then since this one just has an image, we can just do a get component of type image. That's image, not image conversion. So image, so it's this one, the one inside unityengine.ui. So let's get this image and let's modify the sprite and set it to this kitchen object so.sprite. Okay, so that's it, that should do it. Let's test. Over here in the editor, let's just go into the template. Let's drag the container reference and the template reference. And let's also rename this instead of ingredient image, put icon template just to be a bit more clear. And we can get rid of the other ones or leave them, doesn't really matter. Okay, great. So let's hit on play and see. And yep, right away it does work. So we can see a burger is composed of a burger and a bun. A salad, yep, there you go, some sliced cabbage and sliced tomatoes. Then cheeseburger, same thing as the burger with some cheese. And then another burger, let's just deliver until we see the mega burger. So let's deliver a cheeseburger, let's cut it. Get this, get some bread, place it in there, pick it up before it burns. That's a cheeseburger, so that one should vanish. And yep, there you go, it does vanish. Let's see if something else, not a cheeseburger, so let's keep doing until we get the mega burger just to see that everything works. So let's deliver a regular burger. Okay, now let's deliver a regular salad. Okay, just pick up like that, and drop it. Okay, let's see. And yep, there it is, the mega burger. Alright, great. So the visual logic is fully working and the delivery logic, all of it is working. So I can deliver the right recipes and get rid of them from the recipe waiting list, and more are spawned every time. Here we can see the name of the recipe as well as all of the nice icons. Okay, so with all of this, our game is really taking shape. Everything is very close to being done. One massive thing we're still missing is an obvious one, which is sound. So let's do that in the next lecture. Hey again, quick intermission. You're almost at the end, so once again, congrats for making it this far. This is the second secret callout. Go ahead, post in the comments a timestamp and a nice monkey emoji. It will be fun to see how many people make it to this point. By now you already know about the website. I hope it's been very useful to you. And you already know to ask any questions in the comments if you need help with anything. So all that's left for me to say right now is thanks for watching the course so far, and I really hope you've already learned a ton. There's only a bunch more lectures until we get to the final polished game, so let's continue on the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to add some audio to our game, starting with a really nice music track. Okay, so our game is already looking pretty good, but everything is still way too silent, so let's begin by adding some music. Adding this is actually extremely easy to do. In the included assets over here inside the sounds, we've got a really nice music track. I hired the musician to make this, it sounds really good. It's a seamless loop, so to add to our game it's going to be super simple. We just want a constant, never-ending loop. So let's begin by creating an empty game object, call it the music manager. Let's reset the transform, keep things organized, and let's add a component, and we want the component an audio source. Here it is, this one. Like the name implies, this one acts like a source of audio. You will note how by default on the main camera, down here, it already has an audio listener. So the source plays some sound and the listener listens to it. Now over here we just need to set these fields. So for example on the audio clip, let's make sure to drag the music audio clip. Okay, great. Next over here, let's enable play on awake. We want it to start playing right away. And for this track, we do want to enable looping. Okay, great. Then for priority, basically Unity has a limit to how many sounds can be played at once. If you play too many, then some sounds won't play. And which ones do play is all based on priority. We always want the music to play, so let's put this one on max priority. Then for the volume, later on we're going to make a proper option screen to handle this. But for now, let's put it on something like 0.4 or 0.5, just to make a nice background track. Then we have here the spatial blend. For this music track, we want it to play the same regardless of where the camera is. So let's make this all the way fully a 2D sound. Okay, and that's it. We don't need to play around with any of the other settings. And just like this, if we are on play, and yep, there's the music. Now, if you're not hearing anything, make sure that on the game view, first of all, that the game is actually selected. Make sure the scene is in focus. So over here I can move around, so the game is in focus. Then on the game view over here on the top right corner, make sure this sound icon is toggled. If not, then everything is muted. And also again, make sure, like I mentioned on the main camera, that it has the audio listener component. With all of that, yep, you should be able to hear the music. Now this song is playing and it will loop forever, just like we wanted. Personally, I really like how it sounds. I'm really happy with what the composer made. It perfectly matches the vibe of the game. So it really is this simple to add some music to the game. Let me just point out one thing also related to sound. One of the things you can make is an audio mixer. So for example, on the project files, let's create a brand new, and let's find over here the audio mixer. So there you go, here is an audio mixer, then you can double click to open up the audio mixer window. And then over here you have the master node, and then you can create multiple groups. So let's create a brand new group for something else. And then you can play around over here with the effects, with the volume, all kinds of things, all kinds of effects, everything. Then for each sound where you have the audio source, over here note how you have an output. And for this output, you can set it to play on the master, so it plays on everything, or set it on just one individual group. So with this, you could assign a group to one individual type of sound effect or the music or so on. Maybe you could even have your music split into multiple stems. So there's lots you can do, but for me, I'm not an audio engineer. Audio is probably the part of game development that I know least about. I just stick with the absolute basics. But if you want to learn more, definitely look into the audio mixer. This is an extremely powerful tool. But like I said, for me, I don't know how to work with it, so I'm just going to stick with the basics. So on the output, let's revert back into none, close the audio mixer, and get rid of this. And there it is, the music is playing, and it all sounds really nice. Alright, so here we very easily added some music to our game. This lecture is actually super short because it is genuinely that simple. Now the next thing that we need is going to be a little bit more complex, and that is adding sound effects. So let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to add some sound effects for our game. Okay, so previously we already added some really nice music, now let's add a whole bunch of sound effects. In the project files, if we go inside the assets over here, we've got all kinds of sound effects. Basically I hired a really nice sound designer to make all of these, and I think they all sound really great, so let's add them to our game. Now when it comes to sound effects, there are two main ways to play a sound. One is just like we did for the music, so we can create a game object, add the audio source component and play it. That's one approach, but that basically requires pre-preparing the sound objects. So there is another simpler way that just requires one line of code. So let's begin by making a sound manager game object, so a new empty game object for the sound manager. Let's reset the transform. Now let's make our script, so let's go in the scripts folder, create a brand new C# script for the sound manager. Let's attach the script and open. Okay, so now here let's make a function to play simple sound. So let's do a private void, just call it play sound. And over here the way we play sound through code is actually super simple. We just go inside the audio source class. And in here there's a static function, play clip at point. This, as you can see, takes an audio clip, a vector3 for the position, and finally a volume. So basically it won't play that sound on that position. By default, Unity already has 3D sound. So if you play the sound on the left or the right side of the camera, it won't play in the correct place. Also for the volume, the further away it is from the camera, the lower it will be. And if we don't want the 3D sound, we can just play directly on top of the camera position. Okay, so in this function, let's receive our arguments. So for the audio clip, it's going to be our audio clip. Then let's receive vector3 for the position. And let's also receive an optional one for the volume. Let's just default this to 1F. Okay, so here we just pass this into our function, so the position and the volume. Okay, great. So now let's call this nice function. And for example, let's start with a simple one. So let's start with the delivery sounds. So over here on the delivery manager script, down here we have the logic for delivering a recipe. And over here we know when we completed a successful recipe or when we failed and the player delivered a wrong recipe. So this is where we want to play some sounds. And again, here we have yet another very important clean code question. We could technically call the playSound function directly from here. That would work, but of course that would make this class tightly coupled with the sound manager. For a simple game on this scale, that approach can work, just play sounds directly from the logic code. However, again, to make things properly, we should really separate the logic from the sound, just like we separated the logic from the visuals. So instead, let's not call the sound directly from here. Instead, let's make two more events. So let's make one on recipe success, and another one on recipe failed. Okay, so now let's fire off these events. So over here we have the success, so on recipe success. And if we get down here, then we have a fail. So on recipe failed. Okay, great, we have two events. Now back here on the sound manager, we can just listen to those. So let's do a start, go into the delivery manager, access the instance, and listen to the on success and on failed events. So listen to that one, delivery manager, instance, on recipe failed. Listen to both of these. Again, let's write some good clean code. So let's rename this one instead of instance. Let's put it delivery manager. And same thing on this one. Also name it correctly, delivery manager. Okay, great. So now when you have this, we want to call play sound. And now we want to pass in a reference to the recipe failed sound. So technically one approach would be up here to add a serialized field for an audio clip. That would work. But since we've already done that so many times in this course, here let's use a different approach that I also like to use. Let's create a scriptable object to hold a reference to all of our sounds. So similar to how we define the scriptable object to hold all of our recipes. Let's just comment this out just to make sure the code compiles. Okay, great. So back here in the editor, let's make a new scriptable object type. So let's create a brand new C# script for the audio clip refs scriptable object. Now here, let's make this a simple scriptable object with a create asset menu. Okay, so now for the fields, if we look in the S over here, the audio designer that I hired actually made several variations for each sound. So we've got multiple chops, multiple delivery fails, and so on. So back in the code here, instead of storing a reference for a single audio clip, let's store an array for all of them. So we have the chop, then we have all the others, so let's just add all of the references. So there's a chop, there's the delivery fail, then we have delivery success, then we have footsteps, then the object drop, then the object pickup, then we have the stove sizzle, although this one is just one, then we have the trash, and finally we have the warning. Alright, so these are all of the sound references we're going to use. Back in the editor, let's just create the object. So on the scriptable objects, let's create a brand new one. Let's make it of audio clip refs SO. Just name it audio clip refs SO. And over here, let's just drag the references. So let's use that quick Unity tip in order to unlock the inspector. Now I can select all the chops and drag them. All delivery fails, drag them. Delivery success, drag it. Then for all of the footsteps, after that are all of the object drops. Then the pickups, then we have the sizzle, which is just one. Finally, we have the trash and the warning. Okay, those are all the references. So our scriptable object now has all of the data we need. Let's unlock the inspector, okay. And back in the code here on the sound manager, let's make another version of this function. So let's make one play sound, except instead of receiving an audio clip, it receives an array of audio clips. Then basically we just call the other function. So we call the other play sound function and pass in an audio clip from this array. So let's actually rename this, so audio clip array. And let's pass in an audio clip from here. So do a simple random.range between 0 and the array.length. Pass in the position and the volume. Okay, so just like this, now all we need is a reference to our scriptable object. So a serialized field, private, of the audio clip refs SO. Okay, we have this. Then here in the editor, let's just assign the reference, so the audio clip refs. Okay, great. And over here, when we have the recipe failed, let's go into the audio clip refs. And let's pick up, this one is delivery fail. And then the other one is going to be delivery success. For the position, let's just default to the camera.main transform.position. So like this, the sounds will play exactly on top of the camera. Okay, so let's test and see if it all works. Okay, so here we are, and let's do a wrong delivery. Now, quick warning if you're following along, or if you're just watching the video, this sound will probably be way too loud, but let's test. So if I just pick up the plate and I just deliver an empty plate, yep, there you go, there's the sound. And now if I deliver a correct one, so someone wants a salad, so let's cut a nice salad, chop that, chop this, pick up the plate, pick up that one and that one, deliver the correct salad, and yep, there you go, it does work. Alright, great. So the sound effects work, they played perfectly, but they're a bit too loud. Basically that's because these sounds were designed to be played in the world rather than on top of the camera. So when we play the sound, let's actually play it on the position of the delivery counter. Here is the delivery counter script. And based on our design, we're only going to have a single delivery counter, so we can just make this a singleton. So as usual, public static of type delivery counter, call it instance, with a public get and a private set. Then on private void awake, let's just set the instance equals this. Okay, so now over here on the sound manager, we can just grab delivery counter, and we just go in delivery counter and grab the static instance. And then for the sound position, we can just go in delivery counter, access the transform.position. Okay, so just like this on that one and on this one. Okay, so let's test, now it shouldn't be as loud. Okay, so here we are, and let's do a wrong delivery. And yep, it does work. Now let's do a successful delivery, so let's make a nice cheeseburger. So grab some cheese, slice it, grab a plate, just need some bread, and deliver it. And yep, there you go, it worked. Alright, awesome. Okay, so this is really it. This is how we're going to play our simple sounds. Now there are some that are going to require more logic, like the footstep sounds and the stove sizzle, but first let's begin by adding the simple ones. So let's begin with the chop sounds. This is super simple. We just need to go over here onto the cutting counter, and actually we already have the onCut event that we made previously. This was used to spawn the visual, so we can also use it to spawn the sounds. However, there's actually one difference. We're going to have multiple cutting counters, and this one, as you can see, this one is not a static event, meaning each different counter is going to have each list of listeners, and we really don't want to have to subscribe to every single one of the counters individually. So what we can do is, instead of making it a regular event that belongs to each instance of a cutting counter, we can make a static event which will belong to the entire class. But we still want to leave this one just for the visual, so let's do another one, a public static event, event handler, and let's call it on any cut. Basically, for any static events that belong to any object type, I like to add the keyword any. We're going to fire this event when any cutting counter is going to trigger a cut action. So where we fire this event is exactly the same thing. So over here we've got the onCut, let's do the exact same thing. So on any cut with this and event args.empty. Okay, so we have our nice static event. Now over here on the sound manager, let's listen to it. So let's go into the cutting counter. Again, we're going to access through the class name, and let's listen to the on any cut event. And over here, let's just play the sound. So let's play the sound. Let's go inside the audio clip refSSO, and let's grab the chop sound. Then for the position, we want to know who fired this event, and by following the C# standard, over here we already have the object sender. So we know this was the object that fired this event, and we know this is going to be of type cutting counter, so we can just get cutting counter, and we just grab the sender as a cutting counter. Okay, so we have this, and then over here, very simple, access transform.position. Okay, that's it, great. That will play the cutting sound on that position on that cutting counter. Okay, great. Now let's handle the player picking up something, and for that let's go over here onto the player class, and the way we set up the kitchen object parent system is actually already perfect for this. Down here we have a function, so if we scroll down, yep, this function, setKitchenObject. This one is called whenever the player receives a kitchen object, which means really when the player picks up something. So if this kitchen object is not null, then that means the player picked up something, so let's do that. So up here, let's make the event. So a public event, event handler, call it on picked something. And then down here, just do a test, so if the kitchen object is not null, so if the player did pick up something, then let's just fire off this event. So just do our usual invoke with this and event args.empty. Okay, so that's great. Then on the sound manager, let's just listen to it. So let's go into the player class, let's access the static instance, and let's listen to the onPickedUpSomething event. And again, let's rename this to a proper name, so player onPickedSomething. And over here, let's just play the sound. And for the sound, go into the refs and grab, in this case, the object pickup. And for the position, let's just go player.instance and grab the transform.position. Okay, that's it. Next for item dropping. Now we can only drop items on a counter. So over here we have the base counter class. And again, we have the same thing. So we have the setKitchen object. And again, the same thing as with the cutting counter. We don't want to be required to listen to every single counter. We just want to listen to one event. So let's make it up here. So a public static event of type event handler. And let's name it on any object placed here. And then down here, when we have the setKitchen object, we do the usual if kitchen object is not null. If so, then let's fire off this event. Okay, great. And on the sound manager, let's listen. So go into the base counter on any object placed here. When that happens, play the sound. And let's go into the audio clip refs. And this one is the object drop, so that one. And for the position, let's do the same thing we did. So we cast the base counter equals the sender as a base counter. And then we go into the base counter and let's grab the transform.position. Okay, so we just need one more special counter type. Here we have the trash counter. And this one, it never really changes the parent, it just destroys the object. So over here on the trash counter itself, let's fire off an event. But again, let's make it static, even though we're only going to have one trash, but make it static just to be able to support multiple. So public static event, event handler, on any object trashed. And then over here, just fire off this event. So invoke with this and event args.empty, okay. So now if we go into the sound manager, and over here, once again, the trash counter on any, not the on any object placed, but on any object trashed. And on this one, let's do pretty much exactly the same thing. So let's copy this. The sound is going to be the trash sound. Instead of a base counter, we could just cast it to a base counter, but let's make it proper. So let's make a trash counter as a trash counter, and this is a trash counter. Okay, great, that's it. So these are all of our basic simple sounds. As you can see, all the logic is super simple. So let's test and see if it all works. Okay, so first of all, let's pick up an object. So if I go into a container and I pick it up, and if there you go, there's the sound. Now if I drop it somewhere, and if there's the sound. Now for the trash, pick it up, drop it on the trash, and if there's the trash sound. Okay, great. Then also let's check out the cutting. So if I pick up some cheese, drop it there, and cut, and if there you go, got a really nice cutting sound. Okay, so far so good. Now let's handle the more complex ones, starting off with the stove. For this one, the sound is meant to be looping, but only when the stove is on, so we don't want to just play once, but play and stop playing depending on the state of the stove. So for this one, instead of spawning the sound through code, let's actually spawn it on the object itself. So let's go inside the stove object, let's go on the stove counter and open up the prefab. And inside this prefab, let's create a brand new empty game object, name it sound. Let's reset transform, make sure it's on 0, 0, 0. Okay, great. Now let's add an audio source component. And for the audio clip, let's use the pan sizzle. Let's make sure to not toggle play on awake, but we do want it to loop. And let's also make it a 3D sound. Okay, so that's the basic setup. Now to control this, let's make a script. So let's go into our scripts folder and let's create a brand new C# script called the stove counter sound. Let's attach the script over here and let's open it. So now here first, let's grab the audio source component. So we've got a private audio source for the audio source and just go on awake and audio source equals get component of type audio source. Okay. Then we're also going to need a reference to the stove counter. So let's add up here a serialized field, private of type stove counter for the stove counter. Then back in the editor, let's drag that reference. All right. Now on the stove counter, over here we already have the states and we have the onState change event. Again, the same one that we used to modify the visual. So on the sound, let's do pretty much exactly the same thing. Over here, let's do a private void start. And on start, let's go into the stove counter and listen to the onState changed event. And basically, when this changes, we want to check if it's frying or fried. If so, then we want to play the sound. If no, then we don't want to play it. So let's define a bool, call it play sound. And we're going to play if the state equals we are frying or the state equals that it is currently fried and about to burn. Okay, then if we have a play sound, then let's go into the audio source and call play. And if not, then let's go into audio source and call pause. Alright, so that's it, pretty simple. Let's just make sure to save our prefab, go back outside, and let's start on play. And okay, for stars, there's no sound playing. Now if I pick up some meat and I drop it on there, and if there you go, there's the sizzling sound and continues going, and now it is still sizzling, but if it burns, it should stop. So if I go, and if there you go, the sizzling sound stopped. Alright, awesome. So let's take this one out, let's actually trash it. Now let's pick up another one, let it cook, and once it's cooked, pick it up, and there you go, the sound does stop. Alright, awesome. So we just have one more final sound remaining, that's the footsteps. By the way, the warning sound is going to be added during the polish lecture. For the footsteps, we want very much the same thing that we did on the stove. So we're going to want a script to handle that logic. But this time we don't need an audio source on the player, we're going to use the same play method as the other ones. Let's just make a script to run the sounds, so let's make a new C# script for the player sounds. Let's go into the player game object and attach the sound, okay. So now here let's first grab the player reference. So private player, and on private void awake, let's get the component of type player and assign it to the player, okay. Then for the footsteps, basically we want to play them every certain amount of time. So let's do up here a private float for the footstep timer, another one for the footstep timer max, and let's say we want to play, say, 10 times per second. Then we do a basic update, and on update, footstep timer, countdown by time.delta-time, and if the footstep timer is under 0, then let's reset it, so set it to the maximum, and it's in here that we're going to play the sound. So now here we have two options. We can fire an event here, and we can listen to it on the sound manager, so exactly the same thing that we've been doing previously, or we can just trigger the sound directly from here. Doing that will mean that this class is tightly coupled with the sound manager. Usually we want to avoid tight couplings. However, in this case, the player sounds class, this one is really only meant to exist alongside the sound manager. So in this case, it's perfectly fine to tightly couple them. So let's play the sound directly from here, which means we need a reference to the sound manager. We could make a serialized field or just make this a singleton, so let's do that. So a public static type sound manager. Name it instance with a public get and a private set. Then on private void awake, we just set the instance equals this, okay? So then over here we can just access it. So just go into the sound manager, access the instance, and we call play sound, which we actually need to make public. However, this function also takes a reference to the audio clip array. So that means we need a reference to the audio clips. So again, we have multiple options. We could add over here on the player sounds, add a serialized field for the footstep sounds, or we can just make a specialized function over here on the sound manager. Both options can work just fine. Let's go with the second one just to be different. So just make here a public void play footstep sound. We're just going to receive a vector3 for the position, and then we just call play sound. Let's go into the audio clip refs.so, and let's pick up the footsteps and play it on this position. And let's also receive the volume. Just up here a float for the volume. Okay, so that's great. Now we just need to call this function. So over here on the player, instead of calling play sound, let's call the other one play the footstep sound. Then for the position, that's the player transform.position. And for the volume, I just exposed the volume just in case you want to make the footsteps a bit more silent or not. But for now, let's begin with 1F and then see if that's way too loud. As usual, instead of using magic numbers, let's define a float for the volume, put it at 1F, and over here use the volume. Okay, great. However, you might be noticing an obvious issue here. Right now, this is going to play non-stop. Obviously, we don't want to do that. We only want to play footstep sounds if the player is actually moving. So this is pretty simple. We just need to ask the player if it is moving. And we already did that. So player is walking. So if the player is walking, then we play the sounds. If not, we don't. Okay, that's it. So let's test. So here we are. And if I'm standing still, there's no footsteps. Okay, that's great. And as soon as I move, yep, there you go. We got some nice footstep sounds. All right, great. So with all of that, we added all of our sounds. Now here, note how we mostly use this method of going into the audio source and using the play clip at point function. This one is great because it is so simple, but it does have limitations, specifically with regards to all of the options. If we look on the audio source component, here we have all these options, so you can use an output, use an audio mixer like we saw in the previous lecture. We can play around priority, play around the pitch, make it 2D or 3D, play around over here with how the sound falls off. So tons and tons of options that you can't really access if you use that simple function. So one approach, if you needed these options, you could make each sound a prefab, so make a prefab for each different audio clip, and then instead of calling that function, you would simply instantiate that prefab to spawn that audio. So you've got lots of options depending on how complex you want your sound to be, but for a simple game and for simple sounds, this one line of code is super simple. Alright, so here we have added sound effects to our game. That coupled with the music that we added previously already makes everything sound so much more alive. It's really starting to look like a proper game. The one thing we still don't have is some kind of game start and game end scenario, so let's add that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, let's add a simple beginning state to our game. So right now we can play the game. All of the mechanics, everything works perfectly, it's all been implemented. However, in the beginning of the game, it just starts right away as it loads. There's no start, no countdown, no time for the player to get ready. So let's sort that out with a simple countdown. Let's begin by making a general game manager script to handle all of our general game states. So let's create a brand new C# script. And now here you could use the name Game Manager, so you could use this name. However, for some reason, Unity likes to add this custom icon when a script is named exactly Game Manager. Personally, I don't like this. I don't want it to be a different icon. I want this script to look and behave just like any other one of my scripts. So personally, I don't like this, but if it doesn't bother you, then go ahead, use it. It doesn't really change anything, just a visual. But in my case, I prefer to give it a different name, so sometimes I call it Game Handler, or other times just something related to this game, like for example the Kitchen Game Manager. And just like that, it won't have that custom icon. Just need to go inside and rename this to Kitchen Game Manager. Okay, save the script. And alright, now let's make a game object to run it. So a new game object with the same name. Let's attach the Kitchen Game Manager and reset transform. Okay, let's open. Now here we're going to define all of the various game states that our game can be in. So for that, let's define an enum. So a simple enum, call it state. And for the various states, let's say we are first of all waiting to start. Then we are on countdown to start. Then the game is playing, and then we have a game over. Okay, so these are our states. Let's do a private void awake, and on awake let's set the state, so we need to store a state for our state. And on awake we set the state equals, and let's begin on waiting to start. By the way, the point with this waiting to start state will also be very important in the next video covering multiplayer. Basically, we're going to wait until everyone is connected before we start the actual countdown. But over here for now, we're just going to wait a little bit on the waiting to start. Then we're going to trigger the countdown, and then after some time, trigger the game playing state. So pretty much all of these states are going to be time-based. So let's make a simple timer. So a private float for the waiting to start timer. Let's begin on something like 1F. So we just wait for 1 second. Then let's make a private void update. And let's make a state machine just like we've done previously. So do a switch on our state. In case we are on state.waiting to start. If so, then let's go into the waiting to start timer, count it down by time.delta_time. Then if the waiting to start timer, if it is under 0. If so, then let's move into the state, equal state dot, let's go into the countdown to start. Okay, so that's it, and the other states are going to be pretty much exactly the same, so let's just copy this. So we have the waiting to start, then the countdown to start, then we have the game playing, and finally we have the game over, and that one doesn't have anything, so just like this. Like I said, we could reuse the same timer, but let's write our code nice and proper, so let's make different timers for each. So let's make 3 timers. So we're going to have the countdown to start timer. So countdown. For this one, let's default it to 3, so we're going to wait 3 seconds before we start. And then the game playing timer. And for this one, let's put it something short just for testing. So let's put it just test. And then down here, let's just use them. So on the countdown, let's count down this timer. On the game playing, count down this timer. When the countdown ends, we go into game playing. And when the game playing ends, we go into game over. Alright, so that's our super basic state machine. Just a bunch of timers, super simple. Let's do a quick log just to see. So over here, just a debug.log. And let's just print out the current state. Okay, so just like this, let's test. And yep, right away we are waiting to start. After 1 second going to countdown, then after 3 seconds going to game playing. And now if we wait for 10 seconds, after 10 seconds we should be able to see just a little bit. And yep, there you go, we've got our game over. Okay, great, all the logic is working. Although we actually didn't change anything. Technically the game right now is on a game over, but everything still works the same as previously, so I can still play, I can still do everything. So let's sort that. When we are in any state other than the game playing state, we don't want the player to be able to interact with anything. We want to leave it movement, because that's usually nice and fun, but we don't want it to be able to interact, pick up objects, or do anything, so let's do that. Basically over here on the game manager, let's just expose a function, so public bool, let's call this isGamePlaying. Then over here, pretty simple, just return if the state equals state.gameplaying. That's it. So now we can go into the player script. So over here on the player script, let's go down into the interaction function. So over here we've got the interact alternate and the interact. And on both of these, basically let's just ask if the game is in the game playing state. If so, we want to interact, but if not, then we don't want to do anything. So to access the game manager, we could add a peer serialized field, or as usual, let's just make a nice singleton. So peer public static of type kitchen game manager, the instance, make a public get and a private set. Then down here on awake, let's set the instance equals this, okay? So now over here on the player, let's just go into the kitchen game manager, access the instance and test is game playing. And we're going to do an if the game is not playing. So if we are not playing, we want to stop this, so let's just do a return. So if the game is not playing, the code is going to stop executing here, and same thing on the interaction. So just like that, we won't be able to interact with anything once we are not in the game playing state. Okay, so here we are, waiting to start. Nope, I cannot pick up anything. Countdown to start. Nope, I can't. And as soon as we go into game playing, yep, now I can't interact, so I can cut a bunch of things. And as soon as it goes into game over state, there you go, currently in game over state. So now if I try to interact, nope, can't do it. Okay, awesome. Everything works perfectly. So in terms of logic, this is really it. There's nothing else we need to do. But of course, right now the player would have no clue as to why sometimes they can grab and sometimes they can't, so let's add a proper visual. First, let's add a visual to the starting countdown. So let's do that as a canvas element. So let's go inside our canvas, create an empty game object, name this the game start countdown UI. Let's press F to focus on the object, press 2 to turn this into 2D. Okay, so let's see. Now over here, we really just need a text object, so let's leave this one anchored on the center. Let's put the width and height both on 0, we don't need that. And then let's go inside, create a new text object, call this the countdown text. And then inside, let's just put a number, so just a 3. Let's put the width and height both on 0. Then down here, let's put it in bold on a really big font size, so let's say something like 250, okay, really nice big number. Then let's also put it centered and down the middle. Okay, that's great, we've got our nice big countdown number. Also, by the way, when using TextMesh Pro, we can easily add a whole bunch of effects. If we look down here, we have the default TextMesh Pro material, and over here we can add an outline, an underlay, and so on. So that's really great. However, there's one very crucial thing. When you want to add some effects, always remember that the effects are being applied to the material, meaning any text objects that are sharing this material, all of them will modify. So for the most part, usually you don't want to modify the default material. If you do, then everything using this default material will change. Like for example, I want to add a nice thick outline to this one, but over here I've got some regular text that is also using the default material. So if I now add an outline, and I increase the thickness, and if there you go, those also got an outline as well as this. And if I want to downlate and make it quite a lot bigger, there you go, all of them modify, because all of them are sharing the same material. So usually you don't want to modify the default material. If you want to add some kind of special effects, always make sure to create a brand new material beforehand. So over here, let's remove the outline, put it back on the dilation, and let's go up here to create the brand new material. First, we need to find our font. So over here on the font asset, we can just click on it, and we can see it over here highlighted on the project window. So it's inside the TextMesh Pro folder, the resources, fonts, and so on. So here is the default font, and inside this one is the font that we're using. Now in this font, there's a nice little arrow icon, and inside we can see the default material. So let's duplicate this material. Although it's important, make sure you duplicate the material and not the font. So with this material selected, I'm going to press Ctrl D, and there you go, it duplicates the material. And over here, let's give it some name. So let's say this is the material that I want to use for the start countdown. So there you go, just like this. Also, one very, very important thing, the name of the material needs to include the font name, otherwise it won't show up. For example, if I get rid of this, the Liberation Sands SDF, if I name the material just like this, and now I'll look over here on the countdown text, look on Text Mesh Pro, here is the drop-down menu for selecting the material, and over here note how that one does not show up. So it is extremely important, in order for it to show up in here, it needs to have the same starting name. So over here, if I rename this material, put Liberation Sands SDF and then the name, and now back in here, now look, and yep, now I do see my material. Okay, so that's great, and now over here we can add what kind of effects we want, and it will only affect this one and not any others. Okay, so for this one, let's add a nice outline, and let's make some nice thick numbers. So over here on the dilation, let's dilate by quite a little bit. Then for the outline color, let's put it maybe on a blue, something a bit like this. Okay, let's push it back just a little bit. Okay, I think that looks pretty good. Now, if you want, you could add even more effects to this. I made another video covering how to use custom textures in your font. Doing that, you can just import the font directly into Photoshop and edit it with all kinds of effects. For example, that method is exactly what I used in my game Hyper Knight to make the hit counter look really nice. I also have a tutorial specifically on that. So if you want even more custom text, definitely go ahead and watch those videos. But anyways, here we have our countdown text looking pretty nice. Now the number itself will be written through code, so let's do that. Let's go into our scripts, into our UI folder, create a brand new C# script for the game start countdown UI. Okay, let's select the parent object and attach the script. Now here, first thing we need is a reference to that text object. So let's add a serialized field, private. And again, remember what I mentioned a couple of lectures ago with regards to the types. So we want Text Mesh Pro UGUI, we want this one. So it's going to be our countdown text. And now for updating this text, basically we just need to know the game state, so we need to know when the countdown should show up. And as usual, let's use some nice events. So over here on the Kitchen Game Manager, let's fire an event whenever the state changes. So a public event handler. Let's call it on state changed. Okay, just like this, no need for the arguments. So let's go down here, whenever the state changes, let's just invoke this event. So invoke this event args.empty. So we change in there, and change down there. Okay, that's it. So now over here on the game start countdown, let's do a private void start. And on start, let's go into the Kitchen Game Manager, access the instance, listen to the on state changed event. As usual, write some nice clean code, so let's rename this to the Kitchen Game Manager. So when the state changes, we basically want to show this if we are on the countdown to start. So let's go here to the Kitchen Game Manager and let's make another function. So public bool is countdown to start active. And we just return if the state equals the state dot countdown to start. Okay, so that's a nice simple function. And on the UI script, if the Kitchen Game Manager, if this one dot is countdown to start active, if so, then let's show, if not, then let's hide. So else, let's do a hide. So let's make these functions, so private void show, and a private void hide. And on this, let's just do the usual thing, so game object set active into true, or over here set it into false. And on start, right after we subscribe to the event, let's also hide it by default. Okay, so that's the basic logic for showing or hiding it. And now for the timer text, technically over here, whilst inside the countdown to start, we could fire an event on every single update. That would work, but it would have some unnecessary overhead. So instead, another option is just make a function to expose it. So let's go here, make a public, return a float, get the countdown to start timer. And we just return the countdown to start timer, very simple. So then over here on the UI script, we can just make a regular private void update. And on update, go into the countdown text in order to set the text. And let's go into the Kitchen Game Manager and let's get the countdown to start timer and just do a toString. Okay, so that's it, super simple. So on update, we're going to constantly update the timer. So let's see if this works. Back here in the editor, let's just make sure to drag the countdown text reference and let's hit on play. And okay, waiting to start, and after a bit, yep, there you go, there's the number, it's currently on countdown, and now the game is playing. So the show and hide did work, although the number seemed quite a bit odd. That's because over here on the settings, we have wrapping enabled. So let's just quickly disable this and let's test again. So there we are, waiting to start, and there you go, there's our countdown, 3, 2, 1, 0, and there you go, game playing. Okay, so it did work. Now of course, as it comes to the visuals, it depends on what you want. For example, if you want to limit the decimals, you can use over here the toString. This one can include all kinds of string formats. For example, for displaying just 2 decimal places, you can add the string format f2. Let's see what this looks like. Waiting for the countdown, and there you go. Now it does show with 2 decimals. Okay, so this is one approach. Alternatively, another format you can use is number sign, point, number, number. And let's see this one. And yep, there you go. Now it looks like this. So as you can see, there's lots of things you can play around with when it comes to the toString formats. But in our case, I don't really want any decimals. I really just want to see whole numbers. So for that, let's just seal out this number. So a mathf.seal. Let's seal this one out. And then just do a toString. Okay, let's see. So wait a bit, and we got 3, 2, and 1. And there you go, the game is playing. Alright, awesome. So here we have our waiting to start and the countdown to start. All of that logic is working perfectly. Now the next thing we need is to handle the game end, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to handle the game over state. Now for the game over state, this is obviously a game design question. For example, you could make it so that each recipe had a timer attached to it and the player had to create that recipe within the time limit. Then if they failed enough recipes, you could trigger some kind of game over. Or for something more simple, let's just do exactly what we did for the game start. Let's just do a basic countdown timer. After the game is over, let's pop up a game over window and show how many recipes the player delivered. So let's do that. Let's go into our canvas and inside make an empty game object. Call it the game over UI. Then over here, let's stretch it to occupy the entire parent, like this. Now inside, let's begin by making a UI image. This is going to be the background. Let's put it in black with just a little bit of transparency. And let's also stretch this to occupy the entire thing. So just like this. Then let's make some text. So let's make a new UI text. Call it the game over text. And let's say just game over. Let's set the width and height both at 0. Then down here, disable wrapping, put it centered. Let's put it pretty big, so maybe 135. Put it a little bit higher. Then for some more text, let's duplicate this. Let's call this the label recipes delivered text. And over here we just say recipes delivered. Let's put this one a bit lower and quite a bit smaller. Say on 50. Okay, and also on this one, let's put it in bold and change the color a little bit. Okay, next let's make yet another text. This one is going to be for the final number. So let's call this recipes delivered text. And this one is just going to have whatever number of recipes we delivered. And let's put it over here and quite a bit bigger. Okay, so this is the game over window that we want. Also, quick note, like I mentioned previously, the sorting order over here on the UI is based on the order in the hierarchy. So for the game over, we want this one to show up on top of everything else. So make sure the game over is the last one over here on the UI. Make sure it is the bottommost child on the canvas. Okay, now let's make a game object to run this. So let's create a brand new script. Game over UI, let's go into the object, wait for the compilation, and let's drag the script. Okay. Now here, the only reference that we need is just for the text. So let's just make a serialized field of type text mesh pro UGUI for the recipes delivered text. Here in the editor, let's just drag that reference, okay? Now let's make some show and hide functions and also show it just on the game over. So really, we're going to do the exact same thing that we did over here on the game start countdown. So let's actually copy exactly this. Let's go into game over UI, pass the exact same thing. Okay, so we've got the show and hide functions, we test. And then over here on the state change, instead of showing this one on the countdown, we want to show it on the game over. So let's go over here and just make another function. So public bool is game over. And we just return if the state equals the state.gameOver. Okay, that's the function. So over here, if we are is state game over. If so, then we show. If not, we hide. Okay, the last thing we need is just for the text. So this is going to be the recipes delivered text. So we're going to set this to something, which really means that we just need to keep track of all of the recipes that have been delivered. So let's go here onto the delivery manager script. And let's just keep track, so just a simple int, so a private int for the successful recipes amount. And then whenever we have a recipe success, so let's go here into our delivery recipe function. Whenever we have a success, let's just increase this by 1. Okay, so that's it. Now we just need a function to expose this, so a public int for the get the successful recipes amount, and just return the successful recipes amount. Okay, so finally back here on the Game Over UI, let's just print it. So go into delivery manager, access the static instance, and get the successful recipes amount. And of course we need a string, so toString. Except for this one, this is never going to change after the game is already over. So let's not do this on update, that would be quite wasteful. So let's just do it up here. So as soon as we have the game over, we print the recipes, and that's it. Okay, so let's test. So here we are waiting for the timer, and let's wait and just wait 5 seconds for it to finish, and we should see a 0. So let's just make sure that works. So after a little bit of time, yep, there you go. We've got recipes deliver 0, okay. Now back here again, let's try to deliver some recipes now. So let's try to make a cheeseburger. Try to deliver that. Cut this one, pick up this one, pick it up, put it in there. And okay, quickly. All right, good. And there you go, we've got a 1. All right, awesome. Everything worked perfectly. Let's just add one more final element. Right now, we cannot see what is the time left in the game. So let's add a nice clock element. So over here on the canvas, let's make another empty game object. Let's name this the game playing clock UI. And let's also put it behind the game over UI. So let's put it above on the hierarchy so that it shows up behind. In order to be able to see what we're doing, let's also just hide the game over UI, but only here on scene view. So let's click on the eye icon. Okay, so here we have our window. Let's just anchor it on the upper right corner. So let's put it somewhere in there. Then inside, let's create a new UI image. Call it the background. For the sprite, let's go with the circle sprite. So let's click on the eye icon to show all the default sprites, and let's use the one included with the circle. So you have this one. Let's also add a nice little outline. So let's put it on 2.2 with full alpha, and let's also add a nice shadow, just a nice visual. So on 5 - 5 like that. And for the color, let's also put it some kind of dark gray. Okay, so this is our background. Now let's duplicate this, so Control D, and let's rename this one the timer image. And for this one, let's give it a different color, so maybe something like a blue. So something like this, okay. And now over here on the image type, instead of simple, let's go with filled. Let's choose Radeon 360, okay, great. And now over here we can play around with the fill amount, and this will be our timer. Then you can set it up however you want. For me, I'm going to choose to start from the top. So as it starts, the timer is going to count down until the end. Okay, so that's great. Now let's make the script to run this. So let's create a brand new C# script. Same thing, the game playing clock UI. And over here, let's just attach a script. So now all we need is reference to our image. So let's make a serialized field. Private image, let's make sure to use this one, the image inside Unity Engine.ui. This is going to be our timer image. Okay, like this. Back here in the editor, let's drag the reference, all right. Now that we have this, we need to ask the game manager to get the timer normalized. So let's go over here onto the kitchen game manager, and let's make a function to return just that. So a public float, let's call it get playing timer normalized, or game playing timer, actually, just to match the state. So get this one, and up here we have the playing timer. We just need to define a maximum in order to be able to calculate the normalized value. So let's duplicate this, call it the game timer max, and set this one to 10, and this one, leave it like this. And down here, when we change the timer, when we go into game playing, let's set this one equals this.max. That way we only define the timer just up here. Okay, so with that, now down here we can do the compilation. So we can return the game playing timer divided by the game playing timer max. Except just like this is going to be inverted, because for the game playing timer, we're counting down instead of counting up. So all we need to do is very simple, just reverse this. So just 1 minus, just like this. Okay, great. So we have this function. And then over here on the clock, just go private void update. And on update, let's go into the kitchen game manager, the instance. Let's get that. And we're going to use that on the timer image.fillAmount. Okay, that's it. Super simple. Let's see. Okay, here we are on the waiting to start. All right, waiting. And as soon as we start, yep, there you go. There's the timer going. And we can see it constantly increasing. So it's at the halfway point. And just a little bit more. And there you go, yep, we've got the time over and we have our game over. Alright, awesome! So over here we implemented a really nice game over state. We have a playing timer with a nice UI element, and when it ends we get a game over window showing a bunch of stats. Now with this working, the next task is to have some kind of main menu so we can play again after the game is done. So let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to make a super simple main menu and a loading system. Okay, so every game needs a main menu, so let's build one. Let's begin by making the scene, so let's go into our scenes and create a brand new scene. Call this the main menu scene. And okay, here's our default scene. Now over here, for the most part, we really just want some basic buttons, so nothing too special. So let's create a brand new UI canvas. And let's set it up as usual, so screen space overlay, yep. Then let's go with scale with screen size, 1920 by 1080. And let's match with the height. Okay, so there's our canvas. Now inside, let's make an empty game object, name this the main menu UI. Let's stretch it to occupy the entire thing, so 0, 0 on everything, okay. Now inside, let's create a brand new UI button. Let's name this the play button. Then inside for the text, let's say play. Let's size the button to be quite a bit bigger, so let's say 450 by 150. And on the text itself, let's put it in bold, on a font size quite a bit bigger, let's say 70. Then let's also change the color. Let's put the text in white and the play button over here, the normal color for the image. Let's put it on a dark gray. Then also over here on the button background, let's add a nice outline. Let's put it on full black, say something like 3:3. Then let's make a shadow, and for this one 5 - 5. Okay, so that's our basic button. Let's just anchor the button, so choose the play button. Let's anchor it on the lower left corner, and let's push it just a bit like this. Okay, pretty simple. Now let's duplicate this one, push it a bit lower. Let's also make it just a tiny bit smaller, so just 120. This is going to be our quit button, so let's rename this to the quit button. And inside for the text, just say quit, and put a bit lower on the font size, okay, like this. Okay, so we have the two basic buttons that we need. Now let's make the script to run them. So let's make a script with the same name, so main menu UI. So let's go into our script UI folder, create new script for the main menu UI. Let's attach the script and open. Okay, so now here let's begin by making serialized fields for our buttons. So a serialized field, private of type button inside unityengine.ui. This is the play button, and then we have another one for the quit button, okay? Back in the editor, let's drag the references, so that's the play button and the quit button, okay? Now here in the code, let's add some listeners to these buttons, so let's do a private void awake, and on awake, let's go into the play button and go into the onClick event, so the event when the player clicks on the button, and let's add a listener, and now we pass in the listener. Now over here, to do this, we can add a function, so we can make a private void play click. We can define a function kind of like this, and over here add it as a listener. So that's one approach. Or another alternative that personally I like to use is to use what is called a lambda expression. So instead of defining an external function down here, we just go up here and directly we define a lambda. So we open parameters to display the parameters for the function, which in this case we have none, so just open and close. Then we do a nice little arrow, and then we have whatever we want to be our click code. So both the code that I have here and the one that I have here, both of these are exactly the same thing. This one is called a lambda expression, which is also a type of delegate. Definitely go ahead and watch my video on C# delegates in detail. It's yet another extremely powerful C# feature. I find them especially useful, especially over here to setting the click listeners. There's no need to make another function, just use a lambda expression and that's it. So over here I'm going to use that instead of an external function. Okay, so we've got the play, and then let's also listen to the quit. So on the quit button, the exact same thing. Okay, now first on the quit button, it's actually very simple. We just go into application and we call the quit function. This will quit the game, that's it, very simple. Although one note, if we actually test it like this, so here is the game playing, and if I click on quit, and nope, nothing happens. Now the logic is actually working. We can see visually that the button is changing state, so we are indeed capturing clicks. However, when the game is running inside the editor, calling that function, the application.quit, doesn't do anything. But if this were a full build, then clicking on that would indeed close our game. Okay, so now for the play button. For this one, it's also very simple. We just need to go inside the scene manager, which is inside unityengine.scenemanagement. We just need to go inside of this one, and we call load scene. This function will load a certain scene, And for loading, we can either use the scene build index or we can use the scene name. Like I've mentioned several times, string names are horrible, although in this case the alternative using an int is also not very good. Just a number is very hard to read the code and be able to know what scene this is loading. So there's one better approach that I prefer to use, but first over here let's just use the index just for testing. So we're going to load the scene on index 1, so just like this. And then here in the editor, let's go into File and Build Settings. And over here we see the scenes in our build. Right now we just have the game scene. So let's just add our scene. So let's drag the main menu scene and drag it on there. And also let's make sure it's on the top of the list. Basically the first scene is the one that won't be loaded as soon as the game starts. So let's drag it right up top, just like that. Then over here on the right we see the index. So by loading the scene on index 1, we're going to be loading the game scene. Okay, so with this let's test. So here we are, and if I click on play, and if there you go, it does load the main scene. Okay, great, everything is working. So this is the simplest way to do scene loading. However, this method does have one issue. It's not super noticeable in a game of this scale because it loads pretty quickly. But like this, note how when we click on play, there you go, everything freezes for a little bit while the game is loading. Like I mentioned, in this case the freeze is so small, so not necessarily an issue. But if the game was much more complex, then the player would be staring at a frozen main menu for perhaps 30 seconds. That would not be good. One way to avoid that is actually very simple. Basically, it's what I already covered in detail in the scene loading video. That video was made quite a while ago, but it's still very much up to date. Here we're going to do pretty much the same thing. So we first create the scene, just empty, just saying loading. And then from that scene, we load the final scene. That way the game stays frozen on a scene that says loading, which is much more clear to the player. So let's do that. First, let's make our scene. So inside our scenes folder, let's create a brand new scene. Call this the loading scene. Okay, let's go inside. And now in this one, we want this one to be fully black. So let's go into the main camera and scroll down over here under environment. And instead of rendering the skybox, for the background, let's go with a solid color and let's go with full black. Okay, there's our black main camera. Now let's make a canvas. So a new UI canvas. Let's set it up as usual, so scale with screen size, 1920 by 1080, and match with the height, okay? Then inside, let's just make a simple text object. So just say text, then over here, let's say just loading. Let's put the text width and height on 0, put it on bold, let's make sure to disable wrapping, and push it over there on the side, and maybe increase the font size by a little bit. Okay, there you go, we have our very basic loading screen. Now we're going to load this scene, and then whilst on this scene, we're going to load the final scene. Although also one very important thing related to loading scenes is you need to remember the lifetime of the objects. Regular game objects, like for example the ones that we see here in the hierarchy, these get destroyed when you do a scene change. So for the goal that we're trying to achieve, we need to load this loading scene, but then also somehow transfer data so that the loading scene here knows which one is the final scene. Now you might think that over here on the main menu we could create a game object, attach a script that would hold the reference to the final scene, but like I said, game objects get destroyed as soon as we load the loading scene. So for transferring data between scenes, we can't really use a regular script on a regular game object. Now one approach is to use the don't destroy on load. This is a Unity function that helps you stop a particular script or a game object from being destroyed. That way the object won't persist through scene changes, so that's one option. But another option that I prefer is very simple. Let's just make a loader class. So let's create a new C# script, call this loader. And over here, let's go ahead and make this class a static class, and we are not going to extend mono behavior. So just like this. Basically, by making it static, it means that this one is not attached to any specific instance of an object. This class cannot be attached to any object and cannot have any instances constructed. Then inside we can add static functions in fields, like for example a static int for the target scene index. So now this field, we could set this field from over here on the main menu UI, and when we would load, we would not be resetting this field. Also here I should point out one quick thing. You can make fields static without making the entire class itself static. Making the class static is just a good approach if the entire thing, if everything in this class is also meant to be static. If you don't make it static, then you can have regular fields here. You can have both static and non-static. Whereas if you make this static, then you're going to have an error because you cannot have non-static fields. So this is another clean code thing. If it's only meant to contain static logic, then make the class itself static. Okay, so we have a static field for our target scene. But as usual, we don't want this to be a public field. We don't want the main menu to directly write to this field. So let's make this class the only one responsible for anything related with scene loading. So instead, let's make a function, so a public static void, call it load. And for a parameter, let's receive a string for the target scene name. Then over here, we'll load the actual scene, so let's go into the scene manager and load the scene. And let's pass in the target scene name. Okay, that's it. And then over here on the main menu UI, instead of directly loading a scene, let's go into the loader and call load and pass in the scene name, so that's the game scene. Okay, so this is what we're going to do, that's good. Except it's obviously not good. Over here we're using string names, that's horrible, we should never use this. So let's avoid using strings as much as possible, and one simple way is to just define an enum for all of our scenes. So let's go here on the loader and let's define that. So a public enum, let's call it scene. And for all of our scenes, so we have the main menu scene, then we have the game scene and the loading scene. Okay, so then down here on this function, instead of receiving a string, we just receive a scene for the target scene, and we use the target scene. Although, of course, the Unity API does not support loading our custom enum, it has to be an index or a string, so the simple approach is just to convert this one into a string. That's it. So the only thing you need to make sure is that the enum values over here match the actual name on the actual scenes perfectly. So don't make any mistakes, keep it case sensitive, so don't do this, make sure everything matches perfectly. Okay, so just like this, everything should already be working the same as previously. So the main menu calls that, let's actually just use that. So let's use scene.gamescene. So on the main menu we do this, and on the loader we load the scene. Okay, let's test. Here is the main menu, and if we click and wait a bit, and yep, there you go, it didn't load the game scene. Okay, great. So everything still works the same as previously, except now all of the loading logic is inside of this class. And over here, let's load a loading scene in the middle. Basically, when we have this function to load a final scene, let's first off set this field. So this one, instead of being type int, let's make it of type scene. And this is going to be the target scene. And let's make it private. Okay. So when we have this function, let's set that field. Although here, remember how this is a static class. So in order to access this field, we need to access it through the class name. Because over here, we also have a local variable with the exact same name. So let's access the unloader.targetScene and set it to the target scene. So again, don't be confused here. You can even use Visual Studio and put the cursor on top to see what object represents what. So you can see the unloader.targetScene is referencing this field, whereas this one over here is referencing the local field. So we want to assign the member field to the one that we received as a parameter. Okay, so we stored that, and then let's immediately load the loading scene. So scene manager, let's load the scene, and we're going to load the scene.loadingScene.toString. Okay, so we're going to load that. And now here comes the tricky part. If we do this, so if we load the loading scene and then immediately load the target scene, if we do it like this, it won't actually show the loading scene. We're calling these functions one right after the other, so it will load one and immediately the other. Basically, we need to wait at least one frame to render so that the loading scene is visible, and then we can load the final scene. So let's make a script to do a very simple job. Let's create a brand new C# script for the unloader callback. And now let's go inside the unloading scene. So this is important. Let's make this on the loading scene, not the main menu or the game scene. So over here, let's create an empty game object for the unloader callback. Let's reset transform, just keep things nice and clean. And let's attach the script, so the unloader callback, okay. And on this script, we want to basically just wait for the very first update. So let's do a private bool is first update. And we start it off as true, actually. So is the first update is true, then we do a private void update. So if it is the first update, if so, then let's set is first update to false. And we have the first update. Although technically I should point out that we don't really need this. We're going to load right away, so either way it will only run one update, but still I like to add this just to make the logic perfectly clear. Basically, if it is the first update, then let's call a function on the unloader. So on the loader over here, let's make a function, public static void, call it loader callback. Okay, we have this function. So over here on the unloader callback, let's just go into the unloader and call the unloader callback function. All right. So basically now here we have this function that is going to be triggered on the first update. So we know for certain the unloading scene has been rendered. So it's over here that we want to load the actual final scene. Okay, that's it. Here we have a super simple loading system. Just make perfectly sure that the unloader callback with the script, this one only exists on the loading scene. It should not be on any of the other ones. So let's test, and for that, let's go inside the main menu scene. Okay, and now let's hit on play. Okay, so here we are on the main menu. Now if I click on play, And actually, here's the thing that I forgot, so make sure you don't forget this. We need to add the loading scene to the builds in order to be able to load. So let's go up here into the build settings. Let's go into the project, drag the loading scene like that. Okay, so now let's test. So here we are on the main menu. Let's hit on play, and there's the loading scene. And after a bit, yep, here we have our game scene. All right, awesome. So with that, everything is working perfectly. All of the logic is working great. Now that it all works great, let's just make a nice proper visual for our main menu. So for that, let's go inside the game scene, and over here, let's copy a few things. So let's pick up the floor object, and let's also pick up the global volume with the post-processing. So let's copy both of these. Let's go into the main menu scene, and over here, let's paste both objects, okay? Now let's also drag some player visuals. So let's put this in 3D, go back down into the floor, and let's pick up some visuals. So let's go inside our assets on the prefabs visuals. Let's find over here the player visual. Again, make sure you drag the visual only. We don't want any logic components. And by the way, this is yet another great benefit of separating the logic from the visuals. Right now, it's super simple for us to place some players here because we have just the visuals completely separated from the logic. Okay, so on the visual, let's just make it look at the camera. Let's position a bunch more players. So let's duplicate this and put one to the side. We're going to move the camera in a bit, but now let's just place them. And in the included assets, there are a bunch of materials. So over here we see the player body, then we've got a blue, a green, and a red. Like I said, this first course is on making this game in single player, but the goal is to then make a second course after this one on converting this game into multiplayer, so that's why I included multiple colors. So let's just drag these. Let's go into this player visual, and on this one, make it blue. So on the head and on the body. Then on this one on the side here, let's make this one green. So green there and green on the head. And for the one behind, let's make this one the red one. So put it in red and in red. Okay, so we've got our nice 4 players. Now let's also add a camera. So we're going to have the camera kind of like this, kind of from below looking upwards. I think that looks pretty good. For that, let's use Cinemachine. So let's go into Game Object, go into Cinemachine, and let's create a brand new virtual camera. Okay, like this, let's just push it up a little bit. Okay, so this is our nice composition. Now on the virtual camera, let's just go ahead and add some noise. So let's add basic multi-channel purlin. So let's do it just like we did when we first added Cinemachine. So let's use the handheld normal mild. And now let's just play around these fields, which by the way, you can do that while the game is playing. So let's hit on play. And over here, you can play around all the fields. Although actually defaults already look pretty good. But let's put the frequency maybe a little bit less and the amplitude maybe a little bit bigger. So just some nice little sway. And by the way, if you make any changes to the Cinemachine virtual camera, and if now you stop playing, it will actually lose those changes. But over here on the virtual camera, there's this nice toggle, save during play. So if you tick this, and now you exit play mode, and there you go, those changes were saved. Okay, great. Now let's just make sure to untick this so we don't accidentally modify. Okay, so here we have the basic visual that we want. Finally, there's also a game logo in the included assets. So let's just go into our canvas, into our main menu. Let's create a brand new UI image. Let's assign the logo sprite. Then let's just position it on that corner. So let's move it all the way up there. We can anchor it to the top left corner. And let's make it a bit bigger. And by the way, on something like this, if you play around this, it might get a bit stretched. So if so, over here on the options on the image, you can toggle this one to preserve the aspect ratio. So that way, even if you stretch, it won't actually be stretched. It will always be perfect. Okay, just like this. Okay, so here we have our basic main menu. It's a basic setup, but it looks pretty good. And with that, we have built a nice main menu alongside with a loading system. So I can click on play, it goes into the loading scene and then into the game scene, so that's great. The next thing that we need is some kind of pause button, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to add a pause button with a pause window that also has the ability to quit back to the main menu, and in doing so, we're also going to solve some sneaky issues with loading. Okay, so here in the main menu, we can click the play button in order to load the game, and yep, everything works, now I'm in the game. But now let's say I want to pause the game for a bit, or quit back to the main menu. Right now there's no way, so let's do that. Let's go here onto the game scene, and first let's enable the pause, and for that we're actually going to need some input. So let's first go inside our player input actions, let's open this, and then over here let's make a brand new action. Let's name it the pause. For the action type, let's go with button, okay, and for the bindings, over here let's go with escape. And actually, if we use the same method that we've been using, if we listen and press on escape, nope, doesn't work because escape just cancels it. So instead, we need to use the search bar here, search for escape keyboard, just like this. Okay, great. Now again, as always, let's make sure to save the asset and wait for the compilation to happen. There it is. So now here on the game input class, let's listen to it and fire the event as usual. So go into the player input actions, the player action map. Let's go into the pause action and listen to the performed event. And when this happens, let's fire off an event. So a public event handler. Let's go on pause action. And then down here, we're simply going to invoke this event. Okay, just like this. Now for listening to it, here's the question, where does that make more sense? Should we do it over here on the player script or perhaps over here on the kitchen game manager? I think over here on the game manager makes more sense since a pause is more related to the game itself rather than a specific action by the player. So let's add it over here. Let's first of all listen to the event. So let's do a private void start, and on start let's listen to it. So let's go into the game input, and we didn't actually make it a singleton yet, so let's do that. Over here, let's make a public static game input for the instance with a public get and a private set. Then down here on awake, let's set instance equals this. Okay, there's our singleton. So now back in the kitchen game manager, let's go into the instance and listen to the on pause action event. And again, let's rename this to give it a proper name. So this is the game input on pause action. Okay, so here we have it. When we have this, let's call some kind of pause game function. So let's define this. Let's go to the end of the file here. And over here, let's make that function. So a private void, pause game, and over here, we're going to pause the game. Now for pausing, doing this is actually surprisingly easy. Basically, all of our logic is using time.time. For example, over here on the player script, we have our movement speed. Yep, then we get the inputs. And over here on the handle movement function, yep, for the movement distance, we have move speed multiplied by time.time. Or another use case over here on the stove counter, we've got a frying timer, and how we count it down, again, is the same thing, time.time. Well, it turns out that behind the scenes, time.time actually already has a multiplier. When you access this, it is after that multiplier calculation. So over here on the pause game function, we can just go into time, and we can modify the time scale. This one is the multiplier. So if we just put this at 0f, then that's it. This is going to pause all of the other delta times. So let's test. So here we are, pay attention to that and the countdown timer, and I press on escape, and there you go, everything pauses. The countdown timer pauses, over here the script pauses, and I can no longer move, nothing works, everything is perfectly paused. Alright, awesome, everything works. Except one problem, obviously right now we cannot unpause. If I press escape, it's not unpausing, so let's do that. Over here on the kitchen game manager, let's add a simple bool, so a private bool. Let's call it isGamePaused, and let's default it to false. Okay, so isGamePaused. And then down here on the pause game function, let's simply flip this one. So we set this one equals not this one, so that is going to flip that boolean. And then we check if the game is paused. If so, set it to 0f. And if not, then we're going to set the time.time scale back into 1f. Okay, so now this should pause and unpause. So let's actually rename this function, since this is no longer just going to pause. Let's rename this to toggle pause game. This is going to pause and unpause. Okay, so let's test. Okay, so here we are, everything is running. Now I pause, and there you go, everything freezes. I cannot move, the arrow is stopped, the countdown is stopped. Now I press again, and there you go, nice and resumed. All right, great. So all of the logic is working perfectly. The only thing we need is really just a visual. And as usual, let's separate the logic from the visuals. So let's go inside the canvas, let's go into the scene view, and inside the canvas, let's create an empty game object. Call it the game pause UI. Then let's stretch to occupy the entire screen, so 0 on everything. Okay, great. Now inside, let's first of all add a background. So a new image, name this the background. Let's once again stretch to occupy everything. And on the color, let's put it in black with just a little bit of alpha. Okay, just like that. Then let's add some text. So let's create a brand new UI text. Let's name it pause text. And in here, let's just say paused. Let's just make it big, so the width and height both on 0. Let's disable wrapping, put it centered down the middle, and let's increase the font size by quite a bit and put it in bold. And let's also change the color, maybe a nice yellow, something like this. Okay, that looks pretty good. Let's just lift it up by a little bit. Now let's make a script to show this. So on the UI folder, let's create a brand new C# script. Call this the game pause UI. Let's attach it and open. Now here, let's do the usual thing. So let's make two show and hide functions. So private void show, and then a private void hide. So on the show, game object set active into true, and on the hide, set it into false. Okay, that's it, pretty simple. Now we need to know when to show or hide these functions. So over here on the kitchen game manager, let's make 2 events to do that. So let's go up here, make a public event, event handler, and let's name this on game paused, and another one for on game unpaused. Okay, we have both events. Then down here on the toggle pause game, if we have this one timescale 0, that means we have pause. So let's invoke the on game pause, this event tars.empty, okay. And on this one, let's trigger the other one, so on game unpaused. Okay, we've got the 2 basic events. Now back here on the game pause UI, let's listen to it. And as usual, let's do it on start, so private void start. Let's go into the kitchen game manager, access the static instance, and let's listen to the on game paused. And then going to listen to the other one, so the instance on game unpaused. So listen to both of them. And as usual, let's write good clean code, so let's rename this. So kitchen game manager. And on this one, the same thing. So also the kitchen game manager. Okay, we have both. And when the game is unpaused, then we want to hide the pause window. And when the game is paused, then we want to show the pause window. And finally, of course, we want to hide it by default. So over here on start, after we add listeners, let's just hide it. Okay, so that's it. That should work. So let's test. So here we are. Everything is running. Now press the pause. And there you go. Got a nice pause window. Press again. And there you go. Everything resumes. Okay, great. So the last thing that we want is just a button over here to go back to the main menu. And let's also add a button to resume without having to press the hotkey. So over here, let's create a new UI. Let's make it a button. This is going to be the main menu button. Now let's make it quite a bit bigger. Okay, width and height of 30 and 80. Let's put this one quite a bit down there. And inside for the text, this one is the main menu. Let's put the color in white and the background for the button. Let's put this one in a dark gray. And let's also, just for fun, add a nice outline. And let's also add a shadow. For the outline, let's put it on full alpha. And let's put it on about 3.3. And for the effect on the shadow, 5 - 5. Okay, so that adds a nice outline and a nice shadow. And then for the text itself, let's put it in bold and raise it by just a little bit. Okay, just like that, looks pretty good. So this is the main menu button. And then let's also duplicate this. Let's make this one, rename it. This is the resume button. And inside on the text, let's say resume. Okay, we have our 2 basic buttons. So let's handle them in the script. So over here, let's add, as usual, a serialized field, private of type button. So that's inside unityengine.ui. So it's for the resume button. And then we're going to have the main menu button. Okay, let's save the script. And back in the editor, let's drag those references. So that's the main menu button and the resume button. Okay. So now for these, let's add the click action. So let's do a private void awake. And on awake, go into the resume button, the on click, and let's add a listener. So this is going to be our listener. And same thing for a main menu button. So main menu. Now for the main menu, this one is super simple. Let's just go into the loader and call the load function. And we're going to load the main menu scene. Okay, that's the main menu, very simple. And for the resume, this one is only going to be clickable when the game is paused. So we can just trigger the same function on the kitchen game manager to toggle the pause. So kitchen game manager, the instance, and toggle the pause game. This one is actually private, so let's go to it. And let's make this public so we can call it from there. Okay, that's it, super simple, let's test. Okay, so here we are, and let's pause the game. And now if I click on resume, yep, there you go, it does work, everything resumes. And now pause again, and now let's go back to the main menu. Loading, and yep, there you go, back in the main menu. All right, awesome. So everything works perfectly. However, there's one sneaky issue here. You can already see the issue by seeing that all of these animations are still, but let's click on play. And nope, look at that issue, everything is still frozen. I cannot move the character, and over there, the shader, that one is completely frozen. So the timescale is still set to 0. Basically, we need to manually reset it. And the simplest way to do this is really just in the main menu. So we can go here on the main menu UI, and we can just use this as our reset function. So let's just go into time.timescale, and let's set this one back into 1F. That's it, that's the only change, let's test. So here we are, let's pause, let's go back into the main menu, and we can see the animations are indeed playing, and if we go back into play, and if there you go, everything works perfectly, we can pause. And yep, here we do see one of the other 2 sneaky issues left. Basically, it has to do with scene loading and cleanup. So the first one is on input. Over here on the game input class, we are constructing our player input actions, and we are listening to these events. And technically, this object, the one where the game input is attached, this object is going to be destroyed when the scene changes. However, this object that we're creating, this instance of player input actions, this one does not get destroyed automatically. So that is why when I went into the pause menu again for the second time, over here we've got a missing reference exception. Basically, the player input actions of the previous game is trying to show the pause window also of the previous game, which has since been destroyed. So obviously we have a missing reference exception because that object no longer exists. So in this case, we have two options to solve this. One option is we can just unsubscribe to these events. Unity mono behaviors have a really nice callback called onDestroy. So over here, private void onDestroy. So this is the default one. This one is called when the mono behavior is destroyed. So we can go into this one and we can manually unsubscribe. And the way that you unsubscribe is you just do -=. So this would solve that problem because when this object is destroyed, it's going to unsubscribe from those events. So the next time it will no longer trigger. So that would fix it. However, on the game input class, we are still creating a new object of this type. I'm not 100% sure how the input system works in the background, so perhaps this object might stay in memory, which is not good. So another approach we can do, or perhaps in combination with this, is we can unsubscribe and then we can properly dispose of this object. How we do that is very simple. Let's just go into the player input actions and we just call the dispose function. That's it. This should clean up that object and free up any memory. So let's test. So here in the game view, let's pause. Let's go back into the main menu. Now let's go back into the main game. And now if I hit pause, and if there you go, we no longer have any errors. Okay, so that's good. However, now we still have one more potential issue, and this one has to do with statics. Like I mentioned before, statics belong to the class and not any instance of that class, so that means that static fields will not be destroyed or reset when the scene changes. In the case of our loader here, where we have a private static field, this one, the fact that this one doesn't reset automatically, that was a good thing. That's what allowed us to make the unloading system. But in the case of maybe static events, that might not be as good. It might mean that we might be keeping some state from the previous game, which might cause everything to break. So basically we have a similar problem to what we had in the input, where some logic from the previous game might be affecting the next game. In all the code that we wrote, the main place where we used statics were in the singletons, and these are going to be cleared automatically when the underlying instance object, when that one is destroyed, so these do not cause any problems. However, for example over here on the cutting counter, we've got a static event. When the scene changes, this will not be cleared, so this will still have the same number of listeners. We can actually see how many listeners there are by printing it, so let's go down here before we're invoking the event. Let's do a debug.log. Let's go inside the onAnyCut event, and over here we can get the invocation list. This one is the list of all of the functions that are listening to this event, and we can just print out the link to see how many listeners are listening to this event. So let's see what this returns. Okay, so over here, let's pick up some cheese and slice it, and if I look in the log, yep, there you go, 1. There's only 1 listener. Okay, that's correct. However, now if I go back into the main menu, and now I go back and I play again. Okay, so let's play. Let's just wait for the countdown, and once the countdown ends, pick up some cheese, go there, slice it, and there you go, there's the problem. Now we have 2 listeners. In this case, it doesn't really cause an error because the 2 listeners, they're just over here on the sound manager, so we are subscribing to this event and we're doing the cut and playing the cut object. However, if here we do something with this transform, like for example, let's just do a debug.log on this transform.position. If we do this, here let's go ahead on the first one, let's slice, and okay, that works. Let's go back into the main menu, now play again, now wait for the timer, pick up some cheese, go there, slice, and if there you go, there we have our error. That is because we are now accessing the sound manager transform and that one has since been destroyed. So if you do use static events like this one here, if you do that, always remember you need to manually reset that state. It won't happen automatically on the scene load. And one way that I normally do it is just make a class responsible for doing that. So let's go ahead and let's create a brand new C# class. Let's call this the reset static data manager. And for this one, we want this one to run only on the main menu. That's only where we're going to reset things. So let's go inside the main menu scene. Let's go there. Let's create a brand new empty game object for the reset static data manager. Let's reset transform, just keep things clean, and let's attach that script. Again, it's very important that this object only exists on the main menu. Then over here, we're basically just going to go into any script and reset any data. So for that, on all those scripts, let's make a function. So over here on the cutting counter, let's make a public static function. Let's call this reset static data. And in order to reset any listeners, let's just go into the on any cut and set it to null. That will clear all the listeners. So we just do this, and then on this script, let's do a private void awake, and on awake, let's go into the cutting counter under the class, so not any instance. So we're going to access the static, and we're going to reset the static data. That will clear all the listeners on the cutting counter. All we need to do is make sure to do this on every single static event that we have. So on the sound manager, and by the way, here we can get rid of the testing code. Here we can see all of the static events that we're using. So we've got the cutting counter, then we've got the base counter and trash counter. So let's go here on the base counter and paste the exact same thing and reset this event, okay? And now let's go into the trash counter. So here on trash counter, same thing, reset this event, set them all into null. And by the way, here we have a warning. That's because trash counter extends base counter. So basically this is telling us that we are hiding another function with the exact same name. In this case, we do want to hide it. So let's actually make this new to make sure that this one is a different one, just to avoid that warning. And same thing over here on the cutting counter, we also need to make a new. Okay, so that's it. And now we just need to go over here onto the reset static data manager. Let's go into the base counter and reset the static data. Go into the trash counter and reset the static data. Okay, that should do it. Let's see. So here we are in the game. Let's pick it up and slice it. And yep, we've got just one listener. That's good. Let's go back outside, back into the main menu. Let's play once more. And over here, let's pick it up again, go there, drop it, and there you go, still just one listener, because we are now correctly eliminating all of the previous listeners. So this is the one sneaky issue that you must be careful with when it comes to object lifetime and statics. For static fields, you need to remember that they don't manually get cleaned up. That's up to you. So that's something you have to keep in mind, but you can also see how easy it is to solve. Now that this is solved, let's just go into the cutting counter and just get rid of our testing log. Alright, so with all of that, all of our scenes are working. So we can start from here from the main menu and go straight into the game. Then here we are in the game playing normally. We can pause the game at any point. From the pause screen, we can either resume or we can go back into the main menu. And from back into the main menu, we can once again play the game from scratch. And if there you go, everything works. Alright, awesome. Now the next thing that every game requires is some options, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to create a simple options menu where we can modify the audio levels. Okay, so here let's make the options menu. So on our game scene, let's go into the canvas and create a new empty game object. Let's make this the options UI. Let's stretch out this one to occupy the entire screen. Then inside, let's make a UI image. Once again, let's stretch out everything. Let's put this one in black in just almost full alpha. Okay. Now let's make some text. So let's create a brand new UI text. Call it the options text. Then for text, let's say just options. Let's put the width and height at 0. Let's disable wrapping, put it center down the middle, and put it quite a lot bigger. Okay, that's the options. Now just move it slightly upwards. All right. Now let's make some simple buttons to handle our audio controls. We're going to make it super simple, literally just a button we can click. So inside the options UI, let's create a brand new button. Call this the sound effects button. Then let's make the button a bit bigger, something like this. Okay. And inside for the text, let's say sound effects, and then we're going to have a number for the sound effects. Let's just quickly change the color. So put the text in white and the button over here, the button image, let's put it in a dark gray. Okay. Let's also make it just a tiny bit thinner, just like that. Okay. So this is the sound effects button. Now let's duplicate this one. This one is going to be the music button. So let's name this the music button. Then inside for the text, music, and then a number. And that's pretty much it. So by clicking on either of these buttons, we're going to increase and then loop the volume. So let's make a simple script to handle our options window. So in our scripts inside the UI, let's create a brand new C# script for the options UI. Let's go ahead and attach a script and open. So here, as usual, let's get some fields for our buttons. So a serialized field, private, of type button for the sound effects button. And then there's another one for the music button. Okay, both buttons. Now let's add the click event. So on private void awake, let's go into the sound effects button, and on the on click, let's add a listener. And we're going to do the same thing on the music button. Okay, so now when we click, we want to change the volume. So let's go here onto the sound manager and make a function to modify the volume. Let's make a private void change volume. And here we're going to increase the volume by 0.1%, so constantly increase in 10% increments. So that means we need to keep track of the volume. So up here, let's define a simple private float for the volume. Let's default it to 1F, okay. So now down here, we take the volume and we increase it by 0.1F. And now let's loop it back to 0. Now for looping, usually you do it using the modulo operator. So here you could do volume equals volume modulo of 1.1F. That way when it gets to 1.1F, it would reset back to 0. But here, since we're working with floats, which can have a bit of odd precision, with this, let's just do a simple if to make sure that it always works. So if the volume is above 1F, if so, then let's just reset it to 0. Okay. So here we modified the volume, and let's just make sure to use it over here when we actually call the audio source.playClip at point. Here we've got a volume, but this is the one that we received as a parameter. So let's actually receive this one, rename this to volume multiplier. And we're going to basically multiply the one that we receive in the parameter by the one that we actually store. So this way on these functions, when we play a certain sound, we can still give an optional volume if we want to make it louder or quieter than the regular sound effects. Okay, so we have our change volume function. Now we just need to call this from the options UI, so that means this one actually needs to be public, okay? So now here on the options UI, we go into the sound manager, access the instance, and call change volume. Okay, so that is going to change the volume. Then we just need to update the values on the options UI. So let's make a private void update visual. And this one we need to update the text. So up here, let's add once again some more serialized fields. So text mesh pro UGUI, one for the sound effects text and another one for the music text. Okay, we have both these. Then here the sound effects text.text equals, and we go into the sound manager, the instance. And then we need to get the volume. So over here on the sound manager, let's make a function to get it. So a public float return get volume, and we just return the volume, okay. So then here, let's get volume, except the volume is going to be a normalized value. So rather than showing 0.1, 0.2, 0.3 on the UI, let's just multiply the volume by 10F. That way we show between 1 and 10. Okay, then let's just round out this number and then add the text. So here's sound effects, and then we have the volume. Okay, so that's pretty much it. And up here, when we change the volume, let's just update the visual. And let's also make a private void start. And on start, let's also update the visual. Okay, that's it. Pretty simple. Now let's do the exact same thing on the music. Except on the music manager, we named it music manager, but over here we just have an audio source. There's no actual manager. So let's actually make one. Let's create a new C# script for the music manager. Let's go into the music manager object. Let's attach a script and let's open. So here we really just need pretty much exactly the same thing that we had. So let's just go here into the sound manager and just copy these. So on the music manager, let's paste them. We need a volume, so a private float for the volume, just like this. Okay, so that changes the volume. Except again, the music manager, this one, the music is constantly going to be on looping. So after we modify the volume, we need to update the actual audio source. So let's first begin by grabbing the audio source, and we just do a private void awake. And on awake, let's grab the audio source, get the component of type audio source. Okay, so we have this. And when we change the volume, let's go here and update this volume. Okay, that's it. And let's also default it to something like 0.3F. Okay, good. Then in order to be able to call this from the options UI, we just need to make it a singleton. So as usual, public static music manager for the instance. And we have a public get and a private set. And then in awake, just set instance equals this. Okay. So then here on the options UI, we can go into the music manager, the instance, and change the volume. And afterwards, let's update the visual. And down here on the update visual, let's do pretty much the same thing. So on the music text, modify the text to say music. Then we go into the music manager and get the volume. Alright, that's it. All this should be working. Let's just drag our references. So back in the editor, let's drag first the button. So the sound effects button, that's this one. Then the music button, that's this one. Then we have the music text, that's this one. And the sound effects test like that. Okay, let's test. Okay, so here we are, the music is playing, and as I click, the music is currently getting louder and louder. And there you go, music is at max volume, and if I click again, now the music is completely muted. Alright, awesome, and these sound effects also work, so like this, they should be less louder than usual. Okay, great. So everything works perfectly, except obviously we have one big issue. The options window is on top of everything. The goal is for the options window to be kind of a sub-menu of the pause window. We want to have an options button on the pause window that will bring up the options window, so let's do that. Let's first hide the options window, let's go into the game pause UI, and over here we have these buttons. Let's just make one more, let's put it down the middle. This is going to be the options button, and inside let's modify the text to options. Okay, now let's edit this script. So we're going to have another button, so this is the options button, and down here we're going to have another click, so the options button. Okay. And when this happens, we want to just show the options window. So in order to access it, let's make this a singleton. So public static for the options UI, a static instance with a get and a private set. And on wake, as usual, instance equals this. So over here on the game pause UI, we go into the options UI, access the instance, and then call a show function. So we need to make this. So up here on the options UI, let's make those. So a public void show. And this one, as usual, just game object set active into true. And then we have a private void hide. And this set active into false. Okay, we have both these. On the other side, we show it. And over here on start, let's also hide it. Okay. Then let's also hide it manually, so let's add a button to close the options UI. So over here, let's show the options UI, and let's make another button. Let's put it on the bottom. This one is the close button. And over here, let's just say close. So then here on the options UI, just make another button, the close button. And down here for the click event, we go into the close button, and we just call hide. Okay, so that won't hide the window. However, remember that the pause window can also be closed by just pressing escape. If we resume with a hotkey, it will hide the pause window. So let's also make sure this one hides on the same thing. So we can do pretty much go into the kitchen game manager, the instance, and let's listen when the game is unpaused. So when that happens, let's hide this window. So once again, let's do things nice and clean. Let's rename this. So the kitchen game manager. And when this happens, let's just hide. Okay, this should work. Let's just drag all the references. So first here on the options UI, let's drag the close button. And then on the game pause UI, let's drag the options button. Okay, so let's test. And yep, right away the options window is not showing. That's great. And if I press an escape, there you go, there's the pause window. And if I click on options, yep, there's the options window. Now if I click on close, back here, back into resume, okay, works. Now if I pause, options, and now press on the escape key, and yep, there you go, it closes everything. All right, great. So everything is working fine. However, we have one slight issue. The option does work, so I can modify this to change the sound effects and the music volume. So for example, let's mute the music and put the sound effects on 5. So I put it like this, but now if I stop playing and I hit play again and look in the options, and nope, there's the issue. Basically, the data is back to the defaults. Obviously, that is resetting since we didn't actually save anything, so let's save it. Now in Unity, the easiest way to save some data is using player prefs. So let's go over here on the sound manager, and when we modify the volume over here, when we do that, let's access the Unity player prefs, and over here we've got a bunch of set functions. So we can save a float, an int, or a string. This one, as you can see, takes a string and a value. So this is pretty much essentially just a dictionary. Now for the key, as you can see, it's a type string, but again, we should not be using strings directly. So let's go up here in order to make a proper constant. So a private const string, let's call it player prefs sound effects volume. And let's go sound effects volume. Okay, we have our nice certain constant, and down here, when we set the float, let's use this string and save the volume. Okay, so that is going to set the float. And now, technically, Unity is going to automatically save the player prefs. Basically, there are only problems if Unity somehow crashes in between when you call set float and when it actually saves. But if you want to prevent that from happening, you can just go and tell it to save manually, just like that. That will definitely save it. And now we just need to handle loading. So up here on awake, when we have this, let's go into the player prefs and let's use get float. Let's pass in the same key. So this one takes a key and default value, so let's default it to 1F. Basically, the default value is used if there's no saved data on this player prefs on this key. So the first time we run, it's actually going to use this default. And this one's going to return the saved value, so let's just set it on the volume. Okay, so that's it. That's all it takes to save some basic data. Now let's do the exact same thing on music. So over here on the music manager, let's first define our private const string for the player prefs music volume. And this is going to be the music volume. Okay, we have our string. And then down here, when you change the volume, player prefs. And let's set the float on this key, and let's pass in the music volume, okay? And then let's go into player prefs and actually save it. And now up here on awake, let's grab the volume, and it's going to be going to the player prefs in order to get the float on this key, and default value is 0.3f. However, over here on the music, again, we are not spawning the sound afterwards. The sound starts playing right away. So let's make sure to set the audio source volume to the one we grab from there. Okay, that's it. So like this, it should be working. So let's test. So here we are and the music is playing. Let's pause, go into the options. Let's bring the music completely down. So let's mute the music. Okay, the music is gone. And sound effects, let's put it on 5. Now let's stop playing and now play again. And go into the menu, options, and yep, there you go. The data was indeed saved and the music is indeed muted. All right, awesome. So here we have some basic data being saved. And also just a quick note related to saving. For this simple game, the sessions are pretty quick, so I didn't include any kind of save system for the actual game data. But if you want to know how to do that, I also have a video covering that topic. Okay, so with that we have our options window working. The volume sliders work perfectly. The next thing we need to add to our options is some key rebinding. So let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to add key rebinding to our options menu. So here we already have this nice options menu. We can modify the volume of the sound effects or the music. Next, let's handle key rebinding. Okay, so first let's build the elements over here on the UI. So let's create a bunch more buttons. But before that, let's actually make some text on the side and buttons in the middle. So let's create a brand new UI text. Call this move up text. Let's put it on the same size as the other one. So these got a font of 24. So let's put it the same thing, font of 24. Width and height, let's put both of these on 0. And down here, anchor it to the left, okay, down the middle and with no wrapping. Okay, so then over here, this is going to be the move up action. So we have move up, then we have the move down, move left, move right. Then we have the interact alternate, and finally the pause. So these are all of our actions. So let's just make all of these. So rename this. So this one is the move down. Then this one over here is the move left. This one is the move right. This one is the interact text. Then the interact alternate text. And finally the pause text. Now let's just modify the text on these. So that's the pause. That one is the interact alt. Then this one is the interact. Then we've got the move right. Then over here, the move left. And finally, we have the move down. Okay, so those are our labels for our controls. Now let's just make buttons over here on the right side. So let's duplicate one of these buttons. Let's put it over here and put it on some like 50 by 50. So this is going to be the move up button. And inside on the text, this is going to be pretty much just a W, okay? So we have the move up. Then we're going to have the move down, move left, move right, the interact alternate, and the pause. So we just need a bit more space, so let's move all of these up by quite a bit. Let's also move the music and the sound effects. So move all of these like that, okay. let's just name all these buttons. So this one is the second one, so this the move down. Then over here the move left, then the move right, then the interact button, the interact alternate button, and finally the pause button. Okay, those are all the buttons. Let's just position all of the labels exactly where they should be. Okay, so here we have all of the options, all of our bindings. Now in code, let's grab references to all the buttons and all the text inside the buttons. So over here inside the options UI, let's add all of those. So first of all, for the text, we're going to have the move up text, then the down, left, right, and so on. So let's just do all of these. So down, then over here the left, then the right, then the interact text, the interact alternate text, and finally we have the pause text. And for the buttons, let's go up here, make all the buttons. So the move up button, then the move down button, then we have the move left button, then the move right button, then we have the interact button, the interact alternate button, and finally the pause button. Okay, so we have all of these references. Over here in the editor, let's just drag them. So let's make sure we drag them all correctly. So let's do it one by one. So the move up, this is the text. And actually it's not that one, so that's already a mistake right there. We want the text from inside the buttons. So let's pick up all of these text objects. So let's go into the options. So text inside the move up, let's grab that one. Then inside the move down, let's grab that one. And the left and so on. So definitely make sure you grab the right ones. Okay, that's all text. Now for the buttons, so that's the move up button, then the move down, then the move left, the move right, the interact alternate, and finally the pause button. Okay, great. And just to verify that everything is working, let's give proper names to these objects. So the move up button text. Okay, so I've renamed all the buttons. So now over here, it's much easier to verify that we have the correct references. So the sound, music, and so on. So definitely make sure all of these are correct. Otherwise, you might go crazy when things start to go a bit weird. So make sure these are all correct, all right? Now let's begin by updating the text inside over here. So let's go into our update visual. So we go into this, set the text, and now we need to get the binding text for this binding. So for that, let's make that function on the game input. Over here, let's just comment this out. Then over here on the game input script, let's make a function to get the bindings. So technically we could make something just to grab this player input actions, but again, we don't want the options UI to know what input system we're using. It should work regardless of what input system. So we don't want the game input to return anything of this type. Instead, we want to make a nice layer of abstraction. So for that, let's make an enum to define all of our bindings. So let's make a public, since we're going to access it, enum, call it binding. And over here, let's add all the bindings. So we've got the move up, then we have the move down, the move left, the move right, then we have the interact alternate, and finally the pause. So these are all of the bindings. Now let's make a function to return the binding text. So over here, let's make a public. We're going to return a string. Let's just name it get binding text. And as a parameter, let's receive a binding. Okay, so now here, let's just do a switch on this binding, and basically just match up the enum to whatever action we have. So for example, let's begin with the interact, since these are the simplest ones. So for this one, to get the bindings, we first go inside the player input actions, then let's go inside the player action map, then for the action, so in this case the interact, and then inside we've got the bindings. This is an array of all of the bindings. In our input map, we defined all of the keyboard bindings on index 0. Later on, we're going to add gamepad bindings, but for now, we're going to have the keyboard always on index 0. So over here, going to bindings, access on 0, and let's just do a toString. Okay, so let's just return this, and let's do a default to return always this one, just like this. Okay, so let's do a quick log to see what this returns. So let's do it over here on the game input, just a debug.log, go into there, get the binding text for the interact. Okay, so let's test. And right away, yep, we do see it working. So the interact and the binding is on keyboard/E. But we don't want all of this text, we really just want to see the E. Thankfully, the input system has a really great function for just that. So instead of calling the general toString, let's call toDisplayString. Let's see. And yep, this one does return just the E key. Okay, great. So this is the one that we want. Let's do the same thing for all of the other simple actions. So we've got the interact, then we have the interact alternate, and we have the pause. So these are all the super simple ones. So just going to interact alternate, grab the binding on 0, and for the pause, binding on 0. Okay, so these are all super simple. Now the more complex one is the move. It's more complex because you can see all of the others just have one binding, except for the move over here we have a composite binding. So that's basically a binding which inside has 4 separate bindings. Basically the way that this works is that when you use a composite binding, all of these are added to the array. So this 2D vector is going to be on binding 0, then the up is going to be on binding 1, 2, 3, 4, and so on. Then the arrow keys, this one is going to be on 5. Then we have 6, 7, 8, 9, and 10. Let's do a log just to verify. So here, if we do one for the move up action, for this one, let's go into the move, and let's print out just the binding 0. Let's do a regular toString. Let's see what this returns. So up here, let's just modify our log to say the move up. Okay, so let's see. And yep, index 0 does have the move to the vector. And now if we print the one on binding of 1, yep, now this one does have the move on the doubling. So like I said, we can see that all of these composites, these are technically inside that one, but in terms of that array, it's just a flat array. So this one index 0, 1, 2, 3, and 4. So that makes it super simple to add over here. So the move up, down, left, right. And let's just do all these. So we have all the bindings, and over here just 1, 2, 3, and 4. And instead of toString, let's call the display string. Okay, so the binding text, this is all set up. So let's go up here and get rid of our testing code. We can now call this from the options UI. So over here, let's do exactly that. So when we update the visual, let's go into the game input. Let's access the static instance. Let's get the binding text. And this one is going to be the move up. So that's it. This one is going to return a string. Let's write all of them. Okay, here are all of them, so let's see. And yep, there they are, all perfect. WSAD, EF, escape. Okay, great. So the visual is working. Now let's handle the rebinding. So let's add a click event. Let's go into the move up button. Let's go into the on click. Let's add a listener. And for the listener, over here, let's make a function on the game input to rebind this binding. So over here on the game input, let's do a public void rebind binding. And we receive a binding. Now for rebinding, I covered this in detail in the dedicated input system video. First, basically, we need to disable the action map. So let's go into the player input actions. Let's access the player and disable it. So we need to do this first. Then we're going to need to find the action. So player input actions. And for now, let's go into the player and let's just modify the move up action. So we're going to call the function perform interactive rebinding. This one, as you can see, takes a binding index. And if you remember up here, we saw that in order to modify the move up, it's on bindings index 1. So let's modify the one on index 1. Okay, so this is the function. This returns an object of this type, a rebinding operation. This is a pretty complex object where you can modify all kinds of things, add a bunch of limitations and so on. Like for example, make a key not be able to be bound to the mouse or something. So there's tons and tons of options you can play with. Over here for the simple thing, let's just add an onComplete listener. So this one takes in a callback, and this will be called whenever the interactive rebinding completes. So over here, let's define a lambda, so a callback, and inside we have this. By the way, over here, this is the same lambda expression that we saw previously. So exactly the same thing as this, except when we have just one parentheses, we don't need to add them. Okay, so like this. So then on this callback, we can see all kinds of things. Like for example, we can see the action that we just rebound. This is going to contain all the data on the rebind operation. So for example, let's print out the path. So let's go into the action. Let's go into the bindings on index 1, and let's print out the path. So let's do a debug.log. And there's actually another one. So let's log the path and also the override path. These are two different things. Let's see why in a bit. We do this, and after we log, we also need to re-enable the player action map. So let's go into the player input actions, the player, and back enable this. Okay, so we're only going to need these settings on the rebind action. Then we can just call start in order to start the rebinding process. Okay, so this should work. Let's just call this from the options UI. So over here we have the click. Let's go into game input, instance, and let's rebind the binding. And for this one is the move up. Okay, with this, let's test. Okay, so here if I click on the button and now I click on the T key, and if there you go, it did work. So you can see that it print out the regular path, that is W, and the override path, which is T. So now if I exit out of the options, go back into the game, if I press W, nope, it does not move, but if I press T, yep, it does move upwards. Okay, great. So we have successfully rebound this one key. Now here, just one thing. In previous versions of the input system, when doing a rebind operation, you needed to manually dispose of this callback, otherwise it would throw a memory error. In the recent version that I'm using here, there's no error, so it seems perhaps it's no longer needed to dispose of the callback manually, but still there's no harm doing it just in case. Over here, callback.dispose. Okay, so with that the key rebinding is working, except we have two issues. The first one is that it's not very clear that it's listening for an input, and the second one is that the text options also does not update. So let's solve both those. First, let's add a visual when waiting for a key press. So inside the game options UI, let's create an empty game object. Call this the press to rebind key. Let's stretch it out, so put it on 0 on everything. Okay. Then inside, let's add a UI image. Let's put it in black, and once again, let's stretch it out. Okay, now let's also add a simple text. And for text, let's say press a key to rebind. As usual, let's put the width and height on 0, put it in bold, center down the middle with no wrapping, and increase the size by quite a bit. Okay. So that's our super basic window. Now in the code, we just want to show and hide this. So let's do that. And let's actually begin with this hidden by default. So let's disable this object. So here on the options UI, let's add another serialized field. It's going to be a transform for the press to rebind key transform. So you have this. Let's make two show and hide functions. So we show press to rebind key. We just go into that one, game object set active, this one into true, and another one where we set it to false. So just hide and set it to false. Okay, pretty simple. Let's make sure to hide this over here on our start. Okay, just like that. And for showing, let's show it when we actually rebind an action, so right in here. But since we're going to have tons of listeners to these events, let's actually make a nice separate function to handle all of the rebinding logic. So down here, let's make a function. Rebind binding. We receive a game input.binding. And then first we show the press to rebind key. And then let's go into game input, access the instance, and tell it to rebind the binding and pass in the same binding. Okay, so we have this, and now up here on the button event, let's just call in this function. Okay, very simple. So this will work for actually showing the window, but now we need to know when to hide it. And for that, let's use something that we've used a few times in this course, but never directly. Let's use a C# delegate. As usual, I have a dedicated video on them. This is basically how you can define a field or a parameter of a type which can hold a function. It's another super useful C# feature. Definitely watch that video to learn all about it. Let's go here on the game input. And down here, when we have our rebind binding, over here, let's receive a second parameter. This one is going to be of type action. This is one of the built-in delegates. It takes no parameters and returns void. So this one is perfect for a simple callback just like this one. Let's call it on action rebound. And we're going to trigger this right here after we achieve the callback. So we get the callback. Let's trigger this just like that. And let's also get rid of these testing logs. We no longer need them. So just like this. Now back here on the options UI. So we've got that. And for the second parameter, let's just pass in the function to hide that window. So hide the press to rebind key. That's it. Again, remember, we're passing in the function itself. We're not calling it. So there's no parentheses. We're just passing in the function itself. Okay, so with this, let's test. So here on the options, let's rebind the move W, and there you go, it does show up the window. And now if I press a key, yep, there you go, that one hides. Okay, great. So this is working, but over here the text is still not updating. So over here on the second callback, instead of just calling this function, we need to call this and then also call the update visual function. So as usual, let's use a simple lambda expression to do exactly both. So let's open and close the parentheses, and we do exactly this. So we hide the press to rebind, and then we update the visual. Okay, that's it, let's test. So here we are, let's rebind the move W, press on the T key, and there you go, it did rebind and it did update. Alright, great! Now let's just apply this to all of the other bindings. So first up here on the buttons, let's set listeners to all the buttons. So that's the move left, actually the move down, then the move left, move right, the interact button, the interact alternate button, and finally the pause button. And for the bindings, this one is the pause binding, the interact alternate, then the interact, then the move, this one is the right. Again, make sure you don't make mistakes here, you call them the exact same one. So the move down, okay, so all of it is correct here. And over here on the player input, let's do a switch on our binding. So K's move up, we do something. And now we could write this code directly up here and then make a move down and write a bunch more code. That would work, but that would be way too wordy. So let's write our code in a nice clean way. Basically, the only thing we need down here is we need to know the actual action we're going to rebind, and we need to know the action index. So let's just find up here exactly that. So an input action for the input action, and then an int for the binding index. Okay, and then over here, when we have the switch for all of our bindings, we just set those. So the input action, in this case, it's going to be the player input actions, player, and it's the move action. And for the binding index, this one is on index 1. Then we're going to have the other moves. So the move down is going to be on index 2. Then left and right. These are on index 3 and 4. Okay, so we have all these, and now for the other ones. So for the interact, this is the interact action on binding 0. Then we've got the interact alternate and the pause. So interact alternate and the pause. And this one is the pause action and the interact alternate action, and all of them are on binding index of 0. Okay, so that's good. So over here we are assigning the input action and the binding index. And also one thing, we need to make sure to always assign these values. So let's make sure to add a default here, just make sure it always works. Okay, great. So now down here, instead of always accessing the move, let's access whatever is stored in the input action. And for the binding, whatever it is on the binding index. Okay, so now this will work with all of our bindings. So here we are, and let's try rebinding all of them. So let's put them over here on the side. So for the move up, let's put it on T, down on G, A on F, then D on H. For the interact on Y, interact alt on J, and for the escape, let's put it on E. Okay, so all these keys have been rebound. Let's just make sure they work. So here I am moving with these keys, and yep, it does work. Go up here to interact, and do the alt interact, and now the pause, and yep, there you go, everything works perfectly. All right, awesome. So everything worked perfectly, although again, we have the same issue as previously. So all the keys have been rebound, so it's all correct, great. However, now if I stop playing, and now if I play again, and nope, there's the issue, the rebinding was lost. So just like with the sound, we also need to save the new state. Now, thankfully, the new input system has a function that makes that super easy. Let's go down to where we are rebinding things. And when we finish rebinding, let's just go into the player input actions. And let's call this function the save bindings overrides as JSON. This one is going to return a JSON string. Now, if you don't know what is JSON, go watch my quick video on it. Basically, it's a super easy to understand and widely used file format. It's very easy to read and modify. It's a format where it's stored as just text. So let's look at what this says. Let's do a debug.log over here after rebinding something. Let's see. So here, if I rebind one of these, and if there you go, there we have our JSON. So the override bindings that overrode the move on this ID on this new path. So basically, we just need to store this string somewhere. And just like we did with the sound, let's just store it in the player prefs. So first, let's define our constant. So private const string for the player prefs bindings. And let's call this the input bindings. Okay, just like this. So then down here, after we rebind the key, let's go into player prefs and let's set a string on the player prefs bindings. And we're going to save the overrides as JSON. And after we do, let's just make sure the player prefs is correctly saved. Okay, so that saves it. Then let's go on awake to load it. So over here on awake, let's load that. Let's first do a quick test to see if there's a save. So if the player prefs, if it has a key, and if it has this key. If so, then let's get it. So the player prefs, let's get the string on this key. That returns the string, and we're going to use the string. Let's just go into the player input actions, and let's call the function load binding overrides from JSON just like this. And also let's make sure we do this right after we construct the object and before we enable the action map. Okay, so that's really it. Let's test. So here we are. Let's rebind the move up to T. Okay, it rebound. Now stop playing. Now play again. And yep, here it is, still rebound to T. All right, awesome. Okay, so here we created a really nice options menu where we can modify the volume and rebind keys. The only issue that we still have is that we can only navigate the menus with the mouse. So let's add support for menu navigation with a controller in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to set up full controller support for our game, including regular actions and menu navigation. Okay, so first let's just set up the controller inputs. I have an Xbox gamepad controller connected. So let's open up our player input actions. And over here we have all of our actions, and we already made the move one a long time ago. So let's just add the bindings for the other ones. For example, over here on the interact, let's add a brand new binding. Let's go into the path and listen. And for interact, I'm going to press the A button. And again, here you can specify just the A button on an Xbox controller, or you can use the generic South button, which will mean A on an Xbox, or cross on a PlayStation, or B on a Switch, or anything else. So let's go with the generic one. For the internet alternate, let's add a binding, and for this one I'm going to put it on the X on the Xbox, so the button west. And for the pause, let's add, let's listen, and I'm going to press the menu, which is the start button. Okay, so these are the basic inputs. Let's make sure they work, and thanks to this new input system, we really don't need to modify any code. Let's just save this asset. Let's wait for the compilation, and then we can do a test. So here we are, and yep, I'm using my controller to move. Now let's just wait for the countdown, and go up there and pick up a cheese, put it, and slice some cheese. Yep, I can do that, pick up a plate, and so on. All right, so everything works. Let's also pause, and yep, that also works. Okay, great. So everything works, except there are two issues with the gamepad, especially one with the movement that I only noticed just now. The first issue that we have is the dead zone. Right now we don't have one, so if I just lightly touch my gamepad joystick, there you go, it starts moving automatically. In gamepad games, you should always have some kind of dead zone to prevent any kind of Joy-Con drift. Thankfully, that is super easy to solve. Let's just go into the player input actions, let's go into the move, find the left stick binding, and over here for the processors, let's add one, and let's add a stick dead zone. So that's it, pretty simple. This basically considers that inputs under this minimum to be 0, and above this maximum to be 1. So if you have joystick drift, where when the joystick is idle, it's always moving by, say, 0.1 in direction, this helps solve that problem. Except in our case for our game, we're only using normalized inputs. So actually, for our use case, let's increase the minimum by quite a bit. I did some testing and 0.5 works quite great, and the max at default, that is just fine. Okay, so that's it, one problem solved. Let's just go ahead, save this asset. Now the other bigger issue that we have is if I approach a counter and I try to look at it, it's really difficult. It tries moving left and right instead of actually facing the counter. That's because of the logic that we added a long time ago, that logic to help the character controller feel better when moving on diagonals against a counter. That works great for keyboard because it's digital, so it's either moving fully left, fully right, or on the diagonals. But it messes up the controller, which is analog. On the player movement, if we are not moving perfectly up or perfectly down, then it's considered a diagonal. And on the gamepad, it's really difficult to get a perfect just up or just down input. We're always going to have a tiny bit of either left or right. So that's the issue that we have here. And thankfully, the solution is actually pretty simple. Let's go over here onto our player script, and let's scroll down into the handle movement function, okay? So we're doing a can move using the regular move direction, and if it doesn't work, then it's over here that we are attempting only the X movement or only the Z movement. And for doing that, we made it so we can move if there's nothing only on the X, and if we have any movement at all on the X. So if it is different from 0. Basically, the issue here is if the moveDir.x is, let's say, 0.001, that is still different from 0, so it is still going to trigger this logic. So basically, let's just widen this gap. Instead of testing literally just different from 0, let's test if the moveDir.x, if it is under, say, minus 0.5f, or if moveDir.x, if it is bigger than plus 0.5f. So instead of being exactly just on 0, we're only going to consider diagonals if we are at least moving 0.5 either left or right. So we just do this, and same thing over here, except we just test for the Z. So the move there.z and the move there.z. Okay, so like this, it should feel much better on the gamepad and still work exactly the same on the keyboard. So let's test. So here I am moving around, and yep, now it is much easier to just stay around and look straight at a counter. Okay, so that's great. So I can pick up, and this is all much easier, and the character is no longer just sliding left and right nonstop. Okay, that's great. So now that this is working, let's add support for rebinding our controller bindings. So over here on the game input, let's do it just like we did for the keyboard. So let's add a bunch more bindings over here on the enum. Let's add the gamepad interact, then the gamepad interact alternate, and then the gamepad pause. Okay, so we have our bindings. Then let's go down and add them to both our functions. So first the text and then the bindings. So over here on the text, let's copy pretty much this. We're going to have the gamepad interact. Then we're going to have the other two. So the gamepad interact alternate and the gamepad pause. Okay. Now for these bindings, we're going to use the same actions. So this one is the interact alternate, and over here we have the interact. And over here on the input actions, we saw that we added for all of them. On index 0, we have the keyboard, and on index 1, we have all of the gamepads. So over here, that's literally the only change. For the gamepad, let's go into bindings and access the array on index 1. Okay, and then over here on the rebind binding, it's going to be pretty much the exact same thing. So let's copy all of these, change this to the gamepad interact, then the gamepad interact alternate, and then the gamepad pause. So on all of these, all we need to change is just the binding index, put them all on 1. Okay, so with that, all of the code over here on the game input is working perfectly. Now let's go over here into our options UI. So we've got all of our buttons. So let's duplicate our buttons. Let's just go into the interact, the pause, and so on. Let's duplicate, push them to the right side, okay. And just change the name. So let's go into all of them. So this one's the gamepad interact button, then the gamepad interact alternate, and finally the gamepad pause, okay. Also inside, let's also rename these buttons just to make sure the text works great. And let's also make sure that these show up behind the press the rebind key. So let's drag them, put them above. Okay, so that's our setup over here on the options UI. Now let's go over here on the options UI script, and let's add references to our buttons and to our text objects. So let's copy all of these, the gamepad, and add all of these. This is the pause, the interact, and the interact alternate. And then down here, the exact same thing. Let's add all of these. Okay, like this. Now over here, let's drag all of our references. So on the options UI, let's make sure to always drag the correct things. So the gamepad interact text, the interact alternate text, and the pause button text, and then the buttons themselves. So the pause button, interact alt, and the interact button. Again, make sure you always drag the correct references. So check and double check, make sure everything is correct. Okay. Then over here for our code, let's first handle the text over here. So the text for all of these. So the gamepad interact text, then the gamepad interact alternate text, and finally the gamepad pause text. And we just go the gamepad pause, the gamepad interact alternate, and the gamepad interact. Finally, over here on the buttons, let's do the exact same thing. So gamepad interact, interact alternate, and the pause. Okay, so we added everything. Let's do a test and see if everything is working. So over here, let's pause the game, go into the options, and for the interact, let's modify this one. Instead of A, let's put it on B. And yep, there you go, it did go. So let's close, let's resume, and now let's see. So if I approach and I press A, nothing happens. Press B, and there you go, it does interact. Okay, awesome. So the rebinding is all working perfectly, except we have another obvious issue. I can pause with the gamepad. However, now with this paused, I cannot click on any of those buttons. And if I go back to the main menu, over here I also cannot do anything with the controller. So let's solve that. The first step is on the event system object. Look at how it shows us this warning. Basically, if we're using the new input system, we should be using a different input handler here. Thankfully, this is super easy. We just need to click on this button, and yep, that's it. It automatically sets it up. Now, the way that this works is by pre-selecting buttons. And in order to better see which button is selected, we should probably add a more visible color. Let's go into our pause window. So for now, let's hide over here the options UI, show the pause window, and we have these 3 buttons. Let's select all of them. And over here on the right side, on the button, we can see one option for the selected color. So instead of being white, which is going to be really difficult to see, let's put something really visible. So let's say like a bright green. Okay, like this. Let's do the same thing for all of the buttons on the options UI. So let's show this one and find all of the buttons. So we've got all of these ones down here and these 3 ones up here. And let's do the same thing. So on the selected, let's put it all on a nice green. Okay, so all the buttons have a nice selected color. And just like this, if we test, and if I pause the game, and right now nothing is selected. So right now I cannot do anything with the controller. However, if I press over here with the mouse on this button and then let go whilst outside the button, yep, look at that, now that button is selected. So now as long as that one is selected, now if I move with the mousepad, yep, now I can navigate through this menu. And if I press on A, yep, I can essentially click that button. So that's great. Basically, all we need is to make sure that we select the button as soon as the pause menu shows up. So let's go over here on the Game Pause UI script. And then over here, let's go into the show function. So when we show this window, when we do, let's go into the resume button and just call the select function. This will make it selected. So that's it. And with this, if we test, and now here with the game playing, if I pause whilst pressing the button on the gamepad, and if there you go, that one is selected, and now I can select any option. Okay, that's great. So now it works fully with just the gamepad, except now if I go into options, yep, now you can see that the button that is selected is still in the options one over there on the background. So let's also make sure to select the button on the options as soon as the options window shows up. So over here on the options UI, let's go into our show function and let's just select the sound effects button and just call select. Okay, let's test. So here, let's pause, go into options, select, and yep, there you go, that did work. Okay, great. Except we have another issue. As I move up or down over here on these buttons, yep, look at that, some of them are a bit strange. Like for example, over here on A, I'm moving up, and look at that, it actually selected the resume button behind it. So as we are moving up and down, we are actually selecting buttons on both menus. That's very strange. Basically what is going on is that since both windows are visible, the game is trying to guess which button we want to select. Basically what is happening is Unity is trying to use automatic navigation. If we select a button, so let's go, for example, let's hide the options and show just the game pause. Okay, let's select one of these buttons. And over there on the button component, we can see navigation is set to automatic and we have a button to visualize. And if we click on that, yep, over here we can see all kinds of arrows. For example, we can see one over here on the options that seems to be going to some button in there. That is going to be the button that is showing over there. So if we move down from the options, we're going to end up over here on the Interact Alt button. Now usually the automatic navigation actually works very well. The only reason why we're having problems is because we have both windows active at once. One solution to this is to make the navigation explicit. So let's hide the options here, and over here on the resume, on the navigation instead of automatic, let's put none and then let's select explicit. And yep, now we have all 4 fields. So we can decide which object gets selected when we are here and we move up, down, left, or right. So for example, here we would drag for the up. Going up, we could go into the main menu, so we would drag that button, and going down, we could drag the options button. So that's one solution, just add the explicit navigation to every single button. Or another simpler solution is let's leave this one on automatic, and instead we're just going to hide the pause window once we are in the options window. So over here on the Game Pause UI, let's see over here we are showing the options UI, and when we do, let's just call hide on this. So we are going to hide this window when we show the options. And then on the options, we want to know when the options closes so that we can show this one again. So over here on the show function, let's receive an action. This is what we're going to do when we close the options. Let's call it on close button action. And let's store it up here. So let's store a simple private action for this. Okay, so we have this. And then down here when we have our show function, when we have, let's set this equals this, we store this. And then we're just going to run this action whenever we click on the close button. So let's go over here, the close button, we've got that one. Let's hide the options window and trigger this action. So now all we need is over here on the Game Pause UI, let's pass in, and basically when we close the options UI, we want to show the pause UI. Okay, so let's test. So here we are, let's pause the game. Okay, let's go into options and open it. And if there you go, it only shows the options. And over here, moving up or down works perfectly, and moving left and right also works perfectly. And now if I want to go back, let's go into close, press it, and there you go, back into the pause menu. All right, awesome. So everything is working perfectly. Now the last thing we need is over here on the main menu, so let's do the same thing. First, let's open up the main menu scene. Let's save the changes, okay? And over here, let's begin by doing the same thing on the event system, so let's replace it, okay, great. Then let's go inside our canvas, inside the main menu UI, let's select our buttons, and once again, let's modify the select color, put it on nice green, alright. And since over here we only have one menu, we could set it as selected over here on the main menu UI script. That's one option, or we can just go into the event system, and over here on the event system, there's a field for the first selected. So we can just drag the play button and that will automatically make it the selected one. So let's test. And yep, the play button starts off as selected and I can move up or down. And if I press a button, yep, there you go, here I am playing the game. I can pause, I can resume, go back to the main menu and so on. Alright, awesome. So here we added the final thing we needed to make our game fully playable with the gamepad. Thanks to how the input system works and the menu automatic navigation, this was a pretty simple task. With this, our game is pretty much completely done. However, the next lecture is also one of the most important lectures. It's all about polish, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to add all kinds of small things to polish up our game. If you're a regular on this channel, then you've certainly heard me say that polish is what separates good games from great games. So as you build your own games, make sure you don't neglect polish. Here, let's add a bunch of small, tiny things that will make a big difference in the final game. Let's begin with a very simple, very visual one. Let's just add some walls to our map. And first, let's just hide our canvas so that it's not blocking our view. So again, over here we can use the buttons on the hierarchy to hide it. Okay, great. So let's add some walls, and for that, let's create a brand new 3D cube. Let's name this a wall. Let's put it quite a bit thin, so over here on the scale, for the X, let's put it 0.25. Then on the Y, let's put 3. So something like this. Then we modify the Z, so let's put it over here on the side, right next to the counters. Okay, so that's the wall. Let's just stretch it out one direction and the other one. Okay, so that's our basic wall. Now in the included project files, there's a nice wall material. So let's go over here into Assets, under Materials. And yep, here it is, the wall material. So let's just drag it and use this one. And yep, there you go, it's just a nice simple gradient. This is also an example of how you can take something simple and make it a bit more interesting. If you look at this material, the base texture is really just this. It is literally just a simple vertical gradient texture, and then with a color applied to it, and it looks pretty good. Okay, so this wall, let's put the wall on all three sides, so let's duplicate this, so just select and press Ctrl D, duplicate. Let's put one on the other side, so right there, right next to the counters, okay. And finally the one there, so Ctrl D to duplicate it, let's push it over there on the side, and rotate it 90 degrees. And let's put it just like that. Let's just scale it to get to that end and to get to that end. Okay, so we have our nice walls. But over here, if we're playing the game, we can still see the floor on the outside. That looks a bit ugly, so let's fix that. Let's create another object, and let's create a 3D object, another cube. And for this cube, let's put it over here on the side. And this one, let's use the black material. So again, in the included assets, there's this nice black material. There you go, it's completely black, nothing to it. So let's just use this as kind of a hider. So let's just scale it quite a bit and lift it up. Okay, so there it is, a black material right next to the wall. And let's put another one over here on the left side. And just like that. Can also put another one on the back there, even though I don't think the camera can see that part, but still, let's put it. So just put it like that and stretch it out. Okay, that's good. By the way, over here on the outside, it doesn't have to be perfect. It doesn't have to perfectly match. The camera is never going to see that position, so it doesn't matter. It only matters what the camera can see. And if we play like this, and if there you go, now that looks quite nice. If we want over there, we can get it together just a little bit. And we can also move the camera forward a tiny bit. So over here on this one, let's push it just a little bit to the left. Okay, and now on the virtual camera, let's play the game. And now here, if we want, we can push it up a little bit, something like this. So let's put it on this Z, so let's copy it, stop playing the game, and let's paste it just like that. Okay, so here's our game. And as you can see, with just this one tiny change, just adding some walls and a nice black outside, just with that, it already looks so much better than having some counters in wide open space. Now for another simple one, let's add some nice particles while the player is moving. So in the included assets, if we go inside the prefab visuals, over here is a nice one for player moving particles. This one, as you can see, is a particle system. So let's drag it over here into the world to see what it looks like. And as you can see, by default, it's actually not spawning anything. So I can make sure that this one is running and nope, nothing is spawning. So this is actually set up in a really interesting way, is that instead of spawning particles all the time, it only emits while moving. So if I click to move this object, there you go, the particles start emitting, and if I stop, they stop. So this one is definitely perfect for a player particle system. The way this is set up is over here on the emission. On rate over time, it is set to 0, so it doesn't spawn anything automatically, and it only has over here the rate over distance. So as it moves, it's going to spawn that number of particles. Then the other settings, they're all pretty basic. So there's some gravity, so they fall down, just like the stove counter particles. The simulation is over here on space, so that as I move, the particles stay behind. This is important. If I were to put that in local and I move it around, look at that, this is not what we want. We want the particles to essentially stay behind instead of following this transform. So that is why this change is super important. If that one is set to whirl, and as I move, yep, the particles stay behind. Okay, great. And the other properties are all pretty basic. For the shape, it's a cone pointing upwards. Then for the size over lifetime, again, just a basic curve, constantly becoming smaller and smaller. And down here on the renderer, instead of rendering a quad, it's actually rendering a mesh, and it's rendering a sphere mesh. So that is just so that it looks a little bit better, I think, than just having a sprite particle. Okay, so that's it. So in order to make this work, really all we need is just attach it to the player. So let's find the player, make this object a child of the player game object. And again, let's also make sure to set all of this to 0, so the position on 0, 0, and 0. And there you go, just with this, that's all we need. If we test, here we are stopped and there are no particles, and as I start moving, yep, there you go, some nice particles around the player. Okay, great. Next, let's add a pretty obvious one, some kind of mini tutorial. We want a window to show the controls and the goal of the game, and wait for the player input before we start the countdown. So for that, let's go into our canvas. So let's show our canvas. And inside, let's create an empty game object, call it the tutorial UI. Let's drag this one above the game pause window so that it shows up behind it. Let's double click to center it, and let's press on the 2D button to go into 2D mode. Okay. Let's also hide those two windows so we can actually see what we're doing. So let's hide all of these. Okay, great. Now this one, first of all, let's stretch it to occupy everything. So put 0 on everything. Okay. Then inside, let's make a UI image for our background. Once again, let's stretch it, put it like this. And for this one, instead of black like we've used for all of our windows, let's actually leave it on white. Put it on an alpha of something like half, so something like this, just to be a bit different. Then on top of this, let's make another image. So let's make another UI image. And for this one, instead of stretching, let's give it a size. So let's put it on 1280 by 800. And for the image, I created a nice image for the tutorial. If we go inside the assets and then inside textures, yep, here is a really nice tutorial image. So let's just go ahead and use it. So on the image, let's drag it. All right, there's our nice tutorial image. So this has a pretty basic tutorial. So the recipes come in from the customers, then the player has to prepare the correct recipes and deliver them on a plate on the delivery counter. So just a very basic tutorial. And also over here, it's very important for the player to know how to actually play the game. So there's some labels for the controls, and now we're going to dynamically add some keys on top. So let's do that. Let's create an empty game object. Call this the key. Let's put it on a size of 40 by 40. Okay. Now let's go inside. And inside, let's make an image. Let's name this the background. And for the sprite, let's go with the included circle, so default circle. And for the size, let's stretch it to occupy everything. Put it on 0, 0, 0. Okay, there's our nice key. So we have the background, and for the background, let's actually make it just a little bit darker. And let's also add just a nice shadow. So maybe 3 minus 3. And let's also make a nice outline. Let's put it on 2 by 2. Full alpha, so something like this, just to be a nice one, maybe 1 by 1. Okay, so that's just the visual. And then on top of it, let's add a text. And this one is essentially going to be the key. So let's put a key. For the width and height, let's stretch it to match the parent size, okay? Then for the font here, let's go with maybe just a 20. Let's put it centered down the middle. And also let's put it on bold, okay? So that's our nice key indicator. So this is our key. And we're going to have the movement. So the movement on the keyboard is going to have 4 keys. So let's just duplicate. So 1, 2, 3, and 4 keys, okay? Then on the gamepad, that one is actually not rebindable, so let's put this one as static. So let's just go inside the text, and just say left stick. And let's lower the font size so that it fits in there. Okay, great. Then for some more keys, we're going to have the interact action, then the interact alternate, and finally the pause action. Then let's just duplicate these to be on the other side. Okay, so these are all of our keys. Now, instead of having key 1, 2, 3, this is very difficult to understand, so let's give it some proper names. So this is the key move up, then we have the key move down, then the key move left, then the key move right, then this one's going to be the key gamepad move, then we have the key interact, the key interact alternate, the key pause, this one is the key gamepad interact alternate, this one is the key gamepad interact, and finally the key gamepad pause. Okay, all of these, and since we're going to drag references to the text objects, let's also give those a name. So just copy, drop it with text, just like this. Okay, so those are all the names, so everything is nice and organized. Okay, great. Now let's make the script to run this. So our tutorial UI, let's go down into our UI scripts, create a brand new C# script for the tutorial UI, and let's attach the script. Okay. So first, let's drag references to all of our keys. We only need the text, so let's do a serialized field of type text mesh pro UGUI. Again, never make the mistake, always use the UGUI one if we're working in the UI. So the key move up text. So let's add all of these. Okay, these are all the references. Then over here, let's drag on and make sure to drag the correct ones. Okay, let's double check to make sure all the references are correct. Okay, they all seem correct. All right, great. And then over here, let's do pretty much exactly the same thing that we did over here on the options. So we need exactly this. So let's copy this, and over here, let's do just that. Let's do a private void update visual. And on this one, let's do pretty much this. So the key move up text. And on this one, you get binding text of move up. Yep, let's just do all the others. Okay, so those are all the bindings. That's great. Now let's go over here on a private void start. And on start, let's update our visual. All right. And also, let's make sure this updates just in case the player rebinds something from the pause menu whilst the tutorial is still visible. So we just need to know when that happens. So let's go over here onto the game input and make a nice event. So public event, event handler. Let's call it on binding rebind. Okay, we have this event. And down here, when we have our rebind binding function, we do this, we rebind, and over here, let's invoke this event. Okay, just like this. So then on tutorial UI, let's go into the game input, the instance, on binding rebind. Let's listen to this event. And as always, let's rename this. So let's put it game input. Okay, when this happens, let's simply update the visual. Okay, that's it, pretty simple. So let's test and see if the inputs are correct. And if there it is, we do see it correct. So we've got was, we've got E to interact, F, and over there we've got the gamepad. Okay, great. So all the buttons are correct. All that's left is the show and hide. So over here, let's make the usual two functions. So private void show and a private void hide. And for these, game object set active. And this one is going to be into false. And this one is going to be true. Okay. So for show, up here on start, let's actually show it by default, even though it's actually already going to be shown, but still, okay. Then for the hide, this one we want to hide when we press the interact action. However, when that happens, we don't want just this window to hide. We want the Kitchen Game Manager to change the state. So over here on the Kitchen Game Manager, we currently have the waiting to start, and that one actually has a timer. So we count down a timer and then we start. Whereas right now we want it to be based on player input. So let's modify this to not be based on timer. So let's just get rid of this timer. And now let's see all these errors. So on waiting to start, we are not going to count down any timers. Instead, let's listen to the game input. So game input, let's listen to the on interact action event and rename this to the game input. Okay, so when we have this event, when the player presses the interact action, let's check if the state, if this one is on waiting to start. If so, then let's modify the state. So let's go into state and we're going to go into the countdown to start and let's trigger the on state change event. Okay, so that's it. So we're only going to change it on the player input and nothing over here on the update. Then for hiding the tutorial over here, one approach would be to listen to the interact action and hide it, but I think it makes more sense for this to only listen to the kitchen game manager state. That way, if we wanted, we could also modify how this one changes the waiting to start. So let's listen to the state. Over here on tutorial UI, let's go into the kitchen game manager, the instance, and let's listen when the state changes. So here we are going to check if the kitchen game manager instance, if it is on the countdown to start active. So if the countdown is active, then we're going to hide this. Okay, so that should do it. Now let's just do one more small thing. The delivery manager is currently spawning a recipe whilst we're still reading the tutorial. That's not quite right. So let's go over here on the delivery manager. And right now this one starts off at 0F and starts counting it down right away. Instead of always doing it like this, let's just make sure that we only spawn a recipe if the game is playing. So that's super simple. Over here, kitchen game manager instance is game playing. If so, then we are going to spawn a recipe. And let's do the same thing on the plates counter. So let's go in the plates counter. So here we are on the plates counter. So we count down timer and spawn some plates, but let's also make sure we only spawn plates if the game is playing. Okay, so with all of this, let's test. And right away, here we are. We can see our nice tutorial teaching the player how to play. Okay, great. Here we've got the controls, everything. And we're currently waiting for an interaction. We can see over there, plates are not being spawned and recipes are also not being spawned. But as soon as I press the E key, and yep, there you go, the countdown starts playing and we've got everything else. And yep, there you go, the game starts. And after a while, yep, we've got plates and we've got recipes. All right, awesome. So next, let's polish the countdown visual. Right now, it's pretty basic. It's just a static number. So let's add a nice animation to it. Let's go inside the canvas. Let's find the countdown UI. So the game start countdown. Okay. So here it is. We just have some basic text. Now let's go into the main game object and let's add an animator component. Then let's create a brand new animator controller. So let's create a new, down here, an animator controller for the countdown UI. Over there, let's assign this controller. Okay, now let's open up the animation window. So window animation, open up the animation window. Okay, let's create an animation clip. And over here, let's name this the countdown UI number pop-up. Okay, that's great. Now for making the animation, we want to basically make it shake and also make it fade away. So one very useful component is the canvas group. So over here, whilst on the parent, let's attach a canvas group component. This one is a really useful component. In this case, the main benefit is it lets us easily animate the alpha. So let's go ahead, enter on recording. Let's go into the frame just before 1 second. So let's go into 60 frames because we are on 60 frames per second. Over here, let's record the normal keyframe. So let's modify the scale a tiny bit just to record it and let's reset it back to 1. Okay, just to record the keyframe. Then for rotation, let's rotate it on the Z, then put it on 0. Again, just to record the keyframe. Okay, great. So now we can go back into the first frame. And over here, let's first make it smaller. So for the size, let's put it on 0.6. Then let's rotate it to the left. So let's put 17 over here on the Z rotation. Okay, like that. Now let's move up by just 3 frames. So on frame 3. Over here, let's make it quite a lot bigger. So let's put it on 1.3. And let's rotate it to the opposite position. So minus 17. Okay, that's great. That's a nice start. Now let's put it on frame 10. And over here, let's set the rotation to 0. And for the scale, put it on 1.1. Okay, so now finally over here on frame 50, let's set the alpha onto 1. And then on 1 second, let's put the alpha on 0. Okay, so let's preview. And if there you go, a nice simple animation. Okay, so that was great. Now we just need to play this when the countdown happens. So let's stop recording. Let's go inside the animator controller. So here it is. We've got our number pop-up. And we basically just want to play this animation whenever we want. So let's put it and make a transition from the any state onto the number pop-up. On this transition, let's make sure we have no exit time, and for the settings over here for duration, let's put it on 0 so that it's instant. Okay, great. Now obviously we need a condition, so on the parameters, let's create a brand new trigger. Call this the number pop-up. Let's select that one and trigger it on this trigger. Okay, great. So now for handling this logic, here we have the usual question. So do we put this visual logic on the same UI script, or do we separate the animations from the UI? For me, I find that the UI is usually part of the visual, so sometimes I like to mix the two, and sometimes I keep them separate. It really depends on a case-by-case basis. This visual is so simple and so connected to the actual UI logic, so over here let's put them together. So let's open up the game start countdown script. And over here let's first grab the animator, so private animator for the animator. And on private void awake, let's just get the animator and just get component of type animator. Okay, so we have the animator. Now we basically just need to keep track down here where we're modifying the text. We're doing this on every update, but now we need to know when this number changes. So let's basically just keep track of the current number and the previous number. So first of all, over here, an int for the countdown number. And we're going to get this. So this is our countdown number. And over here, we set it to string. Okay, and we just need to use a different function. So instead of cl, let's use cl to int just to convert the output into an integer. Okay, great. So we have the countdown number. Now we just need to know if this one is different from the previous one. So let's go up here. Let's define a private int for the previous countdown number. Then when we go down here, we've got the current countdown number, okay? Then just check if it's different. If it is different from the current countdown number. If so, then let's update it so the previous one becomes this one. And now let's fire off the animation. So let's go into the animator and set the trigger. And again, we don't want to use strings, so let's go up to the top of the file, make a private const string. Let's call this the number popup and number popup. Okay, so we have this, and down here we just set this trigger. Okay, so that's it, pretty simple. And just for fun, let's also add a nice sound effect. So let's go over here onto the sound manager and let's make a function to play sound. So just like we did over here for the play footstep sound, let's make another one. For this one, let's call it play countdown sound. And for this one, let's not receive a volume or position. And we just play, let's say, just the warning sound. So just down on vector3.0 and with the current volume. Okay, so we have this function. And then down here, just going to sound manager instance and play the countdown sound. Again, we could refactor this code to separate the UI logic from the animation from the sound. That is one approach. And it's actually one thing that we're going to do in the next polish stage, but this one is also a possible thing since the UI is always so directly connected to visuals. Okay, so with this, let's test. So here in the options, let's just make sure that we have our sound effects. So let's make sure they are playing. Okay, great. Now let's go ahead and play. And there you go, we have our nice countdown number. And there you go, it looks great. So it looks great and sounds great. All right, awesome. As you can see, just by adding a simple animation and some simple sounds, it already looks so much better. Now the next thing we want to polish is on the stove. So let's go into our stove, back into our counters, back into 3D and zoom in over here. Okay, let's also make sure that we hide the canvas just so we can play around this. All right, great. So there's our stove. And for this, we want to add basically a warning icon and a nice sound when the meat is about to burn. So let's go inside the stove counter prefab. Okay, so now inside of this, we already have a nice generic progress bar UI. And like I mentioned, if you want to get some more custom behavior, you can combine a generic bar like this one with some specific component. So that's exactly what we're going to do right now. So over here, let's create a brand new canvas. As usual, let's make it a world space canvas. For position, let's put all of this on 0. Let's just lift it up by a bit, so set it on a Y of 3. Okay, great. Then let's add our super useful look at camera component and make it camera forward. Okay. Now inside, let's go ahead, create a new image. Let's put it on a size of 0.5 by 0.5. Okay, just a nice square. And for the sprite, there's a nice warning image in the assets. So it's this one. Here we have the warning. Okay, great. Basically, we want to show this when the meat is about to burn. So let's make a script to run this. And on the canvas, let's give it a proper name. So let's call this the stove burn warning UI. Okay, so let's make the script to run this. So a new C# script with the exact same name. And over here, let's attach a script. Okay, great. So now the first thing that we need is obviously a reference to the stove. So let's make a serialized field private for the stove counter, Okay, here in the editor, let's drag the reference of the stove counter. Okay, great. So now we basically just need to know when the food is about to burn, and for that we can actually listen to the onProgress event. So let's do a private void start, and on start let's go into the stove counter and let's listen into the onProgress change event. Okay, so we have this one, and basically we're going to want to show this element. So let's define a bool show. We're going to want to show this when the progress normalized is above a certain amount. So let's define a float for the burn show progress amount, and let's say on 0.5. So on this one we show it. Except obviously we don't want it to be shown when the food is just cooking. We only want it to show when it's about to burn. So that means we also need to check the state on the stove counter. So let's make a function to check if we are in the state that we want. So we're here on the stove counter, let's go down to the bottom, and let's make a public bool is fried. And over here we just return if the state equals state.fried. Okay, that's great. So now here we're going to show if the progress is above 0.5 and the stove counter is on the fried state. Alright, so that's the logic that we want. Then we just want to show our hide, so let's make the usual functions. Private void show and a private void hide. And just do game object set active into either true or false. And over here, if show, then let's call the show function. And if not, let's call the hide function. And of course, on start, let's start off as hidden. Okay, that's it. Let's test. Just over here in the editor, make sure the reference is dragged, and let's save the prefab, go outside, and hit on play. And yep, right away, there's no element. Okay, great, now I place it. And yep, while it's cooking, there's no element. And now once it's on the halfway point for burning, and if there you go, we've got the nice warning. Okay, awesome. So now that this is working, let's just add a nice animation. So once again, let's go inside the stove counter, and on the burn warning UI, let's add an animated controller. Then let's actually create the animated controller. So let's create a brand new animated controller for the stove burn warning UI. Then let's assign it, okay. And over here on the animation window, let's create an animation. Let's put it on the same folder and call it, for this one, let's say flash. We're going to make it flash. And then again, for making it flash, let's use the same component that we used a while ago. So let's add a canvas group. So here it is. Now we can play around the alpha, so super useful. Although I should say that at this point, since we just have a single image, we could just record a change over here on the alpha for the image itself. However, one place where this component is super useful is if you have multiple images. So if over here I duplicate this one and I put it off to the side, if I change the alpha on one of them, then obviously it only affects that one. But if I go over here and I modify the canvas group, that changes the alpha for both of them. So if you have a group of images, then using the canvas group makes it super simple. So anyway, so here we have just our image. Let's go ahead and record, and let's say we start off on an alpha of 0, then after 10 frames go into alpha of 1, and after 20 frames back into an alpha of 0. Okay, so that's it, a super simple, very basic animation. We don't even need any logic since we just want this animation to play non-stop. So that's great, that should be working. Now let's add some sound. So for that we could make another script, but already on the stove counter we already have a nice sound component. So let's open up this script, the stove counter sound. So this is basically where we're playing or stopping the sizzling sound. So over here we can just add the warning sound. We're going to play the sound just like we have over here for the burning UI. So let's actually copy these same components, and over here let's paste it. So for this one, instead of show, let's give it a proper name. So play warning sound, except it's not on state change. So let's actually listen to the other one. So stove counter on progress changed. Let's listen to that one, and it's on that one that we use this. Okay, so we've got that one. And then for playing the warning sound, we're going to want to basically play it every certain amount of time. So let's make over here a private void update. And on update, let's just define a private float for the warning sound timer. And so down here, we just count it down as usual, time.delta time. And if this one is under 0, if so, then let's reset it. So define a certain maximum. Let's say 10 times, or maybe just 5 times per second. That should be good. So we have this, but obviously we only want this to run if we should be playing the warning sound. So let's actually save this one up here. So private void for these play the warning sound, and then we set it on this one. And down here, let's just go, and we're only going to run this if play the warning sound. Then we're going to run our timer logic. All right. And then over here, all we need is to play that warning sound. So let's actually go into the sound manager. And just like we added the countdown sound, let's add another one. So let's say the play warning sound, and for this one, let's receive vector 3 for the position, and we're going to play the warning sound on this position. So now over here on the stove counter, let's go into the sound manager, the instance, and let's play the warning sound, and pass in the stove.transform.position. Okay, that should do it. So we now should have a nice warning sound, and over here we should have a nice animation on the burn warning UI. So let's see both of those. Okay, so let's pick up some meat and drop it. And right now it's cooking, okay, great. And once it gets to the halfway point, if there you go, now we have a nice warning sound. Alright, awesome. Let's just add one more tiny thing. Let's make the bar itself also flash red when we're about to burn. So once again, let's go inside the stove counter. And on the progress bar UI, let's add a nice animator. And let's go ahead and make one. So let's create a new animator controller. For the stove burn flashing bar, let's go ahead and assign it. So it's the one on the progress bar. Let's add the stove burn flashing bar. Then on this one, let's create new animation. Let's go inside the assets, animations. Let's make one and just call it idle. For this one, we're going to want the exact same color as the normal color. So let's go into the bar and set the color, just save a keyframe over there. Okay, so that's what we want. Now let's make another animation. So let's stop recording and let's actually duplicate this one. So duplicate it. And for this one, name it flash. Now, of course, we need to add it to the animator controller. So let's go over here and drag it on top. Okay. Now for the animation, let's select the flash. And for this one, let's go ahead, click on record. Let's start off on this one. And after a few frames, so let's say maybe after 10 frames, let's flash in red. And after 20 frames, let's copy paste the same frame. Okay, so that's our nice flashing bar. Now let's just set it up. So let's go into the animator. And over here, we're going to have a transition from that to flash and from flash back. Now all we need, of course, is an animator to control this. So let's make a new animator parameter. Let's make it a boolean and call it isFlashing. And again, make sure to be careful with case sensitive. Okay, so from idle into flash, let's go ahead, remove the exit time. For duration, make it instant, so 0. And for the conditions, when that one is true, okay, great. And for going back, once again, same thing, so instant. And let's make the condition when it's false. Okay, that's it, super simple. Now let's make a script to run this. So let's go ahead, create a brand new C# script for the stove burn flashing bar UI. Let's go ahead and add it to the bar. So that's the flashing bar UI, okay. Over here, let's do pretty much the same thing that we did on the other one. So let's go over here onto the stove burn warning UI. Let's actually copy exactly this. So let's go on this one and paste this one. Then back here in the editor, let's drag the reference to the stove counter. And over here, the logic is going to be very, very similar. So the only difference is we have an animator. So the animator, and we're going to grab it on private void awake, animator get component of type animator. So we have the animator, then let's define the parameter. So private const string for the isFlashing, and let's set it isFlashing. Okay, we have our parameter. And now down here, instead of showing and hiding, let's just go into the animator in order to set a bool. And the bool will be the isFlashing, and let's set it based on show. So either we show or hide, and we actually don't need these functions. And by default, of course, let's leave it on false. Okay, so that's it, super simple. Let's test. Just make sure to save the prefab and hit on play. Okay, let's go ahead and cook. So let's pick it up and drop it. All right, so it's cooking. Let's wait for it to be burning. And as soon as it gets there, yep, there you go. We've got a nice warning, a nice flashing bar, and a nice sound effect. So all 3 warnings making our stove much more polished. All right, awesome. Now just for balancing, let's play around the timers. So let's go into our scriptable objects on the frying recipe SO. Let's make this one take 5 seconds. Then on the burning recipe, for this one, let's make it take 6. And finally, let's also add another stove. So let's take our stove counter, duplicate the prefab, let's put it over here. So rotate it to the side, let's get rid of this one, and put this one right in there. So on 7.5, 0, and -1. Alright, so we now have 2 stoves. I can put one cooking, put another one, and I can start cutting down some cheese. Start cutting, and before they start to burn, let's actually here. There you go, that one is about to burn, so let's pick it up quickly. And that one is actually going to burn, but I got it. Okay, great. Alright, awesome. Everything's working great. Now for one more polish element, let's make a nice visual when we deliver either a correct or incorrect recipe. I think it would look good as a world canvas on top of the delivery counter, so let's do that. Let's over here find delivery counter, let's go inside the prefab. And now in here, let's create a new UI canvas. Let's name this the delivery result UI. And as usual, let's make this a world space canvas. So put it on world space. And for the position, let's actually lift it up, and then we're going to make it look at the camera. But just like this, it might actually go inside the wall. So let's put it over here to the side a little bit. So let's put it on this position. So on the X of minus 1.6, on a Y of 3, and on a Z of 1.2. Okay, that's the position. So right there, that is going to be looking at the camera. Now inside, let's create a new UI image. It's going to be our background. And for the size, the width and height, let's put it on 2.2 by 0.9. Okay, that's our background. For the color, let's tint it in a nice green. So let's put it something like this. Then let's also add a nice outline. Let's put it on full alpha. And for the size, let's put it on 0.1.1. Then let's also add a nice shadow component. For this one, leave it on half alpha. And let's put it on 0.2 and minus 0.2. Okay, so that's a nice visual. Now on top of it, let's create a new UI text. Let's call it the message text. And for the message, we're going to say something like delivery and then underneath success. Let's put it on a width and height of 0. Let's put it on a super tiny font. So let's say just 0.25. Let's put it in bold and put it down center and get rid of wrapping. Okay, that's it. Let's just push it a little bit on the left side. So on minus 0.32 on the X. Okay. And now next to it, let's make another UI image. For this one, call it the icon image. Let's put it with a size of 0.5 by 0.5 and put it over to the right side, so on an X of 0.7. Okay, and now for the sprites, included in the assets are two nice sprites, so there's a nice cross for when we get it wrong, and there's a nice tick. Okay, so that's the setup that we want. Now on the delivery result UI, let's go ahead and add our look at camera component. And for this one, let's go different. So instead of the camera forward, let's go ahead with the look at inverted. So there it is, this is our setup. Now let's make the script to run this. So let's go ahead, create a new UI, new C# script for the delivery result UI. Let's attach the script and open. Okay, so now here let's make serialized fields for our elements. So a serialized field, first of all for the background image, and this is actually going to be of type image inside Unity Engine.ui. Okay, our background image. Then we're going to have another one for the icon image, and we're going to have another one. This one is a TextMesh Pro UGUI for the message text. Okay, let's save. Okay, so let's drag the references to the background, the message text, and the icon image. Okay, great. Now over here, let's listen when a delivery is delivered. So let's make a private void start. Let's go into the delivery manager, the instance, and we have all of our nice events. So we've got a success and a failed. So let's listen into both of them. So both the success and on the recipe failed. Let's listen to all of these. And as always, let's write good clean code and rename this. So delivery manager on recipe success. And for this one is the on recipe failed. Okay, we have both of our events. So now over here, it's actually going to be very simple. We just want to play around the text, the icon, and the background color. So for example, when we fail, let's go and we want to set the background image to about a red. So for defining the color, let's actually go up here and define a color for the success color. And we're going to have another one for the failed color. And then for the sprites, let's also have that. So a sprite for the success sprite and another one for the failed sprite. Okay, those are all the elements. So over here in the editor, let's just set them. So for the success color, let's actually use the exact same color. By the way, here's a quick tip. If you go up to a field, for example, like this one on the color, you can right click and copy and then go into delivery results. And over here, right click and paste. There you go, the perfect color. Then for the failed color, let's go with a red, maybe a bit darker. And also importantly, make sure you set the alpha to full. Okay, so we have a red nice like that. Okay. Then the success sprite, this one is going to be the tick. And for the fail, this one's going to be the cross. Okay, those are all of our elements. So now over here, when we fail, let's go into the background image and set the color. And let's put the failed color. Then for the icon image, let's set the sprite to the failed sprite. And for the message text, let's set this one for delivery and then failed. By the way, this /n, this means a new line. So over here, let's just set the text on this one. So it essentially means that it will write delivery, then new line, and then failed underneath. Just make sure you're using the / and not the /. So use the backwards one. There you go. There's a new line. Okay, so that's the on recipe failed. And now on the recipe success, let's use the success color, the success sprite, and over here, delivery success. Okay, so that's great. That should be working. Now just one more visual thing. Let's add a nice animation. So just like we did previously, let's go over here, let's add an animated component. Let's create an animation for this one, for delivery result UI. So let's go up here, create a brand new animated controller for this, and let's go ahead and assign it, so delivery result UI. All right, now let's make an animation. So this delivery result UI, let's call it just pop-up. And for this one, let's do just like we did for the numbers. So let's scale and rotate it. However, if we rotate, that's actually not going to work. That is because we have the unlock at camera, and this one is already going to be setting the rotation. So we would end up with this script fighting the animator for the rotation. So that would mess things up. However, one nice and simple solution to this, basically we just put this inside another game object. So let's create a new game object and let's put it inside. Let's an empty game object for delivery result UI and then look at camera. So we have this one. Now the reason why I created it inside is that so over here we can set everything to 0. And now with that one all on 0, we can go ahead and drag this outside of this object. And there you go, that one keeps the exact same settings. And now on this one, we can add the unlock at camera component and set it up just like we had, so the unlock at inverted. And now on this one, we're going to make a child of that one. And there you go, now everything is on 0, exactly as it should be. And on this one, we can get rid of the unlock at camera, and now we can indeed play around the rotation. So for the animation, let's just go ahead and set it. So for this one, let's go up to 1 second, and let's record a keyframe on a scale of 1, and on a rotation of 0. Then let's go back into the beginning, and for this one, let's scale it backwards, so maybe something like this, maybe a 15. Let's put it quite a bit smaller. Then let's go up by 3 frames. Let's put that one on -15, so rotation on the other side, and put it quite a bit bigger. And then on frame 10, put it on, say, 1.1, with a rotation of 0, just like that. So there you go, there's a nice pop-up. And for the alpha, let's also go over here into the 50, and let's just add the canvas group. Let's set this one over here is on 1, and then we scroll it down to 0. Okay, so that's our nice animation. Let's stop recording. Let's open up the animated controller, and over here, let's make our nice animations transition. So transition from any state into that one. Let's make it based on a trigger. Let's call it just pop-up. And for this one, this says no exit time, duration of 0. And let's go when the condition when we have this trigger. Okay, so that's it. Although one thing, by default, this animation is going to loop. So let's just go ahead, we can select the animation. And over here, let's just untick loop time. So that way the animation will not loop. Okay, so that's great. Now let's go into the script. And over here, let's get our animator. So private animator, private void awake. Let's get the animator, just get component of type animator. And let's define over here the private const string for the pop-up. So we have this, and then when we have either fail or success, let's just go into the animator, and let's set the trigger for our pop-up, both up here and over here. Now we just have obviously one issue, which is that it starts off as visible. We don't want that. So over here, we can just do game object, set active into false in order to hide it. And when we get either of these, let's set it both to true. Then afterwards, the animation will make it invisible, so it will still be active, but it won't be invisible, so that's fine. So just with this, everything should be working as we want, so let's test. Let's just make sure to save it and go back. Okay, so here we are. Let's try delivering an incorrect plate. And there you go, got a delivery failed. Okay, great. Now let's try delivering a correct one. So someone wants a cheeseburger. So let's cook it, slice some cheese. Let's get some bread. So bread, cheese, and pick up the burger and deliver. And there you go, a nice delivery success. All right, awesome. Okay, so with these handful of changes, you can already see how we made quite a big difference in our game. We didn't do anything to change any core mechanics. We just made what was already there pop out. We added a nice visual boundary to make the map look nice. We added some nice particles when the character is moving. Then we added a nice tutorial and controls right as the game starts. We also added a bunch of effects on the stove, so it flashes, has a warning and some sound. And lastly, we also added a nice pop-up when delivery is delivered, whether correctly or incorrectly. Now of course, we can always keep polishing the game until infinity. There's always more small things you can add to polish the game just a little bit more. But at this point, I'm very happy with what the game looks like. So after all this work, let's go into the next lecture where we're going to play our game from start to finish and see what we've done. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to look at all of the work that we've done and have some fun playing the final game. Okay, so here we are in our nice starting main menu. It's simple, but it works. I actually think it looks pretty good. So we have our main menu working, and we also have the unloading system that we made. So as soon as I click on play, there you go, loads the unloading scene, and here we are on the game scene. So we start off with our really nice tutorial window, and down here we have the controls. Of course, all of these are dynamic, so depending on if the player rebinds or something, this one is going to update. So we can look at this window for as long as we want. The game is paused in the background, so it's on a paused game state. Then whenever we're ready, we can interact. So again, that's the game input class, listening to the input, and again, all of the code in here is really nice and clean. So when we press the interact key, the tutorial isn't directly listening to that, but rather the general kitchen game manager. That main state machine is the one listening to the input, and this one is listening to that state. So all our logic is very well organized. All of the elements only listen to the things that make sense to them. So anyways, here we have tutorial, let's interact, and there you go, we've got our nice game start countdown, some really nice animation, really nice sound, and yep, here we are. Then we've got our clock showing the game time, and on the left side we can see our recipes. Once again, all of the elements, they're all dynamic, they're all spawned randomly, and the icons for all of the recipes, they're also all dynamic. So over here we have the character control that we built, we have the collisions that we implemented, and of course we have the raycast testing for interaction, so we can identify all the objects in front. Let's begin delivering some recipes. So for example, we need to cook some meat, so let's go ahead, put it on the stove. So here is the really nice state machine that we built. So we've got all of the various states, we've got the visual completely separated from the logic, so everything is really nice. And of course here we have the nice burning elements that we added in the polish lecture. So that one is burned, so let's go ahead and use the trash bin to get rid of that. So let's go ahead, cook another one, and let's make a cheeseburger. So let's put some cheese, let's listen to the Alt interaction key, and we can slice the cheese. We can pick up the meat, pick up the cheese, then also pick up some bread, and deliver the recipe, and there you go, our nice polished visual. Alright, awesome! So here you can already see everything that we've built. The character, the physics, the logic, the input, all of the UI elements, all of the world UI elements, all of the various counters and how they are all prefab variants, all of the plates, the separation between the visuals and the logic, the separation between the sounds and the logic, all of the polish elements that we made, over there the nice shader graph that we made. Then of course all of the basic things that a lot of tutorials won't teach you, like for example how to make a pause menu, how to make the options, how to modify the sound and music volume, how to rebind the keys, and so on. So with all that here throughout this course, we'll learn how to make a really nice game with lots of interesting interactions, which you can now apply to any kind of game, any kind of genre you want. So like I mentioned in the very beginning, you can take pretty much what we made here, which is really just a character controller and a bunch of interesting interactions. You can take everything that you've learned here and make something on a sci-fi space. So like for example, make something like Among Us, you can make something like FTL, or perhaps make some kind of survival crafting game. So all of the interactions you would have like resource nodes in the world, then you can interact to gather those resources. So with that you could build something like Rust or Minecraft or Don't Starve. So hopefully in this course you'll learn a ton that you can now apply to your own custom original projects. And if you've made it this far, then congratulations! Let's go into the next lecture where I'll give you my closing thoughts. Hello and welcome, I'm your Code Monkey, and congratulations, you have completed this course! Awesome! Seriously, congrats. Looking at the stats on my courses, very few people stick with it until the very end. So if you're hearing this, then that's excellent, you're on the top 10%. It means you are serious about learning game development, and I genuinely hope this course has helped you on your own game dev journey. Throughout this course, you'll learn about the basics of Unity and C#, you'll learn how to make a character controller, how to do a physics raycast and use that for both collision detection and identifying objects to interact with. You'll learn about C# interface and events, two extremely useful C# features. You'll learn about scriptable objects, how to use the new input system, shader graph, and tons more. And the most important thing of all, you'll learn how to build a relatively complex game while writing good, clean code. I really hope that's the main takeaway you'll learn from this course. Learning how to write better, high-quality code, learning how to refactor, how to keep the visuals and the logic separate, keep the UI decoupled from the logic. Learning all those things has now made you a 10 times better developer than when you started. So I really hope you enjoyed learning all of that. Let me know in the comments what was the most important thing you learned throughout this course. I really hope this was very fun and very educational. If you enjoyed my teaching style, check out my other courses. I really think the turn-based strategy course would be excellent for you right now. It dives even deeper into some advanced topics, and since you've watched this entire course all the way, you now have all the knowledge needed to follow that course. It will help you really solidify all the knowledge you gained, especially everything related to writing good, high-quality, clean code. And since you use Unity, check out my Ultimate Unity Overview course. It covers lots of tools and features of the engine, so you can really use all the tools at your disposal to make any game you can think of. Alternatively, if you like visual scripting, I have a course on that, or learn how to make a really nice Builder Defender game. And definitely make sure to wishlist my upcoming Steam game, Total War Liberation. I will be posting devlogs, and in those you will see how the code that I use in my own Steam game is on the same level of quality as what you learned in this course. Okay, so that's it for me. This course was a ton of work, so I genuinely hope it helped you a ton on your game dev journey. Thank you so much for watching, and I'll see you next time.